Thank you for watching our 24-hour-a-day live stream here at Explore Scientific, where we show you all the programs that we run live in front of a live audience. Programs like Global Star Party, On the Wing for birders, First Light Chronicles for beginners, and Focus on Astrophotography for astrophotographers. We bring in astronomers and explorers from around the world to answer your questions live. But there's so much cool information there that we decided to package it all together and run it 24 hours a day. We're also on Amazon Live, where we do deep dives into our products and our gear. There's so much important information as we share the education, the experience, answering questions from the audience, that kind of thing. So tune in, and thanks for watching.
Are you having a hard time trying to figure out what telescope to get? Don't worry guys, Tyler here with Explore Scientific is going to help you figuring out what you're wanting to do, either astrophotography or visual. I always tell customers that telescopes it's kind of like golfing, it's carpentry, it's a hobby that you have to learn specific tools in what they do, because these are tools. I consider them as tools, and they have a specific purpose in what you're wanting to do, either visually or astrophotography. First, we're going to talk about this little beauty, the Maxudo of Cassegrain. Great for planets, so if you are wanting nothing but planets, this bad boy is the way to go. If you're wanting some deep sky objects and some planetary, the reflector right here from Explore First Light is also the way to go. But if you just want deep sky objects, if you want wide field of view, a refractor is the way to go. These are just a couple of basics here at the Explore First Light series. The Maxudo of Cassegrain, the Newtonian, and the refractor. All of these scopes come with a red dot finder, a smartphone adapter to get you started in astrophotography, as well as an eyepiece, and whichever mount that you want to choose with the combination of telescope you want. If you need help out there on Amazon, don't be afraid to reach out through the live chat. We'll make sure that we get back with you as soon as we can here at Explore Scientific. Hi, I'm Tyler and welcome back to our Explore First Light series. Today we're going to talk about the Newtonian, and specifically this is the 114 millimeter Newtonian with a 4.5 inch mirror. How these Newtonians work is light will enter through the main objective, bounce off the primary, hit the secondary, and goes right into our diagonal, or our rack and pinion with an eyepiece or our cell phone adapter. This has 40 millimeters of draw tube, and now all these telescopes come with a red dot finder, a 25 millimeter Palossal, and a cell phone adapter. Now with these particular First Light telescopes, they always come with a couple of options as far as mounts. The EQ3, a nano mount, a Twilight 1, or an Alt-Az mount. Now with these particular telescopes, it is always recommended that you get multiple eyepieces. And I always recommend the 52° series that we see here, also with a focal extender. Usually 2 times is plenty enough. Now with these eyepieces, they are waterproof and argon purged, and they make a perfect addition to these telescopes to help you visually acquire what you're wanting to see. Now again, I hope you guys tune in for our next episode. We're going to be talking about our 80 millimeter refractor on the First Light series. And again, my name is Tyler, and I hope you have clear skies and keep looking up.
Products. I tried to get Tyler Bowman to help me, but he's a little grumpy today, so he's not here. All right, so if you're out in the Amazon world, please give us a shout out. I want to know that you're out there. I want to see who's watching. I like to talk to you guys, and let me fix my TV real fast. And so anyways, so here at Explore Scientifics, we have quite a few things that are geared towards children and that a teenage age range. And so anyway, so I wanted to show you some fun things that we have for kids. So here we go. So the first thing I'm going to show you is our nature, water, and land habitat. This I really like. It has a magnifier on the top, which you can take off. So there's a magnifier on the top. So when you put whatever it is in there, you can see down in it and get a close-up view of whatever you have captured. Make sure that you release whatever you capture. Then this comes right off, as you can see. And there's air holes in there, so whatever it is that you have found and want to observe for a little while can still get oxygen. The great thing about this product is that it is a land and water habitat, so you can take it down to the creek, lake, river, whatever you want to, and scoop you up something out of the water and see what you can find. So there's obviously the bucket. Then it comes with this wonderful net. I think it would be fun to catch fish with this, to try to catch fish with this at the river or the creek or whatever. Maybe the ocean. Make sure you hold on to this. Do you think you could catch little things at the ocean? I don't know. I'm used to having somebody talk with me, but today I'm by myself. Anyways, so I have this, and then we have little tweezers to pick up things. Now, be careful when you're picking up insects. Some insects can be poisonous, so we always recommend that you make sure that you try to identify whatever it is you're picking up before you pick it up. One time I had one of the world's deadliest caterpillars on my front door when I went out the door, and it looked really cute and fuzzy, and then we tried to figure out what it was and went, oh, I guess we shouldn't touch that. So anyway, so make sure that you try to identify whatever it is that you're capturing. And I'm going to screw this back on here just for the fun of it. So you can carry that around. It has a wonderful handle. And then, of course, it comes with an additional magnifier. It has a magnifier here, and then it has a higher magnification right here in the bottom. Let's see if I can tell you. It says 2 times to 4 times magnification. Grumpy man has arrived. Anyways, 2 times to 4 times magnification, so you can get up close to those things that you want to observe. This would be great if, let's say, like I said, you found a caterpillar that you didn't know what it was. You could look at it this way, look at it with this, try to identify it, and then if you wanted to keep it or try to capture it and keep it for a little bit, then you can. I think we have a, don't we have a video on this, Paul? Oh, I'm sorry, my screen's not working. It's not working over here, so that's why, because it shows focus on astrophotography from August 19th, 2022. So anyway, so this is our nature, land, and water habitat. Oh, we got kicked. Oh, we're still on Facebook, so there we go. Okay, so this is our nature, land, and water habitat. Here we go, and we are back on Amazon Live. So this is our nature, land, and water habitat. It's a great little thing to keep around, to take your kiddos outside and to explore and find things. This is for ages 6 and up, but obviously if you are if you have parent supervision, then you can also do a little younger. So. Yes, a lot of other people need supervision around here. It's fun. We like to be silly around here. Okay, second, now that I'm done with that, let me move this. No, don't worry about that. I'm getting out the metal detector. And then I'm going to find some still-headed person. Okay, so so anyways, this is our Explorer 1 metal detector. It will. Oh, can you hear it?
Will it detect metal?
Yeah, that's detecting the rebarb.
The what barb?
Rebarb.
Rebar.
Rebarb. I want to call it barb. Rebar. It's yeah. They all know you're here now. So this is Tyler, my grumpy assistant.
Who can't even fit the screen.
He can't fit in the screen.
It's because you're short and I'm tall.
You're short and I'm tall.
You're short.
You're short and I'm tall. This is our this is our Explorer Hut camp. This is our Explorer.
Couldn't see me, could you?
You were camouflaged.
It was camouflaged.
Camouflaged. So this is our Tyler came in our Explorer Hut, camo Explorer Hut. These are really great for kiddos. We had a little girl come in yesterday.
Day before yesterday.
Was it? No, today is Tuesday.
Oh.
So it was it was yesterday. It was yesterday, and she was climbing all through our Explorer Huts.
I have to. It's detecting your eyelids.
Okay, anyway, squirrel. Anyway, so we have these Explorer Huts in quite a few different things. We have a haunted house,
Got a cupcake.
a cupcake truck.
Girls cupcake. People can't see your face.
I don't want people to see my face. See, they can see. No, they can see.
School bus.
They can see my face like this.
They have a school bus.
A school bus.
We have a rocket ship. We actually have a rocket ship as well. And Paul's got a wonderful video load.
Yeah, look. So we have lots of fun. Now he's leaving now. So he was bringing in my Explorer Hut. He was actually crawling around on the floor in my Explorer Hut. But you can see we have a rocket ship, we have a castle, we have a princess castle, we have a haunted house, we have a skid steer, we have a camo tent, we have I'm trying to think of everything. A bus, a cupcake truck. There's so many options. So if you go over to our Amazon page, you can see all those Explorer Huts on there and pick you out one for a kiddo. They're really cool because great reading nooks or just imagination. You can just spend some time just having fun. Kiddos can, it makes their imagination grow. We also have some that have the tops. The top is open on them, and so if you want to take it out at night and maybe do some stargazing, you can do that as well. Just a nice little nook for them to be able to do that kind of stuff and see the stars at night without any extra light coming through. So, but yeah, we had a little girl come in and she absolutely loved this, in and out through it. She was not even. She had to be between 2 and 3 years old. And so this is for ages 3 and up. Great thing to have around. My son, every time he comes here, he tries to pick one out, or he does actually pick one out. And so we put him in a cubicle with it, and he has a fun time in there. So we put toys and stuff in there for him, and he enjoys that. So yeah, that's our Explorer Hut, our Camo Explorer Hut that you can see. That's why I couldn't see Tyler, because it was camouflaged. Or he was just out of frame. So yeah. So anyways, back to our metal detector. This is our Explorer 1 metal detector. It detects precious metals, obviously, down to 6 inches below the surface.
Yeah, I go on the floor.
Oh, you have me on the floor? See, it keeps going the rebarb. I know. Paul doesn't like me saying that. Okay, so yeah, so there's metal in the concrete, obviously, and then it detected the eyelets on my shoes. We've in the past had some coins down. It'll detect that as well. It has a bright LED light right here that you can turn on, and you'll be able to see at night if it's getting a little bit dusk. It can also, I believe, it has a water resistant coil, which means that this portion can go into a puddle, but you can't submerge the whole thing in water. So if you want to go down to the creek or the lakeside or whatever and do some metal detecting with it, then you can. So, so yeah, that's our, and the little flashlight comes off. So you can have that to do things with as well. And I think I'll do one more thing since I've done those 3 things. And that was really fast because Tyler brought that Explore hut in. Okay, so now we did the nature habitat, which is a great thing to go out and just explore during the daytime. Then we have that the Explorer hut, camo hut that I showed. Obviously can fit Tyler in it, kind of, sort of. And then we have a metal detector. And the clubhouse. You know, and then the cupcake truck. You know, it's really cool because the castles are pretty big. I don't think you have a video of those, but we have the Princess Castle and the regular castle. They're really big. So if you have a child that's a little taller or a little bigger and wants to have fun in that, then you can. These ones pretty much fit. I think my son's 5. He comes up to about here on me, and he usually fits in all of these tents. So they're pretty good. They're pretty good size and roomy and comfortable for them to hang out in and do fun stuff in. So I know, I'm sorry, I forget. No stripes. Okay, this is our National Geographic. What size is this? I forget. Oh, here, let me get the box. 50 millimeter. It's our 50 millimeter tabletop Azimuth mount telescope. So this is a great, like I was saying, the Explorer huts. Sorry about that, guys. Like I was saying, some of the Explorer huts have open. The tops of them are open. We actually have a 2-room observatory tent here for adults that you can put your telescope in. The same thing is the same concept with an Explorer hut. You could do the same concept with the child. Put a telescope in there and do some stargazing at night with them. This is a really small, compact telescope that's easy for little hands to carry around. This is for ages 6 and up. So it's a great starter telescope to be able to sit on a table, sit on the ground, then be at their height, and then be able to look through it. It comes with a 12.5 millimeter eyepiece, and then it also comes with a 20 millimeter eyepiece. So whenever you're doing a telescope, you want to make sure that you start with the highest magnification, the lowest magnification eyepiece, which is going to be that 20 millimeter eyepiece. You will put that in there, and then you'll point it wherever you want it to go. And like I said, this is an azimuth adjuster telescope, so so you unscrew this and the locking lever, and it'll go left and right. And then you'll unscrew this locking lever, and it'll go up and down. So it's really easy to use, really lightweight and really compact. So you can take that wherever you want to. Start off with that lower magnification eyepiece, larger number, lower magnification. I know that's backwards, but that's the way it works. You'll put that eyepiece in, point it where you need it to, moon, whatever, and then you'll just slowly work that in and out and get it into focus. It has a little lens cap, so you can take that off. And it has the dew shield doesn't move, but it has a dew shield to try to help keep that dew off your lens cell. So it's easy to just fold up and take with you. You can also, I think this little guy comes out, but I'm not quite for sure how. I have not messed with this. This is the first time I've messed with it. No, it actually is attached straight to it, so you don't ever lose your telescope. That's nice. So it all comes together. So if if you have a little one that's messing with it, it's playing around with it, then you don't have to worry about pieces getting lost or your telescope being in one spot and the tripod being in another. So they're really good, lightweight. I want to get that for my son. No, I want to get that for my son now. Okay, so you can obviously do, so refractors are great because you can do terrestrial viewing and land, and oh my gosh, my brain. You can do sky viewing and you can look at animals as well. So this telescope will allow you to look at birds, you know, stuff in the woods. Just if you've got a back deck and you've got some woods behind you and you're just wanting to see what's out there, this will be a good little telescope to have around. It's 50mm aperture. The focal length on it, let's see, I'm going to tell you, is 360 millimeters, which is a really good focal length to have. The other nice thing too is we have them. We have Barlows, 2x Barlows that you could plop on there, and that'll increase that magnification on your eyepiece, so you can see things a little bit up closer. Let's see, it's an 18 by 28, 8x magnification, so it's got that good magnification for you to be able to see things up close and personal, and you can even see the moon with it, which is always a big hit with little ones. So, so between this, you know, if I was going to get a package set for my kid, I would definitely do an Explore Hut with a telescope or an Explore Hut with a pair of binoculars, and that's gonna really increase their exploration in our world. And so you would have you can take them out, spend some time with them, just kind of listening to what they're hearing and looking, and what a great time to just sit and be in the moment with them and have fun and do some exploring and having some adventure. And you can do that from your own backyard. You don't have to go far off, you know, miles away. You can do that from your own backyard with them, and so that would be a fun thing to have. Now, the nature habitat, you could, if you have a vegetable garden or just your backyard, wherever trees and shrubberies and stuff, finding animals, insects to put in there, or like frogs and stuff like that, you can keep those around as well. So I think right now here in Northwest Arkansas, I was seeing that silkworms are a big thing. So we actually had somebody post on a Facebook page, hey, if y'all want some caterpillars, come get them. So yeah, so you can also keep caterpillars in that nature habitat as well. And I don't know what else to talk about.
You have other products back there?
I do have other products back here.
Magnifying glass?
I don't have a magnifying glass. Because I don't have, oh, I have this. We haven't talked about this in a while. I'm just talking too fast today. Like Speedy Gonzales. Paul's not liking my jokes. This is our Galileo Scope. It's a DIY project. It is a great product to have to teach a child about how a telescope works. It comes with the lenses. You literally build it from the ground up. So I'm going to do that today. I don't think we've had this. I don't think we've shown this in a while. So it has its, yes, I know. It has its OTA. Here's the OTA on it. I'm going to set this off to the side. And this is a true telescope. It really does work. But you just have to put it together. So the first thing we're going to do is we're going to get the lenses out. So when you're getting your lenses out to put them in, you want to make sure that they are in here correctly. One side will be concaved and one side will be curved. So we want to make sure that we put that in the appropriate way. So you can just fill on those with it, and always use tissue paper when touching your lenses. So we're going to put that there, and then we're going to put this here. And then we are going to put, I need the rings to hold it together. A G-scope. G-scope. So these little rings will hold this together. There's a ridge right here, so you'll just slide this on. Put it right here. Great. It's over in that carousel if y'all want to check that out. It looks like I'm missing a larger ring for some reason. Oh, wait, I didn't get it out. But wait, there's more. The one thing I did not put in here is the nut for the tripod, so that's the only thing that I forgot to put in. On the bottom down here, there's a place for you to be able to mount it onto a tripod. So you can have a little, so you're not having to hold it the whole time looking, which can get a little tiresome after a while. Okay, so now I've got those on there. The next thing I want to do is I want to build our draw tube. So, and Kent took out the instructions, so I have to try to wing it a little over here. Sorry, Charlie. So here's a draw tube. So we're going to take another ring. We're going to stick it here. Looks like we left the eyepieces together. That's great. So we don't have to try. I don't have to try to put those together. This will slide right in. This will go here. Wait, I might be wrong. Hang on. This goes in first, maybe. I'm trying to get it in there. Sorry. I think I have it in backwards, though. I feel like I've got something. Lucy and I have done this a million times, and I guess I'm just forgetting.
I think it goes on the other end.
You think it goes on the other end? No, because that's where the lens is at. This is the draw tube.
What are you doing?
I'm putting it in here.
Break it.
I'm not going to break it.
Let's see.
It goes right here.
Well, what'd you need my help for?
You asked what I was doing. I'm trying to tell you what I'm doing. Okay, so here's the draw tube, finally. I just had to get it down in there. So there's our draw tube. Let's slide it out. Hang on. Let me slide it out. I'm going to slide this little sucker down here. I should have put that on first. That's what I was supposed to do. But we will improvise. All right, so there's our draw tube. So once you get it all together, you can put your dew shield on. You have a dew shield. You have a place for a tripod. It comes with a Barlow and an eyepiece. So you just slide that eyepiece in there. You slide that eyepiece in there, and then you'll be able to get that into focus by pulling that draw tube in and out. And then, of course, it comes with the Barlow, which is not put together, so I'm sure I got lenses somewhere around here. But it's really cool because the lenses, they come in little pieces, so you can... I don't fill them in here. So you actually, the instructions will tell you how to put them together, concaved and flat, concaved and curved. And so you'll put those lenses together. You'll put a set in the front, a set in the middle, and then you'll be able to use that eyepiece. This is one of our Explore Alliance ambassadors right now, showing you how to put it together. Those are the lenses that you can see. Her name is Libby in the stars, and she is an amazing astronomer, and so she came in and did that for us, recorded that for us, and did a great job, and goes into more detail and depth on that. If you want to see more detail and in depth on that, I think you can find it maybe on our YouTube channel. I'm not for sure, but yeah. So that's what I have for you guys today. And I hope that it was good. I hope you enjoyed it. Paul G. Newton says, hello. Hello, Paul. And Noah Menard says, hi, Annie. At least I got two people out there. I'm sorry that I'm not Kent. I heard you guys love Kent, but Kent likes to Kent takes a break sometimes. He wears a lot of hats here at Explore Scientific, and so on Tuesdays we like to try to give him a break and do some more do educational stuff for the younger group out there. So if you're a parent that has a little one that would like to look at our STEM products and see what we have, you can go on over to our Amazon webpage, Amazon page, and see all of the things, all the wonderful things we have. And it's growing. We have electronic kit sets. We have the Explore huts. We have, in fact, I think we just put out a Mike Overacker. Thank you. Hi, Mike. I'm glad you're out there with me. We just put out a what is that light? That light. What is it called? No, not an adventure scope. What is that light thing that I had the other day? We have a thing that projects nebulas and stars. So it is a cone on one side, and it'll rotate this. It's a projector, not for at night, and it'll rotate the stars through on the ceiling. And it is a fun thing to have. We've been playing with it in the store. We're going to try to get it set up so people can actually see it and how it works. I have one at my house for my son that's kind of like that, and he loves it every night. He's like, "Mom, turn on the stars," and so he really likes to watch the stars and the galaxies go by. So if you have somebody that, like a little one, or somebody that likes night lights and needs something to kind of keep them feel, cozy and safe, that would be a great little tool, thing to have around. So, all right, guys, I think that's all I have for you today. I'm going to make sure that I have somebody with me next time. Hopefully, we're kind of sparse and in between, but if you see something you like on here, please make sure that you go over to the Amazon carousel and check that out. Mike is saying, "I just came in from outside. I just finished the final program to make my ES 20-inch Dobsonian to a full go-to and tracking scope. It is working great." That's so exciting, Mike. I can't wait to see video and stuff of it going. That's awesome. That is awesome. I'll have to tell Tyler and everybody that you did that. So, all right, guys. Well, tomorrow we won't have any more shows today. Scott is somewhere else, and then tomorrow we'll be back with First Light Chronicles, and then Thursday is Explore Alliance Minutes, and then Friday is Focus on Astrophotography. So we'll see you again on Amazon Live. See y'all later. Bye.
universe is delivering to us right now. So we'll see what happens with the James Webb Space Telescope, which is what I'm really excited about for the future. So James Webb, as I mentioned, was launched Christmas Day, last Christmas, and it's about to release its first science observations a week Tuesday. So I think you'll want to stay tuned for this. I think it's going to be pretty exciting. This is a telescope. It's a 6.5 meter telescope. Hubble's a 2.5 meter telescope. It has 18 mirrors. These are made of beryllium and coated with gold. This telescope, I first heard about 25 years ago. I was on a scientific advisory committee that had been charged with coming up with what would succeed the Hubble Space Telescope. So this was the idea. And a few astronomers were asked to go to the Goddard Space Flight Center. We were giving some advice, scientific advice, and we first heard about this telescope that would have to unfold its mirrors in space. It was going to fly 1 million miles away, 1 million miles from the Earth, unlike Hubble, can't be serviced. It would have a sunshade here that would have to unfurl in space. These things, each of the 5 layers of this sun shield is about a width of a human hair, has to unfurl in space and then be locked into place. And the astronomers in the room looked at each other and said, "This is insane. It will never work." And it worked. Yeah, it's amazing. It was a picture perfect launch. It could not have gone more flawlessly. And I think they said there was something like 100 single point failures. We were literally waiting with bated breath for each one of these things to unfurl. But it made it. It's 1 million miles away now. So here is, here's the moon. This is Hubble's orbit. Hubble's in a low Earth orbit, but well, here, 400,000 kilometers above the Earth. And this, the James Webb Space Telescope is now about 1 million miles from Earth, and it's a place called the L2 Lagrangian point. I'm not going to ask you about that later either. But the first images, they took of a star. There are 18 of them here that just happens to magically match the number of mirrors there are. So it was actually one star, but it was all over the place. They had to spend weeks fine-tuning the positions of the mirrors so they knew where each of these stars should go. And eventually they were able to focus it into a single image. And that image, or the calibration image, turned out to have galaxies in it that had never been seen before. So even the test images now are proving to be just spectacular. Here's an image that was taken by the Spitzer telescope at the 24-inch telescope in space, a mid-infrared telescope. Here was, again, this is a test image from Webb and the mid-infrared instrument taken in May. Now, why is Webb so interesting? Why do we want to observe in the infrared? Here's a picture. This is the Eagle Nebula. It's a region in the Milky Way where it's essentially a stellar nursery. New stars are being born in these pillars here. They're, I think the number is something like 6 trillion miles high, these things. And that's small by astronomical standards. This is a small region in our own Milky Way galaxy. And you can see these dark patches here. We can't see any stars in this nursery. But when we observe in near infrared light, suddenly you can start peering through the dust and you can start seeing where there are stars that just are not visible in optical wavelengths. And then in the mid-infrared, when you go to even longer wavelengths, you start seeing the dust radiating itself, and you can learn about the dust properties. So it has this incredible capacity. Also, because the universe is expanding with time, as we look farther and farther back, we're seeing earlier in the universe, as the universe was when the light left those objects, because light travels at a finite speed. That's something that Albert Einstein taught us. And because of the expansion, the wavelength of light is being stretched and it's being shifted to the red. And so we can observe farther back in time.
Well, hello everybody. It's Scott Roberts, Annie Scarborough, and we are here for Explore Alliance Live. And so
It's
what you were
definitely
hearing-
live.
What's that?
It's definitely live.
It's definitely live. That's right.
And we know,
What you were
and we know
hearing at
Scott's
the-
coffee is hot.
It's
I was
hot.
saying, and we know your coffee is hot.
That's right. So we were listening to a little piece of the presentation from Dr. Wendy Friedman. She's an astronomer, cosmologist type of astronomer from University of Chicago, and her defining work has been on something called the Hubble Constant. Now, this is something that Edwin Hubble came up with as kind of a yardstick of measuring, a mathematical measuring tool to measure the size of the universe. Since he came up with it, it's been refined, and the number's been refined by measuring what they call standard candles. Okay, so those are certain types of stars, certain ways of measuring brightness or energy from the universe, and then trying to statistically remove noise out of it to get closer and closer to a theoretical model. Okay. Wendy Friedman and her colleagues, I think they have it down to a certainty of like 1%. Okay. And they are looking to refine it even further. So it was real exciting for us to be at the Mount Wilson Observatory during a time, a historic first, where the George Ellery Hale family, the extended family, was able to get together to finally meet one another, maybe for the very first time in their lives, and to talk about the legacy and importance of George Ellery Hale, who died in 1938, I think. Lived a relatively short life, only 50 some odd years. But in those years, he built 4 of the world's largest telescopes in succession. He developed the entire field of astrophysics. He developed a journal called the Astrophysical Journal, which is still published today. He created the American Astronomical Society, which is what all the professional astronomers belong to today. And recently, some new developments where they're encouraging amateur astronomers to join the American Astronomical Society. In his spare time, he helped build out the city of Pasadena, helped Henry Huntington develop the Huntington Library, which is an incredible 130-acre estate and amazing archive of science books and all kinds of books. He also developed the California Institute of Technology, otherwise known as Caltech. And so a very busy guy, didn't really have a lot of other time on his hands to get his family together like they did over this last weekend. We were invited to give or to set up and broadcast live the event. So if you had a chance to watch it live over last weekend, you got to chat and see some of this activity as Ed Krupp from Griffith Park Observatory gave a special talk. Sam Hale, the grandson of George Ellery Hale, gave some inspiring talks. And the president of the California Institute of Technology was there on hand as well. And then the second day, they went to Mount Wilson Observatory, listened to Dr. Wendy Friedman talk about the Hubble Constant, which was developed at Mount Wilson, and to talk about her work on the James Webb Space Telescope. She'll be one of the very first observers to use that instrument. And so it was a real honor. We got to see her talk, got to have dinner with her. It was just really, really cool. And then they went off and looked through the historic 100-inch telescope where the, some of the measurements for the Hubble Constant were worked out. So, Annie, you've been studying the James Webb Space Telescope recently.
Yeah, just in the last week. I am new to the education world, and so I'm in the middle of a speech class, and I had wanted I had to pick my own topic. And when I was going through the TED Talks that really caught my attention, I was, because we, work at Explore Scientific. So that's kind of, it's like, oh wait, there's a telescope. We're talking about a telescope. Let's read that. And so let's watch that. And so I was really, really amazed. And in fact, I was telling Tyler about it today, and he goes, "Where have you been, Annie?" Sorry, under a rock. So, but it just really inspired me to think there is so much more out there, and especially whenever the gentleman that was talking, he was talking about new planets and how they're going to be able to see new planets and discover those and things like that. And so it's going to open up exploration really, really big. So it's exciting. It's exciting.
The Hubble Telescope did that for us in it's been up there for like 3 decades now, 32 years, I think it's been up there, collecting data, still working today. But Jay West will be another, just will leapfrog over what Hubble Space Telescope did for us. And so we're going to get to see the universe in a whole new light, amateur astronomers, Annie, a lot of the astrophotographers compare their 60-hour, 100-hour long exposures or whatever to the Hubble Space Telescope. That's kind of their benchmark.
Oh,
You're about to get a new benchmark. Okay, with Jay. And the problem, a hurdle for them also will be is that Jay West images in the infrared, and you and I were talking about it earlier today, and you were talking about the gold that's on the mirror and mirrors, and that's the gold reflects more infrared. It's higher performance in infrared.
Yeah. Well, that's really, and it's really neat how because I know as we were talking today, I was, you said they started this journey in 96, I think you said. They started this whole thing in 96. It's 96. And so it's just crazy to think about how far technology has come and how much further it's probably going to come even more. And so, the things that they've had to overcome and had to think about and achieve in order to even be able to get it into space is absolutely amazing. So I think what was the lady's name that was speaking? I'm sorry, Scott, but we just watched the video on
Wendy Friedman.
Okay, so did she say that was as thin as hair? Is that what she said in her talk? That
it was atoms thick. She might have described it like that, but it is very, very. That's optical coatings, including the coatings that are on our telescopes, are they're the way that they're applied is they put the polished optic into a vacuum chamber. Okay, they pump out all the air. Okay, then they have a way of driving or vaporizing the materials that they want to use. In the case of Jay West, they used gold. Okay, so they had gold pieces in there. They had an ion gun flowing an ion plasma onto the gold. Okay, now it's in a vacuum chamber, so it's making this cloud of gold that's covering everything, including the optics. Okay,
that's crazy.
So it's very, very, very thin. They usually put an overcoat to protect the coating. In the case of Jay West, I'm not sure if they had to do that or not, because there is no air in space to oxidize the coatings. And gold doesn't really oxidize anyways, not like aluminum will, for example.
Yeah. So did they? So then they mainly chose gold because of the oxidization. I can't even say it.
No, they chose gold because of the infrared reflectivity.
That's right.
Infrared, because it's an infrared telescope.
Yeah. So I didn't know if it was because of both of those things. Like I know silver probably doesn't do as well as gold, but I didn't know if maybe it just sounds like it sounds like a material that is more durable and will achieve the things that they're needing. So But it was, as we were talking today, the other cool thing was to think about how strong it is. I think you said that you could see the details of a penny 24 miles away, and then
Right.
and then whenever we started and whenever we started talking about it, then we started talking about, okay, well, how far can we see in a horizon? And you said like 3 miles is as far, if we're at sea level.
It's 2.9 miles or something,
It's
so
like
if you're,
nothing.
I'm not even 6 feet tall. I'm like 5'10", okay? So I can't quite see 3 miles out, okay? Even on a crystal clear day, looking out over the ocean at sea level, I'm only going to be able to see 3 miles out. You get some elevation though. Now you can start to see much further out, and many, hock climbers and stuff like that, or if you've been to the top of a mountain, you might be able to see 100 miles out, okay? But imagine holding a penny out, somebody's 24 miles away.
You can see that. That's crazy.
What's the date on this penny here, okay? That's what Jay West can do. Okay, so.
I mean, and when it's in our hands, we have to like bring it up so close to our eyes just to see it.
Right. I'm using a magnifying glass, right? That's right. So
that is so crazy.
Super, right.
Yeah.
So
well, it's interesting. I think somebody on the chat is asking about what we think about civilization out there, and so that's a great question. I mean, there's so many different kinds of things that could be living and growing that we don't, you just never know.
One of the big problems I think humans have is that we separate everything, right? We separate everything. You're separating the whites from the colors and putting in the washing machine. You're separating, which side of the road you're driving on. You're separating which ring you put your finger. You put your ring. We separate everything, okay? And therefore, we think that we're home base, okay, and everything out there is separate from us. Okay, so when you ask the question, are there civilizations out there? We happen to be part of the out there. Okay,
that's true. That is a true statement.
Absolutely connected to everything else in the universe. So if you want to ask, is there life out there in the universe? Your first answer is yes. Okay, because we're here. Okay, it's self-evident. All right, that we're already here. Now, is there other planets out there that have life on them? Probably, okay? Probably, because it happened here, okay? And so I think one of the big fallacies that humans keep falling into is that we think that we somehow occupy a special place in the universe. It started with us thinking, in Ptolemy's time, okay, that we were the center of the universe. Earth was the center of the universe. And everything went around us, okay? And up until really the turn, when the 1900s are getting established, Harlow Shapley is at Mount Wilson using the 60-inch telescope, measuring globular star clusters. Have you ever seen, have you seen globular star clusters with your telescope?
Not with my telescope, no, I have not.
Yet. Okay. Well, when you do, you're going to be blown away. They look like snowballs of stars. They're beautiful.
Oh,
I had to
Have
wipe
you
mine
seen-
down because I was seeing globular clusters. Once I got rid of that, I was fine.
He was fine. Okay. Globular star clusters are some of the most beautiful objects in the sky, and they can be seen even with small telescopes. There's some real bright ones out there, okay? But they look like snowballs of stars, okay? M13 is like a really famous one, the Hercules Cup Cluster, okay? Well, these globular star clusters are formed around the center of our galaxy, like in a halo, okay? And so Harlow Shapley started making very careful measurements of these globular star clusters and measuring the distances to them, okay? Probably using the standard candle method, of how he's measuring how bright these stars are, okay? Oh, these are a lot fainter, therefore they must be a lot further away, okay? And so he learned after his measurements that, oops, not even the sun occupies the center of the universe. Up until that time, general accepted reality, as we want to call it, okay, was that the sun was in the center of the universe. Wrong. We're not even in a special part of the Milky Way, okay? And then we discovered, oh, well, the Milky Way must be the center of the universe. Wrong again, okay? No, it's not. It's just one of billions or trillions of galaxies out there. So we do not occupy a special place in the universe, okay? Therefore, it's easy to infer that life is not as miraculous as it is, and how, you know, that we think it's uncommon, okay?
Yeah.
We think it's uncommon. And some people, some theorists, you know, or people putting forward hypotheses that this is the only place where life existed, because we have not yet really detected, you know, irrefutable, hardcore proof. Now, we're not like, you know, with on the Tonight Show with an alien, okay? We're not. I mean, it would be really cool if we were, but that hasn't happened yet, okay? To our knowledge.
Well, and I think
So
I
maybe
think that
Johnny
I think
Carson
that
might have been an alien, but you know. So.
you never know. I think that one of the things too is, though, as we wrap our minds around life out there looking like us, and it doesn't. Sometimes
There's
it could be
one.
a small. It could be a small thing, microscopic living thing that's out there that we don't know
Let's
about.
take
You know.
COVID. Yeah, I would say that COVID is a living thing, okay, out there.
Yeah.
It's a virus, okay.
Yeah.
It collectively has a kind of intelligence, okay. It certainly kicked our butt, you know, and right. So and things like viruses can actually survive the environs of the vacuum of space, you know.
Yeah.
And they're not the only things. All right. So there's you know, possibly bacteria that had been blown out of our atmosphere by big asteroid impacts, for example, could have, with the solar wind, kept blowing out till some of it collected, rained down on Mars, you know. So there's an idea that you know, the genesis of life here, as amazing that you know, kind of creation event is, you know, may not be that unusual in the universe. All right. So we, you know, as far as being very technical, you know, humans are still not super ultra technical. You know, I would say they just found, I don't know if you saw this, but they just found some human remains that are now dating 1 million years earlier than the oldest human remains ever found.
Wow.
So it puts humans back to about 3.5 million years. All right, well, let's just take the last 50,000 years. How much did we technically really know? Not much, okay? Then you keep compressing it to, you know, maybe the last 500 years. 500 years, it started getting pretty interesting. The last 400 some odd years, we got the telescope, okay? So, and now today, you know, we go all the way from Galileo's kind of not very great telescope to the James Webb Space Telescope, you know?
Yeah, they were 300,000 years old, according to the carbon dating.
You're talking about these
What
remains?
Yeah, the remains.
Oh.
3 million.
Huh?
He said 300,000.
What's the byline on this? What date is this?
Yeah.
That's why I got to 2017.
Go a little further. Well, you
Like-
know, if you honestly think about it, and like when she showed the Eagle's Nest nebula, and she called it a nursery of creating stars. If you think of everything in that aspect, then you have to come to the conclusion that there must be life somewhere. I mean, that's being created. Life's always being created
It's
here.
right here.
I mean,
It's right here.
you can't just assume that this is the only planet that has life on it. I mean, it's, you know, so it's just, I don't know. It's really interesting to talk about.
We can't say for certain that it is. We can't. Also, you can't say that it's not. Okay, so that's the deal on that. Most people who study science, follow this kind of stuff, do realize the distances involved. Okay,
Uh-huh.
we are, light years away from other stars, and um, so that's the deal. It is very intriguing to think about. If you went to Pekka and Connor and you guys that are really kind of commenting on this, the if you went to the Jet Propulsion Laboratory and you asked the scientists there, okay, what is it that we're studying now? I mean, we kind of went through an era in astronomy where we were making maps. Okay, we were saying, okay, plotting this, and there, voila, we got a constellation. Okay, then
Hmm.
we started trying to refine the positions of the stars. Okay,
Hmm.
then we learned how to measure the stars. Okay, the distance to the close stars, and then we started measuring, and then this expansion thing of which started really and got kicked off big time
Hmm.
in 1923 when Edwin Hubble discovered a variable star in the Andromeda Nebula. Okay, that happened at the 100 inch at Mount Wilson, and
Hmm.
suddenly we went from, oh my goodness, the whole universe isn't just the Milky Way. There are lots and lots of these other
It's a
island
lot of stuff out there.
universes. Yeah,
Yeah.
and so that went from, I don't know, probably thinking initially there's a few hundred of them to a few million of them to a few billion of them, and now maybe it's a couple of trillion, and maybe there's parallel universes. So,
Yeah, you just
that is
there's no
the
cap.
deal.
I don't think we can count how many things are probably out there. Out there, it just keeps going and going and going, which is amazing. I mean, what a great exploration, to be able to be a part of and and
Sure.
watch that journey unfold. I mean, I know that they had major things to overcome, from getting the telescope into the rocket to getting it out into space and unfolding it, and there was just a
Isn't that
lot to
incredible?
do in order
Yeah.
it to be able to do that. And so, and I want to know who thought. Okay, I just can see them trying to figure out. Oh, this telescope is way too big to fit in a rocket. Let's figure out how to origami fold it down so it'll fit in there.
It was an origami, and it was just amazing. I mean, I think Wendy said in the talk there was like 100 points of failure. There was more than 100 single points of failure. I
Hmm.
think it was like 300 and
Hmm.
some odd, just crazy. Okay, numbers of likelihood of failure on this instrument.
Hmm.
But the point I was making about the Jet Propulsion Laboratory, if you went to the Jet Propulsion Laboratory today and asked them how are they studying, what is it that they're really after to study in the universe? It's not
Hmm.
distance, it's not the spectral analysis so much, okay?
Yeah.
What they're searching for is life, okay? And they're
Yeah,
very
that's really what
serious
yeah.
about it, okay?
Yeah.
So,
Well, that's why they're constantly looking for new planets. I mean, the first time I read about, I think Jerry Hubble. I read an article on Jerry Hubble, him figuring out. I can't remember what kind of planets they are, but because of the way they pass, the light that comes, like you could just see the shadow of it, and so
yeah.
that's how I can't
Yeah,
remember what they're called, but
that's how amateur astronomers can see
yeah,
exoplanets. There's
yeah,
methods. They're measuring the brightness of a star. They
hmm,
predict. There's a prediction of the exoplanet. They get these
yeah,
predictions, and so professional and amateur astronomers actually go and study it and see. Oh wow, there's this light curve dip. Okay, match what was predicted. Okay, if it
yeah,
does, then you probably got to, that's that adds strength and weight to,
yeah.
yeah, that's a planet. So,
Yeah. Yeah, and that's really neat to think about. I mean, as hope this telescope will probably help with some more of that study and be able to find more planets out there. And yes, of course, that's what we're looking for is another life, a life out there. Are we the only ones? Which
right.
on this planet
Yeah.
we aren't the only ones. We have so many animals and other things here that it's you can't say.
Right. Yeah. So hopefully someday, Annie, you can go and visit the Jet Propulsion Laboratory. It's a wonderful place. I'm an ambassador,
Mhm.
volunteer ambassador for NASA and JPL, and
Okay.
I've been for many years, and it's just, it's amazing. And the scientists that work there, they'll tell you, they'll say, look, this is a special place. They say that animals come up to them. They talk about it in ways that
They just walk up to him
normal
like
people
Snow
don't
White.
talk about stuff, you know, because they
Is it like Snow White and the Seven Dwarfs where they just come?
very much like that, you know, when they come up and the birds sing to you and so. Not quite, okay, but
I'm just kidding.
the animals are much friendlier to the scientists than just say, you know, because you don't see these animals walking around. This is Pasadena, right? They're in the city.
Yeah.
And so,
Yeah.
they are, you know, it's just really interesting about this. And, you know, the people who work there, they are, you know, the way that they view the universe, the way they think about it, and how hard they're working on these things to explore our solar system and all the rest of it. It's really remarkable. So, you know, if you got people that can figure out how to swing the Voyager spacecraft around using gravity assists around other planets to get around to other planets, and then to extend its life by years and years, to the point now, I mean, they are still getting signals back from the Voyager spacecraft, and they're in interstellar space.
Wow.
So what does that make us? What does that make us? Okay, we've got humans in space 24/7 on a space station. Okay. We send up appliances all over the solar system. We've got rovers, we've got orbiting cameras systems, all the rest of the stuff. We got we got a couple of very nice, in fact, more than two very nice space telescopes out there. Most famous of which are the Hubble Space Telescope and J West. Okay. And of course, we got some billions of people here standing on the planet right now, but we're related to all of them. We're all connected. Okay. All right. So there's not like the astronauts, and they're somehow separate from those of us on the ground. We're all related, right? So we're not just Earthlings anymore, okay? Not really, if you want to be honest about it, okay? We are a spacefaring species.
Yeah.
And so our, you know, I mean, if
do I have to change my title now?
Yes. To Paul Newton, spacefaring.
So
being.
it's Reverend Colonel Paul G. Newton.
Only in
Paul
space.
just got his Reverend status, so pretty soon he's gonna be able to marry people.
I'm also a colonel.
And a colonel. Okay,
Yes.
we're gonna start calling you the colonel.
I'm Reverend Colonel Paul G. Newton. I went to auctioneer school when I was younger, so I'm
Reverend
actually
Colonel.
a colonel.
You're actually auctioneers are colonels. That's oh gosh.
Yes.
I want to say to that, Paul.
Oh my goodness.
No,
I'm
you're
not a doctor.
general.
Jim Norwood said, Dr. Paul Space Traveler.
There we go. That's right.
I'm not a
I think-
doctor.
Dr. Paul, space traveler.
Reverend
I think that
Colonel.
I think somebody asked if we have ever made our own telescope. I
Yes.
have not. Scott, have you?
You have, Annie. You made the Galileo Scope.
Oh,
built one?
that's a kid.
But
it's a kid I
it's-
put it together. That's
It
different.
counts.
Okay, so there's different levels of making your own telescope. One of them is that you've designed a telescope, put it together, made it work. Okay, I would qualify that as making a telescope. All right. There are other guys who took, like John Dobson, for example. John Dobson took porthole glass from ships and beach sand, okay, and ground out a mirror and then polished it. Okay, that's how he made his. That's not the invention of the Dobsonian, but he built Dobsonian or he didn't call them Dobsonians. John Dobson didn't like calling those telescopes Dobsonians. Okay, he didn't attribute any of that to himself because he didn't invent the design. Okay, this is a Newtonian telescope. Isaac Newton mounted into a cannon mount. Okay, and his last name was Dobson, so they started calling him Dobsonians. He hated it. Okay, maybe later on it kind of grew on him. But I remember getting a letter from the guy at one time when I was working at Mead Instruments, and he was telling me, please stop calling these telescopes Dobsonians, okay? I'm John Dobson, okay? And so anyhow, but
Well, we can just name them after
is
me.
Telescope making. That's real telescope making, when you're grinding your own glass, figuring your own mirrors. If you want to get really, really good, really say you made a telescope, make your own eyepiece too. Okay, make your own finder scope. So, but the process of making your own telescope is it's a lot of fun. I did it in making a special camera called a Slevet. It wasn't my design, but I built one of only 4 in the world that existed. So anyhow.
So Beatrice has started a conversation in the chat about if Mac Casses are better at viewing clusters, I'm just paraphrasing, than Newtonians. So she started this whole thing, and I don't know if you've read it. So
I'm reading it right now.
Is it more satisfying? Is that more satisfying
like
than
looking in there and going, that's satisfying?
Some things are. Well, that's the new thing.
What I'll tell you, what gives great satisfaction to a lot of people in looking at deep sky objects is how tiny do the stars look, how contrasty is the image, how black is the background, for example, and that has a lot to do with the F ratio of the telescope, whether it's Newtonian or Maxudo. Okay, most Maxudos have a long focal length, like f12. Okay, and therefore the central obstruction is kind of small. All right, secondary mirror. So think about the light rays coming down, hitting the mirror. Okay, now they're going up a very long focal length till they get to that secondary mirror. And so to capture the whole width of light, that angle is now kind of thin. All right, so they don't need a very big one. Versus if it's a short focal length, now the light rays come down and they have to come all the way up to where they're going to come to focus to hit the secondary mirror. But it's now, this cone, you can see my arms, is wider. So the secondary has to be bigger, okay, to capture all the light. All right. So, and you want to capture all the light, because if you make a small secondary and you got a short focal length lens, you're not capturing all the light of that mirror. All right. So that is, so when you go to a bigger central obstruction over the mirror, the contrast goes down. All right. So the sky doesn't look as jet black. Okay. And what's happening is that actually the airy disk of the star is, if you dissected the actual image, okay, the airy disk is defined by the diameter of the mirror, okay, and the C conditions for the night. So it makes a spot. Annie, I'll have to show you this sometime in the lab.
Yeah, you're gonna have to.
Okay.
Yeah.
And something called the diffraction rings. They look like they're little hula hoops of light going around the spot, the dot of the light there, and then that's the star. When you have a bigger central obstruction, more light, a greater percentage of the light is now going to the first diffraction ring. Okay. And there's other diffraction rings around it too. So more light's being put out. All right. This lowers the contrast. All right.
Oh.
In a refractor where there's no central obstruction, about, 84, 85% of the light is held in the airy disk. And just a little bit is going to the first diffraction ring. So the stars look tighter. Okay. The background looks darker. These kinds of things. So that's the deal. So you could have a Mac that has a very small central obstruction. Okay. Gives a great, beautifully satisfying view of a globular star cluster. You go, that's amazing. Looks like a refractor. Then I get out my refractor and I show you, no, it's not as good. Okay. Because there's no central obstruction. But we have to start shoveling out the money, because real high-end refractors, we know we sell some. Okay. Yeah. They are expensive. They're hard to make. They take very special glass and all the rest of it. Okay.
Yeah.
Macs are easier to make. than a refractor is. They also have the advantage they're very short and squatty. You've seen them, okay?
Yeah.
But they have a secondary mirror, all right? And so it's not going to have as much contrast as a refractor does. Newtonians, most of the popular Newtonians made today, they're very wide field instruments, okay? And so they have big secondary obstructions. But back in the 50s, especially in the 50s, you saw very long focal length Newtonians, really long. Like you have to go into a ladder to go look through a 12-inch Newtonian, okay? So I owned one at one point, and it was an F10 Newtonian telescope. Now, I will tell you that deep sky objects and planets and double stars and everything looked extremely satisfying in this telescope.
Is that the correct image?
Yeah, so there's kind of, this is a standard Cassegrain type of design, okay?
Yeah.
That's a Gregorian reflector. And so you can see that the, what's called the nodal point, you see with the kind of the crisscross of the light rays there, they're crisscross. They're hitting a, instead of a convex mirror, they're hitting a concave mirror. This is flipping the image around and then coming out to the back where the person's eye is. Gregorian telescopes actually show images right side up, okay, instead of upside down as we normally look through them. So they're Gregorian Cassegrain telescopes are really good for making them into spotting scopes. This is a Newtonian design, okay? Isaac Newton's design right here laid out. This has a mirror that's not a sphere. This is a parabola. So the way that they grind this mirror is they start as a sphere and then they start deepening the center. And what this does is it makes all the light rays focus all at the same time. Okay, this gets rid of spherical aberrations. Then we just have a flat mirror and the light comes off to the side. If this was a long focal length, you can see just from the light rays, the ray tracing here, that secondary could be very small, okay? And that would, you get a very tiny secondary, it starts to look like what a refractor looks like, okay? So that's the deal on that. So the satisfaction, Tarek, on these things really is, it all just depends, okay? What is it that you're after, Do you want real wide field views and the highest contrast? You're probably going to go after a refractor, okay?
Yeah.
There's the Cassegrain.
What's that?
I think this is the Cassegrain, right?
Yeah, we looked at a couple of Cassegrains. Okay, now this is a classical Cassegrain. Okay, we've got a primary mirror that's either spherical or parabola, or it could be a hyperbolic. Okay, and then we've got a secondary mirror, which could be a sphere, usually is a sphere. And but the advantage of the Cassegrain is that it made the telescope shorter. Okay, and that advantage meant that we didn't have to have as big of a mount to hold the telescope because it's not as big and as heavy. Yeah. So these are all little trade-offs of what you want, what. So they make most professional telescopes made today are Cassegrain designs because they can fold the light. Right? We don't see big refractors in space. No, we don't see those. Could you? Yes, you could. But
big old that you have to get on a ladder on space and
it's a little bit of a climb.
Gravity, you don't need the ladder. Okay, you just
that's
float up there.
Just float up there.
It's a little bit of a climb. That's all.
Just take your helmet off and look in the eyepiece for the nanosecond that you can do that. So,
speaking of gravity, let's talk about the dust that hit the James Webb Space Telescope. It was dust. So as we were talking earlier,
you're talking about the strike on the mirror, right? That everybody says.
Yeah, because we were talking today, and I said I heard a rock hit at the telescope, and so
polar or
Yeah,
something, right?
yeah. And then you looked it up, and you said it was a tiny piece, and I said, okay, what's the difference between tiny in space versus tiny on Earth?
What do you mean
What
by
is
tiny?
there a difference? So then we
Right.
did some more digging, and we figured out it was dust that
Size of
actually,
dust. Yeah.
yeah,
So,
that hit the
but you've got a
telescope.
piece of dust coming at you at 50,000 miles an hour or whatever it is. Okay, it's got a lot of momentum. Okay, boom.
It's not like the movies where they show the guy floating away slowly into space. That it's actually being propelled at a very fast pace. Is that what you're telling me?
Yeah. Well, even the astronaut, it depends, in relation to what, okay? But, some things are, we got something moving 100,000 miles an hour, then it looks like this 50,000 miles an hour is very slow.
We use,
Yeah.
we're starting to use rail guns, and they take, a half-inch by a quarter-inch diameter, just a piece of metal. And they don't even, no aerodynamics, no nothing. It's just like a cylinder. They shoot it out, those things, the electric railgun. And what is it, Scott? Like 10,000 feet per second, something like that? It's crazy.
So it's only 5,400 miles per hour, okay?
Oh.
Versus spacecraft, which travel much faster than that.
Yeah.
Okay?
So that one little piece of metal that pops out of that railgun can go all the way through any armor that we have.
Right. And that's
So
only 5,000
imagine what a
Right.
piece of dust does at 17,000 miles an hour.
miles per hour. Yeah. Yeah.
But
So
I
this is
don't.
why
I
we
don't.
have to clean up space, because we're flying
Well, and
through
I didn't-
space.
Get a
Well,
broom.
Yeah. Well, and I get to it, Reverend Paul. So
Reverend
I don't think.
Colonel.
Oh, I'm sorry,
Reverend
Reverend Colonel Paul.
Well,
I don't think we understand the reality of how fast that is. I mean, we've seen stuff go fast. Of course, we have race cars that go really fast and things like that. But I don't think that we actually understand the speed of that. And I'm kind of curious what it actually feels like.
well, what does
Like,
it feel
would
like
you-
right now?
Yeah,
I mean, you're there, you're sitting in your home. How does it feel?
we're spinning
I'm not
at,
moving anywhere.
15,000
not
miles
moving,
an hour.
right? Yeah, but we're going
I know,
60,000 miles an hour.
60,000
We're going
miles an hour.
60,000 miles an hour around the sun
Yeah.
right now. I don't know.
And we're
You know, you
spinning
feel
at what? How fast
Can
are
you
we
feel
going?
it? Can you feel? Can you? Scott, can you feel it? Can you feel? I know you can feel it there. I can't feel it
Well,
here.
I do. I feel a little dizzy. I do. I feel a little dizzy. Okay, so
Well, that's-
all right. So
Uh-huh.
think about this. Okay, you're going 60,000 miles an hour around the sun. Okay, the sun is in a spiral arm of the Milky Way galaxy. Okay, it's also spinning, by the way. All right, so that's about roughly. I mean, these are rough numbers. 500,000 miles per hour. Okay, and the whole galaxy is moving. We're all moving. Okay. So, and only I'm giving in reference to the Andromeda galaxy because the Andromeda galaxy and the Milky Way galaxy are on a collision course. They're heading towards each other. All right. So that's relative speed towards Andromeda is about 1.5 million miles per hour. Okay. So we're flying to a new part of space that we've never been to before all the time.
So according to NASA, Webb's mirror was engineered to withstand bombardment from the micrometeoroid environment and its orbit around the sun. Earth L2 of dust-sized particles flying at extreme velocities. While the telescope was being built, engineers used a mixture of simulations and actual test impacts on mirror samples to get a clearer idea of how to fortify the observatory for operation in orbit. The most recent impact was larger than was modeled and beyond what the team could have tested on the ground, and it was just dust.
That's crazy.
It's crazy, isn't it?
It is very, very crazy. It makes me think about you talking about us spinning and stuff like that. Makes me think about all the times, like when you have an ear infection or something like that, and your equilibrium gets off, and then you're like, do you feel like spinning? It's crazy how our bodies are made to be able to withstand the motion of the earth and what's going on with it. It's like you said, it's all intricate. We're all part of everything. And so it's just,
part of it.
It's interesting.
Right. So,
Yep.
yeah.
I do want to make a comment about Jim Norwood's AC.
Okay.
He said he didn't have time to make a telescope because he's putting an air conditioner in his car. I'm going to fix that issue for you really fast, Jim. It's called roll down the windows and stick your head out. There you go.
Now we do have a question.
All the time in the world.
Connor Bradley does have a question that says, with big enough telescopes, can neutron stars be seen visually in dark skies?
Well, that's a good question. Let me check something here. There's something called neutron stars.
Mm-hmm.
Yeah. So the short answer is yes. Okay. There is an object called the Ring Nebula. Okay, M57. And I have used, under really, really dark sky conditions, and I mean dark, okay, an 8-inch telescope and have seen this central star in M57, and that is a neutron star. It's a magnitude 15 or 16 star. And, you have to be good at observing faint deep sky objects. You have to use what's called averted vision. If you stare right at it, you don't see it. You let your eye wander away, you relax, and you can detect it. Okay. So, but certainly we have Dobsonian telescopes with, 12, 16, and 20 inches of diameter. That could, in the 16-inch and 20-inch range, it's easy. And then we have the folded Newtonians, which range from 30 inches to 65 inches of aperture. And it can absolutely see those things, no problem. So that's the deal. And this is, so Pekka, was that question naked eye or with telescope? He did say, maybe you're answering another question, but where it relates to neutron stars, they can be seen. Next question.
They're really chatting it up in the chat. It's really good.
If I stick my head out, I just get my sunburned head. That's right.
No, you're supposed to put sunscreen on. See, then the wind goes across and you've got the wet, greasy feel.
We gotta
and then
be
it
a man.
It just adds.
Gotta be a man.
So when I was a kid, okay, our air conditioning in our car was called a 55x2. Okay, and that was, you roll down both windows and we was going 55 miles an hour.
That's right. That's right.
We didn't have an air conditioner in our car,
I grew up driving a 66 Chevy, so I know exactly how that is.
All right, there you go. That's right.
But air conditioning is nice, Jim. I have to agree.
Yes.
Hey, let's talk about
contributions of humanity's, compassion towards humanity is air conditioning and central heating.
Yeah. Okay, let's go over events real fast. What's going on in Explore Alliance now that we've got off onto many topics of space.
Yes, that's right.
Squirrel.
That's okay. It's fun. It's fun when we chase squirrels. So we have the Arizona Dark Sky Party coming up in September, and then we also have the Nebraska Star Party that's going to be in August, I believe. Is that right, or July? I can't remember off the top of my head.
I think it's August is when it is. let me just double check for you. Nebraska Star Party.
Sorry, I'm at home and I don't have my regular computer in front of me. That kind of puts me at a standstill.
It is end of July, July 24th.
End of July.
29th.
Okay.
Yeah, they changed the new moon, so that's the deal.
Okay. And then there was one other thing happening in September, but I can't remember what it was. It was another star party that's happening. But we have, you know, we have a lot of things that are coming up pretty soon. We're going to be selling the things that you need to watch the eclipse that's going to be coming soon.
Oh, yeah,
And
right.
so we're going to be gearing up towards that. Yep,
these are our eclipse
Yep.
glasses. They just came in today. Okay.
yep,
And
yep. So
they'll be back up on the website. And
What,
so
Yeah.
for
How many did we get? Like half a
thousands of
million?
them. No, we didn't. Not yet. We will.
we might need.
This is the first production run, and so these are USA made, which is important because there were a lot of counterfeit type eclipse glasses made. So these also have a special watermark on them. Okay, so they're authenticated and they are ISO safety tested. All the rest of that stuff, everything that an eclipse glass should be, these are. Okay. And I think that you can get they're going to be sold, I think, minimum packs of 4. We learned our lesson last time during the 2017 eclipse when we offered to sell 1 eclipse glass at a time. And in one day we got 35,000 orders. 35,000 one day. You guys think about licking the stamp, placing one of these and dropping it into the envelope 35,000 times, and for one day, and that's just nuts. So we're going to be minimum order of 4. It'll be somewhere between $9 and $10 retail, but you'll be able to buy boxes of 1,000 if you want, or 5,000 if you want, depending on what's going on for your school or all the rest of it. But here's the main point: let me underline, do not wait until the last minute to buy your eclipse glasses, because that's what everybody does. That's what everybody does. And then they're all disappointed and angry because you can't fulfill them fast enough for them. Okay.
And it ends up being a catastrophe.
Yes, that's right. So,
everybody's sad. Everybody's sad in the situation.
Not everybody.
So
Explore Scientific delivered millions of them in 2017
oh my gosh.
for the total eclipse there. But there were, at the very desperate end, okay, it did get a little ugly. So in private, I'll tell you some of the stories.
When I started here, it was like,
people got it what they said, but it was crazy.
I know. Well, it was great.
We're sorry.
When I started here,
we apologized over and over and over and over again, but anyhow.
Well, I'm sure it'll go a lot smoother this time. You live and you learn from the first event, and then you go on, you fix the next one.
So Harold Block, he says, I'm putting the 8-inch Newt on the SW-EQ6 because the nights are somewhat nicer and will have that scope chained to the mount and pier. Not quite sure what that means, but okay.
We're down with that. And I see that Pekka is saying, Scott, make sunglasses that have a small notebook on the handle so you can notice your eclipses seen with those glasses. Pekka, you're gonna have to draw that out for me on a napkin or something. Harold Locke says, Mom's done at the dentist. You fine people, have a great night. Harold, tell your mom, have a great night. So from us.
We went away. Okay, so it's getting nighttime. Actually, the sun doesn't go down here until almost 9 o'clock. It's pretty nice. The other thing that's going on is we still have that. Nobody has utilized the 20% off the Arizona Dark Sky tickets. So if you're a platinum member,
Yeah.
I would highly recommend utilizing that if you want to go to the Arizona Dark Sky Party, utilizing that 20% off. It's not going to be going very much longer. So
How did they do it?
They need to email me at Explore Alliance. Explore Alliance at explorescientific.com. Sorry, went out the door. And I'll get you a code, or I can set up your order with a discount. So that's not something that we're just going to put on the website, because you have to be a platinum member to do that. So and then the other last thing that we have is we have a pair of binoculars. The SKU on them is 616. I can't remember the specs on them, but we have $100 off for if you're a platinum member, if that's something that you want to utilize as well. I think they're like a $600 or $700 pair of binos. They're Alpen brand.
What brand are they?
Great.
They're Alpen?
There's Alpen Apex 8x56 binoculars.
So
Retail
great for
of $499.99.
So 500. I was quite a bit off, but anyways, so utilize that $100 and get you a pair of great, amazing binoculars to be able to do some nighttime viewing.
Those are ED glass too. Yeah, these would be fantastic.
They're really good.
Astronomy. Get yourself a zero gravity chair, and so here, I'll put the link in here for that.
Yep. So
Excellent.
And then if you have any questions about what benefits come with the with your membership, just email me and I'll be more than happy to answer those questions for you. There's some great opportunities being a part of the Explore Alliance, not just as a member, but as an ambassador or as an affiliate. We want to share your story. We're not just a company that's about just showcasing what the products we have. We want to share your story. And so we would love to partner with you and be able to do that. So if you're part of an education group, or if you have any type of educational outreach or anything like that, please email me, and I would love to talk with you and get you set up with that. So, but yeah, other than that, it's pretty much, we have pretty much the same shows every day. We don't have On the Wing anymore. This show will be in replace of that. We have the new Eclipse show that's on Tuesdays. Of course, Daniel Barth, How Do You Know, is on Mondays. Kent with First Light Chronicles is on Wednesday, and then Friday is a focus on astrophotography with Tyler. So join us. We have a lot of things going on here at Explore Scientific. We have a lot of shows happening. On the Wing has kind of moved to our Amazon live feed that happens during the day. So
yeah, today we talked about the Claypool Reservoir in the 50s with the giant, all the millions of ducks on live TV.
Oh, wow.
It was really cool.
That is really cool. So, but we have a pre-show that starts at 1:30. It happens every single day. It starts at 1:30. Sometimes we're a little late, because time and people and things. Anyways, 1:30 is supposed to start at 1:30 every day.
Time and people and things.
Anyways.
Yeah.
So 1:30. So that starts at 1:30, and then we move on over to Amazon Live. But you can still see us on YouTube and things like that. Those shows happen, and so we are here more than once a day, 2 to 3 times. So hop on, join us. We would love to see you. Please give us a shout out during those shows. We will, whoever's on will engage with you. So and if you want to watch a crazy show, come watch Lucy and I on Tuesdays, because we like to tear things up.
You guys are funny.
You set the place on fire once.
So
what did you?
So you set the place on fire once.
Huh?
Yes.
You guys made fire in the studio?
It was Tyler's fault.
Yeah. Tyler made a product smoke. Okay. Yes, we were building a stem. We were building a one of those. I can't remember if it was the 145 STEM thing with the electronics, and we couldn't get it to work. And I went and got Tyler, and Tyler came in, and all of a sudden he starts taking the batteries out, and smoke comes up. It's because Tyler came in.
I was not here that day. That was the day that I had to go to Dallas. So you can't blame me.
I want to point out that we did not break the product, because the following Tuesday we used the exact same thing, and Kent helped me put it together, and it worked just like that.
Okay, so it's probably the batteries that were smoking, right?
Yes, it was the batteries.
So Jim Norwood's actually saying, here's some electronic wisdom here. Once you let the smoke out, it's very hard to get it all back in, and that's what makes electronics work, is the circulation of smoke.
Yeah.
That's what Tyler kept saying.
Or not the real reason, but
That's what Tyler kept saying, and then I was like, watch me, I'm going to make this thing work.
So Beatrice Hines had a good question here. She wanted to know, how long can you store Eclipse glasses? Can you store them for a couple of years? The answer is yes. Okay, it is yes. Okay, you can store them. And I've used Eclipse glasses that are old. Okay, but if you see any degradation at all, any scratches, any thinning of the coating material itself, let me just put it this way: Eclipse glasses are so inexpensive.
Yeah.
That it's worth getting a fresh pair. Okay, if you have any question at all. Okay, because your eyesight is invaluable, right? So you just don't want to risk it if that's the case.
You can give them
but if
to
you know what you're doing,
you can give them to your nosy neighbor. No? Okay, don't do that.
Oh, they throw people in prison for stuff like that.
Was it on purpose? They knew the sun was hot.
But he's a reverend colonel. He won't get thrown in prison.
Reverend Colonel Paul G. Newton.
Okay, so I really love.
I'm totally fired now.
You're fired now, Paul. Yeah.
Yes. Scott, I really liked that video you made the other day about why you should not. I don't know if it was the other day, but anyways, I watched the video.
That was an old video. That was 2017. So here's the background story to this. Yeah, you weren't here at that time, but we get one of the new customer service people comes running up to me and says, "Hey Scott, there's an amateur astronomer who owns one of our refractors." Okay, now. You own one of our refractors. I'm assuming that you know some stuff about astronomy, but that's an assumption, okay? And so they wanted to know: is it okay to use eclipse glasses to look through the telescope? Okay, and the answer is absolutely not. Absolutely not. So I just dropped everything I'm doing right then, because I'm going, oh my God, if this guy's thinking this, how many other people are thinking about this? Okay. Can I use eclipse glasses to look through my telescope or through my binoculars? Okay. So I took a pair of eclipse glasses out. I took an over the lens solar filter. Okay. And I was showing them how to apply that over the telescope. And that's how you should do it. Versus taking a pair of eclipse glasses, putting those puppies on and looking through the eyepiece. All right. So I just held the eclipse glasses over where the eyepiece was, and it, like a laser beam, just blew a hole right through, instantly through the eclipse glasses. Okay.
Yeah.
And that would have been your eye, just like cooking. Okay, in the eyepiece. So absolutely don't do that.
But I liked your technique that you used in showing that, and that would be a great way to check something, is you pointed the telescope at the sun and you put the product in front of the eyepiece, whereas putting it on your face and looking, so I thought that was really,
I would have boiled my eyeball out. So
yeah, but I know you know that, but I'm saying that somebody who's not for sure, like that astronomer that called customer service asking, well, why don't you just. I mean,
give it a try and call us back. No. No, we did not.
No,
do
no, no, no,
that.
no, no.
Okay.
I'm saying
We're
not
here
on
to
your
protect.
face. At least put it
We're here to serve and protect.
serve
Well.
and protect.
At least sell.
Yeah. Hey, I wanna.
I'm teasing.
Beatrice is a little upset that we don't have On the Wing anymore, but I do want to let Beatrice know that it is still here. It happens at 1:30 on Thursdays and runs over into the Amazon Live show. So it goes to about 1:30 to almost about 3 o'clock. So
Beatrice,
so
we just
y'all
could not, the reason why we did that is our sales season is picking up, and COVID is now tapering off. And so we're not in the office as much as we were before. Okay. We actually have to get out and visit people and do these kinds of things. And as far as our sales function, this is what lets us actually do these shows, is that we're actually underwriting that with Explore Scientific. So, but we as Annie said, yeah, we still have the show. It's just combined, right before we do Amazon Live. Is that right?
No, we
Is it
basically
during
do
Amazon Live?
as On the Wing.
Yeah.
So the way
You'll
the
learn more
shows
about
work.
product and also the bird that you're.
It's really good setup. Like today they were going over what Paul was talking about, but we'll do the 1:30 show and then stop for about just a few minutes, not even 5, and then hop on over to Amazon Live and continue the show. So, but he does implement a lot of that information that he had on the Wing. So
Today
it's really
we were
good.
talking about
Really good.
Ricky Martin. No, a purple Martin. That's right, a purple Martin.
How did you get Ricky Martin out of a purple Martin?
He's just. He's just throwing it out there, and he's
winging it for On the Wing.
He's winging it for On the Wing. That's right.
Oh, that's my only dad joke for today.
All right.
No,
But yeah.
Kent was talking about the purple Martins, and he said, "Go to the next picture." So I went to the next picture, and it was Ricky Martin. He's like, "What?"
It's Ricky Martin. Yeah, that's right. Poor Ricky. Hey, man, if you're watching this show, we're sorry. So,
I'm not sorry.
that's right. All right.
I don't think Paul's ever sorry.
Anyhow,
Sometimes.
I hope you guys are staying cool out there. It is hot here in Arkansas. We're triple digits right now, 100 degrees. I think it's supposed to be
A cold
101.
front's coming in.
Yeah, it's going to be 92.
A cold front's coming in next week.
Really? You look scared.
Yeah. I'm
I was-
excited.
She does look scared, actually.
That's my scare. Oh, I hate for you to see my actual scared face.
Yeah. So do you have an Explore Scientific weather station in your home now, Annie? Not yet.
I plead the fifth.
Annie? You didn't install one.
No, I need to have. I need to install one. So I really need to install one because we get a lot of questions about them, and so they're amazing. We have one in the store, and we have a sensor on the roof, and so in the middle of the remodel we had to find a place for it, so we've got it all set up again, and so it just hooked right up, and it's telling us that it's sweating buckets kind of heat outside.
Sweating buckets.
Is that the actual term that's on the screen?
Yes, that's what it tells you.
We invented here in Arizona.
Yeah.
You should start doing the emojis like, okay, this is a little bit of sweat, and then it's like I'm really hot, and then I'm like I'm dying.
Pekka says he's wearing fur hats in Stockholm.
I don't believe that at all. That's not true. That's
It might
not
be
true.
It might be true.
No, it is not
You're pretty
true.
far
It
up
is
north there.
no, it
Stockholm,
is hot
Sweden.
there.
Sweden's
No,
not
it's hot
that far
there.
north.
Let's see.
I'm
We'll
telling-
check the weather right now.
Calling your bluff, calling your bluff, Pekka. Calling your bluff.
It is hot. It is hot there. I know it's hot there.
Scott's gonna call your bluff.
Let's see. It is kind of chilly. It's 56 degrees Fahrenheit.
Nice.
So
Yeah,
now some people
but
think that
but they
13 degrees Celsius.
Not getting a
13.
tan today.
Yeah.
yes,
So
but
if it had been warm, yeah, you might be putting on a fur hat. That's possibly true. They are experiencing high humidity, wind only 2 kilometers an hour, precipitation chance only 3%. So that's your Stockholm weather for the day.
that's your Stockholm weather for the day. Yes,
That's
but
all.
their temperatures are probably different than ours too. So, yeah.
It's got to be terrible in Finland. Finland's
The
even
same
more north.
planet. And, yeah,
we
you
have
know,
we have moved to the weather section of this show.
Yeah, that's right. The weather segment. Yeah, that's right. I need like a green screen with the wind and stuff blowing.
So my dad had a weather stone.
A weather stone.
Yeah.
Paul,
If it's wet, it's raining. If it's dry, it's hot. If it's cold,
it's
it's
burning your hand.
winter.
It's hot outside. I see.
If it's
All
rolling,
right.
it's a hurricane.
It's on his balcony, so that's getting chilly. It is. You're right. And Pekka says he's already photographed the first quarter moon today.
Nice.
If you guys did not know this, Pekka is quite a lunar photographer. He did. I mean, he had that beautiful image that got shown all over town, and so it's awesome. Keep it up. Keep up the good work, Pekka. Anyhow, do we have anything more to add before we close?
Before we move on to something else crazier? No.
Before we get to the crazy part of the show?
Just leave it to me.
I'm so glad that we laugh on here.
And the Ron Burgundy Weather Hour. Yeah.
That would only be if I had a camera. If there was a camera on me, it would definitely be the Ron Burgundy.
I'm so glad, but I really am so glad that we can get on here and just laugh and have fun and talk about serious things like telescopes and then move into after hours. So it's good.
Right. That's right. We hope we answered your questions about intelligent life throughout the universe.
So tomorrow is Tyler's focus on astrophotography. Make sure you join him at 4:00. I don't know what his show is going to be about, but I'm sure he'll have something good for you. So yeah.
He is wrangling guests as we speak.
Okay. Having guests is important. People want to see new people. That's for sure. So thank you, everyone. We will be back tomorrow. And then if you don't catch us tomorrow, then we'll see you next week. On the 12th of July, we will have the 99th Global Star Party. So it's coming back. And then on the 16th, we will have our 100th Global Star Party, which is our major milestone. So
yeah, it's exciting.
Right.
It's exciting.
And Connor Bradley wants to know, have you built a telescope from scratch? We touched on that a little bit, Connor. Okay. So what is by scratch? Okay. So are we talking about polishing your own mirror? Are we talking about taking a pickaxe and mining the material to build your own telescope? So there's a level of building your own telescope where you buy finished mirrors, for example, and you lay out your design and you build it. That's very rewarding. There are other people, though, that do get into it and polish their own optics. You can still buy glass blanks and the polishing compounds and all the rest of it. So it's a lot of fun. Connor, my question to you is, have you done it? So, and I think that maybe you have. So anyhow, that's all I got. That's all I have for right now. You guys keep looking up. Yep. And thanks for watching. Take care.
Bye.
2, 1, go.
Hey everybody, Kent Martz here from Explore Scientific. Welcome to today's episode of First Light Chronicles. It's Wednesday, although it feels like Tuesday. It's Wednesday here because we had a holiday on Monday in the United States. Today we're talking about getting started in astronomy and how do you do it. There's a couple of ways. Easiest way is to just look up and start learning the constellations wherever you live. But after a little while you want to progress into, we'll say, a pair of binoculars or something like that. But that then leads you into a telescope. And sitting here looking at myself on the monitor, you're going to notice I have earbuds in. We're using a new system. And now I can hear myself in my ears. Boy, that's exciting. About a minute. Yes. 10 seconds late. It's joyous. Oh, Paul got it fixed. Paul's working from home. Nope, it's still there. This is going to be fun. All right, so we're going to talk about a telescope. It disappeared. Thank you, Paul. Nope, it's even longer delayed. So anyway, I'm going to take these out. One out, maybe that'll help. There we go. It stopped. All right, so I'm going to put one back in. And I dropped it, of course. Paul's at home furiously banging on his keys trying to make it quit. And I think he did.
It's
That's
working.
a good thing.
You can hear me now.
This is
I'm
a
talking
series
to
of
you on
telescopes. We're
air.
going to show you a series of telescopes today from Explore Scientific. They're our first light series of telescopes. They're designed for beginners and early amateurs to get started in astronomy. An affordable telescope, yet really sturdy, strong, powerful telescopes that won't break the bank, right? The difference sometimes between a toy telescope and an educational telescope and a full-blown telescope sometimes is not a lot of money and sometimes it's less expensive. So it looks like I have, Paul, I think we frozen, at least we have on my monitor. Not sure what's going on there. So maybe Annie will see this at her desk and come back in. So welcome to Amazon Live and the Social Media Blast. If you're out there, give us a shout out on the Amazon platform. You can use the chat function and give us a shout out, ask questions, anything astronomy related, whatever. Love to get feedback and talk to people out there who have questions. So we're going to look at this telescope. It is a 102 millimeter telescope. This is not a small telescope by any stretch of the imagination. Hey, Noah, can you come see if you can get the monitor unfroze so I can see any chats that come up? Thank you, sir. This has a 102 millimeter aperture, which means the piece of glass that's right in here is 102 millimeters in diameter. The dew shield protects that piece of glass that's way down in here. It has a focal length of 640 millimeters, so 640 millimeters until it comes to focus. This is a good sized telescope, good for lunar, planetary, deep sky objects. It's a nice compromise, right? Comes with a focus. It also comes with a 2-inch eyepiece, just like this one right here. Excuse me, a 2-inch, a 1 1/4 inch eyepiece. It's a 25 millimeter super plossel. Also comes with this device right here known as a diagonal. It has a mirror in it, so instead of having to get down here and look through the telescope like that, you put the diagonal in, put the eyepiece in, and now it's a very simple matter to just look down in the telescope just like this to see what you're looking at. Much easier to use, especially when you start pointing at stuff high in the sky. This would be extremely hard to use in this configuration if you just had to look straight through it, like, you know, a spyglass or, you know, a long tube. This is fine, but when you get up here, it's really difficult, especially when it's mounted on a tripod or you're trying to hand hold it. So it comes with everything you need to get started, including right here, and you can barely see it, I'll take it off, including a red dot finder. This red dot finder is what makes this telescope pointable, because if you start out trying to just point the telescope with no sight, no way to do it, it's impossible to point the telescope at anything up in the sky. You might find something, but finding your target is really difficult. However, with a red dot finder, the red dot finder is a tool that makes that job of finding stuff up in the sky a whole lot easier. Here's how it works. It's the same for every telescope, no matter what kind of telescope it is. A red dot finder, or even if it's a little telescope with a more powerful field of view than this zero power, it all works the same way. You do this same process. You find something that's a long ways off. Miles are better than yards. The directions we supply say like 300 yards. So you want to be at least that far off. That'll be fine. So you can then point the telescope at something, find it, it's however far it is you can see away, top of a radio tower, a steeple of a church, a stoplight that's blocks and blocks and blocks and blocks down, whatever. Miles are better than yards. Yards are better than feet. So you're going to move the telescope and find that object and center it up in your eyepiece. Now you want to do this in the evening or early morning before the sun gets real bright, because when that red dot comes on, it's not super bright and the sun shining is going to make it disappear. Impossible to see. This is designed to be used at night. So you turn it on in the evening, sun's going down, you point it at the top of, let's say, a radio tower, okay? So you point at that radio tower, and what do? You make sure the telescope's pointed at the radio tower, dead center, the very top of it, or whatever, some obvious thing you can see. Turn your red dot on, and you can use the controls. There's a little knob here and a little knob on the other side. You turn them, and you can move that red dot left and right and up and down. And you move the red dot until it's on top of whatever your target is. Let's say it's the top of the radio tower. Yep, I see that. Just came through. The monitor just got back up. Cynthil, hello, Cynthil. Nice to see you. Cynthil says, hi, Kent. We appreciate that shout out very much, Cynthil. So you put your red dot on it, and you move it the red dot so it's on top of the radio tower. And now look in here again, and chances are you move the telescope a little bit. No big deal. You simply move the telescope back to what you were looking at, the top of the radio tower, centered in the eyepiece. Make your adjustments again, and when the two match, now you're ready to start looking at something. So say tonight you're going to want to go out and look at the moon. It's what? 2/3 of the way to full, something like that. It's like 7, 8, 9 days old moon. 14-day-old moon is generally the full moon. And so you're going to go out tonight and turn on the red dot, and you're going to look through the red dot and move the telescope until the red dot is on top of your target. In this case, it's the moon. And then you're going to look in the telescope eyepiece and focus that eyepiece on the moon. If you've done a really good job, what you've done is I'm hearing myself again, Paul. If you've done a really good job, okay, that would probably do it. It was about 6 seconds after I said it, which makes it very difficult. I'm not a professional at this and can't focus. I know it's hard. That's a whole new skill to learn.
Got to start learning to ignore this stuff, Ken.
Oh, great. Paul, are you going out live now too, Paul?
Yeah.
Okay, Paul's going out live too. Didn't know if I need to relay what he said, because
he's
saying it in my head.
On or something?
And he's saying it to y'all too. So anyway, so you got the telescope.
Yeah.
If you've done a really good job.
I'm sitting in the remote control room doing this from a laptop with my phone.
With this phone. It's technology at its finest. What can I say? So you're going to move the telescope. You're going to put the red dot on top of the target centered on the moon. Look in the eyepiece. Now, if you've done a really good job, the moon's going to be centered up, but it may not be perfectly centered up. But now that you've found it in the eyepiece, here's what you do. You move the telescope left, right, up, and down until you get it centered, and now go back and readjust, make some fine adjustments on that red dot, and get them lined up so they're looking at exactly the same spot. And now when you want to go look at, we'll say, Saturn, you've checked out the moon, you want to look at Saturn, close to the moon, you're going to just simply put the red dot on top of Saturn, focus the telescope. Saturn should be in the field of view. It's smaller than the moon, so now you can fine-tune that red dot even more. and then go look at Jupiter over in the southeastern sky rising after dark, and you can start looking at the planets and get a tour of the planets with your brand new First Light 102 millimeter telescope. We haven't talked about the mount it's on yet. So the mount is called a Twilight Nano mount, okay? It is simple left, right, as you can see right here, up, down. It is in the carousel. Right now, if you go to the carousel
right one.
and look,
I had the wrong one a minute ago.
yes, that's it, right there.
Okay.
So you can move it left, right, and up and down very simply, very smoothly. Nice, easy to use right there. So this is the AR 102-600 Twilight Nano. Now I'm going to switch. Oh, the sound has come back in my head. So 6 seconds. Whew. Going to switch telescopes real quick to a different telescope and the same mount. Here we go. I think Paul's doing it just to mess with me. Paul's not denying it. He may be deep in thought, though. Okay, so this is a First Light. No, I'm still hearing it. Still hearing it.
Should be gone now.
Okay.
Shouldn't be any echo.
Nope, I can still hear it.
Where is it coming from?
It's gone now. It's gone now. Okay. I don't know.
I changed my microphone. I noticed that it was scraping, and I was like, no, that's not good. I changed it to my my big mic. It was on the wrong mic. Was it? You can't do it.
It's still doing it. I'm here about 8 seconds late. All right, so this is a First Light 127 millimeter telescope. Now this is a different telescope than we're looking at. That telescope we were looking at before is just a long tube. It's just a long tube that you look through with an eyepiece, right? You might have a diagonal, but it's still just a long tube. This telescope is different. As you can see, it's a whole lot shorter than the other one. But this telescope has a little secret. And I'll tell you what that secret is. Up here in the front, remember that first one we looked at had a dew shield, and the glass was down in there 6 or 8 inches? This has a piece of glass right there in the very front of the telescope. That starts bending the light, right? Back here in the back of this telescope, there's a curved mirror right here. That curved mirror really starts bending the light and making it come to a point. Well, it comes up this way, so the light comes in, starts getting bent, hits the mirror, starts getting smaller and coming to a point, and then right inside this telescope, right there where you see that dot, right there, you can see that dot. That dot has a mirror on the back side of it. That mirror reflects the light back this way, and it comes out of the back of the telescope because that mirror has a hole in it. It comes out of the telescope, goes through a diagonal, comes out the eyepiece, and goes into your eye. Okay? So at that point, then, you can focus the telescope. And the monitor's froze again, Annie. So at that point, you can focus the telescope, and everything is good. So you focus the telescope right here with this knob right here. It moves that mirror forwards and backwards, bringing the image into focus in your eyepiece. This telescope is bigger around, right? Because it's bigger around, it brings in more light into your eyepiece. It also has a much longer focal length. The telescope we just looked at had a focal length of 600 millimeters. This telescope has a focal length, meaning how long it is before it comes to focus, has a focal length of 1900 millimeters. That's 3 times longer than the telescope we just looked at, although the tube is much shorter. That shorter tube makes this telescope easier to handle, easier to transport, easier to store. That's what's nice about it. Now, a downside to that longer focal length is the images can appear darker. That's why a bigger aperture balances that out a little bit, okay? So And while we're talking, if you're on Amazon or the social media blast right now, feel free to give us a shout out. We love having conversations with the people who are watching. And if you are a first timer here and haven't seen our technology with telescopes, binoculars, educational toys, give us a follow so you get notified of what's going on and you can keep seeing our broadcast. So, Paul, let me see if I can hear you. There we go. Okay. I can hear you, Paul. That's good. So, back to the telescope. Over in the carousel right now, you can find a product called a sun catcher. That is a solar filter that you can put on any telescope, and it goes on this end of the telescope right here, so you can use your telescope to look safely at the sun. There it is right now. You can see it over in the carousel as the featured item. Paul, can you run a video from remotely of the sun catcher? Well, we'll talk about for a minute while he figures out if he can make this happen.
Well, I don't think
remotely.
It's not something that I can do because I wasn't prepared to show it.
No big deal.
If I was prepared to show it, I could.
Yeah, so that's the way it goes.
I didn't know you were going to want it.
Yep.
I've got all
Lucy
the others.
Says, howdy, Kent, great show as always. So the sun catcher is a mylar film. It's a mirror based that rejects almost all the light and safely lets the light through into your eye. Now, you need to understand how it works. It always goes on the front of the telescope, never back here, because focused sunlight coming out of a telescope is like a laser, and it instantly will burn through that reflective film. So it goes on the front of the telescope. We sell them in a variety of sizes, one that will fit the telescope you have right now. If you have a telescope, you can go to the carousel, select your size. If you don't know what size you need and can't figure it out, real simple, go on to the Explore Scientific store on Amazon.com and click Contact Seller. And Noah over there will get your message that, hey, I want to buy a sun catcher. Here's the kind of telescope I have. And he'll figure out what you need and let you know. And you can buy it then right here through the Amazon site. And ship straight to you. And you'll then be able to look safely at the sun. Now, what is there to see on the sun? Through this kind of filter, it's a white light filter, so you can see sunspots, you can see some granulation, some fraculae,
There's a couple
things
on
like
my
that.
desk. If you want to go over there and get the little ones.
Hey, Annie, there's a solar filter on his desk. He said, you want to go over and grab one? Yep, okay. Annie's going to grab it. So you can see sunspots and granulation on the surface of the sun. You won't see those long, beautiful arches and prominence that you see through other filters. Those are much more expensive. These solar filters are inexpensive and work fantastic. Here's one right here. It is a sun catcher 4 to 7, and it probably will fit. Look at that. Fits just like that on the telescope. And now you've transformed your telescope that's good for looking at the stars. You have now transformed that into a solar safe telescope. Okay? So with this right here, you can look at the sun. Now, how do you point it? Don't use the red dot finder. I take my finders off when I do this, or put a cup or something over them so people don't try and look through it. Now, you can use it if you just use the shadow method, right? You just move it until you get a good, crisp, solid shadow, and I'll hold a piece of paper right here so I can see the shadow of the finder scope. But as soon as I get it found and see it in the eyepiece, take the finder scope off, right? Here's how this works. It's going to come put together, except that it's going to have 4 pieces of this hard foam right here. This hard foam is what you install. You get 4 pieces of double-sided tape, and you put the 4 pieces of foam in place, and then I put it on the table, take the telescope, set it down centered, push down in, and I'll mark it with a pen or just go ahead and cut it with a knife. You want these foam pieces a little bit too big. You don't want this to just slide easily on your telescope, because it's easy for it to bump or knock off. You want to have to push this thing and really get it pushed down on there so it doesn't just come off easily, because you don't want to be looking at the telescope and the wind come blow it off or somebody pull it off real easy. You want that to stay on there. We have all sorts of sizes, again, that will fit any telescope. If you can't figure it out, contact Noah. You just go to the Explore Scientific store on Amazon.com, contact seller, and Noah will figure it out for you. So this is the First Light 127 millimeter Maxudo of Cassegrain. That Maxudo of Cassegrain talks about the kind of piece of glass here and how the system is put together. This is a Maxudo of Cassegrain. You may have heard of a Schmidt Cassegrain, a Ritchie Creighton. There's all sorts of different configurations. They all work real similar. Piece of glass, curved mirror, flat mirror, comes out the back, goes to your eye. Now you might notice on this eyepiece there's something attached to it. All the First Light telescopes come with that right there. What is that? Absolutely, you're right. It's a smartphone adapter. It's really easy to use. Here's how you do it. Fits in 1 1/4 inch eyepiece, which these are 1.25 inches right here. The other size of eyepieces typical in telescopes are 2 inch, so they're 2 inches across, much larger than this one. And this is how this works. It's real simple. You simply slide the eyepiece in and get it all the way down to where the little rubber eye cup is down in there. And you tighten down the set screw, just like that. Now, and I get it good and tight. I don't try and baby it. I get it on there. And now, you can take your smartphone. And with my smartphone, I have to take it out of the carry case, but that's okay. I wet these little octopus suction cups down with a damp rag. And then I turn my camera on and just put it down until my camera lines up with the circle of the eyepiece. And I stick it on there real good. It also comes with a piece of stretchy elastic material. Put it on there to help hold your smartphone on this adapter. Once it's there, you can simply put it in the telescope and make final adjustments on focus, and off you go. Now, my advice is to get it on something with a low power eyepiece, pull it out, put the eyepiece on, smartphone on, put it back in, because what you're looking at is moving, right? So if it's moving across the sky and you know that you keep having to move the telescope this way to follow it, just move the telescope until it's barely in the field of view, and as it moves across the sky, that gives you time to get your smartphone adapter attached and hooked up so it's ready to go. You start taking pictures and then share them wherever you want to with all your friends and neighbors to show them images of what you've been looking at through your First Light telescope. All right. Say again?
Tim Burris says hi.
Tim Burris says hi. Hello, Tim. Thank you for that shout out. Now, I'm going to switch telescopes here real quick, and it's a different kind of telescope. So I'm covering the 3 different kinds of telescopes effectively that are out there. So we've looked at a standard refractor that's just the typical long tube of the telescope, glass in one end, an eyepiece in another. Then we looked at a Schmidt Cassegrain, or in this case a Maxudo of Cassegrain, that is a folded light path. And now we end up with sort of looks similar to that 127 we just looked at, right? It's about the same length, about the same size, but it's a different kind of telescope. This is called a Newtonian telescope. What that means is, and I'll show you real quick, right here at the end of the telescope, there's no glass, right? There's a center thing in the middle held up by some pieces of metal. That's called the spider assembly or the secondary assembly. There's a little mirror in there that sits at a 45-degree angle. What happens is the light comes in the telescope, comes down to the bottom of the mirror where there's a curved mirror, and that light starts reflecting the light to a central point. But before it comes to focus, it bounces off this flat mirror in here and comes out of the focuser. Moving a little bit to the right to get it on camera for you. There we go. Is that better? And it comes out of the eyepiece right here. So simple, put the eyepiece in. Annie, readjust the camera, please. I can't move so far enough to the right to get this in the camera. So Andy's going to come over here and readjust the camera a little bit so you can see what's going on. So this is known as a Newtonian telescope. It is 114 millimeters in diameter, which means this diameter is 114 millimeters. The focal length, remember how long everything is, the focal length is 500 millimeters. She's done, Paul. The focal length is 500 millimeters. So the longer the focal length, the more magnification it has when you use the same eyepiece. As you can see, it's got a red dot finder, same process. Point the telescope at something, you can see it's a long ways away, and bingo, adjust the red dot finder, and you're good to go using the telescope. Now this telescope is a little bit more complicated to use. Telescope isn't, but the mount is. Instead of simple left, right, up, and down, this is what's called an equatorial mount. It's designed to mimic the rotation of the Earth's axis. This axis right here is set to match the axis of the rotational axis of the Earth. You would point it at the north celestial pole, this axis pointing up at the north celestial pole, or if you live in the southern hemisphere, up at the south celestial pole, not the magnetic pole, but the true north or true south pole. And then, if you rotate the telescope around this axis right here, it's always going to look at the same spot in the sky right now, because we're just looking at north, right at Polaris, and you can rotate this all the way around, you're going to see the same thing. But what happens is, when you want to look at something, say, in the southwestern sky, you can move the telescope like this and use the red dot finder to find something, and now you can look through the telescope in the southwestern sky. And here's the beautiful part. If you've done a good job of getting this axis lined up, you can simply use the slow motion control arm, and you can turn this really slowly and follow your object across the sky. So as this is turning, you can follow it, and you see it's turning, right? It's turning on this axis. Well, if you're off a little bit and it starts drifting out because this axis is not right exact, you can, somebody is taking off, there it is. You can turn the declination right here and keep it going across the sky, right? Real simple to use these two slow motion control knobs, arms, to keep the object centered up in your sky. What happens is, when you watch stars and planets move across the sky, they move in nice, smooth, curved arcs. Whether they're in the northern hemisphere, looking north or looking south, they move in nice, smooth arcs. This telescope is designed to follow those nice, smooth arcs to make it really easy to keep your object centered in the sky. More skills to learn, just like if you wanted to play, say, a guitar. You got to learn more skills to play guitar better. You got to practice at it. I can play chopsticks on a piano right now, but if I wanted to play something else, I would have to practice that and get better at it. That's the same thing. I can learn to use an equatorial mount really easily with just going out and practicing. It takes a bit of work, but once you master it, it's a great tool to make your astronomy a jump up in the game. The key to it is getting this axis right here aligned with true north. So our time today has come to an end. I appreciate everybody who's watched and given us a shout out. Thank you very much. If you're just joining us here on Amazon Live, click that follow button if you like what you're seeing, so we can bring you more content in the future. Talking about telescopes, binoculars, bird watching, astrophotography on Fridays, fun toys, learning through play, with lots of our educational toys on Tuesday, and a science-related show, microscopes, things like that, on Mondays as well. Always at 3 o'clock, thereabouts, here on Amazon Live. So, for Paul, who is over at his house in the remote control room.
The remote control.
It's a remote control room. We appreciate him figuring out ways to make this work while he's at home. Paul Newton, Noah Menard over in the control room.
Hey, don't touch the camera.
Hey, don't touch the camera. You're making the camera move. Noah says,
who's touching the camera?
Annie was touching the camera.
Don't touch the camera.
She's doing it now to mess with you. Now she's doing it on purpose. And for Annie is over there torturing Paul as we speak, and maybe y'all, because y'all can see the camera shake too. I'm
That's
Kent
right.
Martz for Explore Scientific. We'll see you tomorrow on Thursday when we'll be talking about On the Wing. We'll be doing a bird watching show. And I have added a couple of birds to my life list. We'll be talking about those tomorrow as well. Look forward to talking to you. Thanks for joining us. Have a great afternoon, evening, or morning, wherever you are. Goodbye, everybody. To go. Hey everybody, Kent Martz here from Explore Scientific. Thanks for joining us on Thursday here on Amazon Live. Today we're doing a show called On the Wing. It's about birding, which is, sort of an outdoors activity. And I thought, I'm going to add a few other things to the lineup of stuff we've been talking about for the past few weeks. The first things I'm going to add over, and these are over in the carousel, these are the National Geographic trekking poles. These are a fantastic set of trekking poles, and if you look closely, you're going to see there's mud on these trekking poles right here, because this is the set I use myself. I love to take these out hiking. My wife loves to use these. She can be unstable sometimes, and these out hiking give her a tremendous sense of stability and balance, having that third leg out there. And you come apart, obviously, but we don't want to do that. But we do want to put them out to their maximum right there. And I'm getting a bad echo again. And you can set these to whatever height you need them at, okay? So I like to set these. So I've got basically a straight out arm. This might be a little high, but it's okay right here. I'm not up like this or way down here. I like to have it so I got a little bit of reach and can have some stability. Has a wrist strap you can put on, so if you lose it, it'll stay with you right there. Get it right there. Easy to put on. You can tighten it up if you need to, if you want a good tight, to keep a hold of it. But right there. Has a cork grip and is adjustable to many, many heights. You can also adjust the clamping tension on these clamps simply by turning the nut just a little bit, and you can make it clamp a little bit harder if you think you need to. And so here we go. You can see right here how the clamps work, and you just clamp it and unclamp it, and obviously you don't want to pull it out because that's not good. Go to the maximum height, get it where you want it. If you want a little bit more clamp, you just tighten that screw up and then snap it down, and there we go. Same with this one. Has a titanium tip right here that I think you can see on the close-up, and it also comes with these nice feet that simply go on. This would be a foot for a slick rock surface right here, a foot for like if you're indoors on nice carpet or a nice tile floor that you don't want to mess up.
Yes. Holler if you need anything.
I will. So this is a snow basket or a mud basket. Goes on like that, and then the snow baskets screw in all the way up here. You don't want them coming off. Those screw in just like that, and now you've got a snow basket so you can use them when there's snow on the ground. These are the trekking poles from a National Geographic, a great little tool to use when you're out birding. How would you do that? Well, I'll show you how you would do that. Let me put since I'm in here inside on the carpet, Haven't told you, it comes also with a nice carrier bag. You can fit the feet and the trekking poles in here, and this is great, a great keeper for that. How would you use these with binoculars? Well, real simple. Being steady gives you the ability to see better, and you can very simply stand the, it's not going to show it, Paul. Yeah, camera one, just like this. And now you can look through these. Obviously, this is too high because it's on the table, but you get the point. You can look through these, right? And having a stabilizer is going to give you the ability to hold the binoculars steady, and if you hold them steady, you can see better details. You can see a whole lot better details if you can hold this steady. Now, I'm just holding it up, but if you're going to stick it on the ground or prop it up on a rock or on a fence post or something and get it to the height you need it, this is going to provide some image stabilization without having the expense of thousands of dollars to have image stabilized binoculars. The more you hold still, the more you're going to see. So this is a great little addition to your kit if you like bird watching. This is the trekking poles from National Geographic, a fine set of kit, and I'm just going to drop this stuff down here on the floor and pick it up after the show. Another thing, you know, a lot of birding goes on. You want to be out there in the morning, and you want to get outside when the sun comes up, because that's when you're going to see a lot of bird activity. Seeing your way in the dark is an important thing too. This is the headlamp from National Geographic. It is especially bright. It's like 550 lumen, and there we go. This has been set in my truck. I'm lighting up Noah over there right now. I'm sure he's happy about it. This is a lot brighter than you think it is, isn't it, Noah? Even from, it's a lot of light coming out of here, and you can step through it to a dimmer mode. You can go to a sort of a wide, softer light. You can go to a dimmer, soft light. It has a red mode on it, and then it goes into a flashing SOS mode. And so with the red mode, if you just hold the button down, it just goes straight into red mode. So you can use this at night and not ruin your night vision. Great for astronomy. If you wanted to wear it on your head, it comes with a simple little head strap and a little keeper, so you can point the light down to wherever you need to point it. If you need to work it right here, use it working on your car or out setting up your campsite, whatever. This would be a great addition to your kit. This is my personal one that I pulled out of the back seat of my truck. It's been back there for probably 4 months since I've charged it up. It's still bright as day. I've used it a little bit, but it's holding a charge really well. It comes with a magnetic adapter that goes right here, plugs into any USB port, and you have the ability to charge it up out of a USB port. Holds a charge for a long, long time. These are a good selling item right here, especially bright. We've taken them to some outdoor shows, and people were excited and bought dozens and dozens of these from the staff at that outdoor show, and the dealers were buying them left and right. We have these in stores all over the place. You can pick them up, especially right here on the Amazon live program. You can go over to the carousel, and they're in the carousel right now. Aren't they, Noah? Right? Yep. You got those in the carousel. They're over in the carousel right now. You can pick those up. Oh, I see it's clicked up as the featured product. So very popular item. Pick yourself up a National Geographic LED headlamp. It says Bresser, but the picture's of National Geographic. So it's Bresser National Geographic. Same things. Pick them up in your carousel right now. Multi-uses, not just birding. So let's get on down the road and let's talk about birding real quick. If you want to be Mike Overacker, I gotta get me a set of them. The trekking poles, yes, Mike. You can click over in the carousel and get them sent to you right away through Amazon.com, and those will come to you in a nice little package. Everything's there. They're especially nice to use. And I'm going to be using them on a couple of upcoming trips where we're going to be doing some birding and some hiking, looking forward to that. So, pair of binoculars. You don't have to have binoculars to do birding show, but you can do it with your eyes, but a pair of binoculars makes it better. We've got a question here. Yeah, I'm not going to, yeah, those need to be blocked. Thank you very much. Yep. Have some trolls. We don't get trolls very often, but when we do, NOAA runs them back under their bridge because that's where trolls need to stay. So, if you have a pair of binoculars, you can do birding. The other thing that you need, even if you're looking at birds with your eyes, you need a bird book. And over in the carousel, you're going to see the National Geographic Field Guide to the Birds of North America. It's a great tool to use to identify birds. In fact, was out over the weekend, was kayaking on an area lake and saw a shorebird and could get within about 40 feet of it. But when you're shooting with a smartphone that doesn't have a really good optical zoom, you have to do digital zoom, and I did that. And we have video, a couple of pictures. And Paul, you want to pull those up real quick? Do the pictures first, and then do the video. And there you go. You can see the bird, and it's a interesting, unique bird. It's right there in the dead center, just below. It's in the grassy area.
I see the bird.
Yep. It's
right there.
There you go. Now that's a really small bird. That is not a big bird. But you know, it was on the shore. It was going around between the rocks. Paul, go to another image real quick. So you can see it has a long beak, a dark body, a dark neck. And there's another one. You can see it in a different repose. And zoom in, there you go. And see that white stripe that goes up, the little thing that goes up on its breast towards its neck? That becomes a field mark. And go ahead and show the next picture. And here we go. And then we're going to have a movie that's going to show it walking. So there's another view of it. And this bird is only about maybe 6 inches long. It is a really small shorebird. It was the only one. It was by itself. And I determined it was a sandpiper. And let's go to the movie now, Paul. See it bobs his tail there a little bit. That's an interesting field mark. I should have put the picture. There's some deer off to the right. I should have included that. So there you go. You're looking at it. What is the bird? The bird is a spotted sandpiper. I had narrowed it down to, bird is the word. I had everybody said it. I had narrowed it down to either a solitary sandpiper or a spotted sandpiper. And so I couldn't decide what it was. I felt like it was probably a juvenile spotted sandpiper. Wasn't sure, so I put it on a birding page, and the answer quickly came back from a couple of people. It is a spotted sandpiper, and there's two tells. One is the shoulder marking that comes up towards its neck, that little spike that comes up of white that comes up towards its neck, and the fact that it was hanging around the rocks. Solitary sandpipers tend to stay in at the edge of the water, so its behavior up in the rocks marked it as a spotted sandpiper, not a solitary sandpiper. And like the solitary sandpiper's name infers, it is generally a solitary bird. Very, don't fly in big flocks or walk around in the water in big flocks. But this one was by itself, so that gave me pause. But Northwest Arkansas, where Explore Scientific is located, is in the migratory path of the birds, and migration is going on right now. So any given day you go out, you don't know what birds you're going to see because migration is going on, and you can see birds that you wouldn't see any other time of the year other than the spring and fall migrations. So get out there. Birding is a good time to do it now. You're going to need a bird book. If you don't have one, pick up the North American Field Guide the National Geographic Field Guide for North American birds. But you're going to need some binoculars. And how do you start with the binoculars? Well, we sort of focusing on National Geographic so far today. I just said National Geographic today. This is the National Geographic 8x42 binoculars. These are fully coated. They're not waterproof. They're water resistant. You don't want to get them wet. From National Geographic. What do the numbers mean? 8x42. That 8 means the eyepieces right here are 8 power eyepieces, meaning they magnify what you're looking at by a factor of 8. And the 42 is a factor of a measurement of the objective diameter of these binoculars. So these binoculars, diameter of 42 millimeters. The bigger the diameter, the more light gets sucked in. You see a lot of 8x42s, 10x42s, 10x50s, things like that. Those tend to be the wheelhouse of a lot of binoculars. 8x42s, 6x32s, those are popular birding sizes. This is a popular pair of binoculars to start with here on Amazon.com. These are a good seller. They have a rating above 4.5 by the people who have purchased them and given us reviews. And you know, when you buy something from us, we appreciate the review. It helps us sell items here on Amazon. And so these are the National Geographic 8x42s binoculars. They have twist-up eye cups right here, twist-up eye cups. And as you can see, there's a dial right here. This is called the diopter. This is on the right side of binoculars. And there's a little scale right here. You may be able to see that scale that tells you plus and minus. So how this works is you're going to focus with your left eye. I always cover up the eyepiece and focus with the focus knob until I find focus. Then I switch and cover up the left eyepiece down here on the objective end, and I turn the diopter to focus the right eyepiece to fit my eye. By turning this diopter, you're actually focusing it independently than this one. Noah, there's a comment saying that they're sold out.
Yeah, those are very popular. So they sold out. They should be back in soon. But if they scroll down, there's other options we have for 8x42.
Okay, so yeah, Noah's discovered they were sold out today. I didn't know about it. They're working to get them restocked. Now, when do you think they're going to return to stock?
Probably going to be a couple of weeks. But if they scroll down, we've got other 8x42s.
There's other 8x42s down there if you scroll down through the carousel, or you can go over to our store and look for 8x42 or 10x42 as well. So both popular sizes. That's interesting. We're sold out. It just happened apparently. Travel Diva 2. Thank you, Travel Diva 2, for letting us know that. It's sold out during the show. Is what I'm being told by. What's his name? Well, he's not here. I can't see him because Paul, that's his name, the producer. He's remote controlled here in the studio. So thank you, Travel Diva 2, for that comment. Shows how quickly they sell out. They sold out during the show. So thank you very much for those people who took the opportunity to buy that. If you're out there right now, we have a chat function. We'd love to hear from you. Comments, questions, ideas, whatever. If you've got a birding story, I'd love to hear your birding story because this show is all about birding. So I started back 6 months ago now, back at the turn of the year. I guess it'd be 9 months now, or 8.5 months now. I started a life list. Now, I've been bird watching all my life, but I never really, thought about compiling a list of. No, I don't have the 10x42 wings. I got the Tetons. So, producer's talking to me in my ear. Sorry about that. Okay, so let's go. Let's go with, here, we're going to switch over to the Alpen, a little bit more expensive. These are the 8x34s, Alpen binoculars. Now, a little bit more money, but these have features that those National Geographic binoculars do not. What are some of those features? One, these are, and I'll show you another size here in just a second, Travel Diva. And if you're out there, give us a shout, give us a shout out. I'm thinking ahead of what I can speak. So these are the Alpen Wings. Wings is a series of binoculars. From this point up, all these binoculars are purged. So the air inside has been replaced with a neutral gas, either argon or nitrogen. What that does is it removes all the moisture, because both those gases are dry. They don't hold water, and once the air's out, they can't fog up. So if the conditions get right, that some pairs of binoculars would fog up, these won't, because they're sealed, right? They're purged with nitrogen, and yep. So the binoculars, I think we got a little video going. There we go. And we're tight on these right now. These are 8x34, meaning 8 power eyepieces, 34 millimeter diameter objectives. These objectives right here have flip up eye covers and a pair that hooks on to the shoulder strap that comes with these, so you can't lose them right there. And these go on right there. Like all good binoculars, have twist up eye cups. If you wear glasses, I always take my glasses off when I use binoculars. And they have a diopter on the right side. They have a diopter right here on the right side, so you can focus your right eye. So you can focus your left eye and then focus your right eye. So they're both in focus. What is the benefit of that? The benefit of having both eyes in perfect focus for that eye means that your eyeball doesn't have eye strain. Your brain is not trying to get your eyeball to change shape or trying to force things to get into focus. If both eyes are in focus, your eyes relax, your brain relaxes, you relax, and therefore you get a much more pleasant use of those binoculars. So little trick I teach people how to use binoculars. Well, get them in focus wherever you're going to focus on, and then if you want to hold still, like I said, one way to do it is using the hiking staff, the trekking pole, to hold them up. Another way to do it is elbows in, get a good grip, get everything in focus, then bring the binoculars up and push them up onto your above your eye, all right? And now hold your elbows in. You're going to be able to hold still a lot better and get less jumping around. Your arms are moving, your muscles are moving. Every time your heart beats, everything moves. This helps hold that down. And I need to bring a ball cap. Another way I do it is I've got a ball cap on that's fitted, not a one-size-fits-all that's stretchy, but a fitted or a snapback, good and tight. When I come up, I grab the bill of my cap and pinch down. So I've already got them in focus, and now I've locked them into my elbows, I've locked them into here, and they're locked into the bill of the cap. You'll be amazed at how much better you can see with a pair of binoculars, because holding still gives you so much more view. Pekka, hello Pekka, how are you? Can you show how to check out if the binoculars have a good quality prism installed like Poro? There's no real way to do it to check the quality. You get up into our high-end binoculars and you get a prism called an Abbe, A-B-B-E. That's how I pronounce it. I've never found a good pronunciation guide. It's a special design. It's expensive prism to make, but it provides extremely sharp, crisp, and bright viewing. What does a prism do in binoculars? Well, there's a prism in here that you can't see, but they're inside, and that prism, if that prism wasn't here when you looked in binoculars, these are just telescopes, right? And in a telescope, when you look at something, it's upside down and backwards. And if you wonder, well, why, you can look it up, or you can just get yourself a silver kitchen spoon. And if you look at it in the part that holds the cereal or the food, hold it up and look at it, you're going to be upside down in there. Why? Because that's a lens, and it's flipped the image when it reflected it back to you. If you want to turn it around and look at the back side, that's like a magnifying glass, sort of. You're right side up, but you're a lot bigger. It makes you bigger. So a spoon does the same thing. These would be upside down if you didn't have these prisms. What do the prisms do? They flip everything correctly and make sure it's left and right oriented. Because it would be disconcerting if you looked into binoculars and things were right side up, but a horse that's walking that way would be moving this way in your binoculars. That would be disconcerting. So those prisms provide a really good function inside the binoculars. Something functioning going on that if you've never taken a pair of binoculars apart, you have no idea what's going on. Pekka says, and by the way, Pekka lives in Sweden. Hello, Pekka. If you have stretched the binoculars on the handle length from your eyes, the light path should look like a circle, not a square on the ocular side. Okay, so he's saying that if you hold the light away and there's you can't really see the light in here because everything's dark, and you should see, yeah, I can see it there. Oh, it helps if you take the lens covers off, doesn't it? So yeah, there's a perfectly round circle in there that doesn't look square, as Pekka is saying. It's nice and round image. So yes, Travel Diva notes that Queen Elizabeth died a couple hours ago. Sad day for our friends in Britain and her various forms of sovereign nations, but yet affiliated with the United Kingdom. So Canada, obviously, Jamaica. There's all sorts of people who are still affiliated with the Queen, the monarchy of England. Served for, I think it was 70 years, the longest serving British monarch. And King Charles III, I think, is what he decided to go with. Although kings can choose their own king's name, like King George. I believe the Queen's Elizabeth II's father's name was Albert, but he selected to go by King George. So King Charles apparently has chosen to go by King Charles III. And, you know, she was performing her royal duties 2 days ago. She swore in the new prime minister, and I believe that was her last official duty. And she actually, I was hearing on the radio a few minutes ago, she actually stood for it and had been having mobility issues, but was able to complete her duties and in swearing a new prime minister, and went very quickly. So that, you know, the government, she can't, I'm not going to go there. I don't think Paul, are you going out so they can hear you now? Okay. Paul was in my ear saying he thinks the government serves at her pleasure. I think that they form a coalition. I don't think she can disband the government and force an election. I don't know. That's politics in another country. I'm not going to get involved. Kent, make a test with cheap binoculars and real quality ones and see what I mean. So we don't have any, well, we do have a really inexpensive kid pair of binoculars that I didn't talk about. Kids pair of binoculars real quick right here, and we're going to close out the show. This is a pair of Bresser 6x21 kid specialized binoculars. Now, these look like toys. These are real binoculars. They don't flex when you twist them, right? They don't flex when you twist them. Has a nice focus, and you know they're real. They got glass, they got metal, and they have a diopter right there. So these are real binoculars. They're kid specialized, but these are the real McCoys, the real deals. This isn't a pair of toy binoculars, okay? This is not a pair of binoculars right here. That's a toy. They're called kid specialized, but these are real binoculars. I really advocate buying you a pair and buying a kid or two kids in your life some pairs so they have their own. Take them out with you bird watching, or use them for sports or outdoors, or, you know, whatever sport, you know, looking at mountains, trees, whatever. Use these binoculars. So I'm going to use real quick, hold this up. Well, using Pekka's test, by golly, those have perfectly round, not square looking prisms. Means they have a high quality prism according to Pekka. Thank you, Pekka, for that. And David S., I bought some 250 binoculars a couple days ago. David, I hope you enjoyed those. You know, a good pair of binoculars is an investment. We have a pair over here. We're not going to show them today because we're running out of time, but they are fantastic pair of binoculars, super bright, wonderful things. Treat binoculars like their investment. Now, an inexpensive pair like these Kid Specialized, if kid breaks them, you're not out a lot of money, but these are great binoculars. These are nice binoculars. I've done astronomy with them. I've done bird watching with them. Going to Arizona in a couple of weeks, going to use them for bird watching there. You know, the difference is their interpupillary distance doesn't get as wide on these as on a real pair of binoculars. You can see the difference. Therefore, some adults may not be able to use them because their eyes are too far apart. This pair works for me fine. So, appreciate all the comments. David S. said they had some good reviews on YouTube and Amazon. Excellent. That's always a good way to pick stuff. We're going to sign off. We got to get on down the road and get ready for some other shows. For Explore Scientific, I'm Kent Martz. I hope you have a great day. Thank you, everybody, for participating. We'll be back tomorrow when we do astrophotography. And then Monday at 3, we'll be doing a science talking about what's wrong with Artemis and how they're going to fix it. Tuesday will be... what is Tuesday? Global Star Party. Wednesday will be First Light Chronicles talking about astronomy. We may not have Global Star Party on Tuesday. Scott Roberts is out of the country, president of the company. He is in Armenia for a international star party. I believe he'll be back in the office on Monday, but he may be zonked out and not do a show. I may do one in his place. And then back to Thursday for On the Wing. We'll hopefully bring you some more bird pictures and some exciting products for your viewing usage. Bye-bye, everybody. Have a great day.
Thank you for watching our 24-hour-a-day live stream here at Explore Scientific, where we show you all the programs that we run live in front of a live audience. Programs like Global Star Party, On the Wing for birders, First Light Chronicles for beginners, and Focus on Astrophotography for astrophotographers. We bring in astronomers and explorers from around the world to answer your questions live. But there's so much cool information there that we decide to package it all together and run it 24 hours a day. We're also on Amazon Live, where we do deep dives into our products and our gear. There's so much important information as we share the education, the experience, answering questions from the audience, that kind of thing. So tune in, and thanks for watching.
With the National Geographic StarApp 114 telescope, you will find a perfect portal into the realm of deep sky observation. This Newtonian reflector produces great views of planets and bright deep sky objects like star clusters and nebulae. It comes with a special mount that allows you to attach your smartphone to the telescope and use the AR Telescope app to locate and learn about constellations and planets. As you move the telescope across the sky, you will hear facts about the planets, constellations, and other objects in the app's database as they come into view. With the National Geographic StarApp 114, you also get 2 eyepieces and a 2x Barlow lens for multiple magnification options. Exploring the stars is easier with the National Geographic StarApp 114 reflector telescope.
Hey everybody, Kent Martz here at Explore Scientific. Welcome to Thursday when we're going to do the show On the Wing. It is a birding show. Thanks for joining us here on Amazon Live on this great Thursday afternoon. I got up this morning, temperature was a beautiful 63 degrees. I know it's going to get hot again, but by golly, the fall months are approaching, and that's a great time to get out and do bird watching. Why? Because the fall migration is on. And you know, if you've been doing birding, during the summer, you have birds that are resident there all summer long. But now what's happening is all the birds to the north are starting to migrate back to the south in the northern hemisphere. Because of that, birds that you might not have seen a few weeks ago start showing up in your yard or city parks or wherever it is you go to do your birding. City parks are great places, botanical gardens. If you live in a dry area, around water is always a good place to go as well. And wherever you go, you need to take something like this right here. This is my personal copy of the National Geographic Field Guide to Birds of North America. It's a great, awesomely illustrated bird book. See if we can get a shot of a random page here. We're looking at terns right here, T-E-R-N-S. Tip it a little bit so you can see it. As you can see, it has some maps on it that show the range and habitat and summer range, breeding range, et cetera, makes it, there we go, so you can see it. I'm going to flip over to another page just randomly. Let's see, we're looking at eagles, golden eagle and bald eagles right there. And then flip over to back here in the back, the sparrows. This book is organized in a great way. It has the front birds are just hummingbirds and things like that, known as, and then the sandpipers, then gulls, hawks, flycatchers, thrushes, warblers, and sparrows. This is over there in the carousel if you're on Amazon Live. It's over in the carousel right now. I'm looking at the wrong camera. I was looking at the close-up camera. Don't know why, because only my hand can be seen in it. We're, I was close-up, but I'm not close-up now. Correct. Paul's going to wander through. He's going to do something in the background. I don't know what. Oh, he's going to get my computer up, the monitor up, so I can see the comments. So here on Amazon Live, we do have a chat function. We love it when people give us a shout out, let us know they're there and say howdy, or otherwise ask a question or make a comment. Love those out there. So this is a show about birding. We're going to be talking about binoculars and spotting scopes today. Over in the carousel, you can pick up a copy of the National Geographic Field Guide to Birds of North America. I use this book all the time when I go out birding. I take it with me in a backpack so I can look things up. I also have a smaller book that my father... Yep, the sound works. How about that? All sorts of birds in here. You know, it takes time to learn to do this. And you want to start looking at what the bird looks like, right? You want to see if it has a ring around its eye, if it has a bar above its eye, or the color it is. There's all sorts of things. And this bird book talks about how to start doing some of that stuff. And you just look at it and you start looking, okay, that looks like a sparrow. So you go to the sparrow section and start tracking it down. You learn by doing. And the more birds you learn, you're looking at other birds and they come to you as well. And, you know, Paul likes to play Stump the Host by finding pictures on the internet and chunking them out there for me to try to identify. The rules are he has to use North American birds for that. Because, you know, we get some crazy South American birds or Asian birds. Yeah, that's not in my wheelhouse. A lot of American birds, North American birds aren't either, but you know, I'm good with the basics. So, start off with a pair of small binoculars for kids. You know, I encourage everybody to get a kid involved in your hobby, whatever it is. And right now we're talking about birding. And if you want to do birding with a kid, you know, this is the Bresser Specialized Kids Binocular. It's 6 by 21. What does that mean? 6 means the eyepieces right here are 6 power. They magnify things by a factor of 6. And the 21 talks about how many millimeters of diameter the objective side has, where the light comes in, 21 millimeters. Now these are kids specialized binoculars. Folks, these are the real deal binoculars. These are a great pair of binoculars. I've used them for birding. I'm going to be going to the Arizona Dark Sky Star Party out in Arizona, Oracle, Arizona, September 21 through 25. I'm going to take some of these pair of binoculars and I'm going to bird with these binoculars. I'm going to let other people that have never used them before bird with them. This is a fantastic pair of beginning binoculars. These are real binoculars. Sir?
Going to binocular with the birds?
Going to binocular with the birds. That's correct. And it sounds interesting. These are over the carousel right now. You can pick them up. A great product. I suggest you buy a couple, one for yourself and one for the kid or kids you're going to be going out with. That way, you're using the same binocular the kid is. That makes that kid feel special because you're using the same equipment they're using. This is a real pair of binoculars, has glass prism, has glass optics in it, has a diopter so you can change it. A good friend of mine bought these pair a couple of weeks ago, one of these pairs, for a gift for their 10-year-old, and their 10-year-old loved them, and she told me the other day that they're continuing to use them and play with them and is learning about the world of binoculars with them. That's how you get kids started in this hobby or in using binoculars. You can use them at sporting events, going out looking at countryside, looking at deer, animals, whatever. This is a great pair of binoculars for that. So, the Bresser Kids Specialized 6x21 binocular has a diopter, 6 power eyepieces, a great focuser. So, real quick, don't want to assume you know how to focus a pair of binoculars. Real simple. I never use my glasses when I'm birding, so when I'm using binoculars. So, you focus by covering up the right eye and turning the focus wheel, which focuses both sides, right? But your eyes don't focus the same. So we're going to focus for our left eye. There we go. And now I'm going to cover up the left eye. And I'm going to focus for my right eye and get my right eye in focus. And now both eyes are in focus. What that does for you is all the information coming to your brain is in focus. So your eye's not sitting there trying to make the images both in focus. That causes eye strain, eye stress, causes your mind to tire. You want to make everything as easy as you can when you go out and do birding using binoculars. Sir?
These are one of our most popular items on Amazon.
I really push these here on Amazon.com, the Amazon live broadcast. I really like this pair of binoculars. It's just a fantastic pair of binoculars.
It's one of our most popular.
To get started, and as Paul says, it's one of our most popular. And another popular item on Amazon is the National Geographic 8x42 binoculars. This is a 4.5 star plus, in other words, more than 4.5 star rating. And we sell lots of these here on Amazon. They're a very popular item from National Geographic. They're branded National Geographic, and they're 8x42. The number right there tells you. Remember that 8 means 8 power eyepieces right here, and 42 millimeters of objective surface, bringing in more light than those 21 millimeter binoculars. Well, you know, there's balance, right? A kid's binocular can't be big and heavy, you know, because they're kids and they can't hold them up as well. There's trade-offs in everything. So in this, you get more power, you get more light gathering, but you also bigger hands, things like that. So these are the same function. You focus for your left eye, and I'm going to focus over there on Noah's computer. Looks like he's working on some projects and some content for the Amazon pages on some binoculars. And now I'm going to cover up the left eye piece. I'm going to focus, get my fingers on the diopter here. I'm going to focus my right eye. And why am I doing this way? Well, when you close one eye and wink, like I could do this and just look through my left eye. But when you do that, that causes the shape of your eye to change. And that means when you open your eye, you're not back in focus again, perfect focus like you want to be. That's why you focus with both eyes open, but you cover up one eye so all the information your brain is getting is coming from one eye. That's why you focus. With both eyes open, you get better focus that way. Now, How do I use these binoculars? I should bring a ball cap with me on the show so I can demonstrate it. Put on a ball cap, and it needs to be a fitted cap, not a one-size-fits-all, because that's going to slide, and get it good and tight. And when you bring the binoculars up to your face after you got them in focus, you put the binoculars up against your eye socket, lined up with your eyes, and grab, let me get these here, and grab the bill of your cap and hold them together. Now, the binoculars are tied to your head a whole lot better, right? And because they're tied to your head a whole lot better, what does that mean? It means that they are tied to your head and keep your elbows in like this, and all that is going to make the binoculars don't bounce up and down. I'm exaggerating here, but if you're just trying to hold the binoculars like this, every time your heart beats, the binoculars move, right? You want to do everything you can to stop that from happening. So from my photography days, elbows in, binoculars up to your eye, that's going to steady you some. But if you grab the bill of your cap, that's going to steady you even more. This is good for birding, any outdoor sports, astronomy, whatever. These are the National Geographic 8x42 binoculars. Now these binoculars are fully coated, meaning they have specialized coatings on the front surface, the air surface of both sides of these binoculars, where your eyes look and where the light comes in. These are not waterproof. The binoculars we're going to look at in a minute are waterproof. As you get more coatings, more waterproofing, costs go up, right? This is a great pair of binoculars. Get yourself a pair. Protect them like an investment. You're going to get years of use out of them. Any binocular you don't want to drop, even though they're shock resistant or, you know, anything that's an optic that you drop, you run the risk of knocking things out of alignment. And once they're out of alignment, they got to be aligned or they're not any good because you're going to get two images. So you want to protect everyone. Here comes my first sneeze. First time I've done that in a while. I haven't been sneezing as much in the studio. First sneeze of the day, too. Just about like always. Got another one coming. I can feel it working its way up. Here it comes.
The light.
I think it is the light. Excuse me for sneezing.
It's an actual condition.
Well, I know. It's the bright lights in here, the right frequency, and off they go. But these binoculars, like the breasts are specialized for kids' binoculars, have the ability to change the interpupillary distance to fit your face. Now, if you're like Paul Newton, his eyes are way far apart. He has only rarely found a pair of binoculars that he can see through with both eyes. So binoculars become effectively a big double binocular, one for one eye, but he can't see through them. Sir?
Can't wear hats?
Oh, you can. You can just, you wear a watch around your head?
Yep.
Interesting. I've never noticed that. We'll have to get a picture of that and show it to you. So I guess he has big wrists too, is what he's saying. So nice, nice, generous. I knew an 8-year-old that wore size 14 shoe. I need to check out and see what he's doing now. That kid was big. 8-year-old, big feet. That kid's gonna be tall. His dad was a college basketball player, and I think his mom was too. Very, very tall, like 7 foot and 6'2" or something. Kid's going to be tall. Anyway, great pair of binoculars. National Geographic 8x42, a really popular item here with lots of good reviews. You can check it out here on Amazon Live or go to Amazon.com. These are the Wings 8x32 binoculars from Alpen. Alpen is a brand that's been around for a long time. We purchased them 4 years ago, after they'd gone out of business before that, and we reconstituted the line and have modernized all the binoculars. These are 8x34, so yeah, you understand now that the 8 is how much magnification there is, and the second number is how much light gathering ability they have, 34. If you're out there right now and have a question, we would love for you to ask a question, make a comment, or just give us a howdy. We love to get howdies from people who are watching us here on Amazon Live or the live stream, the social live stream. So, another pair of binoculars. These Alpen binoculars are a step up from the National Geographic, meaning they're more of an investment. Why? Because they have better glass and they're fully multi-coated. The previous binoculars were just fully coated, meaning that surface and this surface. This binocular has full coatings on every piece of glass that light passes through. What does that do for you? It gives you brighter, sharper, crisper images. That's what you want. It's sort of counterintuitive that things on the surface of the glass will make it brighter. You'd think it would cut down the light, but it enhances the light, sharpens the light, and those proprietary coatings really give you a bright, bright view. The difference is astounding. But again, you know, if you've not ever done binoculars before, it's always good to not go in super expensive on it. Find out that you love using them and that you're going to use them for birding or sports watching or whatever, and you're going to really get some enjoyment out of them. That's when you want to start talking about moving up. So these binoculars are fully coated. They're also waterproof. Why are they waterproof? Because all the air has been removed and replaced by either nitrogen or argon. Both are dry, inert gases. They force all the air out. The air takes all the moisture with them. They seal them up. They have O-rings so no air can get inside. And if no air can get inside, no moisture can get inside as well, meaning they're not going to fog up inside. Sure, I can fog these up on the outside right now by going, and there's fog on that eyepiece, but it's going to go away. But if you get a lot of fog or dew on it, that's okay. It's not going to get inside the binocular and ruin your binocular. These are the Alpen Wings 8x34 binocular. Comes with eyepiece cover right here. I never put the neck straps on because it makes them harder to pack up, so I just don't do it. End caps to keep the end caps on are just on rings around the ends. Right there, always handy to cover them up. Comes with this nice storage bag. Comes with a lens cleaning pin. And as I said, a neck strap, but I don't have the neck strap in here. And a really nice carrying case, double zipper, nylon, and the hook and loop flip over with a nice shoulder carry strap. I've got it shortened up so it's just a handle. It also has a little pouch right here so you can slip it through the belt and carry it like a holster on your hip. So you always got them in half, can whip them out real quick when you're hiking or whatever and see a bird. Now moving along to, let's see what these are. I'm not sure which ones I grabbed. Oh yes, the Alpen Teton binoculars. Now this is a top of the line binocular, a really, really awesome set of binoculars. Take the end caps off, take the tops off. This is the Teton 8x42 8-power eyepieces, 42 millimeter objective lenses. They're over as the featured item right now in the carousel. These are an investment in binoculars. If you're looking for a really home run pair of binoculars, this is your pair. These, go out and compare them with the ED glass and the Abbe prism. We'll talk about ED glass and Abbe prism in a minute. Go compare these to other brands. These are not cheapened out. These are priced competitively and making them an affordable binocular for anyone who wants to have an investment in those binoculars. So ED glass, extra low dispersion glass. It's high quality glass that's formulated to and designed to not cause light scatter or diffraction. That ED glass makes these extremely bright, extremely sharp, and extremely crisp. The Abbe prism is a specially designed prism with long sides that allows the light to reflect in a really great way. And I could draw a diagram for you on my green screen back here. There's no green screen back here. I could draw a diagram for you about why. I've studied and looked it up, and it causes the reflections to be really good and sharp and crisp in those prisms. And there's prisms in here. Why? Because if this was just a telescope, when you looked in the eyepieces, everything would be upside down. Well, that doesn't work for eyepiece binoculars real well. But binoculars are right side up. Why are they right side up? Because there's a prism in here that flips it right side up and keeps it oriented correctly, so it's just like you're looking with your eyes. All of these binoculars have a prism in them. These have roof prisms as opposed to the poro prisms where the binoculars come out and have that jag in them. Fine pair of binoculars right here. Paul's got some B-roll of these binoculars. You gonna roll it, Paul? Sir? He's coming. So you look through these. Oh, we got a comment. Oh, get my glasses on. I can sort of read it, but easier. Hi, Kent. These 8x34s are perfect for sailing boats, sailing and boating, and whale watching out in the ocean. Egon Reich, that's true. You know, binoculars, this is a birding show, but they're great for anything you want to reach out and look at. Whaling, sailboating, whale watching, you know, if you like backpacking and looking at stuff across the valley, any outdoor use you're going to have, and any of these binoculars I'm talking about are going to fit that bill. What's nice about those 8x34s that Egon was talking about, those 8x34s offer a nice compact design, but a lot of light gathering capacity and the nice power. Compared to these, this is a heavy pair, magnesium body, but they're heavy glass. It's got that ED, extra low dispersion glass, proprietary coatings, fully coated, not fully coated, fully multi-coated, and they got the fantastic Abbe prism inside. All those things working together to create an astoundingly sharp, bright, crisp image. Now, Paul tells a story. He was getting ready to shoot this video. He was shooting video and it got too dark to film. He got a pair of these binoculars, picked him up, was up in Wisconsin with our pro staff director, Rick White. And Iowa, not Wisconsin. And looked out into the woods just to see what he could see and was flabbergasted by how bright they were in relationship to the darkness that was descending upon them at the end of the day. So, Paul, you got that video? Not found the video yet. He's got so many videos. It's like looking for a needle in a haystack, which can be done, but you have to design the right kind of machine to do it. Mythbusters proved that, if they proved anything. One of my favorite shows was Mythbusters because they challenged you to think and found really cool, creative ways to do it, and they blew stuff up. So, no, Paul? Nope.
I don't know, my computer.
His computer is arguing with him, does not want to run. Right before the show, it started running, it crashed, and it was running really slow and weird. So we're going to move on to another final object over here. You can pick up these in the carousel right now. Great price here on Amazon Live. Pick them up so you can have an investment in your binoculars. Now, I don't have the neck strap with me, didn't grab one, but all the higher binoculars from Alpen come with a neoprene neck strap. If you think back to the days when I was a kid, it was a real thin plastic one. My dad, we'd go out birding and, you know, taking them to football games and things like that. And those straps would dig into your neck. They're hot plastic. These are neoprene. They stay cool. They're soft on your neck, nice and wide, stretchy, anti-skid, so you have them on your shoulder. They don't just keep sliding off. That neck strap is a great improvement over what I had when I was growing up. So, switching off to, and I didn't grab a monopod. That's all right. This is the Alpen Apex, 20 power to 60 power, meaning it's a zoom spotting scope. It has an objective of a gigantic 80 millimeters right there. Look at that pretty piece of glass up front. This spotting scope comes with a extendable dew shield. It's not twist up, just slides up. You can twist it if you want to, doesn't matter. An extendable dew shield right there helps keep dew and glare off of the glass when you're using it. The zoom eyepiece is right here. It zooms from 20 power all the way up to a 60 power. Now think about it. We were talking about the binoculars had 8 and 10 power. This starts out at 20 power and goes up to 60 power. With a spotting scope, you get a whole lot of magnification, which means you can see small things a lot farther away. Comes with standard cups on both ends. Twist-up eye cup, just like the binoculars. Didn't talk about the twist-up eye cups. Twist-up eye cup to help with your eye relief. And a coarse focus knob and a fine focus, so you can get it into absolutely sharp, tack sharp focus, no matter how far out what you're looking at is. Now, on the bottom, there is a hole right here that has a 1/4 to 20 threading in it, meaning you can attach this to any tripod that has standard 1/4 to 20 threading. That's basically most or all of North America. On a tripod, You know, you can handhold these, but the reality is you really don't want to. There's the video running now. And you can just see that beautiful piece of glass there. Nice, pristine. This is an investment in your hobby right here. If you've never had a spotting scope and looked through one, you owe it to yourself to do it. Go check it out and look how far out. Sir?
Great choice for
There we go.
even if you want thinking about astronomy.
Oh, you know, it's a little telescope. It's a right image up, a little telescope, has a nice 45-degree angle to it. So if you're going to put it on a monopod and look overhead, the eyepiece is still easy to get to. It's not, you know, down here like this where you have to look up. And even in astronomy, you never look overhead because it's hard for any of your mounts to go directly overhead. Great for astronomy, great for bird watching if you're a hunter, great for that as well. All sorts of options for this. This ring right here, if it's mounted on top of a tripod, you can turn this and get it at a more comfortable angle for you. Like if you're sitting on a table or sitting on the ground with a tripod, you can be here and not have it in front of you, but yet look over here and scope out what's out there and what you're looking at trying to find. So this is the Alpen Apex 20 power to 60 power zoom spotting scope. Has a fantastic piece of glass up here, 80 millimeters in diameter, bringing in massive amount of light, squishing it down and focusing it on your eye. One of the things I like about this spotting scope comes with a nylon carrying case. The nylon carrying case allows you to use it even in the carry case, and here's how you do that. Goes in the carry case, unzip it all the way, so it makes it easy. I like to do it the hard way. Love to struggle, force myself to struggle. There we go. Got it up here in the front. Now I'm going to zip it up. And we can keep it stored like this, keep it clean, but if we need to use it real quick, this end unzips. There's a little slot right here where you can put the tripod connector to it. Unzip it, pull off the eye cover, and you're ready to start using your spotting scope. So yeah, it's a waterproof spotting scope. It's fully purged, fully multi-coated, but you still don't want to let it get caught in a downpour if you can help it. Won't hurt any, but take care of your stuff, right? If you have it here, you can simply zip it up and it's protected better from the elements. This is the Alpen Apex 20 to 60 by 80 spotting scope. And with that, folks, we're going to wrap up the show. Thanks for watching here on Amazon Live. We appreciate it very much, and out there on the social media feed. Thank you for sharing your time with us. We do this because we love the interaction with our customers. It's a one-to-one relationship, and we appreciate it very much. I'll be back tomorrow with Focus on Astrophotography at 3 o'clock, and we shall see what I have in store for that show. Might have some pictures if we get a chance to do some stacking tomorrow. Don't know if we're going to or not. But anyway, on behalf of Paul Newton over the control room and Noah Menard, who is hard at work over in the marketplace, we'll see if he waves hi or he has his earbuds in. Oh, he's waved hi. He said, hi, everybody. I'm Kent Martz. For everybody else here at Explore Scientific, thanks for watching. We will see you tomorrow. Bye-bye.
If you're in love with the stars, you love the Milky Way, and you want to be out with astronomers under a really dark sky, come to the Arizona Dark Sky Star Party with Biosphere 2. It's going to be amazing. You'll be at Oracle State Park, Oracle, Arizona, and we're going to have music, stars, astronomy, door prizes, a lot of fun. Come to explorescientific.com/events and sign up.
Sorry. Hey, guys. I'm just hiding off over there on the other side. I was waiting to refresh my thing. It's okay. It's all good. It's all good. All right. So hello to Amazon world out there and anybody else that is watching. I am Annie, and I'm obviously with Explore Scientific. And today is Learning Through Education. So I'm gonna show you a couple of things that we have here for younger.
Such enthusiasm.
Younger adventurous people. Sorry. Yes, I know, Paul. I have such enthusiasm. Anyways, yeah, it's just for the younger crowd that wants to get out and explore and see what the world is like and stuff like that. So we here at Explore Scientific have STEM products that are available to preteens, teenagers, and the younger crowd. So if you're out there and you're a parent, what I'm going to show you today is for 7 and under. So the first thing I'm going to show you is our Explore One interactive fun board. It comes in fun board. He calls it a pun board. Hang on, I'm going to refresh my screen. So yeah, he calls it the pun board, but but I don't know why. I think because he says that if you press the thing, it'll do some kind of pun. I don't know. Who knows? That's his joke. So the interactive fun board comes in 4 different colors. It comes in orange, blue, green, and white. This is for ages 3 and up. I keep it around. I keep it in my car for my son, who's 5 years old, to play with, like when we go to a restaurant or we have a doctor's appointment that we need to go to or something like that. It keeps him engaged and having fun. He really likes it because we do a game on here where it's kind of like pass and play. He'll draw something and then he'll have a family member add to it, or the family member will draw something and he'll add to it. And so it's just a great way to get your family engaged. Deep breaths. Deep breaths. I can't get this thing to reload correctly, Paul. I've pushed it 3 or 4 times and it's not. So this board is rechargeable. It comes with a cord that you can charge it. I like it.
Category with the arrow buttons, then press the power button to select.
I like it because there's so many options on here. It has a screen that you can do activity things, like right now it's showing a boat. You can also, there's an airplane. This is the drawing mode. It has math, alphabet, drawing, and games on here. So you can choose a picture and then try to draw that. If you want to go back to the menu, you would hit the power button. I'm sorry. I mean the reload button, excuse me. You hit the reload button again, and it has the couple of different items on here that you can, or categories you can choose, and then you just use an arrow, and I'm going to do games. I'm going to hit the power button to select, and you can do draw and guess with your friend or your family or whoever's with you. Let's see here, tic-tac-toe. And then draw and guess, of course. But we, like I said, and in my house, we like to come up with a couple of different things that we can do to be able to. Sorry, I just heard myself in the background. Kind of threw me off. Squirrel. Squirrel. Anyways, my son and I like to just have it around so we can just play with it. He likes to draw, so I like it because I don't have to carry around crayons. I don't have to carry around pencils or pens or paper or anything like that. So the really neat thing is, let's see here. I'm going to do tic-tac-toe. Draw that real fast so I can do my X. So there is a feature on the top of this. There's a little locking key on the top of this, so I can lock this. And if I wanted to play this game with somebody and I didn't want my stuff erased, then I would be able to lock it and pass it to the next person, and you can still draw on it. And so therefore you would just continue to play tic-tac-toe with yourself, like I'm doing right now. And so there we go. It's a tie. Oh, I did. I'm looking at it upside down. I beat myself. Thank you, Paul, for pointing that out. Anyways, so it's really cool because then if you go and you hit this trash can button, it does not go away. It stays on there. So you are able to pass and play this this item and not have things erased. In order to erase that and go to and clear it out and do something else, you would just unlock it, and then you would hit that trash can button, and it's all clear. The other feature I like about this is, let's say I don't really want the screen, which is the way we usually play with it, just because my son and I are a little different than, we follow the rules to some extent, but we get creative. So, so this is the feature I like about this product the most. So I have charged mine at the house for a really long time. I haven't charged it for a really long time. I think it's been 4 months now. And we don't, like I said, my son doesn't usually use the screen very much, but we just do pass and play and things like that at functions or whatever I need him to sit and be still or something with. But you can still, even though the screen's not on, you can still draw on it. You can still draw things on it and have a fun time with your family or your kid, or they can enjoy their time just being creative and getting their minds working on just things that they're trying to create and draw. So it's really neat because you can do that and you don't need the screen for it. So if I wanted to erase it, I can erase it, and that screen will stay on. I don't think we've charged this one for quite a few months now as well. We only use it in here in the studio. So it stays on for, the battery doesn't run down. So if you're not using it, obviously. In fact, the other day, we finally got ours out. It was in the car, it had been left in the car for a while, and Daxton could still draw on it, but he couldn't erase anything. So I know it needs to be charged up again. So, but yeah, if you, let's say your child's playing with it and you don't realize that the lock button is on and they start drawing and they go, oh gosh, I can't erase everything, then you'll just unlock that and it'll go away. So it has a nice place to hold the pen, the stylus with it. Like I said, it has math, alphabet, and games and drawing on there. So it's a very creative way to get your kids engaged. And if they're younger, 3, it helps that fine motor skills on holding a pen correctly and things like that. So like I said, comes in 4 colors: green, blue, white, and orange, I believe.
All sound like me.
Oh yes, and Paul is the voice on there, our video guru in the back is the voice on there. So you'll get to hear him all the time if you would like to have Paul in your house all the time.
Yes.
Yes, he says yes. So,
Everyone wants that.
so anyways, great tool, great item to have just hanging around. Like I said, we take it to doctor's appointments, restaurants, things like that. Keep the kids busy and engaged, and also it helps them interact with people at the table. So yeah, great tool. So definitely recommend it. So there's that. Okay, now on to our second item. This is our 14 electronic science set. I chose this one because it's only 14 pieces. No, I'm just kidding. No, I chose this one because I like the cases and I like the instruction manual. So it has 14 different things that you can use. It's a circuit experiment set. So it teaches you about electricity and circuits. Reminds me of back in the day whenever we used to use potatoes to make light bulbs. I think that's what we did. Isn't that what we did, Paul? I think that's what we used. Light bulbs. Paul did not. He was so ancient. He just refused. He refused to do it. So yeah, this is our Explorer Science 14 electronic science set. It comes with this case, these two boxes, which I really like because I don't know if y'all have ever stepped on a Lego, but it's not fun. And I don't know if y'all have ever lost a piece and not been able to find it. It's not fun. It is not fun. Hey, if you are out there in Amazon world, give us a shout out if you have any questions. I'd like to know you're out there. I'd like to recognize that you're hanging out with me today in the studio. Lucy's usually here, but that's not happening. She's not here today. Okay, so there's 14 sets. This is a bubble blower. So you can do a bubble blower. This is a color wheel, has a color wheel. This is a disc that flips up. This is this right here, here, right there. Oh, here. Ta-da! Oh my goodness! I can't get it to stand up, or I would. Bickety back, bickety back. Right here? Yeah. Oh, I need it way up here, is what you're saying. Look, there you go. So that's the bubble blower. Of course, you've got to put everything together. It comes with the wires already attached. There's a piece to it. Comes with a little bell that you can make ding. Here's the battery packs, the switch, and then a couple little connectors, it looks like. This is the little thing to make the bell ring. Another battery pack, a motor, a hand wand. I mean, it's got tons and tons of stuff in here, and then the connectors to connect everything. Huh? I just learned Paul is answering machine voice at Explore Scientific too. He is the owl that, oh, he's the AI that will become Skynet. Yes, he is also, Paul is also our answering machine here at Explore Scientific. Yes, he is a jack of all trades. He's got that radio voice, so we just use him all the time, you know? Okay, so
Annie, press 75.
Yeah, you can press 75. I don't think it'll get you anywhere. It will get you nowhere really fast. 0, 0, 0. I've done that before, called into places and be like, okay, I'm just ready to get through this. Okay, so I think today what I'm going to build is... Do I have time? I got 15 minutes. You don't think I can build something in 15 minutes? The challenge is on. Okay, let's do the, I'm going to do the disc since that's the one that Lucy likes the best. And in honor of Lucy not being here, I'm going to do that one. So we're going to take this box. I'm going to push all these little pieces up out of my way. So we're going to put the things in that we need. We're going to leave the things out that we need for the disc, and we're going to put the things up that we don't need. So let's say, okay, I don't need the bubble blower, and I don't need the bubble blower box. This is the nice thing about this thing is it can, actually I'm gonna put it in here, so I'll have more room. Put everything away, and then you can, I'm going to keep this thing because I like that thing, little wand. This is another little disc. I don't need the color wheel. I only need this, and I need these things. Okay. So all of that gets housed in this box. This is the one feature that I really liked about this, because as a mom, putting things away is key to keeping them. So, okay, so the first thing I need is a motor. So put this here, put the motor there, and then it needs a C-clamp thing. I just had it. Did I lose it already? I think oh, there it is, hiding from me. So it's going to go on here. I always forget how to do this thing. Oh, wait, I don't need that one for that. Okay, so I need the motor, and then I need, let's see, I don't want to do the bell. I need the motor, and I need a battery, and I need a switch, and then I I'm missing my metal wire, but that's okay. I'll find it in a minute. Let's move the switch up here.
Where's the music coming from?
And then a connector, and then the connectors. These are the connectors. They come with it. They're little just wire, they're just kind of like little springs. They are bendy, and you are able to stick those wires in each one and make that connection for the current. So let's put this here. I think I need 2, 3. Normally we normally put the bell in the middle, so I'm going to take that out today and see if I can still do it. See if I can find them. Just bear with me. Bear with.
There are no bears.
There are no bears. Are you sure? There's no bears in here. None whatsoever. Okay, so we're going to need this wand, and we're going to need, I don't know what I did with my, maybe I stuck it in here on accident. My wire, I must have dropped it. Doo-doo. That's okay. I must have dropped mine. There was a metal wire, but I guess I must have dropped it somewhere. Okay, so what we're going to do, we're just going to leave that part out. We will take this connector. We need to go black to a black connector. So I'm going to put this little guy back here. We got to do the battery, and the motor needs to go. I do not. Should I be hearing music? Paul, can you share the music that's in your head with us? I'm just kidding. So you just stick those in there like that, and that's the connector. They're connected. And then you're going to go, so the red switch, the red battery switch needs to go to the same connector as the red switch. So got those connected. And then you're going to go, where did it go? This one to this one. I think I've got it. I think I have too many connectors because I was supposed to have that other wire, but that's okay. I don't know what I did with it. It's the story of my life. I drop it and it goes out of sight. That's why you need boxes like this to hold stuff together. Okay, so now we got 2 batteries. 1 and 2. Let's see if I made it work. I'm really woo! The switch is on already. And there it goes. And that's how you play. But it's the really cool thing about this is the wire, if I had, oh, here it is. I knew I dropped it. The wire, if you connect the wire to a couple of circuits, a couple of connectors, here, let's do that. So if I take this and I take the red switch wire out of that one and I put it into this connector, and then I take another connector. Here, move this little guy back. Move this over. So I'm going to put another one in there because I need another one for the wire. Then I'm going to take the wire. And the really neat thing is you can make this into any shape. On the box it shows it's shaped like a dinosaur, but you could shape it. It's very, very flexible, very bendable, so you can just make it whatever shape you want it to be in. So I am going to try to make mine into a little heart since it's already going that direction. So we're going to stick it in one connector, and then we're going to stick it in the connector that has the red wire from the switch going into it. Stick that there, and then we need to attach this. This is the wand. This is what will complete the current, because right now there isn't a current going through it. It's not on right now, but it's there's a current going through it. If I turned it on, it's not connected completely all the way. So in order to do that, you have to have this wand, and this wand needs to go. Give me just a second. This wand needs to go in the same red, where the wire comes from the red motor. It's going to go in that same connector as that one. So we'll put this here, and then I'll turn it on. Oh, obviously it's not spinning because the connection, this completes the connection. So, well, I say that, there it goes. So when I touch it, it'll start spinning with this metal because it completes that connection. This wand has a little hole, has a little gap in it, so it's almost like it is a game pretty much. But what you try to do is you try to get it in here and not touch the wire, and see who can, because when you do, then it flips like that. So it goes. It is a lot of fun. And like one of those nerve-wracking games, kind of like Operation is what it reminds me of. So you don't want to complete that connection. So you just sit here and you just be really still. And like I can't get it around that part, but slow and steady. And who knows, you might teach your kids how to have steady hands. They could become a doctor one day. You never know. But this is all of, this just gets their mind thinking and understanding how things are connected through electricity and current. So you can really, really see how it works. It just isn't like a picture in your, so you actually can understand the mechanics of a circuit and it working. It has 14 different, sets that you can do. Like I said, it has the color wheel, the flying disc. Of course, it comes with 2 battery compartments, so you could use both boxes at the same time, so you could make one big thing. Charity Rose, how are you today? So yeah, so this is a really good starter circuit set. We have one that's 125 experiments on it. We also have a V8 engine model that you can build. We have a magnetic toss-through game. We have rumbling robots. We have quite a few different of these STEM Explore Science sets that you can do circuitry on. So if you have a little mechanic or you have somebody that likes to take things apart and put things back together, this is a great item for them. It gets their hands working, gets their brains engaged, and they understand the mechanics of things that are working or how they work. So there is that. So I'm going to turn this off so I don't think you will electrocute yourself, but always turn it off just in case. So, and then like I said, everything gets housed back into this wonderful box so you can get it out and use it whenever you need. I am good. So yeah, so I really I need to get one of these for my son. I think he would like them. This is actually for ages 8 and up, but it's one of those things that I would definitely recommend. Of course, parental supervision, but if you know your child would like this and they're a little younger, parental supervision, but it's recommended for 8 and up. So fun toy, fun educational product. I would get that. So again, we have the that's all I'm showing today, but we had the now you want me to say pun board. Now I want to say pun board, Paul. So today I showed you the interactive fun board, digital learning activity pad, great for 3 and up. It teaches fine motor skills, alphabet, numbers, math, that kind of thing, drawing, tic-tac-toe, whatever, games on there, and you get to have Paul's voice in your house. Yes. So if you miss Explore Scientific, you just hit that, and then you'll have one of us right there talking to you. But your voice will always be forever on these. His voice will forever be on these. And then, of course, we had the 14 electronic science set. You can find those over in the carousel. On the Amazon carousel, you can find both of these in the Amazon carousel, along with all the other wonderful things that we have here at Explore Scientific. We have tons of stuff for kids. We have nature habitats, microscopes, binoculars, magnifying glasses, and if I would have been proper and used well, you would have retorted with good. That's a funny joke, Harold. So we, what else am I looking at? Oh, hey, Tariq. Howdy, y'all. I am watching from my smart TV, but I am commenting from my laptop. It's amazing how technology works like that. That's so cool that you can do that. You can stream it to your TV, and then comment on your laptop. So yeah, so if go check us out on the Amazon, in the Amazon carousel. Check out our store. We have stuff for older people as well, all the way up to, we had a gentleman come in the other day that was almost 100 and bought an eyepiece. So doesn't matter what your age is, you can always learn something new. I don't think I have anything else. What? Oh, Paul. Paul says there's music. Can anybody else hear music coming through the live stream? He hears it. I wish I could hear it. What kind of music is it, Paul?
It's that music that I used to put underneath everything.
Oh. So I have music going as well. All right, yeah. Oh, yeah. See, there's an Explore Hut. There's an Explore Hut that we have, too. Those are fun as well. Get the imagination going. My son always likes to come into the store and pick one whenever he has to be here with me, and he thinks they're absolutely amazing. We have, I think, cupcake truck. We have the rocket ship. We have a haunted house. We have a castle, a princess castle, a regular castle. This is just an adventure hut, I think is what it's called. Or clubhouse, I'm sorry, clubhouse, kids clubhouse. We have a plethora of these, and a great place for the kids to hide away. You could even, some of them are open, so you could even take them out at night and do some stargazing if you had a pair of binoculars or a little telescope for your kid. You also can turn them into a reading nook for them, or just a place to go and hide out and hang out and just feel cozy and comfy. So I think that's all I have for you guys today. Kent, I believe, no, Scott, it's coming on later today, and we have Global Star Party tonight. We would love to see you there, so if you want to check us out, make sure you do so. But otherwise, check out all of our stuff on the Amazon store, and we'll be seeing you tomorrow. Bye. Oh, wait, I have another message. I want that hut. Oh, so Charity Rose, make sure you go to the Amazon, our Amazon store, on Amazon.com. and look for Explore Scientific, and that'll be on there for you. Yeah, you can check out all those other huts too we have. I think that's it. Goodbye. Products. I tried to get Tyler Bowman to help me, but he's a little grumpy today, so he's not here. All right, so if you're out in the Amazon world, please give us a shout out. I want to know that you're out there. I want to see who's watching. I like to talk to you guys, and let me fix my TV real fast. And so anyways, so here at Explore Scientifics, we have quite a few things that are geared towards children and that a teenage age range. And so anyway, so I wanted to show you some fun things that we have for kids. So here we go. So the first thing I'm going to show you is our nature, water, and land habitat. This I really like. It has a magnifier on the top, which you can take off. So there's a magnifier on the top. So when you put whatever it is in there, you can see down in it and get a close-up view of whatever you have captured. Make sure that you release whatever you capture. Then this comes right off, as you can see. And there's air holes in there, so whatever it is that you have found and want to observe for a little while can still get oxygen. The great thing about this product is that it is a land and water habitat, so you can take it down to the creek, lake, river, whatever you want to, and scoop you up something out of the water and see what you can find. So there's obviously the bucket. Then it comes with this wonderful net. I think it would be fun to catch fish with this, to try to catch fish with this at the river or the creek or whatever. Maybe the ocean. Make sure you hold on to this. Do you think you could catch little things at the ocean? I don't know. I'm used to having somebody talk with me, but today I'm by myself. Anyways, so I have this, and then we have little tweezers to pick up things. Now, be careful when you're picking up insects. Some insects can be poisonous, so we always recommend that you make sure that you try to identify whatever it is you're picking up before you pick it up. One time I had one of the world's deadliest caterpillars on my front door when I went out the door, and it looked really cute and fuzzy, and then we tried to figure out what it was and went, oh, I guess we shouldn't touch that. So anyway, so make sure that you try to identify whatever it is that you're capturing. And I'm going to screw this back on here just for the fun of it. So you can carry that around. It has a wonderful handle. And then, of course, it comes with an additional magnifier. It has a magnifier here, and then it has a higher magnification right here in the bottom. Let's see if I can tell you. It says 2 times to 4 times magnification. Grumpy man has arrived. Anyways, 2 times to 4 times magnification, so you can get up close to those things that you want to observe. This would be great if, let's say, like I said, you found a caterpillar that you didn't know what it was. You could look at it this way, look at it with this, try to identify it, and then if you wanted to keep it or try to capture it and keep it for a little bit, then you can. I think we have a, don't we have a video on this, Paul? Oh, I'm sorry, my screen's not working. It's not working over here, so that's why, because it shows focus on astrophotography from August 19th, 2022. So anyway, so this is our nature, land, and water habitat. Oh, we got kicked. Oh, we're still on Facebook, so there we go. Okay, so this is our nature, land, and water habitat. Here we go, and we are back on Amazon Live. So this is our nature, land, and water habitat. It's a great little thing to keep around, to take your kiddos outside and to explore and find things. This is for ages 6 and up, but obviously if you are if you have parent supervision, then you can also do a little younger. So.
Other people need supervision around here.
Yes, a lot of other people need supervision around here. It's fun. We like to be silly around here. Okay. Second, now that I'm done with that, let me move this. No, don't worry about that. I'm getting out the metal detector. And then I'm going to find some still-headed person. Okay, so so anyways, this is our Explorer 1 metal detector. It will, oh, can you hear it?
Will it detect metal?
Yeah, that's detecting the rebarb.
The what barb?
Rebarb.
Rebarb.
Rebarb. I want to call it barb. Rebar. It's, yeah. They all know you're here now. So this is Tyler, my grumpy assistant.
Who can't even fit the screen.
He can't fit in the screen.
It's because you're short and I'm tall.
You're short and I'm tall?
You're short.
You're short and I'm tall. This is our Explorer Hut camp. This is our Explorer.
Couldn't see me, could you?
You were camouflaged.
It was camouflaged.
Camouflaged. So this is our, Tyler came in our Explorer Hut, camo Explorer Hut. These are really great for kiddos. We had a little girl come in yesterday.
Day before yesterday.
Was it? No, today is Tuesday.
Oh.
So it was, yeah, it was yesterday. It was yesterday, and she was climbing all through our Explorer Huts.
I have to. It's detecting your eyelids on your shoe.
Okay, anyways, squirrel. Anyway, so we have these Explorer Huts in quite a few different things. We have a haunted house.
Got a cupcake.
A cupcake truck.
Girls cupcake. People can't see your face.
I don't want people to see my face. See, they can see. No, they can see.
School bus.
They can see my face like this.
They have a school bus.
A school bus.
We have a rocket ship. We actually have a rocket ship as well. And Paul's got a wonderful video loaded.
Yeah, look. So we have lots of fun. Now he's leaving now. So he was bringing in my Explorer Hut. He was actually crawling around on the floor in my Explorer Hut. But you can see we have a rocket ship, we have a castle, we have a princess castle, we have a haunted house, we have a skid steer, we have a camo tent, we have I'm trying to think of everything. A bus, a cupcake truck. There's so many options. So if you go over to our Amazon page, you can see all those Explorer Huts on there and pick you out one for a kiddo. They're really cool because great reading nooks or just imagination. You can just spend some time just having fun. Kiddos can, it makes their imagination grow. We also have some that have the top is open on them, and so if you want to take it out at night and maybe do some stargazing, you can do that as well. Just a nice little nook for them to be able to do that kind of stuff and see the stars at night without any extra light coming through. So, but yeah, we had a little girl come in and she absolutely loved this, in and out through it. She was she had to be between 2 and 3 years old. And so this is for ages 3 and up. Great thing to have around. My son, every time he comes here, he tries to pick one out, or he does actually pick one out. And so we put him in a cubicle with it, and he has a fun time in there. So we put toys and stuff in there for him, and he enjoys that. So yeah, that's our Explorer Hut, our camo Explorer Hut that you can see. That's why I couldn't see Tyler, because it was camouflaged. Or he was just out of frame. So yeah. So anyways, back to our metal detector. This is our Explorer 1 metal detector. It detects precious metals, obviously, down to 6 inches below the surface. Oh, you have me on the floor? See, it keeps going the rebarb. I know. Paul doesn't like me saying that. Okay, so yeah, so there's metal in the concrete, obviously, and then it detected the eyelets on my shoes. We've in the past had some coins down. It'll detect that as well. It has a bright LED light right here that you can turn on, and you'll be able to see at night if it's getting a little bit dusk. It can also, I believe, it has a water resistant coil, which means that this portion can go into a puddle, but you can't submerge the whole thing in water. So if you want to go down to the creek or the lakeside or whatever and do some metal detecting with it, then you can. So, so yeah, that's and the little flashlight comes off. So you can have that to do things with as well. And I think I'll do one more thing since I've done those 3 things. And that was really fast because Tyler brought that Explore hut in. Okay, so now we've got we did the nature habitat, which is a great thing to go out and just explore during the daytime. Then we have that the Explorer hut, camo hut that I showed. Obviously can fit Tyler in it, kind of, sort of. And then we have a metal detector. And the clubhouse. You know, and then the cupcake truck. You know, it's really cool because the castles are pretty big. I don't think you have a video of those, but we have the Princess Castle and the regular castle. They're really big. So if you have a child that's a little taller or a little bigger and wants to have fun in that, then you can. These ones pretty much fit. I think my son's 5. He comes up to about here on me, and he usually fits in all of these tents. So they're pretty good. They're pretty good size and roomy and comfortable for them to hang out in and do fun stuff in. So I know, I'm sorry, I forget. No stripes. Okay, this is our National Geographic. What size is this? I forget. Oh, here, let me get the box. 50 millimeter. It's our 50 millimeter tabletop Azimuth mount telescope. So this is a great, like I was saying, the Explore huts. Sorry about that, guys. Like I was saying, some of the Explore huts have open. The tops of them are open. We actually have a 2-room observatory tent here for adults that you can put your telescope in. The same thing is the same concept with an Explore hut. You could do the same concept with the child, put a telescope in there and do some stargazing at night with them. This is a really small, compact telescope that's easy for little hands to carry around. This is for ages 6 and up. So it's a great starter telescope to be able to sit on a table, sit on the ground, then be at their height, and then be able to look through it. It comes with a 12.5 millimeter eyepiece, and then it also comes with a 20 millimeter eyepiece. So whenever you're doing a telescope, you want to make sure that you start with the highest magnification, the lowest magnification eyepiece, which is going to be that 20 millimeter eyepiece. You will put that in there, and then you'll point it wherever you want it to go. And like I said, this is an azimuth adjuster telescope, so so you unscrew this and the locking lever, and it'll go left and right. And then you'll unscrew this locking lever, and it'll go up and down. So it's really easy to use, really lightweight and really compact. So you can take that wherever you want to. Start off with that lower magnification eyepiece, larger number, lower magnification. I know that's backwards, but that's the way it works. You'll put that eyepiece in, point it where you need it to, moon, whatever, and then you'll just slowly work that in and out and get it into focus. It has a little lens cap, so you can take that off. And it has the dew shield doesn't move, but it has a dew shield to help keep that dew off your lens cell. So it's easy to just fold up and take with you. You can also, I think this little guy comes out, but I'm not quite for sure how. I have not messed with this. This is the first time I've messed with it. No, it actually is attached straight to it, so you don't ever lose your telescope. That's nice. So it all comes together. So if if you have a little one that's messing with it, it's playing around with it, then you don't have to worry about pieces getting lost or your telescope being in one spot and the tripod being in another. So they're really good, lightweight. I want to get that for my son. No, I want to get that for my son now. Okay, so you can obviously do, so refractors are great because you can do terrestrial viewing and land, and oh my gosh, my brain. You can do sky viewing, and you can look at animals as well. So this telescope will allow you to look at birds, you know, stuff in the woods. Just if you've got a back deck and you've got some woods behind you and you're just wanting to see what's out there, this will be a good little telescope to have around. It's 50 millimeter aperture. The focal length on it, let's see, I'm going to tell you, is 360 millimeters, which is a really good focal length to have. The other nice thing too is we have them. We have Barlows, 2x Barlows that you could plop on there, and that'll increase that magnification on your eyepiece, so you can see things a little bit up closer. Let's see, it's an 18 by 28, 8x magnification, so it's got that good magnification for you to be able to see things up close and personal, and you can even see the moon with it, which is always a big hit with little ones. So between this, you know, if I was going to get a package set for my kid, I would definitely do an Explore Hut with a telescope, or an Explore Hut with a pair of binoculars, and that's gonna really increase their exploration in our world. And so you would have you can take them out, spend some time with them, just kind of listening to what they're hearing and looking, and what a great time to just sit and be in the moment with them and have fun and do some exploring and having some adventure. And you can do that from your own backyard. You don't have to go far off, you know, miles away. You can do that from your own backyard with them, and so that would be a fun thing to have. Now, the nature habitat, you could, if you have a vegetable garden or just your backyard, wherever trees and shrubberies and stuff, finding animals, insects to put in there, or like frogs and stuff like that, you can keep those around as well. So I think right now here in Northwest Arkansas, I was seeing that silkworms are a big thing. So we actually had somebody post on a Facebook page, hey, if y'all want some caterpillars, come get them. So you can also keep caterpillars in that nature habitat as well. And I don't know what else to talk about.
You have other products back there?
I do have other products back here.
Magnifying glass?
I don't have a magnifying glass. Because I don't have, I have this. We haven't talked about this in a while. I'm just talking too fast today. I'm like Speedy Gonzales. Paul's not liking my jokes. This is our Galileo Scope. It's a DIY project. It is a great product to have to teach a child about how a telescope works. It comes with the lenses. You literally build it from the ground up. So I'm going to do that today. I don't think we've had this. I don't think we've shown this in a while. So it has its, yes, I know. It has its OTA. Here's the OTA on it. I'm going to set this off to the side. And this is a true telescope. It really does work. But you just have to put it together. So the first thing we're going to do is we're going to get the lenses out. So when you're getting your lenses out to put them in, you want to make sure that they are in here correctly. One side will be concaved and one side will be curved. So we want to make sure that we put that in the appropriate way. So you can just fill on those with it, and always use tissue paper when touching your lenses. So we're going to put that there, and then we're going to put this here. And then we are going to I need the rings to hold it together. A G-scope. G-scope. So these little rings will hold this together. There's a ridge right here, so you'll just slide this on. Put it right here. Great. It's over in that carousel if y'all want to check that out. It looks like I'm missing a larger ring for some reason. Oh, wait, I didn't get it out. But wait, there's more. The one thing I did not put in here is the nut for the tripod, so that's the only thing that I forgot to put in. On the bottom down here, there's a place for you to be able to mount it onto a tripod. So you can have a little, so you're not having to hold it the whole time looking, which can get a little tiresome after a while. Okay, so now I've got those on there. The next thing I want to do is I want to build our draw tube. So, and Kent took out the instructions, so I have to try to wing it a little over here. Sorry, Charlie. So here's a draw tube. So we're going to take another ring, and we're going to stick it here. Looks like we left the eyepieces together. That's great. So we don't have to try. I don't have to try to put those together. This will slide right in. This will go here. Wait, I might be wrong. Hang on. This goes in first, maybe. I'm trying to get it in there. Sorry. I think I have it in backwards, though. I feel like I've got something. Lucy and I have done this a million times, and I guess I'm just forgetting.
I think it goes on the other end.
You think it goes on the other end? No, because that's where the lens is at. This is the draw tube.
What are you doing?
I'm putting it in here.
Break it.
I'm not going to break it.
Let's see.
It goes right here.
Well, what'd you need my help for?
You asked what I was doing. I'm trying to tell you what I'm doing. Okay, so here's the draw tube, finally. I just had to get it down in there. So there's our draw tube. Let's slide it out. Hang on. Let me slide it out. I'm going to slide this little sucker down here. I should have put that on first. That's what I was supposed to do. But we will improvise. All right, so there's our draw tube. So once you get it all together, you can put your dew shield on. You have a dew shield. You have a place for a tripod. It comes with a Barlow and an eyepiece. So you just slide that eyepiece in there. You slide that eyepiece in there, and then you'll be able to get that into focus by pulling that draw tube in and out. And then, of course, it comes with a Barlow, which is not put together, so I'm sure I got lenses somewhere around here. But it's really cool because the lenses, they come in little pieces, so you can... I don't fill them in here. So you can, the instructions will tell you how to put them together, concaved and flat, concaved and curved. And so you'll put those lenses together. You'll put a set in the front, a set in the middle, and then you'll be able to use that eyepiece. This is one of our Explore Alliance ambassadors right now, showing you how to put it together. Those are the lenses that you can see. Her name is Libby in the stars, and she is an amazing astronomer, and so she came in and did that for us, recorded that for us, and did a great job, and goes into more detail and depth on that. If you want to see more detail and in depth on that, I think you can find it maybe on our YouTube channel. I'm not for sure, but yeah. So that's what I have for you guys today, and I hope that it was good. I hope you enjoyed it. Paul G. Newton says, hello. Hello, Paul. And Noah Menard says, hi, Annie. At least I got two people out there. I'm sorry that I'm not Kent. I heard you guys love Kent, but Kent likes to Kent takes a break sometimes. He wears a lot of hats here at Explore Scientific, and so on Tuesdays we like to try to give him a break and do some more do educational stuff for the younger group out there. So if you're a parent that has a little one that would like to look at our STEM products and see what we have, you can go on over to our Amazon webpage, Amazon page, and see all of the things, all the wonderful things we have. And it's growing. We have electronic kit sets. We have the Explore huts. We have, in fact, I think we just put out a Mike Overacker. Thank you. Hi, Mike. I'm glad you're out there with me. We just put out a what is that light? That light. What is it called? No, not an adventure scope. What is that light thing that I had the other day? We have a thing that projects nebulas and stars. So it is a cone on one side, and it'll rotate this. It's a projector, not for at night, and it'll rotate the stars through on the ceiling. And it is a fun thing to have. We've been playing with it in the store. We're going to try to get it set up so people can actually see it and how it works. I have one at my house for my son that's kind of like that, and he loves it every night. He's like, "Mom, turn on the stars," and so he really likes to watch the stars and the galaxies go by. So if you have somebody that, like a little one, or somebody that likes night lights and needs something to kind of keep them feel, cozy and safe, that would be a great little thing to have around. So, all right, guys, I think that's all I have for you today. I'm going to make sure that I have somebody with me next time. Hopefully, we're kind of sparse and in between, but if you see something you like on here, please make sure that you go over to the Amazon carousel and check that out. Mike is saying, "I just came in from outside. I just finished the final program to make my ES 20-inch Dobsonian to a full go-to and tracking scope. It is working great." That's so exciting, Mike. I can't wait to see video and stuff of it going. That's awesome. That is awesome. I'll have to tell Tyler and everybody that you did that. So, all right, guys. Well, tomorrow we won't have any more shows today. Scott is somewhere else. And then tomorrow Kent will be back with First Light Chronicles. And then Thursday is Explore Alliance Minutes. And then Friday is Focus on Astrophotography. So we'll see you again on Amazon Live. See y'all later. Bye.
It'll stand up like it is right now, or you can close the leg and use, again, these two screw holes right here. You can mount these on a wall somewhere. Real easy to do. You would simply put in two screws, the measured distance apart, get them level, and screw them in until it snaps down in. You have to force it a little bit. That will keep this on the wall and make it good and sturdy. This is the large weather station, large display weather station from Explore Scientific. It is over in the carousel right now. It'll pop up here as the featured product in just a minute. This is the large display weather station. Yes, Annie.
Hang on, I was going to tell you something.
Got a question?
Never mind, changed it.
Tabby Tux, hello. Does the one with the large display have a backlight? Yes, it does. You can't see it here, and it's a touch display. It doesn't say it all the time, but it does have it. Thank you for that question, Tabby Tux. That's a great question. It also has a snooze function for the alarm, and the alarms work well every morning for a period of time. We could not find what was beeping because it would go off in here, and you know how you can't find a sound. And finally we determined it was a clock that was hidden behind a box. It took us a long time to find that alarm clock. So it's a nice, gentle, subtle backlight. It's not going to blind you in the middle of the night when you turn it on. It's not like hitting a spotlight or anything. So here on Amazon Live right now, if you're watching and haven't followed us before, we would appreciate it if you click that follow button. Also, as Tabby Tux figured out, there is a chat function. We love when people ask us questions about what we're talking about, because I can't think of everything, and by asking questions, I'm able to add that to my repertoire in future broadcasts, and I appreciate it very much. This is the large display weather station with indoor and outdoor temperature. Go over it one more time. It has atomic clock function, so it sucks in the time out of the radio waves that come in. Like in here, it's we're in the middle of a very large metal building. Might have to move to a window or towards a door and let it find it, and then it'll pick it up, and then it'll be okay after that.
I remember my question now.
Yes, Andy, your question. She remembered it.
Can you plug it into the wall at all, or is it just battery operated?
have to look on this one. This is just battery operated. There is no adapter with this one. That's a good question. The next one I'm getting ready to show you, you can plug into AC outlet and power it without batteries. Look on here and make sure. Yes, there is no power port on here. It's simply runs off 2 AA batteries. And again, it's been 4 or 5 months since I've done weather and time products. So this has been going for easily 4 or 5 months. And the station is working just great. The weather sensor on this one, I haven't put batteries in it. I noticed it right before we started, and I didn't bother to put batteries in it because, you know, don't need it really. So the question is, how do you know? How do you know what's going on with the weather? Weather stations like this is a great way. Weather affects our lives in many ways. For instance, you know, as school gets going, you want to know what's going to be going on with your kids. Yes, we all have smart devices we can look at, but you also want to know what it is exactly where you live. And this is a fine way to keep that monitored, as well as monitor a number of other rooms in your house or the outdoor temperature as well. This is the Explore Scientific large display weather station and clock. Has dual snooze, a host of functions right here. So, we have another question. Tabby Tux, can you show the light function? Tabby, I can't because it's just, it's so bright in here, the studio lights just don't, I mean, I can barely see it here. No, that's going to throw the cameras in a disarray. Yeah.
But that's a nice function, right? Because you don't want it to just blast your eyes
it's
in the middle of the night.
Exactly. It's not so bright in the middle of the night you're going to hit it and blast your eyes. Because last thing you want to do is blast your eyes with a whole bunch of bright white light, because then it's going to wake you up, and that's not what the goal is. So, Tabby, I'm sorry I can't show that to you. It's just, there's just too many studio lights. Hey, there's a message I can't read that's got some stuff in front of it. Noah, could you come over and...
Yeah, because do any of the ones you have on have a weather alert function?
None of these do. These are not the weather alert radios like if there's a tornado watch or warning issued for your area. It does not have that kind of alert. That is a great question as well.
But we do have one that does that.
None of these that I'm showing today do. We do have one though.
Yeah, we do, but it's not any one of the ones you're showing today. But it might be on Amazon.
It's on Amazon. What? Go ahead and put it.
I think it's the 7-in-1.
That's a big weather station.
It's the 5-in-1 and the 7-in-1 . I think both do
You
that.
can go ahead and put those over there. I mean, they'll show up. They're really big. They're full-blown weather stations. Yeah, put them in the carousel. So we're going to put those in the carousel there for you, Tabby. These are. They have a large unit that mounts outside. I did not bring one. I'll do one next Monday for you. So come back next Monday, and I will show you the 5-in-1 weather station and the 7-in-1. These are big, robust weather stations that offer a host of information, including the 7-in-1 has UV index indicator for current UV levels, a UV level predictor, all sorts of stuff on that big weather station. And again, I will do that next Monday because we have a whole bunch of weather and time products we want to talk about. So this is the color weather station. I actually have one of these and use it in my travel trailer when I go camping. It's really nice to know when you're out at a state park and you know it's going to get cold because the forecast has been to get cold, and you're snug as a bug inside, and you find out by looking at the weather station that it's a whopping 17 degrees outside, and you're just snug as a bug inside your camper, and makes it awful nice as well. So this is the color weather station with multiple sensors. This comes with 2 colors, either black or white. I have the black version, and it has 3 sensors. So the sensor here that's built in, and then 3 additional remote sensors. So I have, when I'm camping, I put a sensor under the sink, so I'm sure of what the temperature is there, because you know you don't want it to freeze up in there. You want to take steps before that ever happens. And then I put the other sensor outside, and I don't use the 3rd sensor. I keep it as a backup. So great. I've really enjoyed using it. It's nice and well lit. The colors make it easy to see. As you can see, it's got this one has a plastic cover on it showing them. But as you can see, it's got a forecast right here, partly cloudy and sunny. And it's got a cute little flower on it right there that shows up. Time, date, indoor, outdoor temperature, sensor temperatures, outdoor 1, outdoor 2, outdoor 3, indoors. Very nice design, very nice to use. A lot of information right there at your fingertips.
Pull it back just a little bit.
Tabby says, lost the signal. I'm not seeing myself on the monitor now.
The internet's spotty again.
We have, is it live?
Yes.
Over there, Noah?
Yeah, I'm seeing you live.
So, all right, we're still going apparently. We've been having spotty internet trouble here periodically, and last Friday was chaos. Not chaos, just uncontrolled chaos. Mayhem, I don't know. It was frustrating. We had a couple starts and false starts and stops and everything else. So,
will you pull it back just a little bit because we can't see it? It's got a reflection. Oh, there you go. That's perfect. Thank you.
There you go. Okay, thank you. So I can't tell where the reflections are going to hit. It's just angles and lights and everything else. So this is the Explore Scientific weather station. It has the slogan, Explore Better Living. And this way you can tell what's going on temperature-wise and has a forecast as well. It's based on the barometric pressure that's going on. So if the barometric pressure is going up, you know it's going to be partly cloudy. If it gets high enough, you know it's going to be clear, and that's how it does that. So those weather stations should be popping up in the carousel at some point fairly quickly, Tabby, so you can take a look at them directly. We can't refresh our browser because if we do that, it shuts down the whole switch in studio. So we're just along for the ride until we actually lose signal, and then we'll reboot some stuff.
There's a question.
Yes.
On another platform that says, can you program the names of the sensors?
They're already programmed, outdoor 1, outdoor 2, outdoor 3. Okay. So if you put outdoor 1 in your kid's bedroom, you're just going to have to remember that outdoor 1 is outdoor 1, right? Is really kid's bedroom, and outdoor 2 is the kitchen, and outdoor 3's the outdoors, or your garage, or whatever you need to put it in to control the temperature. My dad had a wine cellar where he made wine, and he had a thermometer in there, and he was always going in and checking it just to see what the temperature was, especially if it got warm in the fall. And he would have loved to have had one of these, so he didn't have to go down in the cellar. But it was always good to go down in the cellar and watch the grape juice bubble away, working its magic. The yeast working its magic. All right, so what else? Did I miss anything? Let me see if I missed anything. 3 sensors, low battery monitor sensors, backlight, 3 outdoor sensors. Yes, this one runs off of AC power. It has a 5-volt DC adapter, and it draws 150 milliamps to keep it running. So very, you could, if you have it inside, you can plug it into the wall adapter and have it run off the AC power. And I'd say keep batteries in there so the power goes out, you still know what the temperatures are.
Yeah, so one of the things that we found in our weather stations is that if they come with a wall adapter, it's recommended that you keep them plugged in, because sometimes the battery is actually only equipped for if the power goes out. And so,
do you have a microphone over there?
Yes, I'm talking in a microphone.
Okay, all right. I didn't know if you did or not. I can see this much of Annie.
I'm small. I'm sorry. I'm short.
And she's over there in the dark, and I can just sort of see her top of her head moving. So
yes, that's one of the things we learned. So we usually recommend that you do keep it plugged in, so that way that battery lasts and you don't have an oops whenever the power goes out.
Absolutely. That way you can keep the time and temperature. Last night the power went out in my house. I found out because I use a CPAP, and it went off, and I took it off and said, "Dadgummit, what's going on?" Finally, I realized that it was off, and the power was off for about 5 minutes, came back on. So thank goodness, because I would have snored my way through the night, and that wouldn't have been pleasurable for me or my wife. So the cats may not have cared, but my wife would have cared. Anyway, we have a whole bunch of other weather and time products here on Amazon. You can go over to the Explore Scientific store on Amazon Live and check out our weather and time products. There's a whole host of products. I think we have like 32 or 36 different products. We'll be working through those for the next couple of weeks and showing you some differences in those. So let's see.
So I have a question.
Yes.
Can you put the sensors out in direct weather, or do they need to be covered up?
I would not put them out in direct weather. I'm going to say don't do it. I don't know what the directions say, but when you're getting temperature, you don't want it to be in direct sunlight. You want it to be where it's measuring the air temperature, not sun pounding on it. So it needs to be, under the eave of the house or on your patio or something like that. If you ever look at official weather station sensors for the National Weather Service or NOAA, they're generally housed in a white box that has the air can blow through it. It's 4 or 5 feet off the ground, and they're always painted white. Why? Because white doesn't absorb the temperatures from the sun nearly as much as the others. But I would say do not put these sensors out in the weather. Now, when you get the 5-in-1 or the 7-in-1 weather forecasting station, that has rainfall, has a rain gauge on it, has a wind speed, has an anemometer, wind speed indicator. It also has a direction indicator, so that actually does go out in the weather and is perfectly fine to set out, mounted on a pole on the eave of your house or in your backyard somewhere. So yes, those are made to go outdoors, but I'm going to say these are not. I could look them up real quick, but that would be boring watching me read until I found it. But my instincts tell me, and I think my instincts are about 100% right, don't put these out where they're going to get exposed to lots of rain, right? And that's the enemy of electronics is rain.
Now, do any of these smaller ones do barometric pressure, or do you have to have or is it only our bigger ones?
The bigger ones display it. The forecast comes because of barometric pressure, but this one does not display barometric pressure. I'm going to make sure that's correct. Yes, it does not. But it does have a forecast function on it. Oh, it does have barometric pressure. It just doesn't show you what it is. It shows you whether, no, that's not barometric pressure. It shows you whether the temperature is rising or falling.
Oh, that's cool.
But it does not, I do not believe it has barometric pressure displayed. It's always nice to see what the barometric pressure is. And that's one thing that unless you have dig into some of the smartphone apps, it's not readily available many times. So conversations, questions, if you're out there, we would love to have a question, a shout out, or give us a follow if you like what you're seeing.
One Mon says hello.
Who does?
One Mon.
One Mon says hello. Hello back to you. Thank you for giving us a shout out. We're always eager to hear from the people who tune in, and we thank you for that. It is a gift of your time to us, and we truly appreciate that very, very much. Thank you for it. So I'm going to cycle back, and we're going to spend the next couple of minutes talking about the first item we went to here on the show, and that first item is the wireless rain gauge with outdoor temperature. All right, so this is a rain gauge right here from Explore Scientific. It's part of our Time and Weather series. It comes with the rain gauge and an indoor monitoring system. It has a thermometer in it as well. I'm always fascinated. It was years before I understood how a rain gauge worked. Had some ideas, but the rain goes through a very known size of area, and it drips into through that little hole, and the rain goes into this little rocker right here. It's like a seesaw, and when this side fills up with 1/10 of an inch, it flips over. And it just, every time it flips over, it adds 1/10 of an inch of rain to the rain. And then after a certain period of time, it resets itself. This is the wireless rain gauge with temperature from Explore Scientific Weather line. It is a fantastic line. They're nice, beautiful, white, elegant, well-designed pieces. that provides you with a host of information at your fingertips about right there in your backyard. They're over there in the carousel right now. Did the 7-in-1 and 5-in-1 pop up? I can't see the whole carousel.
I'll put the 5-in-1 and I can put the 7-in-1.
That's okay. The 5-in-1's there, so you can take a look at it. The 7-in-1 is a little more expensive, but it's much more powerful in what it does as well. There we go. There's the 5-in-1 showed up right there. The 7-in-1 is the one that has the UV indicator and a couple other things that the 5-in-1 does not.
So I have a question real fast about this. If it's like a downpour, will it immediately read however much water is in there, or does it take time, like a little trickle?
No, it'll as that 1/10 of an inch thing fills up, it'll go click, 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 click.
Okay.
And what does it do with the water? It literally just dumps it out the bottom. It literally just, when it goes in, it flows out right here, right? So the rain goes in and then it just flows out right here, right there on each side. So it just dumps the water out and resets. And
almost like a strainer.
Almost like a what?
A strainer.
Yeah, almost like a strainer. And it just, water goes through it. Now, obviously, if a leaf or something gets in this, and you want to set these away from trees where they're going to get a bunch of leaves and stuff in it. A leaf obviously could plug the hole and it'll fill up and not give you an accurate gauge. But if it's raining so hard it can't keep up, it's whether it rains 6 or 7 inches probably is not going to matter too much at that point. So, any other questions over there, Annie, coming in from?
No, I don't have any questions.
Sandy says, stuttering and chopping video for me. Yes, Sandy, we're sorry about that. We've been having trouble with our internet here. It tends to happen in the afternoons, which is when the broadcasts come on. We've been working on it and trying to find a solution. We had been using wireless. We've gone to a wired connection, and that's helped a little bit, but not much. But thank you for letting us know, Sandy. We appreciate that feedback. It gives us more ammunition to go and say, hey, we're getting comments from the viewers, and we need to get this fixed so they have a good experience with Explore Scientific and our products. And it's 3:30, so it's time to wrap up our show. Thank you for spending some time with us today here on Amazon Live. You can click over there on the carousel for the next couple of seconds and make a purchase and find out what's going on in the weather specifically in your house and around your house. For the staff here at Explore Scientific, including Annie, who's setting in and doing the director duties in the absence of Paul, who is on vacation. I don't know who approved it, but golly, but it's a good reason for Annie to learn new skills. And Noah Menard over in the Marketplace Brain Center. Noah waves hi like that today instead of waving over his shoulder. So we appreciate what Noah does, and he gets everything up and current on the marketplaces, and that makes a huge difference in your ability to make accurate, well-informed purchases. So, again, on behalf of everybody here at Explore Scientific, thanks for watching. We'll be back on Tuesday with Fun Day Tuesday. Annie and Lucy will be up here showing some of our fun toys and kid-oriented STEM gear. It's going to be a great show. Wednesday, I've got First Light Chronicles. Thursday, On the Wing, a birding show. And Friday, Focus on astrophotography. It's going to be a full week. I hope you're having a pleasant Monday. And some places, it's already Tuesday, so I hope your Tuesday is off to a good start. Thanks for watching. See you tomorrow at 3 o'clock. Bye-bye, everybody.
Are you having a hard time trying to figure out what telescope to get? Don't worry, guys. Tyler here with Explore Scientific is going to help you figuring out what you're wanting to do, either astrophotography or visual. I always tell customers that telescopes it's kind of like golfing, it's carpentry, it's a hobby that you have to learn specific tools in what they do, because these are tools. I consider them as tools, and they have a specific purpose in what you're wanting to do, either visually or astrophotography. First, we're going to talk about this little beauty, the Maxudo of Cassegrain. Great for planets, so if you are wanting nothing but planets, this bad boy is the way to go. If you're wanting some deep sky objects and some planetary, the reflector right here from Explorer First Light is also the way to go. But if you just want deep sky objects, if you want wide field of view, a refractor is the way to go. These are just a couple of basics here at the Explorer First Light series. The Maxudo of Cassegrain, the Newtonian, and the refractor. All of these scopes come with a red dot finder, a smartphone adapter to get you started in astrophotography, as well as an eyepiece, and whichever mount that you want to choose with the combination of telescope you want. If you need help out there on Amazon, don't be afraid to reach out through the live chat. We'll make sure that we get back with you as soon as we can here at Explore Scientific.
It turned you off. Go.
Okay, I think the audio is back on now. Is that correct? Poor Annie, who is a customer service person, not a videography studio technician, is covering for Paul, who deserves a couple of days off. And she's done it for a couple of weeks, but doing it with no help at all is always a learning experience, and she's doing a great job of learning. So,
Well, thank you very much.
oh, well, we'll find Monday if it goes well, because Paul won't be here Monday either. So your test is Monday as well. So young Connor took this picture we're getting ready to show you, and Annie will tell me when she has it ready. And so, and we've now gone to about the lead graphic again. So Connor uses a computer to control this, probably.
Thank you for watching our 24-hour-a-day live stream here at Explore Scientific, where we show you all the programs that we run live in front of a live audience. Programs like Global Star Party, On the Wing for birders, First Light Chronicles for beginners, and Focus on Astrophotography for astrophotographers. We bring in astronomers and explorers from around the world to answer your questions live. But there's so much cool information there that we decide to package it all together and run it 24 hours a day. We're also on Amazon Live, where we do deep dives into our products and our gear. There's so much important information as we share the education, the experience, answering questions from the audience, that kind of thing. So tune in, and thanks for watching.
Hi everybody, Kent Martz with Explore Scientific at the Nebraska Star Party. Sun's going down, want to get ready for a beautiful night. There's some clouds, but we're going to take advantage of whatever open holes we have. I have Richard, it's Carroll, right?
You did well.
Richard Carroll, who won an Explore Scientific reflex sight a couple of days ago, right?
Yeah.
And you took it out of the box, and tell me the story about it.
Well, I gave a telescope to my granddaughter, and I wanted to get rid of the red light, the red dot finder, and so I was hoping when we were doing these that I'd win one of those.
And you did.
And I did. And I took it out and looked at it, and I says, oh, I want to put that on my telescope. Well, the one I just bought.
Well, yeah. So what he came up to me and said, do you have one? I said, yeah, I brought a couple. I can, I'm not going to be using it, so I can sell it to you. And he said, this is my second one. I went, huh? He says, oh yeah, I won one. And he was telling me the story. And I'm like, he liked it so much that you bought one, right?
That's right.
So you bought it for a 50% discount. It's what the reality is, because you.
Well, yeah.
Yeah. So, but what did you like about it?
I like the ergonomics of it.
Okay. Well, the smooth curves. And
oh
stuff?
yes, and also it's light. And I like the mount.
So it'll go on a mini Vixen dovetail. So Explore Scientific telescopes used to come with a sort of like an upside down T-foot for their finders, and it was the Explore Scientific / Mead foot, and so you had to have, if you bought that, you couldn't use your finder scope, and so we could have kept doing that, right, and made people buy our finder scopes. But we felt like the right thing to do was come up with that hybrid 2-in-1 foot. So now all of our telescopes come with a foot, so you can either put on a mini Vixen dovetail or an Explore Scientific foot. So it's really changeable. And you're going to be doing the same thing with a cup on your telescope, right?
Yeah, I have a finder scope that uses that kind of foot, and so I can just change them back and forth when I want to. Yes,
That's
it
awesome.
is.
That's awesome.
Yeah.
So anyway, sun's going down. I got to get set up here real
right.
quick, because I don't want to be stumbling around in the dark. I'm going to be carrying the 120 millimeter giant binoculars. So 660 focal length, 120 millimeter. Yeah, come up and look at them here after a while. All right. Hey, Kent Marshall from Explore Scientific. Thanks, Richard, for coming and sharing our story with everybody.
Thank you very much.
I appreciate you very much.
Thank you very much.
Thank you, sir.
Bye
Bye-bye.
now.
Bye, everybody.
No, there we go.
Hey guys, Annie here with Explore Scientific. Gotta pause. I forgot who I was for a minute. Life is a little crazy. Kent is not here today. He had to go take care of his kitty cats. So that's where he's at today. So I hear that he has a fan base out there. So I just want to make sure that you understand where he's at and why he's not here today. So anyways, today's show is called First Light Chronicles. We try to go by our afternoon shows when it comes to titles and stuff here. So we're just going to talk a little bit about telescopes and the IXOS 100 and a few other things. So the first thing I want to show, obviously, is this beautiful IXOS 100 and 80 millimeter 640 refractor telescope. This is our First Light series. Really great starter package out there for, to get you up and running if you're wanting a tracking mount or or an easy little telescope to start off with. So what'd you say? I can do it. So let's first talk about the telescope. This is an 80 millimeter refractor. It's very lightweight, and this all comes in a package. This is, let's see here, I was going to turn it. Let's see if I can turn I'm trying to find the clutch. Hang on just a second. Clutch on the IXOS 100. So as you can see, it comes with an eyepiece and of course a diagonal. It usually has a red dot finder on here. I don't currently have it on there because things like to have legs and walk away around here. But anyways, it'll come with a little red dot finder. It, like I said, is lightweight. It should have a handle on it. I don't see one on there right now. I think it's because the telescope's turned sideways. But so it has everything you need to mount it to the mount or any other mount that you want to put it on. I'm not quite for sure the weight on it, but it obviously is good for the IXOS 100, which actually has a seeing rate, visual weight capacity of about 15 pounds. And then if you're doing astrophotography, it's about 9 pounds. So today, obviously, we're just doing viewing. So deep breaths. Paul's trying to calm me down. So, okay, so thank you, Paul. So today I'm going to show you this little eyepiece. So we've got it comes with the 26 millimeter eyepiece, which is great. It's a great starter little eyepiece. 26 millimeters is the magnification. Not really. I think it's probably about 52 degrees in circumference, but 26 millimeters is like middle of the road for magnification, so it's a great place to start off if you're a beginner. You don't want to get something that's too high in magnification because it's harder to see, especially if you have any type of atmospheric disturbances. You could take it out at night and then stuff looks kind of fuzzy. So we always recommend starting off with that 26 millimeter eyepiece to get you up and going. You would take the telescope out and you would line.
Also, too, though.
Yes.
It's one thing you probably want to purchase along with your telescope when you're getting the First Light models, or really any of them, is to purchase a 52 degree eyepiece that's
Yes.
either a 15 or a 10?
Yeah.
Because once you get lined up with your 25,
Yeah.
you're going to want to punch in and see.
Yeah. Yeah.
But you don't want to go to a 6 or a 4 because your seeing can get in the way at that point.
Yeah. So so each telescope has a high magnification on it, has a highest useful magnification on it. And like Paul was saying, if you get too high in your magnification, which is a lower number, you're going to have a little bit more difficult of a time to actually see things clearly. And it is a lot more difficult to get locked on to stuff as well. So we usually, like I said, we usually recommend starting off with that 26 millimeter, getting used to that, and then changing it over to like what Paul suggested, a 15 or maybe even a 10, somewhere around there, to kind of increase that magnification. But we, like I said, always start off with that highest number because it's the lowest magnification on a telescope. So what you'll do, like I said, you'll put the eyepiece in the diagonal. You'll then take it out during the day and get it pointed at something. And once you get it pointed at something, you're gonna look, of course, you're gonna be looking through the eyepiece to get it pointed there. It needs to be at least a mile away because further is better. And so once you get it a mile away, you'll and get it pointed at what you're looking at, kind of get it into focus. Then you'll go to the red dot finder that's on it, that's located on it. You'll look through the red dot. The red dot has adjustments on it. So you'll point, you'll start adjusting that red dot to get it into view of what you're seeing in the telescope, and you'll continue working back and forth between the telescope and the red dot until they're both in line, and you're not having to do any more adjustments. So this is a really great beginner scope. It is not equipped for astrophotography, but you can get a cell phone adapter to put on it so you can take some pictures and things like that, like you would like to do. So yeah, so that's our 80 millimeter 640 focal length first light refractor, and then the mount it is on is the IXOS 100. The IXOS 100 is a go-to tracking mount. It's our lightest weight one that we have currently here at Explore Scientific. It's great for lightweight things or doing DSLR photography. You can stick just a camera on there. We have a camera dovetail plate that you can stick on there as well. So I'm going to talk a little bit about what is on here. This is a clutch. Noah, do you mind to refresh my computer for me? So this is the clutch for the deck, so you can turn your telescope, which you're going to need all this for balancing. So I just forgot. Hang on. How to undo the deck and how to undo the RA. You can do it. Yes, I know, it's the back end. Okay, so the RA, so what you'll do is you're gonna need to balance it. And as you can see, this telescope actually is heavy. This is going to be telescope heavy, and so we would recommend that you put counterweights on it to kind of balance it out. Some people like their telescope or their mount telescope heavy, and some people like it where it is camera heavy if you're doing a camera. So you would balance that, put a counterweight on there and get that into balance. Being off balance just a little bit is good. The drives in our mounts are not perfectly round, and so in order to keep it on that high spot, low spot, it's good to have that just a little bit unbalanced, so you don't want it to be perfect. Once you do that, once you get it balanced this way, you of course would then unlock the deck, which here, let's do it this way. So I'm going to unlock the RA. So I would get it in balance this way, and then of course then I would unlock this, and I would try to slide this up and down to where it would be in balance for the deck as well. Once you do that, you're all set to go for doing some viewing. That helps with motor it running smoothly. So I currently do not have a counterweight on it, so I'm going to try my hardest to see if it. We'll see if it takes off for us. So if not, I'm going to snag one and stick one on there for you guys. So it has a this cable it goes from the mount to the back. So that's where your motors are at, and your computer is out in the back here on the back of the mount, and that's where the PMC unit is. I currently have a power bank going to it. We keep those on hand here just because we show mounts a lot here at Explore Scientific. And so this mount actually comes with a battery adapter, so it'll come with that. It'll come with D batteries, or not come with the D batteries, but you're able to put D batteries in there and run the mount as well. That only gives you about 3 hours of viewing, so we usually recommend, if you're going to be doing a lot of viewing with it, we usually recommend upgrading to like a power bank or something like that. So, which of course we have some here that you could purchase as well. So I'm going to get our iPad. It runs off an iPad. It can also run off a computer. In order to run it off a computer, you would need a micro USB or micro cable to USB cable in order to do that, and it needs to be one that is a data transfer and not a power cord. We've had people try to use a power cord and it didn't work as well. So. Just make sure that's a data transfer. So if I wanted to plug it into a computer, I can use it that way. I can. The iXOS 100 also has its own app called Explore Stars. We designed it specifically for our mounts, and so we have this one, and then we have a heavier duty version called the Exos 2, and then a really big heavy duty version called the G11. And all of those are able to be run off of the app. So what I'm going to do is the mount has its own network. It does not have internet access. So when I connect to it, it's sending a Wi-Fi signal to the iPad, but there's not any information transfer through internet. So I'm going to change it to PMC86358 is the name of the network. And then what would happen is it already knows it because Kent's played with it, but I would type in password PMC, those are all capitals, dash capital EIGHT, and then hit OK, and it'll connect. It'll say secure, no internet. So again, because there's not a internet transfer with that network. So once we do that, we would go into Explore Stars. And when you get into Explore Stars, you're going to see a compass rose when it's connected. I don't know, is there a glare on that, Paul? No. Okay, perfect. You're going to see a compass rose, and then you're going to see a number keypad, and then all this stuff in the middle is just information that the mount is sending to the app, so we can know what's going on with it, what's moving, what's not moving, and things like that. So right now, I have it set at a speed of 3, so I'm going to change it to 9. And then right in the middle of the up, down, left, and right keys, that number right there changed from 0 to 9. So we've got it up at the highest speed that it can go. Then I'm going to hit Menu, and I'm going to go Catalog. And I'm going to go take this thing to the sun. So now this is where we're really going to test it, because we usually have a counterweight on it. So let's see. So I hit Menu, Sun, Slew to Object, and then Go To. There is a setting in the app that you don't have to always hit Go To. But, oh yeah, Kent supposedly checked all that for me. Oh, it's right there. Oh, ha ha, he didn't check it too well, did he? He was wrong. He was wrong. That's okay. So there it is. There's the sun. That's where the sun's at. If the sun was out here in northwest Arkansas, unfortunately, it is rainy and cloudy. So, and it went with no counterweights. And it went with no counterweights. Look at that. And so now, right now, it is on. Not recommended to run it without. Yeah, it's not. Yes, it's not recommended to run it without counterweights. So right now we're on point mode. Point mode means that it's not going to track an object. It's pointing to a location in the sky, and the RA and the deck are always moving to try to keep it in line with that area of the sky. So as the world is turning and the sky is moving, it's going to stay in that location. If we had it on track mode and I pointed it to the sun, it would know the RA and know where it was at, and so it would follow the sun across the horizon like it goes. So the other cool feature about this is on here. Let's say I wanted to move. I wanted to. Right in front of the mount, we can see it. Oh, really? Right here? That right there? Yeah. Okay. Point at the other camera. This camera? Okay. So. To your left. right? Like this?
Yeah,
Okay.
now we can see it.
Okay, so I don't know if you can really see it because the sun's red, but there's a red dot in there. This has like an overlay, a compass overlay. You can't really see the compass, but if I took that dot in there, just like if I was on the compass rose and moved it, then the mount would start to move wherever I needed it to, and I don't want to go that way because it's about to hit the table. But it's going whatever direction. I can just pull it down, whatever direction, if I wanted to only see a certain portion of the sun, or I wanted to go a little bit in another direction, or if I wanted to line it up a little bit better.
Some weird noises because it's not balanced.
Yeah, I didn't balance it.
Well, like they can't hear me.
Oh, Paul is saying it's making some weird noises because it's not balanced.
Don't worry about it.
Yeah, so we don't have to worry about that because the design of our mount is made to where there's no grinding or anything. It doesn't damage the mount, but we really recommend putting counterweights on it. Unfortunately, mine had walked away, and so here we are today with a mount without counterweights. But you can see that it holds up. Okay, the other thing with this is I'm going to put it in. So I'm going to go menu, settings, and I'm going to put it in track. Let's see. Oh, I'm sending it home first. So I just hit the park button. So it's going to go back to where we started from. And then I'm going to change it to the track mode. It sounds really good right now, Paul. And there it goes, it's going back home. So in order to change it from point mode to track mode, on the compass rose here, on this screen, I'm gonna let it stop. Give it just a second. Okay, on this screen here, can you see that, Paul?
Yeah.
Okay, just like that? Okay, on the screen here, you can see over by the number keypad, there is a triangle that says P. I'm going to press that, and it's going to change to a box that says TR. That'll change it from point to track mode. So let's do that. And then I'm going to go back. Let's see here. Let's find something to go to. Let's see what's in the sky today. It looks like Mercury is in the sky right now. So let's slew to that. Slew to object. Go to. Ton, you have a question. Go ahead. There it goes. It's going to Mercury. What planetary camera do you recommend? Because mine fell off and broke. Oh my gosh, that's an awful situation. I'm so sorry about that. You know, I really don't know of a camera because I'm not into astrophotography. But Tyler, one of our CSR manager here, does astrophotography all the time, and he will be on Friday on Focus on Astrophotography, and he probably could give you better recommendations than I could ever do. You
could possibly get a T adapter to a DSLR, and if you're doing planetary, you should be okay with that because planets are so bright that you can use a higher ISO or a lower ISO, and you don't have to take 10-minute photographs like you do with the distant nebulae, but you get a DSLR and an adapter for it if that is, of course, if you can find one that fits the opening. What's the end of it called? I'm not a telescope person, so.
Talk about the focuser?
Yeah, the focuser. That's it.
Yeah, the focuser draw tube.
Yeah. So if you get one, if you can find you an adapter for that, and you have a DSLR or SLR, then you can just use the telescope as a giant lens.
Yes. Well, yeah. So, but yeah, like I said, Paul obviously has done is obviously a photography guy as well. So we have him, and we also have Tyler, who is able to answer those questions. I'm just new to this hobby, so I don't know a lot. I just have a little kid.
Behind you back there?
What?
Is there a camera laying down behind you?
No.
I saw a red box back there a little while ago.
No, it walked away. So I currently have a Canon, a Rebel XS, which is from like 2007, and Tyler was so gracious and had the sensor modified for me. So you have some options out there for doing some photography, astrophotography. You could use a telescope with the camera, or you could use just a camera. So, but we also have that show, like I said, on Fridays, every Friday at 4 o'clock, and he will answer your questions. So if you hop on there, he'll be able to answer that question for you. So hey, if you're out in the Amazon world, give me a shout out, because I want to be able to see who's on there, and I'd love to talk to you and answer your questions. That would be great. I think that's what Kent calls it, Amazon world. It still is kind of funny. It's kind of nice. Amazon world. The Amazon world. Okay, so right now it's going to start tracking, because I have it on that TR mode, and you can hear it slightly. It's not a really loud mount, so it's really good for areas and things like that. We've had a couple people not like the music. It kind of makes like a harmonic music sound as it's going. There is not a way to turn that off. It's just the motors and stuff that are moving. So you have to be able to do that. So I had a next image 10 planetary camera, hoping to get something similar. Very nice. I'm so sorry you dropped it. That's no fun. So, but yeah, Tyler will be able to, he's a guru at that stuff. So he's very smart with that stuff. So he'll be able to help you out with that. I wish I had more information for you, but I know that he could answer that as well for you. So, okay, so I'm going to send it back to park, menu, settings, and park mode. Is it really 322? Okay. So this is our IXOS 100 with our FL AR 86640. This is a package deal. It's over in the Amazon Carousel. Amazon Carousel. It's a great starter package, especially if you're wanting to get into using a tracking mount. It's a great price up there. And so if you want to check out that price, you can check it out in the carousel over there. So the next thing I'm going to talk to you guys about is our soft-sided carrying case. So I used to do photography, like just taking pictures of houses and some friends and things like that, and I always hated having having lenses everywhere. So it was really nice when I got a bag, and that's the same way I feel like it would be for viewing through a telescope. So, get all these eyepieces and all these different degrees and things like that. And so it makes it a little difficult to keep it housed somewhere. So we have come out with this soft-sided carrying case that can hold quite a few eyepieces. Everything in here is adjustable. So it's all Velcroed out. So you could just Velcro, undo it, and move it over, just like a regular photography bag. And so you can move that over for whatever eyepiece you're needing to put in there. And then these are also adjustable as well, the long pieces as well. It's very soft, very durable, so it's not going to scratch anything, and it's going to keep it all protected. What I have done is I have grabbed some of our 52-degree eyepieces to show you guys. This is a 5240. Look at that. Look at that big guy. So these are also in the carousel as well, if you want to check those out. So this is our 5240 eyepiece, and it's obviously a big guy. So the great thing about this bag is you are able to move these things. If I can make sure the Velcro work with me. And then you're able to slide those eyepieces in there, and it fits just right in there. And then you're able to put some more eyepieces in there. So it depends on the size of your eyepiece, how many you can get in here. But if you have some smaller ones, you can get those in there as well to keep those safe and together, and not having to I'm trying to read this message and talk at the same time. I'm not. Okay, so what astronomical event amazed you the most, meaning solar eclipse, transits, meteor showers, etc., for example? I say the solar eclipse. I'd have to say the solar eclipse. It's amazing to see.
Meteor showers.
I haven't seen a meteor shower, so I guess I can't compare it to that, Paul.
Meteor showers are fun because you don't know what's happening and you got to chase.
So, So, because you're trying to find everything?
Yeah, you got to, you know about where it's going to show up, and you know where it's, oh my gosh, my microphone's going crazy. You know about where it's going to show up, right?
Yeah, yeah.
So you get you a wide eyepiece and find the area.
Yeah.
And then I would suggest going up and up and just staring through it, and you'll start seeing them.
Yeah.
I think that's fun.
Yeah.
Or binoculars. You can do that.
I've actually not seen a meteor shower. I've seen solar eclipses. That's been really neat and amazing to see. The reason I say that I like that one the most, Connor Bradley, is because let's see, I'm going to give my age away. In 97 or 98, somewhere around there, maybe 96, somewhere around there. I don't remember quite the year because I'm getting up in age. But anyways, we went to NASA and we got to see the shuttle launch, and it literally lit the sky up like daytime. So it was neat to see. It reminded me of the difference between solar.
Did you see the last one?
No, I didn't see the last one.
Did you see the one where they crashed?
I didn't see that one.
So, okay. It wasn't Columbia, I think it is.
Are you talking about the one that I saw? Was it Columbia?
Yeah.
I don't remember. I'm telling you, I'm ancient. Tyler calls me space dust. So that's
whatever.
So
I remember being a little bitty child in first grade, second grade. I can't remember.
Got a good memory. He's like an elephant. He never forgets.
That's true. So watch what you do to me. Anyway, so I remember we were watching, I don't know when it was, actually. So we were watching the space shuttle take off live in the library at Tyson's elementary school.
Oh.
And we're sitting there, it's like, oh, that's interesting. And I was thinking about reading Tolkien or something. I was like, I wonder what that's about.
Yeah, yeah.
And then the space shuttle blew up.
Yeah.
I mean, and they ran us all out of there as fast as possible.
That kind of thing I could understand and not ever forgetting. I just remember standing on the beach, like we were miles away. We were miles away, and the shuttle went off, and then everything separated, like you could actually see that come apart, and it was really neat. So just the idea of a solar eclipse is it's not. It's kind of the same, but not the same. So it's just really neat to see something just completely change the world. I mean, it's just insane to be able to do that. So, but yeah, Paul is pointing at me. Let's see here. I like transits. Connor says, I like transits. I saw Jupiter's moons transitioning. Cool seeing its moon shadows casting off the planets. Yes. Scott was talking about that the other day on a show. I've never seen that. I bet you that is really amazing to see and just to think about that's happening out there in space, and it's just really cool. It's really, really cool. So
2 minutes. All
right, guys, we have 2 minutes. If you're in Amazon World or you're in another platform, hop on over to Amazon World.
Or in another world?
We have a camp. Yes, we got different worlds going on.
Yes.
Go on ahead and go over to explore. Go on over to our carousel and check out all the products we have.
Harold said hi.
Who says?
Harold Locke.
Harold, hello, Harold. How are you today?
Right.
Yeah. So if you want to go on ahead and go over there and check out what we have, we don't. Here at Explore Scientific, we're about education. We don't just have telescopes. We have stuff for little guys all the way up to older people. In fact, we had a gentleman come in here that's almost 100 the other day and buy an eyepiece. So no matter what your age is, we have something for you.
Don't forget, if you're looking to get the telescope, an eyepiece, that Tyrion planisphere, you're going to need it. A red light flashlight, and a solar sun filter. Never look at the sun through your telescope without something, without a correct sun filter on the front of your telescope.
Yeah, you've always got to have special equipment. And speaking of solar, since Connor Bradley asked what I liked, the solar eclipse is going to be coming up soon, and we also have those. For sale as well. So be prepared for that because we're going to have
one behind you, right?
2. We're going to have 2. No, I don't have any solar.
Where did it?
Eclipse glasses.
People have.
I think he likes to get me to turn around and look behind me. You know, like how somebody taps you on the shoulder and you just. I think that's Paul's way of getting me to turn around.
I think somebody. Oh, here, come get these.
Oh, here, okay.
But I was looking for the solar filter for the.
Well, there's solar filters over there.
That's what I was. Solar filter for the telescope.
No. There's not a solar filter over here.
There's supposed to be 2.
Everything's gone. These.
Why
these
did
our
they
solar
take
eclipse
all the
glasses.
solar? Where's mine at?
Somebody wanted to do some solar viewing for Paul. Anyways, these are our solar eclipse
doubt
glasses.
that.
You can buy them in a package. I'm not for sure how many are in a pack, but they are. There, you found it. But they are for sale right now because we're gearing up for the solar eclipse that's going to be coming up. We're going to have one next year and then one the year after that, and we're actually going to have a huge star party for that. So we're really excited about that. So
And
make sure you get your
definitely
eclipse
do
glasses.
not wait to the last minute to get
Yes.
your solar glasses and filters, because the last time everyone ran out.
Yes. The last time everyone did run out.
And and then you won't get one at all.
And then you get
Or you'll have to pay $100 for one.
Yeah, it's kind of like a whole like story here at Explore Scientific, how eclipse glasses were like thousands and thousands of orders came in overnight.
I wasn't here.
Crazy. So, but yeah,
I was not here.
Yep. So anyway, so make sure you don't wait to get these glasses so you can have them to do that viewing and get yourself prepared, because they're like here in Northwest Arkansas. I think up in Rogers Bentonville area, there's going to be totality, but we are going to be having a star party somewhere else. So just make sure you're prepared to be able to do that viewing that day. So I think that's all I have for you today. I appreciate you hanging out with me. Kent will be back tomorrow. Tomorrow's Thursday. So Kent will be back. He had to go rescue his kitties from the doctor. I appreciate anybody that hung out with us.
Can I go home now?
I appreciate anybody that hung out with us and asked questions. Connor, your question was great. I loved it, and it's going to make me start thinking more, and I'm going to try to see Jupiter's moons. That would be awesome. So, all right, you guys have a great day, and we'll see you next time. Bye-bye.
Hi, I'm Tyler and welcome back to our Explore First Light series. Today we're going to talk about the Newtonian, and specifically this is a 114 millimeter Newtonian with a 4.5 inch mirror. How these Newtonians work is light will enter through the main objective, bounce off the primary, hit the secondary, and goes right into our diagonal, or our rack and pinion with an eyepiece or our cell phone adapter. This has 40 millimeters of draw tube, and now all these telescopes come with a red dot finder, a 25 millimeter colossal, and a cell phone adapter. Now with these particular First Light telescopes, they always come with a couple of options as far as mounts. The EQ3, a nano mount, a Twilight 1, or an Alt-Az mount. Now with these particular telescopes, it is always recommended that you get multiple eyepieces. And I always recommend the 52 degree series that we see here, also with a focal extender. Usually 2 times is plenty enough. Now with these eyepieces, they are waterproof and argon purged, and they make a perfect addition to these telescopes to help you visually acquire what you're wanting to see. Now again, I hope you guys tune in for our next episode. We're going to be talking about our 80 millimeter refractor on the First Light series. And again, my name is Tyler, and I hope you have clear skies and keep looking up.
am currently waiting on Scott to join me. He's scooching on in.
Here we go.
Here he comes. Here he comes. I
Lights, camera action.
Lights, camera action. The party can begin because he's here. Because you have arrived. Right?
It seems like I'm looking at delay and I see my chair scooching in.
You're looking at the past.
I am looking at the past, and we always do.
Yes,
you know?
we always do.
We always do. You see me, I see you right here.
Yeah.
There's a little bit of space between us.
Yeah.
We see each other in the past.
I know. I told my friend
the
that.
briefest fraction of a second ago, but it's not in real time.
It's not in real time. No, I was telling that to a friend recently, and she's in her early 20s, and she was just like,
mind blown, right?
like, we're always looking at the past.
And that's what learning about astronomy does for a lot of people.
Yeah.
I mean, we were talking just yesterday for the Starmus event, and I was talking to David Eicher and Michael Bakich, and we were talking about the reason why astronomers and music kind of go together.
Mm-hmm.
And I think that the reason is that some of the concepts, like this look back time concept,
Mm-hmm.
okay, further away something is, the further back into time you're seeing it.
Mm-hmm.
I mean, that's just one of them, okay?
Yeah.
So a star explodes in a galaxy is 30 million light years away. Well, it exploded 30 million years ago, and you're just now seeing
Now seeing it.
okay, right? But this also works for near space, too. I mean, any distance, you're seeing it in the past slightly. So there's a slight distortion to almost everything you're seeing and experiencing, because you don't get it in real time.
Yep.
Briefest fraction of a second ago, but not real time.
Yep.
Sorry.
Yeah, no, it's just really neat to think about. I mean, you don't actually stop and think about it because we're so, everybody. In fact, I'm actually studying being in the moment right now. Just stopping and being in the moment, and so we're more about that instead of actually realizing that yes, we are.
Well, I think there's something called flow that you can experience.
Yeah.
But the music part of it at Starmus, I think, puts people in that state of flow. Okay. You're listening to a rhythm or a tune or something like that, and you are getting, you start to get into that feeling of the moment, right?
Mm-hmm. Yeah.
And so you hear a great song or something, and no sooner you start listening to it, it's over, and it's like, okay.
Well, I mean, that really is the technical term for it, flow. I mean, just like that, you're driving down the road, listening to a song, the next thing you know, you're a mile or two down the road, and you're like, how did I get here?
Right.
How did I get here?
Maybe that's the reason they put radios in cars or something to make the trip somehow seem shorter to you or more enjoyable.
But I think you could do the same thing. I'm sure astronomers do the same thing when they go out and they look in a telescope and they're looking at the stars and gazing and things like that. They probably get in that flow moment, and next thing you know, it's 4 hours later, and they're like,
it's a meditative state, especially if you're relaxing while you're looking in the eyepiece. You start to remember some of the concepts and teachings about, what it is that you're doing. You're looking back into time. You're actually having a kind of a contact, because the photons created in stars that are coming to your eye, it's not a reflection.
No.
It's the original photons made in that star or that galaxy.
Yeah.
And so it's not a copy, there's this kind of a contact kind of thing. And so it's part of understanding how you're hardwired to the whole universe. So
Yeah. Let's see who's on here with us.
Okay.
Check that out. Let's
All
see.
right.
It looks like we've got, if I can make this thing scroll. He always has it weird.
There we go.
Anything to it.
I know, I'm teasing you. Mike Wiesner's on here.
Yep.
Hey, Mike. And I don't know how to say that.
Wajdi Gazara, I think.
Hello.
American people.
Yes. And Beatrice is on here. Harold is on here.
I think on this show, we're all just like humans here on this pale blue dot that we call Earth. So
yes.
That's it, so that's the other concept, if you've never read Pale Blue Dot by Carl Sagan, I think it's something you should do. I used to make myself, in fact, for about 2 or 3 months solid, I made myself read it every morning when I woke up, because it really does help you reframe your condition here. We are on this planet. We are, against a background of this vastness of space, hurtling through space at unbelievable speeds.
Yeah.
And we're somehow all connected to it. So
yeah, it's pretty amazing. Hey, Sentinel, how are you today? He's saying hi to us. So today, as our topic of our show is going to be about 10 crazy facts about space. But before we do that,
how crazy?
I was telling Kent about some of them, and he goes,
that's crazy.
He said it doesn't sound real. He goes, you better cite your website. And so I actually have a website.
Okay.
I really have a website that I have that I found this article this morning. Anyways, I don't have it up.
Oh, never mind.
We are in the process of giving our store a facelift. We're almost done with it. And so we have a new Instagram page for the Explore Store, and we have a new Facebook page for the Explore Store.
That's true.
So I've started posting some social media on there. So one of the things I wanted to start doing that I started this morning was posting fun facts on there about space. Okay. And that's where I found this article, because I was like,
give me your first crazy.
Okay, so I have to get it up because I can't tell you off the top of my head. Okay. Now, let's see here. Do you know whether or not space is silent or has noise? I'm going to quizzing.
Well, I know that there has been music made from the sound or the waves from quasars and pulsars and galaxies. So I would go with that. Audible sounds could be created from celestial objects. That's how I would say that.
Well, according to the Arizona State University, Arizona State University, space is silent.
Well, no one can hear you scream in space. That's true. You rip off the space helmet and scream. No one's going to hear that, right? Because there's no air to carry the sound wave.
That's right. Because there's no atmosphere in space, which means that sound has no medium or way to travel to be heard.
Right. That's true.
So it's like when you wake up, when you're having that terrible dream and you're waking up, you're screaming, but no noise is coming out. That's what it would be like.
But you're like,
it's like
nothing.
Nothing's happening. Nothing happened. Okay.
Right.
Do you know? You probably know this, but do you know which planet is the hottest in our solar system?
Told me I could have got the
It's either Mercury or Venus.
Venus is the hottest planet in the solar system and has an average surface temperature of around 450 degrees Celsius.
So I wonder what the surface temperature is like of Mercury, since it's the closest to the sun.
I'm about to tell you that, because Mercury is not the hottest planet, which is really strange. So you would think that Mercury would be the hottest, but Mercury has no atmosphere, which regulates temperature, resulting in big fluctuations. So they don't know the temperature of it, but it doesn't.
So what if you put your hand like on a metal plate that's sitting on the ground during the daytime? I bet it's pretty hot.
I don't know, but it's not as hot.
But you could fry an egg like that.
Let's try it. I remember back in the day those commercials like that. Do you remember that commercial? Now you got me on a rabbit trail. Do you remember the commercial where they go, "This is your brain on drugs"? Yes.
Yeah, grilling. Yeah.
And then for a while there, the hottest temperatures, whether people would go out and put eggs out on the ground to see.
Yeah, I have heard of that. I actually never saw it done. But
maybe we should have tried it. When it was
the American idiom. It's hot enough to fry an egg on the sidewalk, right?
Why would you want to do that? I don't understand.
I don't know.
I mean, if you're desperate, don't have a frying pan. Okay. Do you know the cost of a spacesuit?
I do not know the actual cost, but I think it's millions.
Okay, so the cost of a spacesuit is $12 million. That's 70% of that cost is for the backpack and the control module. However,
no, is this like a moon?
No, it's the actual NASA spacesuit.
However,
the spacesuit that NASA uses were built in 1974. So that's the cost of them in 1974.
It cost $12 million in 1974.
Yes. So if these were priced by today's prices, they would cost an estimate of $150 million.
Yikes! Wow. Okay, so I'm probably not getting one.
Hey, anybody out there?
Unless
figure out.
NASA
Yeah.
wants to call me and say,
Or-
Scott, don't worry about it. We're going to give you a free ride. Okay.
Or if there's somebody out there generous enough to give you that for Christmas or your birthday. There you go.
Okay.
Gift ideas for Scott.
Gift ideas. That's right.
Okay. Do you know
I had a G.I. Joe, though. It didn't have a spacesuit, I think.
how much do you think that spacesuit cost?
Pennies on the dollar. I don't know.
Hey, but if you had it
I know
today,
the markup of toys. So,
but if you
know.
had it today, it probably would be cost a lot. It probably would
probably
be
true.
a lot. Let's see his.
Probably
I'm
true.
just seeing. Jim Norwood says I've cooked eggs on the dash of a closed up vehicle in direct sunlight. Takes a while, but they'll cook. That's.
I wonder what that smelled like, Jim. Okay. All right. Now, somebody made a comment about the music that they listen to. And Mike Wiesner says he listens to classical science fiction themes and spatial music when I'm in my observatory. Love listening to the Hearts of Space albums.
That's really neat that you pick that you have those that you do while you're observing. That's interesting.
I like Dark Side of the Moon by Pink Floyd, especially if I'm looking at the moon.
You like Pink Floyd?
Oh, yeah. Who doesn't like Pink Floyd?
I don't listen to them.
You don't? You're anti-Pink Floyd?
I'm anti-music. No, I'm not. I'm just kidding. I'm not anti-music.
Well, it's just not your generation. You know, I'm a lot older than you are.
Pink Floyd's everybody's generation. What are you talking about?
They're that good that they're timeless, and you don't like
Yes, I mean you can go out and buy a Pink Floyd T-shirt right now.
You can, and the Pink Floyd Dark Side of the Moon album happens to be still one of the best-selling albums out there. So there you go.
Yep, they're pretty famous. Okay, do you know that the sun's mass takes up 99.86% of the solar system?
There's not much left over for us planets, huh? And so how much room do we take up in the solar system? You know? So,
well, we're about to tell you.
You know, I've been wanting to live in a tiny house. And so, you know, and even if you own a 3,000 or 4,000 square foot home, you know, and think that that's a lot of room, it's really not.
Well, technically you are, if you're thinking about Earth in comparison to the sun, you are living in a tiny home because 1 million Earths can fit inside the sun. 1 million.
Yeah, you're already a tiny homeowner, even if you own a 100,000 square foot Goliath of a house. So
even if it takes up the biggest mountain in the world, you're still in a tiny home.
Still a tiny home. That's right.
The sun, it says the sun is large enough that approximately 1.3 million Earths could fit inside if squashed in, or if the Earths retained their spherical shape, then 960,000 would fit. But can you visualize the number of Earths?
See, that's the hard part, is visualizing this. And so that was, and all these concepts of, you know, the vastness of space, the sizes of things, you know, all of this is pretty hard to wrap your head around. And when I first started in amateur astronomy, these things were really overwhelming to me. Like I would just be like numb, okay, over trying to imagine, you know, these things. And I'm going to make an argument here. I think that the act, you know, of being involved in astronomy, maybe this flow experience that you can have while looking through the eyepiece, this meditative state of, you know, trying to use averted vision and seeing a galaxy, and you're looking deeper and deeper into space. And if you happen to hear the right kind of music for you, which might be different,
that's why there's so much music.
Buck Owens, and one of them might be Yoko Ono, and then the other one might be, you know, Debussy's Clair de Lune. Okay, whatever floats your boat on this, I think that it helps you get into that state of flow.
Yeah,
and I think that opens your mind up a bit, so that you can start to somehow grasp. These
things, I
concepts.
mean, and getting into that helps you actually relieve stress. Like it actually it centers you. It just calms your body. Like there's so many great physical elements to that it can do a lot for you.
Right. And Jim says, do not listen to Slim Whitman.
I don't know who that is.
I think that was the yodeler. I don't know, Jim. Was that the yodeler that was on Mars Attacks? You know,
Mars Attacks.
Yeah, that was a funny movie.
Okay, so all
All right.
Did you know that there are more trees on the Earth than there are stars in the Milky Way?
Is that true?
According to our Arizona State University, they say there are about 3 trillion trees, on planet Earth, and between 1 to 400 billion stars approximately in the Milky Way galaxy.
Now, I've heard revised estimates, and we get these things revised all the time, that they think there might be over 1 trillion stars in the Milky Way galaxy. So,
but it's something to think about.
It is something to think about. That's true.
But it kind of puts it into perspective, because when I saw this morning, I was like, okay, wait. Because I only think about the trees. I mean, the whole world is filled with trees, but I only think about the trees here because we're in a wooded area. We're not in the desert.
Big time.
You know, and so I only think about the trees
everywhere
here. And I'm like, wait, can that really be possible? Because to me, we have a lot of trees, but we don't have a lot of trees, I guess, because I'm used to seeing them all the time.
Well, we could always use more, right?
Always use more.
Yeah. Go plant trees, guys. So
plant stars.
And that too.
So, okay. So, did you know that the sunset on Mars appears blue?
Yes.
How did you know that?
How did I know? Because I've seen it.
You've seen the sunset on Mars?
Yeah, you haven't seen the sunset?
No, I haven't seen the sunset
on Mars. You got to go
Mars.
see some sunset photos from Mars.
Oh, I thought you meant you physically went to Mars.
No, this.
I have
asthma. Okay, I have asthma. I have a tough time breathing here. I am not going to be able to breathe on Mars. Okay.
120 million.
And I'm allergic to dust, so Mars dust and the fact that there's really not much air, and it's in a vacuum. It's all tough.
Lubo in China says, we people will make sure that the star number will prevail over the trees. Love it, Lubo. That's awesome. That is awesome.
Yeah. There's not even enough people in China really to match all that. So it's true.
Okay, so I'm going to tell you how that is possible. It says, just as colors are made more dramatic in sunsets on Earth, sunsets on Mars, according to NASA, would appear bluish to human observers watching from the red planet. Fine dust makes the blue near the sun's part of the sky much more visible, while normal daylight makes the red planet's familiar rusty dust color the most perceptible to the human eyes.
There you go.
So it's the way the light shines through it.
Yeah, you got to see some of these sunset
I'm going to have
photos.
to go. I am going to have to go.
There's also an eclipse photo of the moon of Phobos in front of the sun, which is cool. So they got an eclipse photo. There's a lot of cool stuff about Mars. You could probably do a whole show on the crazy facts of Mars.
Maybe that's what I should do. Maybe I should do the crazy facts of Mars. That would be fun.
It's true. Because we can go way back. There's been a lot of crazy stuff about Mars.
Okay.
Mostly about how humans think about Mars.
Okay, so number 8, there are more stars in the universe than grains of sand on Earth.
One more time.
There are more stars in the universe than grains of sand on the Earth.
Sure.
It's kind of weird to think about because we just said that there's more trees on Earth compared to the stars in the Milky Way.
They were talking about more galaxies, right?
Yeah.
Galaxies. Okay, so they really don't know how many galaxies there are, and they also don't know how many universes there are.
Yeah.
We can say that, oh yeah, well, there's one universe, but they're getting into this multiverse thing.
Yes.
Okay. So another mind blown. Okay. So
maybe Spider-Man was always real.
Maybe.
Because they always
I don't know.
all those Marvel shows are like getting in the multiverse.
There's some cosmologists that think that, well, since you're part of the universe, that your wildest imagination, just make it up, okay, in your mind. All right. Because you're making it up and you're part of the universe, okay? It's part of the universe too. So there you go.
Maybe we don't want to put my made up things out there. Harold, I think it's great that you think I get class credit for this research. It actually was fun reading.
Everybody gets an A today. All right. So
but Lubo says, but there is more atoms in the grain of the sand than there is stars in the universe. What?
Lubo, don't blow our minds here. Okay. We're having a tough time holding on right now, okay? So
I'm blowing Scott's mind right now.
Yeah.
Blowing your mind. Okay, so that was number 8.
My mind gets blown almost regularly every day.
How long do you think one day on Venus is?
1.5 years.
1 day.
One day on Venus, how long do you think it is?
I've known this number before. I don't think it's 24 hours, though.
No, it isn't 24 hours.
Right? It's a long time, isn't it?
It is. 1 day on Venus is longer than 1 year. Venus has a slow axis rotation. Paul was right.
Paul's like looking at the internet over there.
Venus has a slow axis rotation which takes 243 Earth days to complete its day. The orbit of Venus around the sun is 225 Earth days, making a year on Venus 18 days less than a day on Venus. That's crazy.
That's crazy. Harold Locke, he's writing that Heinlein, who is a science fiction author, wrote that every novel creates a new universe.
That is a very good point. Because it's giving your imagination. Somebody's writing down what their thoughts and their whatever. And that's crazy. I never even thought about it. That's a good point.
That because we're somehow self-contained, and that the universe is out there and we're in here, right? Somewhere in here. I don't know exactly where we are in here, but wherever it is, that's us, right? And the universe is out there. But the universe means everything.
The question I've got,
right? Universe.
The question.
And so,
Scott.
Yeah. Yes.
The question I have is, when you begin a novel and you don't finish it, does that new world now implode and is dead?
If you think so.
Or are they?
If you imagine it to be.
Are they in suspended animation?
If you want it to be.
It's whatever your mind and heart desires.
If you don't finish
it, right.
If you don't finish it,
really?
I don't know.
You just stop and quit doing anything with it. Do they just go on their own lives?
Well, we don't know.
We don't know because you stopped reading. You stopped reading the book.
You stopped writing it.
Oh, you're talking about writing it.
Yeah.
I wonder how many novels. No, I'm not even going to talk about that. I was going to say.
Yeah, we're going down a rabbit hole, folks.
Okay.
Although we've been in one the entire time, so.
No, this has been fun. This has been a
rabbit hole.
Lubo says you can ask the same question about Mercury 2 to 3 resonance. So are you saying?
Oh, he's talking about the length of day.
Oh, the sun at one point on Mercury rises, then goes backwards, sets where it came from, and then it rises again.
Isn't that crazy?
That is insane. I didn't know that.
Yes.
Jim Norwood makes a good point.
What does he say? Does each novel make a new universe, or does each read of each novel make one?
Both.
I think a new universe is made for every single person that reads it.
So maybe multiverses.
It's multiverses because if you're reading it and just like you said, you're whatever your mind, you said you can make it your universe.
Yeah. So people will go, oh, Scott, you're being crazy here. Just because I think and imagine it, that can't be real. That's outside of the universe. Okay. Universe means everything. It means everything. Okay. So it's not a collection of stars and galaxies and nebula and comets and all the rest of it, but there's something separate, not touching or part of the universe. Well, then that can't exist, right?
It's almost like we have a mentality that we are not part of the universe. We're only actually peering into the universe.
Yeah, we're just like an observer, somehow separate.
But we're actually part of the universe.
Yeah. From our atoms to, all that.
The master of the universe.
Lubo says the sun at one point on Mercury rises. Oh, I already said that, didn't I?
Yes, you did.
I'm sorry.
And Harold Locke is laughing.
Harold, it's amazing.
Harold knows it's true.
It's amazing. See, and that's one of the things I was hoping to do is to find out more fun facts. Like Lubo's telling us some things. It's like, really, is that really true? I mean, yeah. That's insane. Okay, so my last one is there is a planet made of diamonds.
Ooh.
There is a planet made of diamonds twice the size of Earth, the super Earth, aka 55 Cancri. I don't know how to say that.
Cancri?
Is most likely covered in graphite and diamonds. Paying a visit to that planet would probably pay for the $12 million
trip
spacesuit needed to get there.
Trying to scoop up all those diamonds.
So if you want to be rich, go to that planet and then come back.
Yeah, if you want to be the richest person in the universe.
But you have to buy that $150 million spacesuit first.
Yeah, and get into a rocket.
So are they just using the same spacesuits they've always used? Or have they made new ones?
It would be interesting to know, but I think that they do take them back to Earth. They have them professionally cleaned, right? Right.
I wonder what kind of cleaner they use on them. This is like,
So there's a documentary that's out. I have one of those Oculus, where you get like this 3D VR immersion things.
Oh, yeah.
And one of these experiences, and this is the reason why I bought the Oculus, you go into the International Space Station. And it's cool. I mean, you have this feeling, the motion and stuff. So, but they were talking in detail during one of the episodes. They were talking in detail about the suits and how they kind of smell a little bit because they don't wash them after every use, so you're hopping into a suit that's been kind of sweated in, before, but you're in space. You don't care, right? You don't care about the smell.
Do you sweat in space?
Oh yeah, sure. Maybe not in the vacuum of space. I don't know. Well, you probably do, but it probably instantly dries. So it's a real dry experience.
It's a dry sweat. But doesn't that defeat the point of sweat? That's actually hilarious to me.
It does. It defeats.
There's so many things. There's so many things that only astronauts. Astronauts have experienced that we don't know and have never experienced. But one day,
well, they come back and they tell us.
I know, but it's
yeah. They say like space smells like maybe like burnt electronics or something. When I talked to Harrison Schmitt about going to the moon, the dust, when they went back into the lunar module and they took off their helmets and stuff, they said it tastes like gunpowder. It's like, okay, I haven't really tasted gunpowder.
I know.
Before.
Like, how
but
do you
guys, if you want to know what the moon tastes like, just take a little gunpowder taste, just touch your tongue with it, and that's what the moon tastes like.
Don't do that.
Scott is telling everybody to lick.
Break open a bullet, okay? Maybe with a hammer.
Scott's telling everybody to lick a bullet.
Don't make any sparks, right?
I'm curious. So now they launched a rocket to the moon. So what is that exactly as a mission? Because I missed that.
I'm curious. So now they launched a rocket to the moon. So that what exactly is the mission? Because I missed that. Now, Tom, back in the 60s and 70s, we went to the moon. Okay.
Yeah.
And Harrison Schmitt was one of the last. In fact, he was on the last mission to the moon, Apollo 17.
Okay.
And he was describing to me, because he was a moonwalker. Okay. He was describing to me what the taste of moon dust is like. We also had a conversation about moon dust itself because he had a mild allergic reaction. Okay. A mild allergic
That's
reaction.
something you wouldn't think about. I mean, you probably can't prepare somebody for that if you don't have the elements from wherever.
Right. And so, and the guy that, there is a guy that actually took the moon suits, took the moon rocks, the moon dust, all this, the lunar, it's not soil, but lunar regolith is what it is. Because soil would have organics in it that could, but anyhow, he had such a bad allergic reaction that he had to stop doing the job.
That's pretty bad.
Yeah. So, all you people out there that like to be moon colonists, you need to go see your allergist first, okay? Because it could be kind of nasty. And I think that the dust on the moon is going to be really one of the biggest problems that we're going to have. It's going to get into everything. It's going to get into, you know, if you're making, you know, daiquiris or something, you're going to have some moon dust chopped
moon
up
daiquiri.
moon daiquiris, right? So, and everything's going to have kind of a, you know.
Hey, Steve from Idaho. It's nice that you're with us. Ton says, yeah, but what is the current rocket's mission now?
The current
for
rocket,
the moon. For the moon.
The Artemis mission. Okay, so that's the one that's going to the moon. So they're planning. In fact, it's supposed to come up any day or any week right now. Artemis 1 is supposed to make a flyby of the moon. It's unmanned. Okay, so they're going to send a rocket up there.
Okay.
They're going to send the last stage of it out there, and the rocket that would be flying around the moon, like on the Apollo mission, it's going to do it unmanned. Okay, so they're just going to go through the whole process of doing that. Then there's going to be Artemis 2, which will actually have people on it, but they're not going to land. Okay, that's the next stage. Then the third stage is Artemis 3, and they plan to put a male and female on the moon for real.
Like living there?
Well, like they're going to make a trip there and walk on the moon, like the Apollo mission did.
Because we haven't walked on the moon in a while, have we?
It's been a long time. Yeah, 50 years. So
50 years?
Yeah, last one.
Wow.
Yeah, this year is the last time that we had people actually on the moon.
That's crazy.
Yeah.
That's crazy. I wonder why we waited so
long. Well, we were in something called the space race, and we won the space race. So it was political, right?
100%.
It was political. And so we accomplished that. And once we accomplished our mission, they stopped. Okay. Right?
There was no
back to the moon.
Yeah, there's
again.
no need to strive for that.
We have other reasons now. Okay. There's still a space race. It still is political to a degree, but they now want to see if they can set up camp and stay there for a while. You know?
So Lubo's asking, is NASA going to fly the Titanium Lake?
Fly to the Titanium Lake? We do not know, because I do not know about the Titanium Lake. Will they take footage around the moon? You can bet. Yeah, it's probably going to be in super high resolution.
8K, something like that.
It's crazy.
Our cousins Elon and Jeff will be financing mining operations. Yes, I'm sure they will. Soon you will see the flat earthers and moon landing deniers all over the place. That's true. Yeah, I mean,
there's so many things. You know, and I was just sitting here thinking, you know, I wonder if, you know, how they got the
I think they ought to take all the moon landing deniers, and they should be the first to go to the moon. That's what I think. So.
They're like, no, I fall off the side. No,
I'm good.
I'm gonna fall off the edge of those. But I'm just sitting there thinking, you know, I wonder how the way they were able to get the James Webb Telescope into space. I wonder how much more that's going to open up our exploration, because you know they did that all remotely and so far away.
The moon?
No, the James Webb Telescope.
Oh yeah, it is. That's true.
You know, and it was all done remotely here. So it makes me think, okay, so I wonder how much more that's going to open up exploration to other planets and things like that.
Well, I think it certainly is another major milestone, another step in the right direction. So, but okay, so here's the argument about putting people in space, okay, and going to the moon and going to Mars, is that they say that we need to go and inhabit another planet because for the survival of the human species. What do you think about that? What if we just said no rockets, they don't exist, okay? Do you think that the human species will somehow get wiped out? I mean, we already experienced a pandemic, right? Okay, there could be a major asteroid hit, okay? That could be another one that could take us out. We could annihilate ourselves. You know, we have maybe enough weaponry to do that. I don't know.
Well, I mean, you just don't, I mean, I can't say yes or no because I don't know. I mean, honestly,
it's all
honestly,
opinion.
it's just like, you know, try to prepare for things. Like when they sent the telescope up, they try to prepare for things, but still a speck of dust was going so fast that it hit it, and you can't prepare for everything. So we don't know. We don't know if there's an asteroid, meteor, or whatever flying at us right now at 20 million, 500,000 bazillion, whatever, gonna just take us out. I mean, we don't know that. I mean,
okay, but no. So if that happened, it could wipe out.
It could wipe out.
Could wipe us all out. So is it worth spending the trillions of dollars that it's going to cost? Okay, to set up colonies on the moon and then later to Mars.
I don't see why there's a problem with that. I mean, there's nothing wrong with trying to go to the moon and set up a colony. I mean,
I guess
think
when you
it's
die,
nice
you
to
can't
have,
take your money with you, so you might as well spend it.
Well,
even if it's trillions
but even
of
at
dollars.
that, if you think about all the other things that we go and explore, I mean, there's so many, people that cave dive and all these things, like they do all these things in exploration. And so why is it such a big deal for us to say, hey, we want to set up a colony on the moon? What is wrong with that?
In my book, there's nothing wrong with it. Okay. There's nothing, but there are people that feel, okay, this is the argument. They feel, oh gosh, you're going to spend trillions of dollars going and putting people on the moon or Mars. And we've got hungry people right here on this planet.
We do have hungry people on this planet.
You know what, though? For all the hungry people on this planet, all we have to do is curb how much electricity we use by about that much, okay? Global electricity use. So turn off the lights, use proper lighting systems, turn off those baseball fields, dog parks, whatever, okay, you got light going on like crazy, and take all that money, just that little incident of money, and go feed the whole planet, because you could.
There's a lot of things you could do. There's a lot of things that you could do, like
and you could go spend the trillions of dollars to go to these other places.
Yes, just like I'm thinking of. I actually don't do this, but driving through Starbucks every day. Like I have a friend that goes to Starbucks 3 times a day. I mean, there's ways
3 times a day.
3 times a day. There are things that you can do to feed people.
That's true. That's true.
Steve Howard says he describes in precise detail how the Earth would look from the moon, essentially providing mathematical proofs of
Copernicus's heliocentric model.
So he I really enjoyed
Harold's comment up on the screen.
Today they announced that JWST will be turned to study the new water world found by tests and discovered by scientists at the University of Montreal.
Of Montreal?
Yeah, Montreal. Sorry, I mispronounced that.
Montreal?
I said Montreal because it's real. Montreal is real.
It's really real. Here we go. I'm trying to get up to
I know you have to go. You have to go down. You have to go down to go up. Wait, it's not. Oh, it's here. It's here. You have to go down to go up. Okay, there. Steve Hauser has an actual way more long post than that.
Let's see.
There it is.
I just learned that Kepler authored what might have been the first science fiction story in 1609. Oh, Kepler, the astronomer Kepler. Titled The Dream, not published until 1634 after his death. They should make a movie about it.
That would be cool.
Yeah.
There it is.
In the story, he described an island 50,000 miles up in the sky. The people that live there think the Earth revolves around them. Interesting. The new water world found by tests, that's pretty interesting to me.
Yeah, that's cool too.
Yeah, I'll have to read about that. That's great.
I knew that they had found a water world because when I I think about 6 weeks ago, I watched a TED talk on the James Webb telescope, and they talked, and the gentleman talked about that they had found a water world.
Yeah, they're going to find. So, the thing is, it just seems like whatever we look for, eventually we find it.
And it's interesting because to me, they're like yesterday I was talking to a coworker about I think it was about, I don't remember if it was Jupiter or what we were talking. We were talking about one of the planets and how everything is clouds, and how nobody's gotten on the planet because it's all dust and clouds. And as soon as he said we've sent stuff there, but then it just burns up and dies. And I said, well, how do you know it burns up and dies?
Oh,
like,
he's talking about Venus.
Yeah, that's what we're talking Venus. I couldn't remember what planet.
Oh yeah, it's so hot there that the Russians have sent landers there. They work for a little while, but then it's so darn hot. Okay. That, like, I guess lead can melt on its surface.
Oh, wow.
It's that hot.
Well, not it. The planet, I could have swore it was Jupiter he was talking about. Because he was talking about how, because we found it, because I guess James Webb Telescope just took a picture of it, and it almost looks like everything's moving on the planet. It looks really flowy.
Yeah, so Jupiter is mostly gas of helium and hydrogen.
That's what he was telling me.
With water and ammonia clouds floating in this.
Yeah, that's
okay? So that's going on.
Yeah.
So that, it's, I guess the model, as well as they understand it, it's gas until things start getting to a concentrated state. Then it goes to like liquid.
Yeah, that's what I was seeing on the model.
And then even like liquid metals. Okay. And they say if there is a hard surface to Jupiter, it's probably no larger than Earth.
But it was funny because my joke was we keep sending stuff there and it keeps just like disappearing, blah, blah. I'm like, how do you know there's nobody there capturing it? That was my joke.
Well,
but yeah, it was really, reading this was really interesting to me. I just to think about all those crazy facts that we don't stop and actually think about, because we're always consumed by ourselves.
Yeah.
And not focusing on things around us. And so anyways, when I started reading that this morning, I was like, this is what I'm going to talk about today, because I thought it was really good.
Yeah, that's good. It's refreshing.
It is.
It's good.
Yeah.
Now, Paul is sharing the NASA page here. It says NASA's Webb detects carbon dioxide in exoplanet atmosphere. So this is really one of the things that James Webb Space Telescope was designed to do. And so I think we're going to find a lot more of this kind of thing. So we're just getting started.
It's going to be pretty amazing. Just that telescope's it's going to be amazing.
Yep.
It's going to be amazing, the things that they're going to find and see. So
it's going to make them build a bigger one and send that one out there too.
It's going to get better and better.
That's right.
It's going to get better and better. And then maybe you can afford $150 million.
Yeah, maybe that's
150 or 120 astronauts.
That's nothing, when no one's using money anymore for anything. You don't even think about $1 million because it's enough, right?
It's whatever.
Yeah. Webb captures stellar gymnastics in the Cartwheel Galaxy. Now, yeah, this was out a little while ago, but it's really not old news. It is amazing to see how the JWEST instrument and its infrared can kind of see through galaxies, so it's really cool.
Yeah.
See through all those dust lanes.
Yeah. I mean, the stars that they can see now and things like, it's just been, it's really been neat to see the Hubble, the pictures from Hubble and then the pictures from this and compare them. It's been pretty amazing to see the difference in them. So, yeah.
So tonight we have the Global Star Party,
yes.
Our 103rd Global Star Party. I have to go get ready for it. Okay?
Yes, and that's fine.
Yeah, we have kind of an early login for our presenters, but we've got a great lineup. A lot of young astronomers are coming on, including Libby in the Stars, who has not been on for a while. Deepti from Nepal. She's now gone through high school and is starting to apply for university. She wants to come to school here, which would be very cool. Who else? Connell Richards is going to be on.
Very nice.
And we've got, who else? Dr. Daniel Barth. You did a show with him.
Yes, I'm really enjoying doing shows with
Daniel
Dr.
Barth.
Yeah, I'm really enjoying it. I always walk away just a little bit more, mind going and thinking about things. So it's really good. He really challenges you. It's good. It's good.
That's true. And so, of course, David Levy will be there. David Eicher will not be there. He and I both, and as well as lots of other people, we're all getting ready to go to Starmus in Armenia. And so a lot of prep going on there.
That's cool.
we are preparing simultaneously to go to Armenia. We've got Global Star Party tonight.
Yes.
We've got
Arizona Dark Sky
Arizona
Party.
Dark Sky Star Party and the
Yeah.
Oracle Dark Sky Cultural Festival, which is going to have
Yes.
music and stuff.
Mhm.
When I go to Starmus, I'm going to be taking notes because they've got real, high-end rock stars there, the best minds in the world.
He's going to come back with a lot of ideas.
Man. Yeah, I'm going to come back very mind blown many times over. So.
And then we've got the Explore Store Star Party at the end of September.
That's right. That's right.
And that's going to be our grand reopening. We have Instagram page, Facebook page. Go follow it, like us on there. And then we are going to have the
Mount Wilson Observatory
in October. Mhm.
Yeah.
So we have a lot of things coming up. So be watching us, and we'll make sure we get the word out there and get all that information out there to you guys. So, but yeah.
Great.
So,
Anything else? Any other crazy fact you want to throw out there before we leave?
I have no crazy facts. I'm all crazy fact out.
That's right.
Treat a moon telescope like we treat Antarctica. Joint nation missions for scientific purposes.
Moon telescope's better.
Yeah, I like the idea of an observatory on the moon. That would be definitely something I'd want to go visit.
Yeah.
Yeah. So if I went to the moon, if I got to do the trip, okay.
Mm-hmm.
First off, I'd make sure I bring my inhaler, okay, just because,
I think you would need a nebulizer.
Yes, to make nebulas. Okay, so, but I would like to go see. I would love to go see the Apollo 11 moon landing site. Okay, that would definitely be a bucket list thing to see that.
Is our flag destroyed up there?
They think so. There's a lot of radiation. There's nothing, protecting this stuff up there. But the spacecraft will be there. It would be cool to see the first moon buggy that we used up there and maybe turn it on, see if it still runs. I don't know. They probably wouldn't let me do that.
Then you're gonna have to go find the shop on the moon that has like all the stuff to fix it.
Yeah. And then the other landers that are up there that Russia sent up, that we sent up, and stuff like that. That'd be kind of cool to see these artifacts. I wonder if we'll have treaties or something that will protect these things. Because people like to go and tag, and scratch their initials and things like that into things. So I wonder if I guess if you're spending the money to go to the moon.
What would be really interesting? I'm just going to throw this idea out there. Would be really interesting if you showed up and then you looked and it was tagged, but we had not been back there. So who tagged it?
Like with some sort of alien letters or something?
That's not going to happen until they get that Dollar General bill.
Because where are they going to get the spray cans, right? Okay. Well, I can tell you there's going to be something, I think that probably inside the lunar bases, let's say that they build a lunar base in a lava tube. This is a real idea that they have. Because there's lava tubes on the moon.
But wouldn't you be worried that lava would come out of them?
No.
It's not an active.
Yeah, it's pretty.
Are you sure?
Well, it's dangerous enough just going. I think the long list of dangers that might kill you on the moon, lava is going to be way down that list, probably down there with alligators and piranha as well. Right. But yeah, I guess lava did actually exist there, and piranha and alligators probably didn't.
Did you see this is random, but did you see the post where it's been so dry, I think in Texas, maybe that one of the rivers dried up and they found footprints of a dinosaur?
Yeah.
Cool.
Did you know that? Did you hear that?
I didn't know that, but
Yeah.
I do know that because I'm from Texas, and in Boy Scouts, when I lived there, we went to Tyler, Texas, and nearby Tyler, Texas, they have lakes. They're very shallow, with a little bit of water in them. You can see perfectly down to the bottom, and you can see dinosaur tracks going in.
Yeah, that's because it dried up so much that they found dinosaur tracks.
Yeah, there's a lot of dinosaurs in Texas.
That was so cool.
Cowboy hat wearing dinosaurs.
Speaking of Texas, Tyler went to Texas. He's doing a photography class down there.
Oh yeah,
and we were teasing him
at Fort Worth Camera, right?
Yep, and we were teasing him because he took his cowboy boots. I don't think I've ever seen him wear cowboy boots.
Do you have cowboy boots?
No.
I have a pair. I'll wear mine sometime here at Explore Scientific, okay? And I have cowboy hats. I'm proud to wear them, okay?
All right. Well, we better hop off.
Okay. Yeah, I got a star party to do. But thank you very much. Very interesting,
Thank you. Thank
Annie.
you for coming. I
Thank you.
appreciate it. So tomorrow will be Kent. I don't know if he's going to do focus on astrophotography. I don't know yet. But he will be on for Amazon Live. So we will see you guys later on.
All right. Have fun.
Bye.
Keep looking up. Bye-bye.
Oh,
There we go.
there we go. Paula's over frantically mashing buttons, flicking switches, pressing pressers, mousing, goosing mouses, mousing
That
gooses.
doesn't sound like something we should talk about.
He was doing something. So anyway, I've got a guest here on Monday's broadcast.
How often do I have to show up to where I'm not a guest? I'm just a nuisance.
Well, you're
like
a guest.
Your brother-in-law.
You're a guest on this show.
Okay.
Yeah.
Fair.
My brother-in-law is not a nuisance. He's a great guy. Sister-in-law too. In-laws were great people. So
Dang.
you're part of the family.
Thank you.
But you're a guest on the show. I guess 3 or 4 times you become a co-host at some point. Don't know. Dr. Daniel Barth.
Hey, everybody.
He has a new book out.
That's right.
What's that book?
Star Mentor.
Star Mentor. And it's a book that will help anyone do better outreach, right?
That's right. Do better outreach. And I wrote it particularly, Kent, for 2 kinds of people. One, the folks that are out there maybe watching us, and maybe they've got their shiny new Explorer telescope, and maybe they have been thinking about ordering one, and they're clenching, and they're going, but I don't have anybody to help me.
Mm-hmm.
And that's a problem, because a lot of us, we would love to do astronomy. There are millions more people who would like to do astronomy who do not, because they're afraid they won't be able to master it.
That's correct.
They see it as difficult and cumbersome, and there's going to be math. Math makes my wife cry, y'all, so I sympathize. And I wrote this for you, because it starts out, it does not assume anything. It assumes you have a small telescope like this one, or a pair of binoculars.
Or a desire.
Or desire. And it will take you through learning about telescopes and binoculars. If you need that, I put that at the end of the book in case you need it. But you start out and you say, oh, let's start exploring the sky. Let's learn how to read a star map. Let's learn how to spot constellations. Let's learn how to locate things. Let's learn how to track with our telescope, which means to follow an object as it moves across the sky. And let's figure out what we're seeing in the eyepiece. The other group of people, Kent, that I wrote that for, people like you and me.
Mm-hmm.
Because you know a telescope is a party in a box. You go set it up somewhere, and unless you're hiding in your backyard behind a high wall, people will find you.
Mm-hmm.
It's like putting out a slice of fresh apple pie on the porch and waiting for the ants to show up at the picnic.
Yeah.
People will find you. Mm-hmm. And when they do, they go, oh, Kent, you're such a genius. I'm sure you can help me. And
I have a telescope and I can't do this. It's like, you know, you give advice, but until you get them in front of the telescope, their telescope, it's hard to help them.
Well, this book, Star Mentor, you're the Star Mentor because you're helping other people learn, and it gives you the kind of structured lessons, step by step. How do I help these people learn to choose a telescope, operate a telescope, find different things, explore the sky, tell the difference between nebulas and clusters, look at star clusters, what do the colors of stars mean? And it gives you little step-by-step exercises to take people step-by-step through.
Right.
And it gives you a whole year's worth of observing material.
And I can say this, a couple Fridays ago we did a star party in downtown Bentonville at the Meteor Cafe. And there was a couple that showed up, and they had a telescope. They'd seen we were going to be there.
Okay.
And they brought a 114 millimeter telescope from another company and had never seen anything through it. And I said, not a problem. Here's how you set it up. And I talked them through it. Now, here, you do this. And I told them, okay, that's north, and made them set it up and made them put it together. And then told them how to find the finder scope. Didn't have a finder scope with it. So I had to barrel sight using the...
Right. You just use the lugs that hold the tube.
Yeah, exactly.
All the
to
time.
Make a sight. And went to the moon and said, okay, look in there. And he went, no, it's not there. And I said, okay, turn these handles a little bit. And, went, and he was doing, he went, oh my God, you know. And she said, get out of the way, because it was her scope. Get out, elbowed him out of the way. And so showed him how it works and showed him how to track.
Absolutely.
And then I looked over a little while later, and people were looking through their scope, and they were talking about this scope and looking at the moon. And then they wanted to look at something else, and they went off and looked at the star, and just a little bit of help, Daniel.
Just a
little bit of help.
That's right.
And now they're
Turns frustration into joy.
And I told them the key is to use this telescope at least twice a week for the next 2 months.
Absolutely.
If you'll do that, then if you take a break, you're still going to remember how to do it, because you're
That's
set
right.
it up and you used it.
That's
but you've
right.
got to develop that muscle memory.
Right. You've got to learn how to do it, just like anything else, like any other hobby. And I don't care if you're talking about painting with watercolors or digital photography or anything else. Playing a guitar. You got to play it once in a while, otherwise you don't hold the gains.
Mm-hmm.
The other thing that we're looking at here, Kent, is a lot of people get a telescope and they're excited about it. And for the first month or two, they're like, ooh, good, the moon, oh, wow, and everything's new and everything's fun. And then you hit this fatigue point. And you go, but is that all there is? What do I do next? What's the next exciting thing? Show me something to do. And that's where a book like Star Mentor really comes into its own, because it's not designed like this sort of book where you have to go step by step and work your way through it like a bunch of exercises. It gives you a whole smorgasbord of things, and they're designed and laid out by season. So you can go, oh, well, it's high summer right now. Let's look at the chapter on things to do in the summer.
Mm-hmm.
And let's see what constellations are fun to look at, what fun things are out in the sky. I was out looking a couple of nights ago with a pair of binoculars, and I found Comet K2 Pan-STARRS.
So did you?
Yes, I did. Yes, I did.
Paul was trying to find it over the weekend, and I think he finally determined that there was trees in his way. And I suggested the Explore Scientific chainsaw.
That's right.
Yeah, exactly. It's cut them down. We don't sell a chainsaw. But if you need one, I can sell you one through Amazon for sure. We'll put one up in the carousel after a while. You can buy a chainsaw through. Yes. So
anyway.
Yeah. So okay, let's talk about the comet.
Sure.
You found it in what size binoculars?
15 by 70.
Okay, bigger binoculars.
Binoculars.
Do you think they could find them in a standard 10 by 50s, or would it be so not comet-like?
You can. I worked my way from a 15 by 70 down to an 8 by 42, but you have to understand that where my ranch is high atop Round Mountain out in the Ozarks, I have very nice skies.
Yeah, so Bortle 2, Bortle 3, probably Bortle 3.
2 to 3.
High 2,
Depends,
low 3.
Right, depends on the night and the atmosphere, humidity, all that. But Milky Way is a naked eye object for me.
Right.
Orion Nebula is a naked eye object. And in brilliantly clear skies like that, I went down to an 8 by 42. And with an 8 by 42 binocular, I can peg down to magnitude 9.
So you can see it. Did it look like a comet?
No.
Okay. So
no, it looked like a globular cluster. It was just a little
diffuse nebula.
Slightly diffuse.
Yeah.
It wasn't a pinpoint star, folks. It looked like somebody taking a snowball, throwing it against a brick wall. It was kind of, instead of being a point of light, it was a little bit smeared out. Right. It did not have in naked eye the traditional
Tail.
lovely cometary tail.
And people see that there's a comet, and they expect that traditional lovely comet tail.
They do.
Comet Neowise had it if you looked at
did.
it just right, but it wasn't much of a tail. No, excuse me. People want. I crave. Daniel, I crave
Like Hale-Bopp.
a great comet. We need to invigorate people into science and astronomy.
Nothing like it.
We need a great comet. Now, describe to me what you think of. Great comet is an uppercase proper noun.
Correct.
That's given to comets that are fantabulous.
Yes.
Describe what we're talking about.
You're talking about an object in itself that's probably about 1 kilometer across or a bit bigger. And comets like these come in, they are young objects, relatively.
Maybe the first or second time through.
First or second time through the solar system, because however much water and vapor, frozen carbon monoxide, carbon dioxide, ammonia, methane, water ice, these ices that are on these comets, every time they pass by the sun,
the comet loses mass.
Yeah, many tons of mass are blown away, and the comet shrinks. Eventually, the comet dies and just becomes an asteroid, just becomes a periodic asteroid without a tail. But these great comets, like Comet Hale-Bopp, we don't know if it had been in the solar system at all before. Yeah. And we figured it has an orbit of something on the order of 8,500 years. So it's gone probably for the lifetime of our civilization.
Yeah. So, but we're talking about when you hold a head in the sky, maybe the size of your thumb.
That would be very big.
Which,
That's very big.
Or pencil eraser, but a long tail.
Yeah.
Right? That's how I remember Comets Bennett and West in the 60s.
Yes, I was going to say
70s.
Comet West, yeah.
Was like...
Hyakutake was like that, too.
Hakatake, Hale-Bopp was under dark skies.
Had a good pair of binoculars. It was spectacular.
It was spectacular. And, you're talking about maybe pinky or maybe a pencil eraser in diameter, but this tail that arcs for feet across the sky. Right. I mean, fantastic imagery. Something that when everybody walk out and goes, oh my gosh, there's a comet, right? Whereas Neowise, if you weren't looking for it, you'd never notice it was a comet. That's correct. I mean, honestly, you just go on and think it was a jet or something, a contrail way far away.
Right.
I love those comets because it keeps people talking about science and astronomy.
It does.
But it's also disenchanting when you find it and go, that's it? Yes, sorry. Hello, Kent and Daniel and all.
Okay.
And I know Pekka had a couple of comments. Hello, get here so we'll all be happy. So, they just showed up, Paul.
Let's learn how to walk around at night without tripping over my telescope. Okay, Mike, there are a number of products, and they are not made or marketed by Explore. If you email me, I can give you some references. I have a red LED light with a magnet on it, and it magnets to the bottom of my tripod. And once it does that, it illuminates. I know a lot of people have gotten little battery-operated LEDs, just little dim ones, and tape them to the bottom of their telescope legs. I've done that. I feel your pain, Mike, because teaching astronomy, students do this all the time. Oh, I want to see, boom, and they're not watching. They're watching the eyepiece, not where the legs are.
At public star parties,
oh yes,
I will use red LED Christmas lights.
Yes,
they come in they'll take 2 or 3 AA batteries.
Yes,
and they're a little bright, so you can just pull out every third or every second bulb or something and dim them down. And I just literally run a triangle
around the
legs and going down the road. Out at Hobbs State Park, where we do star parties, I have taken them and put them along where the curb is, so people can see there's a curb here.
People see there's a curb there. Don't trip.
But again, I tell kids, don't run.
No.
Don't run. It's the dark. And the problem we face is people having to, using their flashlights all the time. Okay.
Oh, yes.
Connor Bradley from England. Hi, Kent. The heat is tremendous. I got my scope inside. They're really warm to the touch. What's the best recommendation to keep them cool? It's 32 centigrade. Will the heat harm them?
No.
32 centigrade is going to be 105.
No. 32 centigrade's about 88 to 90 degrees.
Is it 88
Fahrenheit.
to 90? Okay.
Yeah.
But not going to hurt them any?
No.
We face that all the time. The problem is they're facing a heat wave in England.
They are.
And like 5% of the houses have air conditioning.
Oh, yeah.
And so they're getting...
My sister lives in England, so...
She's getting hammered?
Yeah.
Yeah, by the heat.
She says it's going to be 100. It might hit 100 here. And I said, well, we call that Tuesday.
and this week, Tuesday and Wednesday and Thursday and Friday. I think I saw, looked a little while ago, 104, I think, is the
Connor,
Fahrenheit.
these temperatures will not harm your telescope. Here's the issue. As soon as it starts to get sunset, set your telescope outside.
In the shade.
In the shade, so that it begins to cool off. Because the real issue is, as your telescope mirror cools, it contracts.
Or front element, not...
Either one.
He's got a refractor, so glass
He's got a
elements.
refractor.
Same thing, though.
Same thing. There's two issues. The glass changes shape slightly as it contracts, and you won't get the best image. The other thing is, if you've got hot air in your telescope tube, that hot air can roil with air currents. And if you have a refractor, if you set it horizontally and take the diagonal off, and that way the hot air can drain, rise and go out of your tube. And when you're ready to use your telescope about an hour after sunset, it should be at ambient temperature, and your view should be nice and sharp. People with big reflectors, big Dobsonians, 10 inches and bigger, find this is true. And the old joke is, tell me if I'm wrong, the best view through a Dob is after midnight when the mirror has had a chance to completely cool off.
You know, big mirrors...
They take a long time. They do.
time.
It's a lot of mass.
Maxudo of Cassegrains and Schmidt Cassegrains take a long time to cool off too, because that corrector plate on the front is a lot thicker than you think it is.
Yes.
And it's heavier than you think it is.
Yes.
And it holds heat and has to dissipate heat. But here's the deal. I don't worry about it.
No.
I just, if my telescope's been out in the trunk of a car or something, okay, I worry about it. But you know what? I don't sit there and wait 2 hours for it to cool down. I put an eye, as soon as it gets dark, I put an eyepiece in it, and I go on down the road. And look, if I'm doing outreach, and they see Jupiter, they see Jupiter, or the moons of Saturn for the first time, those people don't know there's currents rolling through the telescope. They don't know.
It's different if you're an astrophotographer, if you're someone who's worried about precise image quality. But even then, with the frame stacking technology we have today, it's not the issue that it was 10 or 15 years ago.
But again, if you've got the opportunity, take it, set it outside.
Go have a ball.
One thing that I've done before is put a white trash bag over it, right?
Yeah.
Put a white trash bag with some holes in it so air can get in and out.
That's right.
But that white will help, or a white sheet. A white bed sheet will work.
White bed sheet works
because it doesn't attract the heat like it does. If you can keep it in the shade of a tree, anything you can do to keep it out of the sun.
Correct.
And then as it starts cooling down, it's just going to slowly cool off.
That's right.
You know, hopefully the air temperature is going to cool down and not stay up in the 90s, but that happens. And if it doesn't, you enjoy a sweaty night at the telescope eyepiece.
Ignore those people who say put your telescope in the refrigerator before you observe. They're just silly.
So, Pekka, and this is something to discuss. I got my diagonal smoking when projecting the sun on the ceiling. He was using eyepiece projection to project an image of the sun.
Buddy, you got to be careful.
And well, he realized it, you know, and he's not. I don't think it was a super expensive.
That's good.
So, you know, generally it's not going to be a problem, but when it's a problem, it starts smoking.
Can we point this towards the so we can see the end?
Let's talk, Connor. Could I buy cooling fans for my scope if I knew the correct fittings? It's a Skywatcher Dob.
You can.
You can cut a hole in the side of your telescope right above the mirror. I would take the mirror out to do this, Connor. And
yes, please.
Like the 12-volt.
Yeah, the fans they sell for computers.
Computer cooling fans?
Yeah, you can buy them anywhere. Amazon has them.
You can cut a hole on one side and put felt or something over it, you know, air.
Cheesecloth works great, or air filter.
Air filter.
Air filter. You take apart a cheap box air filter, and you can take that fabric and use that.
And you make a little frame sticking in so the fan is pulling air across the mirror.
Right.
Put the lens cap on so it's pulling cooler air across.
Correct.
And you want to pull it, not blow it.
Right.
If you've got a place for it to come in. Even if it's coming down the tube, You want to pull the air across the mirror, not blow it across.
Correct.
And
Many
so,
people with Dobbs put their fans behind the mirror so it blows on the mirror that way.
Our truss tube Dobbs actually has
Yes, they do.
one that blows in and one that pulls out.
Yes,
The
it
one that
does.
blows in is filtered on the front. That's why you don't want it blowing in, because you got to
You don't want to suck in dust and deposit it on your mirror.
or blow it across your mirror anyway, because
No, either one.
ionic attraction is going to stick to it.
Yep.
And now you got to clean it. So don't clean your mirror. That's the other thing. People see a little bit of dust or something on the mirror.
They get out the Windex and the paper towels.
Just look. Don't clean your mirror. I have had a Dobsonian telescope for 22 years now. Daniel, you know how many times I've cleaned the mirror? Goose egg. Zero, zilch, nada, nunca, none.
I will
Have
tell
not
you,
cleaned it.
when I was teaching astronomy in California, I had a fleet of 6 and 8 inch Dobsonians. I don't know, I think I had about 10 in my program, and these were used primarily by students, teenagers that did not own them. You know how good teenagers are at taking care of equipment that they didn't buy.
Yep, we got to move the table over.
They basically, those scopes were still working fine. Now, I was working in the low desert where it's extremely dusty, and I did clean and collimate my scopes annually. But if you're not a professional, just do yourself a favor. Don't do this. You're not going to see enough change to make a difference, and you may very well damage the coatings on your mirror, and that's an expensive bother. You have to, if your mirror is damaged.
The dust does not matter. Paul, what you got?
I think the best example was when somebody's mirror got shot.
Yeah, McDonald Observatory in 1971 or 72, one of the telescope operators or assistants had a slight break with reality, and so he went and got his 9mm or his 38. I think it was the 38, and proceeded to unload the cylinder into it and reload it, and then unloaded more until he got tackled. He put nine holes. I think it's 9 holes in the mirror.
9 bullets in the mirror.
And they thought, oh my gosh, the mirror's destroyed. The next night, they were out of service for one night. The next night, they did some testing and discovered that it was far less than 1% degradation.
That's right.
That telescope is in use today. It has,
with the bullets in it.
It has bullet holes or cones, and just shatter cones. And it's going down the road. It does. It
put a little liquid pitch in the holes.
Yeah, a little dust does not matter. A lot of dust does not matter.
You can sneeze on it by accident.
I would want to, sneeze a few times would be a challenge because, but dust is not going to do anything. All right, so.
So we're talking about solar observing and our good friend Pekka and his smoking hot diagonal. I'm going to come around here. This is what they call an offset mask. When you take this out, what this does is it reduces the effective diameter of the telescope by about 1/4.
Is down like a fifth.
About a fifth, down to about 20% of its original. The thing is now, this will effectively make your telescope a longer focal ratio instrument, and you're not, Pekka, getting as much heat energy.
So one thing, and with a Newtonian, I try to put it 90 degrees.
Right, you put it in between.
You can put it in between.
In between the two
put it
supports.
one place or the other.
Yes, absolutely.
So I'm going to put it right there because I know where it is.
There you go.
And you can't tell it.
No.
It's not, you don't see it.
And you can make something like this out of a bottom of a pizza box.
I have done it.
Tape it on with duct tape.
We were doing a lunar eclipse at Northwest Arkansas Community College up front.
Sure.
And it was so bright, it's like poking yourself in
It
the eye
is.
with your finger. And so one of the students went in and found a manila file folder. And I literally I had a 8-inch Celestron. I literally just with my knife cut out 3 circles and just folded it over and taped it on. Not a problem.
Yep.
And cut the light down by, I figure, 2/3, something like that, and it worked fine.
A lot of people do the same thing when they're looking at a bright moon more than half illuminated.
Bradley apologize for asking so many questions, and I don't think
No.
you asked too many questions.
Yeah. Never apologize for asking questions.
Hush.
Connor.
No.
He says, mine is a bit dusty, but it's not affecting the view.
You're right,
When
it's
I've been
not.
Yeah, we can see him, Paul. Connor, I'm telling you, I know people that are OCD, they clean their front lens elements every time.
Yeah.
I have my own OCD tendencies, and I will tell you what they are. I eat things like M&Ms, have to be in units of 4. If somebody hands me a handful of them, I sort them out by color groups as best I can. If there's one extra, I eat it. And now I have 3 groups of 4 sorted by colors. Eat green peas, don't matter because those are like a bulk food. But things like candy and peanuts and things like that, really, I also, and this is a weird one, I had never thought about it until somebody said it to me. And I was like, they said, so do you listen to the radio volumes by units of 4? And I was like, darn you, because now I have to listen to the radio volumes by units of 4.
No, I don't do that. But
yeah, don't worry about being
generally, friends, you keep your telescope covered up and the tube closed when you're not using it. I just had a question this weekend. Somebody said, well, I was cleaning the objective on my Explore refractor. And I'm like, oh no, this isn't, it's one of those, you hear the violins and it's not going to come out well, like in a Hitchcock movie. And he said, I took all the lenses apart and I got them all shiny clean with Windex, and now I don't know how to put it back together.
Yeah, this is on Facebook.
It was.
Yes. So this gentleman literally took his lens cell apart.
Don't do that.
And didn't. Okay, if you're going to do it, talk to somebody, index them, put a pencil mark on, right?
Yeah,
index the direction, because they have to face a specific direction. And we don't know. We're going to take one apart for him this week, get a junker back here that's got a crack in or something, or has bad astigmatism, and we're going to take it apart and try and figure out if you can tell, because it's a crown glass, it's either a flint and crown or crown and flint. I can't remember which comes first.
I don't.
And then a
I'd have to look
fluoride
that
element. But we're going to try and figure out which one is which, see if we can identify them and give you some guidance about how to put it back together.
Right.
Because just don't
do that.
Don't take it apart.
I can tell you I've done a lot of cleaning and repair work over the years. And when we did this, we would be taking pictures. We would take things out and we would mark the edges of the lens with a fine point permanent marker, element 1, element 2, element 3.
And an arrow.
And an arrow showing which way they go.
Actually, I did one that the telescope we got from Swarthmore College.
Right.
The 6-inch f12 finder scope. 6-inch f12 finder scope.
Yeah.
That's the finder scope. How big is the telescope, you ask? 2 feet in diameter by 36 feet long. It's a 24-inch f18. It's a wee little big. So anyway, when we took it apart, we did exactly that. We put a 1 and a 2, and then we drew
the arrow.
We didn't draw like a line with an arrow, but we put a obvious angle notch.
Right.
That's out.
Right.
And when we did it, it was like we were handling nitroglycerin when we did it. Clint and I were so scared to do it, but by golly, we did it. Now I had no problems doing it after the first time, but just don't take it apart.
Don't.
We had to take this one apart because it was a wee bit dirty. You couldn't see through it. That's how bad it was. So, all right. Anyway, so you have your show coming up.
I do.
At 4 o'clock on the social media broadcast.
Correct.
It's going to be on
the discovery of Neptune.
The discovery of Neptune.
And what does it mean if you discover something?
Right. So there was a lot of people who saw and documented, including Galileo. Galileo came very close to being the first person to document this as a planet. And he even showed it moved a little bit on the drawings that match up. He did very good sketching and specific nights. And we can go back with planetarium programs to that night. And Neptune is in exactly the right spots in his drawing. And from one night to the next, he actually measured it. It was moving a little bit. Telescope was not good enough to discern that it was an area had a disc.
A disc, right.
Had a disc instead of a pinpoint. Otherwise, he would have discovered it purely by accident while observing Jupiter in like
1612, 1610
or something like that. Yeah. So, but you're going to talk about that as well. So I don't want to give
Absolutely.
away the storyline. We'll talk about it more. What time is it, Paul? Okay, so real quick before we go, if we got time, don't ever think you can pull this off and then look through the telescope at the sun.
Oh, Lord.
You will blind yourself. You can put solar safe film over this and do it. But do not ever think you can just pop this off and go, oh, I'm going to cut down the light enough that I can look through the telescope. Don't do that.
You will injure yourself. And the thing is, your retina has no nerve endings for pain.
So, Ralphie, you'll put your eye out.
Yeah. You will be destroying, you'll be damaging your retina before you realize.
There's no way to heal it.
There's no way to heal it.
All right, we got to go. We'll be back. Patriot, Dr. Daniel Barth. His show is How Do You Know? On our social media blast. It comes on after a while. This broadcast is the Amazon live broadcast. So we're going to be talking about some products here. We have a chat function up. And if you want to say howdy to us, you can do that or ask questions as well.
Happy to hear your questions, friends.
Well, the questions make this a whole lot more fun for you and me.
Yes.
Because otherwise, if I'm up here just, bloviating is probably a little bit strong of a term, but if I'm up here just talking for an hour, it gets dull and boring. I love the challenge of questions.
Yes.
Because
you don't want to feel like a carnival barker getting people into the sideshow.
Exactly.
You want to be of service to people and help them out.
That's why I try hard to make our Amazon Live broadcast an educational platform.
Absolutely.
Not just buy this and here's how much. Buy this, these pretty earrings. Here's my makeup. Here's the lipstick I use. Which frankly, that's what most of the shows are. If you go to Amazon Live, we don't do lipstick. However, we actually do have some Vixen jewelry that we got from Vixen when we got there is Vixen telescopes. Optics makes apparently some Vixen jewelry that we just haven't put up on the website.
Oh, of course they do.
So I guess we do sell jewelry. Actually, we do sell some pretty stuff though, Daniel.
We do sell many pretty things.
Here's a really cool pretty thing that we have. It's up in the carousel on Amazon Live right now. This is the Explore Scientific radio control clock. It's an atomic clock. Sets itself to WWVB, which works in the United States, Canada, and Mexico. So it's always accurate. Runs off of a single AA battery. This one's been running for, I don't know, 5 months now, probably, something like that.
I've got to get myself a new one. My old atomic clock is so old, it has a specialty battery that you can't get anymore. And one of my viewers noticed, hey, Doc, your clock's wrong. I'm like, yeah, I know.
Golly. So you could just pull the back out and rewire it, and it's a 1.5 volt battery, right?
I suppose.
That'd be a fun little science project.
It would.
But sometimes you could just buy this for $32.99 or whatever it is and have yourself a pretty
Mine's not that nice.
Clock. This is a pretty clock right here.
Mine is not
very
that
pretty. You can talk about your show people in your office or home that you love. Explore Scientific time.
That's right
there. So we do sell a little.
It's telescope time.
It sort of is. Make sure that doesn't fall over. It is sort of jewelry, I guess. All right, so here we go. Huh? What? What? I don't know what he said. I don't know what he said.
You need a new butler.
Yes, I do. So this is the Explorer 1 20 power, which is a low power binocular eyepiece, not a monocular eyepiece.
It's a stereo microscope.
It's a stereo microscope. It's designed to look at stuff from the top. Most microscopes people are familiar with have a prepared slide or very, very, very less than millimeter, very thin slice of something that they look through to see
the light comes from the bottom up through.
Right. So this is different. There was one in here. This one looked really awesome under the microscope right here. I'm going to put this up here for you, Dr. D, and let you describe it. So this is a piece of, it says gray rock. I don't know what it is, but hang on.
You got tweezers?
No, I can't get the rock out.
This is made for kids, folks.
Fat finger syndrome. So I'm going to use my key.
There you go.
There we go. All right, Dr. D. I'm going to turn the light on for you.
Thank you.
So he's just going to move it around until he sees it in there, and then he's going to...
And I'm adjusting the interpupillary distance so that it fits my face.
And there's one of these faces that I got. I think it's maybe... There we go. That's the one right there.
Oh, I think this is a piece of quartz.
It looks...
I'm not a geologist, y'all. That's just my... But the nice thing is with this type of a telescope, not only can you adjust the interpupillary distance for everything from full adults to very young children, but when you look at this, what we call the plane of focus is fairly thin. So you can dial it. You've got a rock that's this big, and you can dial the focus up and down to look at different parts.
So that's what I like about this one. It has a fairly flat surface, which it gets. Do you see the iridescence in there?
Yes.
Let me turn
I'm having
the light
fun.
off. Just go. Does it show up in the studio lights? I can't remember which way.
It does not.
Okay, so it
Not
has
as
to have
well.
that LED on. There we go.
The blue one, that's the one that did.
Oh, this one did too. I can see it from. I can see it from here. Let me ink pen this time. Well, that's going to help.
What'd you do now, Ken?
He chewed the little
No,
nubbin off of
no,
his...
it's made that way. There's no. I can't chew a pretty perfect point like that.
Well, so you say.
He's always breaking something.
So.
Oh, this is great.
That is these are all jumbled up. That's not quartz.
No,
I can read
the
these.
wrong color. Have a peek.
Oh yeah, look at that.
I wish we could take y'all down through the microscope eyepiece to see what we're seeing here, because it's spectacular. The nice thing about a microscope like this, everything, you don't need prepared materials. Everything is fair game. Kid can go out in the backyard with this. I want to look at a leaf. I want to look at an ant. Oh, look, here's a piece of dirt.
Here's a butterfly wing.
Here's a butterfly wing. Oh, those are spectacular. And you can just put all sorts of things. Insect life on these are amazing.
We've got a picture of a bee. Paul probably can get up.
You can see that bees do have 4 wings, and you can look at the hairs on an ant.
The eyeballs.
It gets so close, you
on
can
a
look
fly.
at the eyes.
Yeah, absolutely.
Yeah, you see the eyes. Now, this is 20 power. It's not high magnification.
No, it doesn't need to be.
So the depth of field is actually thicker. That's the plane of focus is actually thicker than on a biology microphone.
Oh, heavens, yes.
Where it's thousandths of an inch thick. I mean, the focus is very, very precise. So this comes with a number of samples here of rock specimens. Daniel has clips on it too.
So you can hold a specimen down?
So you can hold a specimen down.
Oh, you got slides.
But it also comes with some slides that, here is the German, see if you can pronounce, see if you know what this is, the Stubenfliege Kopf Total.
Short wing.
Fliege.
Is that short wing?
Stubenwing. Fly.
Okay.
A Stubenfliege. Flyhead. Kopf. Head. Total.
There you go.
So we're going to slide this in. Now this is a glass slide, so I want to be a little careful. I'm going to loosen up the springs just a little bit so we don't break it.
Yeah, don't break your toys.
Glass slides will break. The plastic ones generally won't. So there we go. Take a look at that, Daniel. I've looked through this before. Here, let me take the springs off completely.
No, it's okay.
Did you move it?
Oh yeah, you can see his. Oh, you can see the hairs. You can see the tongue.
Yeah. And I can't tell if I think this is a slice.
Yes.
I don't think this is a whole smooshed fly.
No.
It doesn't look like it. Yeah. It's not smooshed. It's been probably frozen.
Frozen and sliced. And by somebody who knows what they're about, too.
Frozen in probably carbon dioxide, and then
something
sliced off, and then the carbon dioxide evaporates, and you got a Stubenfliegen.
Look what
you
I
can
found.
see the hairs underneath the wings, and it's pretty spectacular.
What'd you say, Paul?
Look what I found.
Oh, look what he found. That is an American penny. So to give you an idea of what 20 magnification looks like.
There you go.
There you go. That gives you an idea of what 20 power looks like. If you got an American penny, and there's old Abraham Lincoln's head.
Yep.
So it gives you a real good idea of
what
you can do with this microscope.
That's right.
I would have loved, Dr. D, to have this when I was, 10, 11, 12-year-old out in the world, knocking about and looking at stuff and looking at rocks and looking at, butterfly wings, bugs, beetles, leaves. You're only limited by your curiosity.
And this is a very well made, for parents who may be looking out there, this is very well made. This is it's a metal and polycarbonate body and steel springs and a steel shaft. It has a nice rack and pinion focusing system, and this is rugged and robust. It's not that it's unbreakable when we talk about children and anything. That's silly, but
anything, sir,
anything
is breakable.
But it's very rugged and under any sort of normal use, and it does have its built-in light. It's a very nice system, and it has there's a place for a battery underneath for your little LED, and with that tiny LED, I don't know that you ever have to replace that battery.
If you turn it off,
it would last for a long time.
It's probably going to start leaking.
It'll leak
3 or 4 years.
Yeah.
Before, if you turn it off and you're not using it, it'll leak before it goes dead.
Before it goes dead, yeah.
All right, so we're going to look at another microscope. This doesn't have German on it, so I'm not going to try and stump you with German. This is the Discovery 900X biologic microscope.
This is comparable to what you would see in a middle school or high school classroom.
Right. This comes with a great carrying case. As you can see, it's got almost said the telescope. The microscope, a hatchery where we can hatch our brine shrimp.
Brine shrimp.
Which when
sea monkeys.
When you and I were kids, sea monkeys. We need to find a sea monkey ad.
We do.
So that Paul can show it. Okay, we got Paul. Look for sea monkey ad and get one so we can show people that don't.
Do you know the copyright person that I can use? That call it.
Just search for sea monkeys and show it.
It's an advertisement. They didn't copyright it. They put it out there.
They put it out there for everyone to use.
That's right.
A petri dish, a cutter so you can make your own. Comes with red food dye and blue food dye. These are food dyes. You can eat it. If you want to make a birthday cake out of this stuff, you can do it. It's not poison. You're going to be fine. Paul, do I need to come forward to get focus or back? Because it doesn't look.
Okay. All right.
All right. So, also has sea salt, so you can make some sea salt crystals. Move forward. Some sea salt crystals. You can grow your own crystals. Brine shrimp for the hatchery. Some tweezers, beakers, little vials, some manipulation tools, and right here are the 7 prepared slides. We're going to go ahead and pull these out, and I'm going to pull out the microscope, and we're going to let Dr. D talk a little bit.
Very traditional with microscopes, friends, and I'm not sure if you can see this here, but we have underneath there is a mirror, and on the other side is an LED light. Actually, if you have sunlight is going to do a much better job for you than the little LED. For a variety of reasons, it's full spectrum. LEDs are not. And this mirror, and we've got lots of light in here with the studio. And
sometimes I can find the mirror and sometimes I can't.
Yeah, well, how's the switch on this work now?
Just keep going around. The LED comes up and it comes on. Right
Oh,
there.
it's positional.
Yeah.
Oh, that's nice.
Yeah, it's a positional switch. Absolutely.
And then
There's
you
the
can
Sea
look
Monkey
through
ad
and
on YouTube.
you know when you got it because you see.
Hang on, Sea Monkey ad's coming up.
Oh, Sea Monkey ad.
Yeah,
Oh, there it
that's
is.
the ad.
$1.25.
Yeah. Sea
You
Monkeys.
never get them back. That's the one I remember from the comic books.
Yes.
And I've sent off my money, returned
never got 'em?
envelope, never got them.
Well, that
Oh,
was
I
the Postal
did.
Service.
I
My parents are like, you're not buying sea monkeys. That's not what they look like. Go outside and play in the heat. Okay. I went outside and played yeah.
And then you went and saved your quarters and.
Nah.
You didn't?
No.
Oh, I did.
No, I didn't.
I did. I mailed off and checked the mailbox every day.
Look, my dad was, I mean, I was using power drills at 5, jigsaws at 5, and I think I was probably 7 when I started using circular saws. Sea monkeys got outside of my wheelhouse fairly quickly. Because, I mean, Dad was like, be careful, it'll cut your hand off. Okay, that's enough training. Off we go. Yeah. Just go do it. Here's how it works. Yeah, I was running a linotype at 6 and 7, a machine that has molten lead squirting out of it.
Well,
and my dad was letting me play with that.
Being the physics instructor, when my boys said, "Wow, that's cool," they would watch Mythbusters or something, and they would say, "Oh, could we do that?" And I'm like, "Sure, let's go to the garage."
Yeah. So Dad walked down the back porch one time. He says, "Oh, you're making gunpowder. Good." Turned around and went back in the house. We were 13 years old. He's like, "Good, you're making gunpowder." And he's just that's the way to get today.
Oh, you can. Yeah.
You can, but don't let people get caught. Don't tell people your kids are making gunpowder because that marks them as somebody that needs to be on a watch list.
Oh dear.
Yes. So anyway, all right. So this
Well,
is
we
designed.
can't wear our shoes on airplanes.
Exactly. That's why I have to take shoes. No, that guy was a moron. We didn't. We
That's
never,
what I was saying.
We never would have thought about using it for evil intent. We were using it for fun intent. Yeah, for fun. And it was fun.
It was.
Made a lot of smoke, though. Made a lot of smoke. Very not smokeless. Very smoke powder. All right, anyway. So, got the microscope. You got the light on. Here's a slide. Go to it. Oh, talk about the turret real quick.
Right. We have a turret up here.
Turn it up a little
turn
bit.
that
Maybe
up.
see that a little bit better.
What the turret is for, friends, is the turret rotates different magnification eyepieces. Objective lens in. This one is 400x. And it starts and it goes all the way up to 900x, which is really quite astonishing. So it has a 900 objective, it has a 400 objective, and it has a 100 objective.
So Dr. D, I want to see that super magnification. I want to start there, right?
No.
Oh, but I want to see
No.
that.
No.
But
No.
start.
No.
Why not?
It's a true thing. You always get the best view at the lowest power. That'll show you what you want to see. Number 2, lower powers have sharper, crisper, higher contrast views. Number 3, just in terms of finding your target. Searching for your target at 900 power is like trying to read the New York Times through a soda straw. Your
From
field
10
of,
feet away.
your field of view is so restricted
Right.
that it's very difficult. You use low power. Oh, there's what I want to see. There's the fly's eye. There's that part of the rock I'm interested in. There's that cell that looks like it's dividing. And then you slowly, after you see what you can see at low power, you bump it up, and then you bump it up. The other thing you have to make sure of to do here, friends, and I don't know if this is a problem with this microscope or not. This one's pretty well designed, but in any
Are you
case,
talking about striking?
yes.
No, it's going to get real close, and so I don't think it strikes. It's very, very close. So let's play with it.
Sure.
Here is an onion bulb epidermis. Now I'm giving him this because he just mentioned. I was giving him the Hydrilla verticillate leaf, which is just a leaf, and you can see the cells in it. I'm giving him the onion bulb epidermis, which means the skin
of the
onion bulb. That's the part that grows the fastest.
Right.
To grow, you have to have what? Cell division. There you go.
That's right.
So
and
I took the one 107 out, and I took a 24.
There's a 102,
eyepiece.
Paul.
102, sorry.
There you go.
I'm not a... Anyway, so I got the 24 eyepiece.
Slide it down more. Yep,
And
all the
if
way
I
down.
would have been working with the 14, I would have never found this weird nebula that I found, or whatever it was. I still don't know what it is.
Yeah, but so, you know, low power is the way to go. People get a telescope and they want to go to the highest power it can go to because that sounds the more bestest, but that's not the way you do it. So Dr. D was having trouble finding it. I could see that he didn't have the sample on the hole in the stage. The stage is that flat area where you put your sample, and I moved it to the hole in it where the light's coming up. And he's like, oh, there it is, and he focused on it. Now, I will tell you that people with this microscope focus way too fast.
Very slow, friends.
So Dr. D, go all the way down and start. So he's all the way down now, and he's going to turn it. And it's going to come to focus about now. He sees it in really sharp focus. That's it. So you turned it a 32nd of a turn. People will call and go, it's not working, I can't see anything. And I'll say, I want you to focus all the way down, put the sample in the middle, move it around. Do you see red? Yeah, okay. Now then, focus as slowly as you can without actually turning it. Or with actually turning it. Turn it as slow as you can. And it comes to focus real fast, right?
That's what Annie did the other day. She was up there fighting with it, trying to find stuff, and I'm just sitting here watching the screen because, you know, I've got my back to you. Sitting here watching the screen going,
focus slower.
I finally got up and said, let me do it for you.
Focus
like,
slower.
Why?
It's a mistake people make. They think it's going to be like a camera where you see it coming to focus from a long ways off, and it comes to focus and goes past, and you got to turn it a whole bunch. No, it comes to focus really fast. All right,
and goes out of focus.
And once it's out of focus, past focus, you don't see anything. No. It's just gone, right? Yeah. And so if you're focusing, there's nothing there. It's not working. It's working. You just like anything else, you're not working it right. You don't know how to use the tool. All right, so Daniel, do you see any cell division in there?
I think I do. I'm looking in here and I see a cell, and you can look and have a peek. There's a cell with a distended area in the center, and I think that's what we're looking for. And I'd have to go higher power to be sure.
Yeah, it's that. And it's just to the left of center.
Yeah,
right? And it's a round thing. All the others are.
The cells look like bricks, irregular bricks.
They look like long bricks with a point on each end.
Yeah.
And so, but here's two or one that looks like it's a circle and a blob attached to it. So it looks like it's breaking off. So
and they have materials in this kit. You can make your own slides. Get yourself a fresh onion and just that real thin, transparent.
You mean the onion skin?
The onion skin that comes between layers.
That's why it's called onion skin. Yeah.
And you go ahead and you put it on there, and you can look and see what you can see.
Let's do that next week.
Yes, and then you try staining it with some red stain and some blue stain, and you can get amazing stuff.
We can. I'll work on that. I'll work on getting some onion skin and make our own slides.
Yes.
Yeah, and I want to experiment with an eyepiece camera, see if we can figure out a way to hook up a live view here.
That'd be
fun. So cool.
We've tried.
It's so cool to
smaller than
there's
most
a way.
Cameras.
We just need to get Alex to 3D print an adapter, or cut this off right here so we can make an adapter that goes on it.
We have one. We have a microscope that comes with a camera that works fairly well.
But I want to prove that this inexpensive microscope is hunky-dory, not, spend $89 on one, spend $29. Now, we didn't talk about that.
There you go.
So right here is a filter that you can use different colors of light on.
Correct.
And so you can see it right here. It's
clear,
green,
red, and blue.
And another clear one. And then some smaller holes.
Right, the smaller holes are to restrict the aperture. That's exactly
down a little bit.
Sorry. Yeah. Smaller holes restrict the aperture. That's exactly what we were talking about over there with restricting the aperture of the telescope. And it restricts the amount of light, and it helps you to see what you're interested in.
And the colors add contrast and they highlight right. some things and make other things disappear.
You've
so
done
you
these things when you were a kid where you held a little red cellophane to your eye and you saw one picture, and then you swapped to blue cellophane, you see a different thing. And why can't I see the blue lines with the red? Because those colors are filtered out.
Right.
And it's exactly the same thing here. The colors filter out some things and let you highlight and see others. And again, this is kind of a try and experiment sort of a thing. You've got to put the filter on there and take a look and see what you can do.
Okay, that one's missing one because there's a green one that's missing.
Okay.
So that extra hole that's just, so that's green light. Oh, look at the difference.
Oh yeah, it's quite profound. Especially with staining, folks, because some things in the cell will pick up red stain or blue stain.
Yeah.
And if it's picking up red stain, you're going to see those features through a blue and a green filter. If it's picking up blue stain, you're going to see those details with a red and a green filter.
Opposites attract, so to speak, I guess.
Transmission of light.
Transmission of light. All right, so the device comes, the kit comes with a downloadable experiment book.
There you go.
And that you can, tells you how to grow the brine shrimp and the salt solution to make, and how to grow salt crystals. I mean,
Correct.
It's really a really nice book that you can download and print in whatever language you need it to be printed in.
That's right.
What else do you want to talk about?
Annie is mad at me.
Well, she's joined the club, Dr. D.
Oh, I actually had the color wheel on the smallest hole, and that's why I could not see. Oh, all right, Andy.
That would be...
It's very much like everything else with optics. If the smallest aperture doesn't show you something, dial up to the next larger aperture.
Let in more light.
Let in more light.
I just want to say, okay, we'll go with that.
She's going to come in here and whack you, buddy.
You have to... It's science, and the nature of experiments is we don't assume what we're going to get. We're trying to find out. And one of the ways we find out is we try different things. So with every specimen, you want to try the different aperture holes, spin the wheel slowly, and don't just go click, 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 click. That's not what you want. You want to click that into a new hole, and then you want to take some time, move the specimen around, take a look, see what you can discover, take some notes, then switch to the next setting, and again. And it's sometimes if you find an interesting area, try it with the whole sequence of colors and apertures.
And take notes.
See which one worked best for you. Write it down.
Write things down. Now, you got to remember, science is sort of like baseball. Baseball is about mastering your failure. Science is about mastering failures, or learning from failures. Because if you failed, you did learn something from that, right?
Yes.
And so if you take notes of what failed and continuously take really good notes, you might start seeing success somewhere, or those failures may point towards some success somewhere. And
I've got to tell you, as a science teacher and as a professor who trains science teachers, one of the things that really bothers me is this sort of a canned experiment that we get in school. Okay, put solution A in the beaker, put solution B in the beaker. What color does it turn? Write your answer in this little bitty box.
Green. Now dump this in and stir it around. What color does it turn?
Yellow.
Yellow.
Yeah.
Okay, science.
No.
That's
Science,
baking a cake.
That's baking a cake. That's Betty Crocker, and that's fine, but it's not science. Science says, what's going to happen? I don't know. Here's what I think's going to happen, and I write down what I think will happen.
And that's called a
hypothesis.
hypothesis.
And you write down why you think so. Because if it's just a guess, say so. That's not nearly as valuable if you have an informed idea.
Right.
Well, I saw this before. I think this will be the same, or I think this will be different. And then you run trials, and you only change
an experiment.
One thing at a time.
You craft an experiment.
You do.
And then you run the experiment.
You do.
And you change one variable at a time.
do.
And you take notes when you do it.
You do.
Because if you're not, Jamie Heineman on Mythbusters, if the difference between, have you heard this quote before?
No.
The difference between play and science?
Scientists take notes.
when you're doing science, you write it down. If you're not writing it down, you're just playing around. But if you write it down, you're doing science.
You're doing science.
And good notes leads you to conclusions, right?
Why do you guys get on to me all the time when I'm just like, oh, I saw this, I saw that? And you're like, did you write it down?
Then we'll rely on memory, which...
If it's an hour or a day or weeks later, you know, how many people have been convicted by eyewitness testimony that was clearly flawed because the DNA proved it wasn't them, right?
In a little more kinder, gentler example, in my astronomy classes, Kent, everybody has to turn in their sketches and their lab work before they leave the field. They're not, I tell you, if your notes see the light of day, they're no good.
So if you also have the ability to go home and Google it and then draw it, and you're going to go, gee, that's a really great picture of M13. It looks just like one taken with a 24-inch telescope. How'd you get access to that, Kent? Yes, indeedy. Not that some students would ever do that in college. Never. All right, so what else I want to talk about?
31.
31, okay. Let's do this. Daniel, we haven't talked about this.
No.
Have you seen this?
I have not.
This, ladies and gentlemen, is the Star Maker video kit. Now, Paul's like, okay. The Star Maker video kit comes with a clapboard, so you can record your scenes in chalk at the start, making it real easy. Comes with an LED flashlight. Comes with a blue-green chroma screen. And the heart of the matter is the 1080p HD camera, right?
It's astounding what they can pack into small packages these days.
With a tripod that comes with an 8-gigabyte card, which will hold up to an hour and a half of video, Dr. T. It'll take up to a 64-gig card, which 8 times 8 is 64. That'd be 12 hours.
12 hours of video.
12 hours of video, roughly. Probably more like 10 and a half, but, you know, that's a lot of video.
That's a lot of video.
But look at this. If I'm over there and I want to see what you're doing, watch this. Look at that. And so I can...
B-roll.
There we go. Oh, we got some B-roll up now. Here we go.
There's no sound.
There's no sound with it yet. So we got to look over here to see what's going on live.
Oh, okay. There she is. She's putting up the chroma screen.
Look on his monitor, the top monitor.
Okay. Oh, she's got the clapboard.
Yep. And she's... So there we go. She's just hammering around for Paul's camera.
I was going to have
That's my
Kent do
grandson.
that, but...
Guy in the orange is my grandson.
Like a selfie stick.
Yeah, well, yeah. Exactly what it is.
Yeah. It's blue and green.
There you go.
So, this is a great little thing. It's going to be a big seller this fall. If you have kids in your life, and, you know, this is for ages, I believe it's 10 and up.
Teachers, well, a lot of times, like students to make their own videos. Where we used to do posters as kids, they now make videos. Oh, take your phone and make a video and turn it in.
You know, it's 10 and up. I say 10 or 8. 8 and up.
8 and up.
We know that social media is going to be a big part of your kids' lives.
Oh, boy.
It's just making movies, making videos, is get them started. This is a great way to get started. And as we saw in the video, it's a selfie stick or a raise the tripod. It has a 1.3-inch screen, so you can review your videos to see if it's what you wanted and know you need to record or not. It has playback functions. It has a built-in microphone. It also has a microphone jack, so you can use an external wired microphone
like we wear.
Not a battery pack, but you can do wire in it.
Wire in.
There's probably battery packs out there. I need to find that out. That you want. Cool thing is, it has face detection, so it focuses on the faces. Right, so it has face detection, all in for not a whole lot of money. You want to be a hero gift giver. You got grandkids out there or something that are in that 8, 10, 12 range. This might be the 8, 9, 10 before they get a smartphone.
There's a teacher you know
that wants one suddenly.
Well, you know what? For a teacher, I'm going to make a recording of your presentation. Teachers do this all the time in classrooms now.
Yeah. Oh, and so they could just, so you're saying
could.
for a teacher,
Absolutely.
they could just set it up here and set it right there, do the presentation to the class.
They can record their
and
presentation.
have it recorded, pull it out, stick it in the computer, and done.
They can also, you know, kids do presentations. I wish I could be there to see my child do History Day project, Science Fair project. Fine, there you go. Do it. Email it home to parents. There's your child doing great in my class.
That's awesome.
Yeah. Oh, yeah.
Educational end of it.
Oh, yes. Oh, yes. And what does this retail for?
What's it over in the Amazon thingamajig? Carousel.
Gotta find it.
Oh, okay.
Yeah.
$99.95.
How much?
$99.95.
$100.
$100.
$100. Yeah.
That's nuts.
Yeah. You know, the green screen comes with it, blue screen, green screen, so they can play with chroma key and work with putting on artificial backgrounds. It has a LED light that comes on bright, dim, and strobe effect. There you go. I can see it strobing right there. It can mount on a wall, and you think, gee, there's no way. I mean, look at that. It comes off really easy, right? There's no, wait a minute. You can mount it on a wall. Look at that.
You can.
You can mount it on a
and
wall or
because
somewhere else.
this
The base.
cup and ball system, like your hip joint, it can rotate pretty much anywhere.
And, you know, pull it off. It's not like it's not crazy.
Yeah, it's just strong enough.
Yeah. It's not so strong. I mean, you could, if you can get it to come off.
It wouldn't take a big impact.
But yeah, put it on a wall or on a piece of wood so you can move it around and get the light where you want it. This would be a fantastic gift right here for, and again, you want to be a hero. I think this is going to be a hero gift come birthday or Christmas this year. So if you're joining us just now here on Amazon Live, this is Explore Scientific channel. We work hard to do a lot of education. Yeah, we're selling stuff, but we try to talk about education and things like that.
We do.
How scopes work, how microscopes work, how this works, what it can do for you. And if you have just found us and have not clicked that follow button,
please do.
Please do. If you like what you see and want to get notified of more of this, you can click that follow button. That follow button also helps us in the Amazon algorithm. It's really weird. The more people that follow you, the more people they give it to. But how do you get...
It's that old pull yourself up by your bootstraps.
You got to pull yourself up by your bootstraps. Which came first, the chicken or the eggs? Well, we got to come up with them both at the same time. That's what the answer is. That's what I've always actually thought the answer was. Which came first, the chicken or the egg? Neither. The chicken and the egg came together. I mean, that's sort of been my feeling. So anyway, let's talk about your show.
Yes.
Is going to be about something pretty cool.
Show is about, this week is about the discovery of Neptune, but it's more than about Neptune. The question is, what's a discovery? It's rarely as simple as, Eureka, I found it, I'm naming it after myself. And we think of examples like that, like Galileo and the moons of Jupiter, Darwin and his finches. They're all named Darwinii, by the way, for himself.
Hey, Micah, you want to come join us on the broadcast? He shook his head no.
No. Well,
Micah's our graphics artist, does a great job, or does photography, does websites. Yeah, so he does it. If we got to be careful what websites we say because we're on Amazon Live. Can't send people off Amazon Live, but he works on the website, so we appreciate that a lot.
So we'll be talking about what it means to discover something, and people argue. So, I discovered it. No, I did. No, you didn't. I was first. And the discovery of Neptune, Britain and France almost went to war over this.
It matters.
It matters.
Not that much, but it matters. But you know what astounds me about that is people saw it. It wasn't like somebody went, "Oh, that's a planet." There were people who had seen it since Galileo, the first person to really use this telescope as an astronomical device. Documented evidence, he saw Neptune. He drew it. It matches up exactly with a planetarium program.
He didn't know what he was seeing.
But he didn't know what he was seeing. He was the first guy to use a telescope, and astoundingly, he was looking at Jupiter, And
Neptune was conjunct.
was right there close to it. He actually drew it over the course of a couple of nights, and he showed it moving slightly just like it would have. It's an astounding idea that the first guy to turn a telescope skyward and document it,
Found a new planet.
Early. I mean, not like he'd been doing it for years.
Part of the discovery process is being aware of what you've done and then sharing it with others.
So if you see it for the first time, it's a personal discovery.
Absolutely.
Right? And there's no dishonor in having your personal discovery. But from a scientific standpoint.
K2 pan-stars.
Right.
I discovered it in my backyard a couple of nights ago. It wasn't my discovery.
It's not
but
like,
it's my personal.
It's not like it's not like the comets that David Levy has discovered and said, "Hey, there's
I'm
a
the
comet
first
right
one
here."
in history ever to see this.
Yeah, exactly. And he's done it 16 or 18 times.
I have discovered things before.
What have you discovered?
Among other things, a meteor shower, the Ursa Majorid meteor shower, which you can't see anymore. It was a one-time event. A comet coming in broke up. My students were out to watch for the landed meteors, and if you're documenting meteors on paper, they make this brilliant sunflower pattern. They explode out from a center point called a radiant, and we found there was 2 centers, and we were very excited. And my class and I, discovered this meteor shower.
Cool.
But it was a comet that just busted all to pieces, and the meteor shower never came back. It was a once-off.
So Dan, I discovered something once.
Sure.
I was about 6 years old, was walking back from Dr. Shrigley's office to my dad's newspaper office, and walked past the cleaners. And there was this pipe about that big around coming out, and there was steam over here. But between the pipe and 4 or 5 inches, there was nothing. I discovered plasma. I stuck my finger down where there was nothing.
Tell me you didn't.
And guess what I discovered?
That hurts.
Just because there's nothing doesn't mean there's not something. And there was something hotter than steam, and it was a wee bit warm. I stuck my finger in it and went, oh, that really hurt. And walked back to my sucking on my finger. Never told my dad until years later that's what I did. But I discovered that. That was a personal discovery.
Yes.
And it was important.
Yes.
I learned my lesson that just because you can't see it doesn't mean there's not something there.
That's right.
Yes, and which is an important lesson for life.
And that's one of the amazing things. We think about things Galileo discovered with his telescope. There was a real question at the time, Kent. Is what I see with my eye all that there is?
Yes. And we know the answer
In
today.
other words, if we look with a telescope, are we just going to see the same stuff but closer? Or are we going to see more?
Yeah.
And you remember that famous line from the movie 2001, oh my God, it's full of stars.
Mm-hmm.
The Milky Way looks like this smeary band of light across the sky.
It's
but
full
you
of
put a
stars.
small telescope on it, and it's full of stars. You realize this is myriad points of light, distant stars, different world systems, far, far away. And we need more aperture, gives us more resolution, the ability to see things that are smaller, dimmer, and farther away.
Telescopes outside the atmosphere that see in infrared. And so, yeah, I'm talking about James Webb Space Telescope. You pick a spot in the sky where there's literally nothing shows up on Hubble Space Telescope images, nothing. And we're talking about a fraction of a degree. And stare at it for a measly 11 and a half hours, and look what they found,
It's
right?
full of galaxies.
It's full of, this tiny little speck is full of galaxies. Extrapolate that across the entire globe of the sky, it's mind-boggling. And
Prediction. After we've used Webb for a couple of years, you're going to see people upping the number of galaxies in the universe. They're going to say, there's more than we thought there was.
I think there's going to be, you can't count them, there's so many. I mean, it's just, there's just so many out there.
Yeah.
It's going to be hard to count. Now, another thing that I think, and people have sort of, they're talking about these beautiful pictures. Spectre is boring, right? Spectre is boring to look at. It's just a bunch of lines.
You have to bring a lot of knowledge to it to make it exciting.
Right. And the fact that the first exoplanet that transited a star and they measured the spectra of the atmosphere, showed many forms of molecular hydrogen, hydrogen, H and O2, and showed not water, but there was some signatures of actual H2O. There's various forms of oxygen in the spectra, hydrogen, oxygen, some other minor elements. And I predicted in writing before it came out.
I remember, I was here.
I predicted in writing before it came out that the spectra, because they were talking about it, I knew it had to be something, is going to show oxygen, I said water, and carbon. And I should have thought, a little bit more. Carbon is going to, in the atmosphere, is going to indicate probable life, CO. Potential, possibly a carbon-oxygen cycle. A lot of the carbon could be on the surface of the star. I was half right. We got water, right? Hydrogen, oxygen, and no carbon yet.
You realize we're effectively sampling the atmosphere of a planet almost 40 light years away.
Yeah. We can look at it and go, oh, and once you understand how the spectra works, specific elements give off a light at a very specific wavelengths. That's why the auroras are red and green and blue.
That's right.
Because it's specific gases, noble gases, elemental gases, giving off light when they're excited.
Yep.
The same thing happens. If it's absorbed, then that's an absorption line. If it's given off, it's a, what's the opposite of it? I'm drawing a blank.
It's an emission line.
Emission, thank you. Drew a blank. And so we know from all the elements we've got spectra of.
Fraunhofer lines and Kirchhoff lines.
Right. And we know what those are. And we simply just have to match them up and go, oh, those match up. Here they are. This is what they are. And we can also measure the redshift on them, which tells us the distance, because the farther the redshift, the more distance, Doppler effect, basically. Right. So I don't really think that spectra has gotten the love that I think it deserves.
No.
Because of what it shows and just the mind-boggling, we're able to measure what's in the atmosphere of a planet 40 light years away. And that's the tip of the iceberg. Now then,
stunning.
We can't say that's the first spectra. That's the first one they released. My guess is they took numbers of spectras.
And they're going to be taking more.
Yeah, and they picked the one that goes, oh, this is the one we're going to tell the public about, right?
Probably.
But so they picked the best, and this is doing science, pick your best targets and focus on those. Don't just, if you want to do a random thing, you can do a random thing. But if you want to try and discover something, pick your best thing. That's why there was so much effort put forth to map the moon in the 60s, 50s and 60s, to pick a place for the Apollo landing. Where are we going to put them to discover the most stuff we can? Same thing with where we land on Mars. So much effort is going through there. So Caitlin Ahrens, you know Caitlin, right?
Yes.
You know what she's doing now? Caitlin Ahrens graduated from the University of Arkansas. She ran with a degree, a doctorate in something. She's doing postdoctoral work, doctorate work now. She works for Goddard Space Flight Center.
Right.
And she's doing modeling and research on the permanently shadowed lunar craters to help decide which crater we should go to. That's cool. You know, a girl graduated from the University of Arkansas, ran the Pluto lab.
Boom.
Yeah, boom. You know, it's just about being curious. You know, it's about, you know, and learning. And don't be afraid to fail, because science is about failure, you know, and learning from your failures.
It is.
And if it didn't kill you, you learn from it.
You did.
So, all right, so let's talk a little bit about this telescope. This is a 114 millimeter Newtonian telescope. Paul, do we have any chats going on right now? We haven't seen any. Want to make sure, because we're not seeing any pop up. So if you're here, we're on for another, 10 minutes or so. We would love for you to give us a shout out and say hello to us. Pekka, yeah, an amateur astronomer reaching and yelling after at least 50-inch Dobsonians with golden coatings. Well, you know, a 50-inch Dob, I actually have, it wasn't a Dob, it was a Newtonian, but look through an eyepiece, through the Struve telescope on McDonald Observatory, has a 6-foot mirror. Yes, indeed, folks. The widest view we could get with the eyepieces that they brought was, Daniel, 1/3 of a degree.
Oh, yeah.
I mean, it was fantastic. We actually saw the 12th planet that Michael Brown discovered and then said it's not a planet. We saw it. It was magnitude 19. Limiting magnitude that night was magnitude 19.3. It was like a lighter shade of dark, but we all saw it.
There you go.
And it was a fantastic night using that telescope. We stayed all night. We're the first people to ever stay all night, the professional astronomers that ran the telescope said. We were done. It wasn't, sun was it's not up yet, but getting dark. And they said, well, they'd looked at their entire list of things that we had looked for. And I said, well, let's look at M42. And they were like, why do we want to look at M42? And I said, what else are we going to look at? So they slewed to M42. And you couldn't see, I mean, the trapezium was astoundingly too big. The trapezium is a little star pattern in the very center of the Orion Nebula. And we were seeing yellows and blues and greens and little tendrils with little planetesimals you could see. It was truly astounding. The first guy that slewed to it, he said a comment I probably shouldn't say, but it was holy something or other. And nobody believed it. And of all the people, and I still talk to a couple of the guys from the St. Louis Astronomy Club that were there, and that's the thing they talk about, is what that looked like in that telescope. Was truly mind-boggling that you could actively see yellows and greens and reds and these little pillars of creation in an eyepiece of a really big telescope. A really big telescope. That up and thank you for it. So this is a small telescope on an equatorial mount. We're not going to go into details about how to polar alignment other than tell you this axis right here has to be pointed at either the north celestial pole or the south celestial pole. Daniel, what does that do for us when we point that axis at?
When you do that, that means that the telescope can rotate exactly the way stars rotate around the celestial pole. And so with one knob, you can track things like planets as they move. Because one of the problems, folks, is when we magnify the sky, we magnify the motion in it.
Just as much.
Correct. If you're looking at Jupiter at 150 power, you're speeding up its apparent motion by 150 times. And at science, at astronomy labs and outreach, people tell me, I've lost the moon, I've lost Jupiter, it went away, it drifted out of the eyepiece. Well, you have to, basically what we're doing is we're counteracting the rotation of the Earth. Right. The Earth turns this way, we're turning the telescope that way, so we stay pointed at the same target. And one knob, properly lined up, one knob does that for you, and it's easy. You're at the eyepiece, and you dial it a little bit.
They're called slow motion control arms.
Slow motion control.
Right. So this is called right ascension.
It's the polar axis.
It's the polar axis. It is lines up with the axis of the Earth. How do you know where to put it at? Well, find out the latitude where you live. Right here in northwest Arkansas, we're just a wee bit over 36. Yep. So there's a scale on the side of every equatorial mount. You just put it to 36, and now you've got that part of it done. Now you just have to figure out where the north celestial pole is, which if you can see Polaris, you just wait for the sun to go down and go, oh yeah, there's Polaris, and point it, get it lined up. The more you do it, the better you get. I have a way where I use a compass and find magnetic north, and then understand that magnetic north is not true north. Same for south. I use the northern hemisphere, but our friends in the south that watch southern hemisphere, you have to do the same thing, right, because there is no guide star. There's nothing close to the southern celestial pole that you can use. So you find out where north is, and here in northwest Arkansas, our magnetic north is about 1 degree west of true north.
Correct.
But if you get out on the Pacific coast, you're 15, 16 degrees. You get up in Maine, you're 15, 16 degrees. So we have a question coming in apparently. So you've got to understand that magnetic difference to line it up with a Yeah, compass.
We have a question, is it possible to manufacture narrowband filters for visual observation? Yes. And they're marketed under various names, but you can get what's known as an oxygen-3 filter.
We sell those.
I'm sure you do. Explore sells these. I just don't know what the product name is from Explore. But oxygen-3 filters cut out sky glow.
Right.
There's
light
also
pollution, light pollution, LCS, LPS filters, things like that.
They also are narrowband filters. There are filters specifically to cut out artificial lighting.
Like metal halide and low pressure sodium.
Right.
And we sell a number of those filters. Right. You can find them over. They're not in our carousel, but here on Explore, on the Explore Amazon Live broadcast, you can go to the Amazon store and search for Explore Scientific and filters, and there's a whole host of those as well. So, all right, well, we're getting the shutdown sign. I'm gonna steal a couple more minutes, just talk about the other axis here. This mount also has another axis on it. Helps if we lock the right one and unlock the right one. This one is sort of, think of it as up and down.
North-south.
North-south.
The other axis takes you east and west.
Right. I think of it as up and down. These two work in concert with each other to point at an object. So if I want to point at something in the southwestern sky, right there, I'm pointing the southwestern sky. Notice my telescope is on the east side because this is north, this is the east side, but I'm looking west. Why? Because that's how this system works, right? And if I want to look at something in the southeast sky, then it's real simple. I'm just going to have to turn the telescope around and get it pointed with the telescope. It
becomes intuitive after you practice for a while.
Right. And the first few times, it's very difficult. It is a challenge if you don't understand and have at least a basic idea of the principle of how this is going to work, right? But once you get it, it's real simple, and it's hugely effective. All right, we have a question. I thought they were for astrophotography.
Not necessarily.
Some of them are. Some of them are so narrow that you have to have such dark skies to see anything. You can't hold them up and see anything.
No.
But they are letting light through, but you have to have dark enough skies to where you're going to see something. If you have any light pollution around that's causing your pupil to get bigger or to get smaller, you're not going to see them. So, Daniel, we've got to go. It's 3 o'clock. Thank you for watching us. We'll be back tomorrow with Fun Day Tuesday. For lack of a better title, they haven't come up with it, so I'm going to go with that. Annie and Lucy talk about some of the great educational products that we have.
There you go.
And then Wednesday is First Light Chronicles. We talk about first light things, telescopes, all sorts of stuff.
And the 100th Global Star Party is coming up.
Yes, Tuesday night, the 100th Global Star Party is coming up. We have to be careful what we say because Amazon robots don't like us doing that. But we have the 100th Global Star Party coming up on Tuesday. And then Thursday is On the Wing. I'll be talking about our fine feathered friends. And Friday then is Focus on Astrophotography. I will not be with you next week on anywhere close to a regular basis. So, Daniel, you may be in here pitch hitting with Tyler or somebody.
Nobody's called me for that assignment yet.
I will be going to the Nebraska Star Party where I will be doing some, if we have enough signal, I'll be going live from there a little bit. And I might try and come up at night a few times with Scott, just talk about it. Okay, or do you mean that I can see all the blue gases around M45 with O3 visually?
Probably not.
Probably not.
Those tendrils of gas you're talking about are very, very faint. And a camera, you open the aperture and it collects light like a bucket out in the rain.
Yeah.
Your eye sees photons as they come in, and basically it's an instantaneous detector. It doesn't collect anything.
So what it does is they will increase contrasts at the eyepiece.
Correct.
Is how I have experienced.
Correct.
Peck, the reality is, I don't use the filters. I'll use a neutral density on the moon every once in a while, but I just, it's one more piece of kit that I have to mess with.
I use filters pretty extensively.
Yeah, do you? Yeah, I just
I use
colored filters.
I have a set of color filters that I use primarily for planetary observing.
Right, which is what those are meant for.
I have a neutral density for the moon, and I have a deep sky filter. I will tell you, I use colored filters for planetary work more often than I use deep sky.
Right, right. I'll agree with that. Yeah. So we got to go. It's 3 o'clock. Thanks for joining us, everybody.
Bye, everybody.
We appreciate you sharing your time with us. It's a blessing to us to have you watch.
That's right.
On behalf of everybody here at Explore Scientific, including Paul Newton, the disembodied voice over in the control room, and Noah Menard, the Amazon guy. Hey, Noah, give us a wave, would you? He waved like this tonight. Just like that's how it looked when he saw him. And my sidekick here, Dr. Barth. Always a good time to get him on the show.
Absolutely.
Much more educational. It's a lot nicer to have somebody to talk to. I appreciate it, sir, very much.
You betcha.
So
we're out of here. What you got, Paul?
I'm like chopped liver, I guess.
No, you push the buttons. You make it happen.
You said you'd like to have somebody to talk to. See,
on stage. I mean, on stage to talk to. It's
Just
harder
saying.
to talk to somebody who's sitting comfortably in a chair.
Let
sipping,
me enjoy this.
sipping
It's
a
so
soda.
rare anybody's jealous at me for anything.
Sipping a soda over there. If he wants to eat lunch, he can eat
I ain't
lunch or
got
snack
no
or
soda.
whatever.
I got lemonade.
Okay, shake it up. Now it's soda.
It's not soda. There's no carbon in there.
Bye, everybody.
Bye now.
Thank you for watching our 24-hour-a-day live stream here at Explore Scientific, where we show you all the programs that we run live in front of a live audience. Programs like Global Star Party, On the Wing for birders, First Light Chronicles for beginners, and Focus on Astrophotography for astrophotographers. We bring in astronomers and explorers from around the world to answer your questions live. But there's so much cool information there that we decide to package it all together and run it 24 hours a day. We're also on Amazon Live, where we do deep dives into our products and our gear. There's so much important information as we share the education, the experience, answering questions from the audience, that kind of thing. So tune in, and thanks for watching.
Well, the deer are just starting to come out. Hi, I'm Rick White with Alpine Optics, and I want to talk to you a little bit about the new Alpine Teton binoculars. ED glass, multi-coated lenses, magnesium body, and Abbey Koenig prism. Now, people wonder, what's an Abbey Koenig prism? Well, it's a longer prism, and it's a V-shaped prism that allows 94% more light into a pair of binoculars. Waterproof, lifetime warranty, doesn't get much better than that. If you're looking for a great pair of binoculars, and I mean a great pair, check out the Alpine Teton binoculars. You'll be glad you did.
Thank you for watching our 24-hour-a-day live stream here at Explore Scientific, where we show you all the programs that we run live in front of a live audience. Programs like Global Star Party, On the Wing for birders, First Light Chronicles for beginners, and Focus on Astrophotography for astrophotographers. We bring in astronomers and explorers from around the world to answer your questions live. But there's so much cool information there that we decide to package it all together and run it 24 hours a day. We're also on Amazon Live, where we do deep dives into our products and our gear. There's so much important information as we share the education, the experience, answering questions from the audience, that kind of thing. So tune in, and thanks for watching.
National Geographic's CF600 PM telescope lets you explore the intricate contours of lunar terrain or the brilliant clusters of Pleiades. Use the red dot finder to accurately line up this entry-level scope with the Alt-Azimuth mount and tripod to begin your journey into the world of amateur astronomy. The 90-degree diagonal mirror assembly makes viewing comfortable, and the built-in storage trays keep your 2 included eyepieces safe and secure. The easy-to-use telescope lets you see clearly with an aperture of 50mm with a 600mm focal length, and the unique carbon fiber styling of the CF600 PM gives this scope a modern, rugged edge. Use the included online astronomy software and star map with the National Geographic CF600 PM telescope to begin your journey to exploration of the stars.
Scientific radio weather station provides the precision of a radio-controlled clock and calendar merged with the weather station in an elegant frame that can be placed in any room of the house. The color display shows the weather forecast using 6 different icons, clearly displays the temperature and humidity both inside and outside, thanks to the supplied sensor which can be placed up to 30 meters away from the main unit and still have connectivity. The Explore Scientific Radio Weather Station also houses the digital barometer, which can help you predict the weather for the day to come.
Mart's here from Explore Scientific. Today I'm going to teach you how to polar align your telescope using a broom. Why do you need to polar align? Well, with a telescope that has an equatorial mount, you have to get that equatorial axis lined up with the rotation of the Earth. And to do that, we're going to start with the tripod. We're going to decide which one of these legs is going to point north, and we're going to set the tripod down so that leg is pointed north. First thing I'm going to do is use a level to make sure my tripod is level. So if it's tipped one side or the other, that's going to cause your polar alignment to not be accurate. So we're going to use a level for that purpose. Then we're going to take a compass, and just to make sure that I've got it pointed north, I'm going to use the compass, line up and go, yep, that looks like it's pointed north. So here's what I'm going to do now. And this is where the broom comes in. The broom becomes a measurement device, if you will. So I'm going to put the broom on the ground with the tip of it right against the north leg of the tripod. And I'm going to back away, and I'm going to use the compass. I'm going to close one eye, and I'm going to use the compass to make sure that the broom is lined up with north, right? And so I can tell I'm off just a little bit. So I'm going to move the tripod just a little bit, and I'm going to turn the broom, and the broom is what I'm seeing that line with to line up. So closing one eye, now my broom is lined up perfectly to magnetic north. Right here is we're going to talk about something called magnetic declination. The magnetic north is not true north. The difference between true north and magnetic north can be off by as much as 15 or 16 degrees if you live on the east coast or west coast of the United States. Around the world, it varies, and you have to figure out what that is for where you live. Because if you point at magnetic north, you're not going to be pointing at true north. You could be off by 15 degrees. Your go-to will never be accurate. So for this system to work, you have to know what that offset is and be able to program that into your compass. We're going to provide a link to a website and a video that talks about that a whole lot more. Now, we're going to make sure that the tripod is not angled wrong. I'm going to use a small tape measure, and we're simply going to come down here and be careful not to move the broom, and I'm going to measure the distance from the tripod leg to the center of the broom. That is 470 centimeters. That way, it is 470, a little, I'm going to call that good. Actually, I'm going to move the tripod a couple of millimeters, just like that. So now we know that we're lined up true north with that leg, and these two legs are the equal distance from right here. So it's not pushed that way or that way. So now that we have the tripod with a good alignment to north, we have to put the head on the mount. And that's going to entail this. We're going to be very careful when we do this because we don't want to move the tripod. We're going to put it on and simply screw on the polar head just like this. Remembering everything's going to the north. Now if you're in the southern hemisphere, you're going to do the same thing. You can do the same exact same in the southern hemisphere. Because it's not polar, it's polar alignment, we just don't use the star Polaris, which we're not using here. This is really good if you can't see Polaris, or if it's daytime and you want to do some solar viewing with a solar safe filter. So the last step of this process is to check the scale of your altitude, right? So we live at 36 degrees north, and I am going to turn the altitude until it gets to 36 degrees north. I'm going to stop, and that's it. With this system, using a broom, a compass, and a tape measure, you can achieve a good, decent starting polar alignment. Personally, I've used this. I've got an amazingly close polar alignment. There's ways that you can use to refine your polar alignment, specifically drift alignment, but it all starts with a good polar alignment. You can do this in the daytime. You can do this in the nighttime if you can't see Polaris. It works all the time. It's a good way to get started learning the process of polar alignment. Isn't that great? I hope you've enjoyed this video. For Explore Scientific, I'm Kent Martz. Get out there and start doing astronomy. And keep looking up.
Are you having a hard time trying to figure out what telescope to get? Don't worry guys, Tyler here with Explore Scientific is going to help you figuring out what you're wanting to do, either astrophotography or visual. I always tell customers that telescopes it's kind of like golfing, it's carpentry, it's a hobby that you have to learn specific tools in what they do, because these are tools. I consider them as tools, and they have a specific purpose in what you're wanting to do, either visually or astrophotography. First, we're going to talk about this little beauty, the Maxudo of Cassegrain. Great for planets, so if you are wanting nothing but planets, this bad boy is the way to go. If you're wanting some deep sky objects and some planetary, the reflector right here from Explorer First Light is also the way to go. But if you just want deep sky objects, if you want wide field of view, a refractor is the way to go. These are just a couple of basics here at the Explore First Light series. The Maxudo of Cassegrain, the Newtonian, and the refractor. All of these scopes come with a red dot finder, a smartphone adapter to get you started in astrophotography, as well as an eyepiece, and whichever mount that you want to choose with the combination of telescope you want. If you need help out there on Amazon, don't be afraid to reach out through the live chat. We'll make sure that we get back with you as soon as we can here at Explore Scientific.
Hi, my name is Levine Nassars from Explore Scientific. Today I'm going to show you the Discovery 900 times biological microscope set. In this kit, you're going to get your microscope, a hatchery, a petri dish, dyes, specimen vials, prepared and blank slides, and other tools. With this microscope kit, you can see the microscopic world around you. The magnification ranges from 100 to 900, and there's an LED light located underneath so you can see stuff. This microscope also has a color wheel located underneath. The different colors on it show different contrasts, so if I was to look at something through a different filter, it would look different than what it did before. It shows different things that you can't see with your own eyes. In this kit, you'll have everything you need to do your own explorations, including the blank and prepared slides that are really cool, and they have their own little blank ones. And there's some that are already prepared that have different specimens in them. If I were to explore this kit, I would probably explore pollen, because right now it's spring and it's allergy season, and allergies are very annoying. I'm Levine Nassars from Explore Scientific, and this is the Discovery 900 times biological microscope. Keep on looking up.
Thank you for watching our 24-hour-a-day live stream here at Explore Scientific, where we show you all the programs that we run live in front of a live audience. Programs like Global Star Party, On the Wing for birders, First Light Chronicles for beginners, and Focus on Astrophotography for astrophotographers. We bring in astronomers and explorers from around the world to answer your questions live. But there's so much cool information there that we decided to package it all together and run it 24 hours a day. We're also on Amazon Live, where we do deep dives into our products and our gear. There's so much important information as we share the education, the experience, answering questions from the audience, that kind of thing. So tune in, and thanks for watching.
Hi, I'm Kent Martz, Customer Service Representative with Explore Scientific. I'm going to show you how to put together the National Geographic NT114CF telescope. We're going to start by unboxing the telescope. On one end, you'll find the directions, which are contained in a plastic box. You can refer to those as you go. Be careful with this part because you don't want the two boxes inside to fall apart. The first thing you find is the tripod spreader bar plate that also serves as an eyepiece holder. I'm going to remove it from the plastic bag and set it aside at this time. Inside the larger box is the optical tube. At this point, I'm going to open the smaller box and remove the tripod and the panhandle that are inside. Be sure to not throw away this part because this is what moves the telescope. I'm going to take the accessories tray, spreader bar piece, and if you notice, the base has a sort of like that. Align the notches so the tray goes down onto the pieces of the tripod and simply turn it and snap it to lock the pieces into place, and now the tray will not come out. I'm going to set the tripod aside and get the telescope tube and prepare it for assembly. The larger box contains the optical tube, a small white box contains the eyepieces and other accessories, and a larger white box that contains a piece that goes onto the tripod. At this time, I'm going to remove the smaller white box that contains the eyepieces and other accessories. Now I'm going to lift the optical telescope tube out of the box, being careful to rotate it so the eyepiece holder comes out of the box. Carefully remove the plastic bag that is on the outside of the telescope. Be sure to properly dispose of the plastic bag because it is a choking hazard for small children. With the tripod, I'm going to remove the mounting nut. I'm going to finish unscrewing the mounting nut, being careful not to drop the washer or the clear plate. I'm going to unscrew this a couple of turns to make sure that the head of this screw is not inside this shaft. I'm going to place the clear washer on top of the tripod. Make sure you have the metal washer on top of the nut. Insert the mounting head into the hole and screw the nut into the bottom of the tripod. Tighten it, but don't get it so tight it can't move. I'm now going to unpackage the panhandle, removing it from the plastic. Again, discarding the plastic safely. I'm going to screw the panhandle into the mount hole. And now I can use the handle to turn the tripod. Turn it until it gets tight. The tighter you turn it, provides the tension to keep it from moving. So I'm going to tighten it up now so it's good and tight. Now it's very steady. I'm going to tighten this nut a little bit more. Now it's good and steady. There's very little wiggle movement and there's no up-down movement. With that done, I'm going to unscrew the mounting screw. This screw holds the telescope onto the tripod. And I'm going to unscrew it almost all the way out. There, so now it's no longer sticking out. To attach the telescope, carefully lift it from the table and place the triangular shaped dovetail into the saddle plate and tighten this screw until the telescope is firmly attached. Once it's attached, it will not slide back and forth, and now it's in a solid position on the tripod. Open the small white accessories box and remove the red dot finder. Remove it from the plastic and carefully insert it onto these 2 feet. It simply slides into place. It comes with a battery pre-installed. On the back side, there's a red on-off switch that turns it on and off. Now we'll remove the lens cap. The design is a 2-piece affair. A smaller lens cap comes off, revealing this circle with 3 screws in a triangle and a small screw in the middle. Do not turn these screws. To get the lens cap off, use your fingers and pry off the larger lens cap like that. After it's been on off a few times, it comes off much easier. This part of the telescope is the focuser. It comes with this white cap installed to keep dust out of the telescope. Turn these 2 silver screws to remove the white cap. Get the small white accessories box and remove the 2 eyepieces from inside. They're inside 2 white plastic protective cases. We want the PL26 eyepiece. The smaller one is the 9.7 eyepiece. Unscrew the top, remove the eyepiece, which is also contained in a protective sleeve. Put the PL26 into this part of the telescope, which is called the draw tube, and tighten down the 2 silver set screws so the eyepiece will not come out. You turn these knobs to bring the object you're looking at in focus. So you look through it and turn the knob until what you're looking at comes into focus. Now we have a fully assembled National Geographic NT114 CF telescope. For more information, follow the link in the comments below to a video that contains significantly more information on how to operate and use this telescope.
Hey everybody, Kent Martz here from Explore Scientific. Am I on?
Obviously not. You can keep talking, they can hear you.
Apparently things aren't cameras. Something's going on. Paul's banging on things with his thumbs and index fingers and such. It'll be up here in just a minute. I can understand you hear me.
You're up.
I don't see it on the monitor anywhere, but supposedly almost up here, getting ready. So another quick countdown here. Maybe we'll be up in 3, 2, 1. There we go. Hey everybody. Kent Martz here on Wednesday for Amazon Live warm-up broadcast via our social media platforms. Today we're going to be talking about first light telescopes and how to get started in amateur astronomy. Lots of people have an interest in amateur astronomy, but they don't know where to start. Well, a great place to start is with our First Light Hour, Explore Scientific's First Light series of telescopes. I have here to my left the Explore Scientific First Light series achromatic AR, 80 millimeter by 640 millimeter focal length. What that means is there's 80 millimeter diameter objective glass up here that has 2 pieces of glass that start focusing the image, and then a focal length of 640 millimeters to where that image comes to focus at the eyepiece. The eyepiece is right here. This telescope comes with everything you need to get started. A 25 millimeter super plossal, a 1 1/4 inch diagonal, which fits into the 1 1/4 inch focuser. And just tighten that down so it's there. Put the eyepiece in. Attach the telescope to this little tripod it comes with. This was a Twilight Nano. It's very simple. Left, right, up, down tripod. Let me see if I can move this a little bit over, get more of it in camera range here. A simple left, right, up and down tripod. Very intuitive, very simple to use. Great way to get started. You can actually see the glass down in there. There you go. See the glass shining off on the, with the lights, the studio lights. There you go. There you go. You can see the glass in there, right there. This is a great telescope. Does not have a massive amount of magnification. People crave massive magnification. The problem is that makes it really hard to focus, really hard to point, and really hard to keep things in the eyepiece. That's why we ship this with a 25 millimeter eyepiece. Not a huge amount of magnification. Makes it easier to find things in the eyepiece of your First Light telescope. Paul's got a question, had a question, forgot his question.
This telescope, right, it only takes certain eyepieces, correct?
That's 1 1/4 inch eyepiece. So generally there's 2 sizes of eyepieces, 1 1/4 and 2 inch, meaning they're 1 1/4 inch in diameter or 2 inches in diameter, so that'd be yay big around, not this big around. There's a third one out there that's like 0.986 of an inch, so smaller than 1 inch in diameter. Those tend to come on very small, really basic beginner and educational and toy telescopes. They will not fit on this telescope because they're too small, right? So they won't fit on it. That answer your question, Paul?
I just wanted to make sure that we cover the basics.
Good. So my monitor's turned really far sideways, so I can't see it. We'll deal with that here. I don't want to step off camera. So this tripod raises up higher than this, but we have it set this way so it looks good. Good positioning on the studio. Hey, Paul.
Oh, move it.
Nah.
Oh my gosh. Complain about something.
No, there's an observation, not a complaint. So, one word of caution, it comes in various places. This little thing says in like 19 different languages, don't look at the sun with a telescope. Why? Because you'll burn your eyeball, and that will be very, very, very bad because you can't fix it. You're always going to have a burned eyeball from looking at the sun. Now, there's ways to safely look at the sun. We'll talk about that here in a minute. Offerade says that looks like a 45-degree diagonal. Nope, it's a 90. Here we go. Turn it sideways, and you can see right here that it goes. Turn it a little bit better. You see it right there. So it's a 90 degree diagonal. That diagonal is just a mirror, is all it is, set the mirror is at a 45-degree angle. It allows you to look down at 90 degrees, right? If it was a 45 degree, the eyepiece would be about right here, and the mirror would be set at 22.5 degrees. So you can get that 45-degree angle. 22.5 is, yes, 22.5 degrees, half of 45. So what this does is, you know, if you were looking at something on the horizon, looking into an eyepiece, and there are some telescopes that do this, and you could do this with this one, put the eyepiece here, and you might be able to get it into focus, right? Which is all well and good if you're looking at something out there on the horizon, right? But if you start trying to look at things over up in the sky, the higher it gets, if you're gonna look at something like, you wanna go out and look at Vega tonight, this is almost an impossible position. As you can see, the eyepiece is not on the screen, but you get the point. The eyepiece is so low, you can't really get to it. So that's why we use a diagonal. It goes in there, we can tighten it down, we can find a comfortable position to look at. And if we're looking at something in the sky that's high up, it's a lot easier to see into the eyepiece because you're looking down into it, not having to look up through it. It was a trick of the camera. Yes, I can see that. Could be. You get weird angles, and you don't know how it's going to look once the camera starts looking at it. So I'm going to move over here and move this monitor, step off a camera just a second, so I don't have to keep craning my neck to see my monitor and see the questions pop up. A nice, lightweight but yet sturdy tripod is the telescope mounts to it. How do you mount the telescope to it? It's real easy. It's going to come, you just unscrew that screw, and telescope slides right off. Now, I tell people, you start turning that knob, you want to make sure you have a hold of it really well, because you don't want it to fall off and hit the ground, right? One other thing it comes with, and I don't know if we're going to take it off so you can see it. It comes with, right here, a red dot finder. That red dot finder is what you use to locate, right? The red dot finder is what you use to locate objects in the sky. How do you do that? Well, if you just stick the red dot finder on, and it does come off, if you want to store it, put it back in the box it came in, right here, right? So you can put it back on, tighten down the set screw, it's on. If you stick it on there, the red dot that shows up in here is not aligned with where the telescope looks at. It can be off, left, right, up, or down. So you turn it on, and how you're going to do it is, you're going to put it on the mount, the tripod, and tighten down the bolt that keeps it in place. And now you're going to move the telescope and point at something that's distant. The manual says, I believe, 300 yards. That's the probably lowest minimum distance you can do it. But if you can find something that's a couple of thousand yards or even miles away, I always say miles are better than yards, and yards are better than feet, right?
If you're going to miles, though, you probably need, because I was doing this earlier.
Mm-hmm.
And just, to prove what's going on. And what I found was that you probably need like a 14 to go if you're out of a mile. To be able
A 14 what?
14 millimeter eyepiece.
Well, look, with it,
What I had a 25.
I've done it.
Could not get it exactly in the middle.
No, but you do the best. You do the best you can. You do the best you can with what you got.
Well, you're
right?
going to need a bigger eyepiece.
And we'll talk about that here in a minute. It's a good point, Paul. So you can, but what you're going to do is,
I guess it matters that my
Paul went to a
microphone
place
wasn't
where he
even
could see a cell phone tower half a mile away, something like that.
3/4 of a mile.
3/4 of a mile away. And what you do is you put an obvious point of it, a unique, a light that you can see at the very top, or one of the antennas. And you're using something on land because, look, you've got to move the telescope to find it. So you know it's over there, and you just simply move the telescope looking through the eyepiece until you find it, and then you go up the tower, or whatever, the tree, whatever, until you get to the unique part. You're going to use a broken branch sticking out of the very top. There's a tree line, there's a taller tree, and you use the top of the taller tree or the top of the cell phone tower. Once you get centered up in the eyepiece best you can, you simply turn on the red dot finder and look through the red dot finder and move. There's two little knobs. You move them, and the red dot will move left, right, and up and down until you get that red dot on top of the cell phone tower. Now, you don't want to just go on down the road and start viewing, because you want to look through the telescope, because it's very possible you move the telescope a wee bit, right?
Oh, I kept moving it constantly.
Yeah, and so you want to get it centered up, look through the red dot, center it up, look through the red dot until whatever it is in the center of the eyepiece is also covered up by the red dot. Now you're ready to go out at night and look at something in the sky. Say, you want to go out tonight and look at the super, what are they calling it? Anyway, there's a supermoon. It's 13 or 14% larger.
You got K2 as well.
Than average. It's going to be 30% brighter than other full moons. But, 13% larger. Most people can't tell the difference by naked eye. But, hey, it's popular, and people are going to go do it. And I'm going to tell you that a 30% brighter moon through a telescope is going to be really bright in the telescope, because it's really bright in the telescope when it's normal brightness, right? All right. Osmosis 007, howdy y'all. And Tariq, howdy. Tariq says, hi, Paul and Kent. Osmosis says, in Iowa, we use the wind turbines. Oh, absolutely. If you're out where there's a lot of the gigantic electric generating wind turbines, you can do it. You also, where you're in very flat country with not a lot of trees, you can see things a long ways off. Looks like you had a what is that? 102? Yeah. That's it's an AR 102.
No, it's an ED 102.
It's an Essential Series 102 out in front of our building on a MAZ 01 tripod. That is a combination you could order today off of the Explore Scientific website.
It takes 3 extension tubes to get that to get in focus.
Because you're so close.
3/4 mile.
Yeah, because you're so close. It also, if you look closely, has a straight through finder scope. I think they're like $89 on the website. Has a straight through finder scope as well. It's an upgrade from the red dot finders. The red dot finders are an entry-level item, easy to use. I've used them for years. They work great.
I'm making sure I use one heck of an eyepiece, though.
What, did you focus on the camera? Did you focus that thing? Looks almost out of focus or not sharp.
Well, it's because I'm zoomed in.
Oh, yeah. What did you use?
Just my iPhone.
Oh,
just
okay.
Snap.
Right, just
see,
use
it's actually a video, see?
Yeah. So there we go. So same process. That mount is the MAZ 01, the Twilight 1 mount. Has slow motion controls on it. That we'll look at another one, an equatorial mount that has slow motion controls, but works the same way.
I wanted that one because I didn't have to wait or anything like that. I just go on.
Wanted to go play with it. And,
I'm going to take it. That's what I'm taking home tonight. I'm going to point it at the sky, show some kids.
I would not look at the full moon with that, Paul.
I'm going to look.
Without getting, if you're going to do it, get a neutral density filter to put on it to cut down some of the brightness.
I don't have one, so there.
We have them here.
Well, is there one? You'll have to give it to me, Ken.
Yeah, we can check out a neutral density filter.
The expert.
Nope, you're not. Nor am I, but I know
I
a little
love that
bit.
eyepiece. Whenever I use a telescope from here, and I'm lucky because I get to use whatever I want. Because
here we get to use whatever we want. Yeah.
That eyepiece, I took it from back there behind you, off the set.
Mm-hmm.
It's a 2500 degree, I think it is.
Big 2-inch eyepiece.
It's so nice.
We have some 2-inch. Those 100-degree eyepieces in the 92 and the 82s are all nice. The 82s are generally our best-selling line, although we sell a lot of the 52s And that's a good segue, Paul, into talking about eyepieces. The telescopes come with an eyepiece, in this case a 25 millimeter superplossel. How that works is, let's talk about eyepieces and such. First, eyepieces are one component of magnification. The other component is focal length. So it'd be the focal length, in this case 640 millimeters of focal length, divided by the focal length of the eyepiece. That's the number printed on the side of the eyepiece, 25. So 25 will yield a magnification of, what I'd say, 640. 25 will go into 600, 24 times. So it'll be 25 power, almost 26 power is what you'll get. So whatever you see is going to be, is that right? That math's right, isn't it?
I have no idea.
4 will go into 100 4 times. It'll go into 600 24 times. It's a 25, so that's 26 times. And it's almost 650. So yeah, it might as well be 26 power. So anyway, focal length divided by the focal length of the eyepiece. Interestingly enough, if it's a microscope, it's not division, it's multiplication. It works the same way. Focal length times the focal length of the eyepiece yields the magnification of a microscope. It's multiplication. Telescopes are division. So if you want to, one of the first upgrades many people make to a First Light telescope is buying eyepieces. And we offer the 52-degree waterproof eyepieces from the same engineering, same design, same everything as our more expensive eyepieces. The 52-degree are our least expensive eyepieces. They're, as I said, waterproof. They're argon purged. So as they're made, they're assembled and then set in 1 meter of water for, I believe, 30 minutes, and then checked for leaks. And if they pass that test, they get shipped out to you, the customer. It's a pretty cool process. I've seen videos of it. So they use argon because argon is a inert, hydrophobic, in other words, doesn't like water or moisture. It's a dry gas. So if you replace all the air with argon, guess what? There's no moisture, and it can't hold any moisture, and therefore your eyepiece can't fog up internally. They'll still fog up with dew on the outside, on the glass, or somewhere else, but they will not fog up internally. Mateus Volkovas, hello, does Vixen eyepieces are good for beginners? That becomes a budgetary question. You know, Vixen eyepieces are great eyepieces. They can be pretty expensive. So that becomes a budget question. They're good eyepieces. You can spend as much money as you want in astronomy pretty well. But if you're just starting out, don't get hung up on super expensive gear. You work your way up to stuff. When I started, I didn't have any expensive gear. You know, I worked my way up and ended up buying a used 8-inch Celestron telescope, and then slowly bought better and better eyepieces and worked my way up. And that's on a telescope. I collected up a couple of Dobsonians and some other telescopes, but this was, then I came to work here and already had a background in astronomy. Really was good to come into the company with the knowledge I had, because it translated very well. Off-raid, 80 millimeter f8 should have less secondary spectrum than the common f5 acromats. That's correct. A little bit longer focal length. Okay, let's talk about acromats and what off-raid said. A 2-lens system, the light comes in, it starts focusing into a point. However, because of refraction, effectively, that second piece of glass becomes like a prism and starts breaking the white light into its constituent elements of blue on one side and red on the other. So when you see a bright object, like a planet or the moon or bright stars, you're going to see a blue fringe or a red fringe, depending on where your eye lands and what part of the spectrum you're seeing. You're going to see a red fringe or a blue fringe or maybe a purple looking fringe, right? That's the white light starting to break up. It's really close to being all white light, but it's really not. It's breaking up into the prisms, and you're seeing the ends of the rainbow, right? Red on one end, blue on the other. You're seeing the ends of the rainbow. A double lens system is called an achromat, and very short focal length telescopes can really start having a lot of chromatic aberration, where it's a bigger and bigger because it's spreading out more. So with longer focal length, it cuts down on that somewhat and gets rid of some of that chromatic aberration. Don't scare you off in this telescope. It's not like you're looking at something and you have this big purple circle around it. You know, chromatic aberration doesn't bother me. Coma, where the stars sort of look like little comets, little smears, that doesn't bother me either because I understand what it is. You know, if you want to not have things like that, you have to spend more money. And that's not what I'm talking about today. I'm talking about getting a good starter telescope that's a solid telescope with a good mount.
Sometimes get diamonds in the rough too. So some of these scopes, when they come out, are just fantastic.
They're still going to have chromatic aberration, but some of them are
really good.
not as bad as some, right? But I use, you know, we sell a lot of these at telescopes, and nobody complains about the chromatic aberration. Oh, I wouldn't say nobody. I could probably go back through the system and find somebody in the past 5 years that has, but
I would, but only because I'm like super photographer.
Well, yeah, but then you probably wouldn't spend the money on this telescope. You'd spend.
I'd get a mid-grade at least.
You'd spend $1,000 on an optical tube, not $359 or whatever the price is for this system, right?
If you're not that big, not that picky, and you're just wanting to start out and see if you even want to do it, I mean, you can even start it with a pair of binoculars if you wanted to.
Oh, absolutely. That's a great way to start doing this. That's frankly, with the Mark 1R and Mark 1L and a pair of binoculars, that's how I start astronomy. Osmosis 007. I believe argon gas is a smaller molecule than air and transmits heat much slower. It's why they use in high-end windows and high-end high-end eyepieces. Let's see. Argon is a larger molecule than, I'm trying to remember a periodic table. It's smaller than oxygen by 1 proton, maybe? Can't remember. But, you know, helium and hydrogen are the two smallest atoms, and they are significantly smaller than argon. But it does create a vacuum effect, not a vacuum, but argon-filled windows do have a low E transmission, right, an efficiency. And Osmosis 007 says, as a Mac user, field of view doesn't bother me. I'm looking for eyepieces as a new user. It will really nice not getting hung up on mega field of view since I love planetary. Right, so an interesting subject to talk about, field of view. Maxudo of Cassegrain and Schmidt-Cassegrain and Maxudo Newtonians all have very long focal lengths generally. That focal length means that with the same, if this is 26 power, right? 26 or 27 power at this focal length.
Cheat.
And you double the focal length to 1740 and use the same eyepiece, you're going to double the magnification to 50, what did I say, 27 to 54, right? So longer focal lengths with the same eyepiece offer more magnification, and that's what Osmosis is getting when you use the Maxudo. They're generally 1400, 1900, some get up to into the 2000 millimeters of focal length. So the same eyepiece, they start offering significantly more magnification than this telescope does. So with that, looking at planets and the moon can be very enjoyable because you're getting larger images of it. Now, one cautionary tale or word of caution, there's some nights the stars are twinkling, right? Well, you put a low power eyepiece on, let's say, Saturn or Jupiter, and they look fantastic and crisp at low power. So you go, man, I'm going to start going high magnification. You start adding magnification. You get to a point where it looks terrible, and people think, oh, my telescope's broken or something. It must be the eyepiece. It's not the eyepiece. It's the scene of the sky. You've magnified the scene so much that you're seeing the effect of what's causing the stars to twinkle. Stars twinkle because of different densities of air. So just like, think about the sky as a big pool of water, a swimming pool, and there's no ripples or anything, perfectly still. You can see leaves, toys, everything on the bottom, little tiny stuff. You can see them really well. But if you slap your hand on the water a little bit, it's a lot harder to see. You get 4 or 5 kids, hang on, you get 4 or 5 kids splashing around the pool, you really can't see the bottom of the pool. The sky's the same way. If the stars are twinkling, which is the star, which is a pinpoint, that under perfect conditions doesn't twinkle or move, but as the air changes density, the star moves around, right? Well, if you take the surface, the circle of a planet, there's a star here, well, that density that makes the star do this and this star do this in a different time than that one does is going on all over the surface. At low power, you don't see it, but at high power, you do. So you got to be careful, you know, when you're starting out, understanding that. What you got?
I think the best example that we should do is we should take the camera and put it in the telescope and film the highway just outside of here and show all that heat coming up off the highway, and you will see exactly what you're talking about.
Thing.
And it's the same thing, but since it's so much, you can actually show people what's happening.
Yeah, we should do that on some night when the stars are twinkling real bad. Go show a picture of, and we'll have to wait till this fall when Saturn gets back up and becomes a fall thing. Easier to do in the evening than get up at 4 in the morning to do this, because we get set up as soon as it gets dark, we can take pictures, show Saturn, and we're looking really nice at low power, and then you start jacking up the magnification, and boy, it goes to heck really fast. So, Offred, this scope seems a good choice for beginners who get into astronomy by media coverage of comets. Remember the Comet Catcher in the 80s? However, that was a weird scope. I don't remember the Comet Catcher, but there's plenty of weird scopes out there, and some people love that scope. I'm sure people loved it and didn't think it was weird at all. The coverage of comets, the coverage of moon. There are people who hear about the supermoon and buy a telescope and want to go out, and their first view is going to be looking at the supermoon. It happened when they have the eclipses, you know, lunar eclipses where the blood moons happens. People buy a telescope and they want to go out and use it tonight for the first time, looking at the supermoon, because man, it's a supermoon. I want to see it bigger, and that's all well and good. My strong advice is, if you're interested in astronomy, buy the telescope now and learn how to use it, so when those things come along, you don't have to struggle. You can simply just go do it. For instance,
so hint,
if you've never
we've got just seconds to go to Amazon. So if you just put yourself on hold for a second,
and we'll
come back and you can finish your thought. Okay?
Jump in with both feet. Hello, everybody. Welcome to Wednesday's Amazon Live broadcast, where we're streaming out there to the world. Woo-hoo. We're talking today about First Light Chronicles, named after one of the series of telescopes Explore Scientific produces. It's the telescope right here in front of me. It's the First Light AR 8640 on a TN, Twilight Nano Tripod. Let's talk about it real quick. The telescope comes, it'll be disassembled. You put the tripod together. The telescope is going to come, and this is how you put it on. It's real simple. Sorry. It just simply slides on, tighten down that screw, and hand bolt, whatever you want to call it. And there you go. It's attached. And now you're going to have to put on the diagonal, which comes with it. This little doohickey right here. And let me get it down here. Where's the camera at?
I've got both.
This little doohickey right here, the diagonal, and the eyepiece. You're going to simply put the diagonal in there. That diagonal makes it much easier to look into the telescope. Tighten down the tension screw, put in the eyepiece. Get your red dot finder right here and slide it into the obvious slot it goes into. Tighten the screw down. And you're ready to start using this telescope right now, out in the parking lot, in your front yard, or when the supermoon comes up tonight, you can look at it and it's going to be really bright and hurt your eye. Not injure it, but boy, it's going to be bright.
Now, I'm not going to look at the moon. I'm going to look at the comet.
You do have to remember to take the lens cap off, right? That's what you got to do as well. So Paul's going to go out and look at the comet tonight. The problem with that is the full moon is going to make it difficult to see because it's about magnitude 8 point something, which, you know, gets into some real technical stuff. We don't need to. 8 something, 9 is dimmer, 10 is dimmer, 11 is dimmer. As you get to
at like
3, 2,
negative
1, 0,
40, right? The moon's like at a negative 40, right?
Yeah, it's something like that. And so it's going to make the sky bright. And if there's a lot of humidity in the air, which there is because it's northwest Arkansas and it's July.
You can still see it.
You know, we were talking at my astronomy club meeting last night, Sugar Creek Astronomical Society, that it was difficult to see last week, 2 weeks ago. One of the guys had a go-to telescope, and he found it, but he knew exactly where it was and what star it was next to.
It's the closest it's going to be today.
Yeah, but it's still like 2 astronomical units away. Astronomical units.
It's just a little bit past, like, it's a little further away than Mars.
You need to consult, and it's very small, relatively. You need to consult a good sky chart to be able to find it, but even last week, a master observer, Paul Anderson, said it was it didn't look like a comet. Photographically, they could see a tail when they took pictures of it. You could see a little tail, but this is, you know, I look forward to the day, Paul, when a truly great comet comes by, and you can see it.
Hellbop.
Everybody, you know, Hakatake, you know, back in the 90s, Hellbop was a good one, you know, that you can look up in the sky and go, wow, there's a comet. Anyone can do it. They just have to look up and notice it. It's not like one of these things where you say, okay, see those 2 stars right there? Well, make a right angle triangle. That little thing right there, that's the comet. You know, Comet Neowise, you could see it visually. Barely with binoculars, you could see it and know it had a tail, but those aren't great comets. It's been more than 20 years since we've had a really, what's called a great comet that has a head and a tail. I can remember 2 comets back in the 60s and 70s, Comet Bennett and Comet West, that was a big bright ball in the sky with a tail that stretched halfway across the sky. I pine for one of those to come by, Paul, because that will excite people. And will get people interested in astronomy, and hopefully not just a flash in the pan. But if you have an interest in astronomy and have never taken the leap into a telescope like this is the way to go. Why? It's simple to use. You just saw me. You set up the tripod, you put the little tray in, You put the telescope on it, you put the red dot on it, put the diagonal in, the eyepiece. Now you're almost ready to use it. What you have to do is take the telescope out in the evening is the best, or under the shade of a tree like Paul was doing a while ago. Well, you weren't using a red dot finder. You're using a
I was
8x50.
not even under a tree.
Well, yeah, but you weren't using a red dot finder either. You should go out in the evening, before it gets dark, and you want to look at something that's the farthest away thing that you can see. I think the manual says 300 yards away. That's the minimum standard. If you can get half a mile or 2 miles or 5 miles, or maybe you're out in Kansas where you can see 15 miles away, find the thing you can see that's farthest away. Paul was out looking at a cell phone tower that's 3/4 of a mile away roughly. And what you do is, and you pick something that's easy to find, because you can't be surprised how hard it is to point a telescope at something without a aligned finder scope. So what you're going to do is you're going to move the telescope looking through it until you find the radio tower, and then you're going to go up to the top of the radio tower. Now you're going to turn on the red dot finder and look at the red dot. There's no laser that shoots out. It's just a red dot projected on what amounts to a heads-up display, right? And so you're going to look at that, and you center up on the top of the tower in the eyepiece, and using the red dot finder, you're going to move. There's 2 little knobs. Figure out which ones they are. One moves it left or right. One moves it up and down. And you move that red dot until it's pointing, covering up the top of the radio tower. Look in the eyepiece. Chances are you've moved the telescope a little bit. Well, you recenter it, and you keep adjusting the red dot, making sure it's centered. When it's centered and the red dot is on it, you're good to go. You're going to go out tonight, and you're going to say, I want to look at the moon. And you're going to find the moon by looking through the red dot finder this time. Right? You're going to find the moon, and then you're looking at the eyepiece. And if you've done a good job of getting the alignment right, the moon's going to be in the eyepiece. Now, it may not be centered up. Why? Because it's farther away. And because of parallax, you pointed the red dot to something that's a lot closer. That's why I say if you can get something 10 miles away, that's better than 300 yards, right? And so you pointed at the moon, you got it in the eyepiece, centered up, and now fine-tune the red dot towards even better. Now, as you go on your journey across the sky, you see something you want to look at, you simply just get down, look through the red dot, move the telescope until you get it on the red dot, look in the eyepiece, and there you go. Now, don't forget to turn the red dot off. That way your battery will last for a long time. Or you can do what happens and you forget to turn it off. You say, I'm going to turn it off when I get done using the scope. Well, you get done using the scope, you don't turn it off, you pack your telescope away, you come back 4 weeks later and the battery's dead. Well, now you're frustrated and you got to go buy another 2320 or 3220, flat battery and put it in there. And remember to turn your red dots off, right? This is a great telescope for someone who's just starting out. It has enough objective power. The bigger around, the more light it pulls in and focuses on your eye. It's got enough to get you started and get you going down the road to amateur astronomy. It has enough magnification power to see things slightly magnified more than your eye. By slightly, I mean this is going to be, let's talk about magnification real quick. Magnification is a division process. It's the focal length of the telescope, in this case 640 millimeters, divided by the focal length of the eyepiece. There's a number on here. It's at 25. Comes with the kit. So 4 will go into 100 4 times, and 100 will go into 600 6 times. So 6 times 4 is 24. And so now up to 600 power at 24, but it's 40 more millimeters. It's almost 50. So 24, 25, 26, 26 power, right? So this gives you a magnification of 26 power of what your Mark 1R and Mark 1L eyeball sees. So this is a 26 power magnification. One of the first things some people do is when they get a first light telescope, they'll go buy some of our waterproof eyepieces. Those come in the 52 degree series. This Super Apostle is a 52 degree series eyepiece. However, our waterproof eyepieces have more design to them. This is a Plössl design. Ours is not a Plössl design. Has more glass, better engineering, and they're waterproof. This one is not waterproof. What does that waterproof means? Means that all the air inside has been forced out, replaced with argon, an inert, dry gas that won't fog up because there's no moisture inside of it. So it can't get any internal fogging. As long as you don't unscrew the barrel and take the eyepiece apart, the purge is there. I've had people call and say, yeah, I got the eyepiece and I wanted to see what was inside of it. And when I unscrewed the barrel, that would be the silver part right here, they said, I mean, let's come off of this one, no problem. They said there was a psst, and was that a problem? Yeah, you just ruined your eyepiece. It's not waterproof anymore because you destroyed the perch. And I go, oh, okay. So don't be taking things apart that you don't need to, right? All right, so once on the moon, you simply turn the focusing wheels, focus it in and out to where it focuses for your eye, and you can see it sharply and clearly. Now, let's say you're looking at the moon. As the moon's moving across the sky, you're going to have to follow it periodically by moving the telescope left or right and up or down, depending on if it's in the southeast or the southwest, and you just follow it across the sky. You move the telescope while you're looking through the eyepiece. You don't look up here and go, okay, I'm going to move it. You're going to lose it. You look in here, and before the moon gets out of the eyepiece, you move it like that while you're looking at it, and you keep moving across the sky with the moon. Now, so if you want to double the magnification of this telescope, this is a 25, you'd go down to a 12.5 millimeter eyepiece, because if you cut the focal length in half, right, 52 goes into 640, we determined 26 times, right? If you go to a 12.5 will go into 640 millimeters. You cut it in half, so you multiply the 26 by 2, and you find out it's how much? Yes, 52 power. If you cut it down to a 12.5, say go to a 6, you're going to go to 104 power-ish, right? Real close. Not exactly, but really close. All right, so that's how magnification works. When you double the magnification from the 26 to the 12 or 10 or whatever you have, that's all well and good, except now the moon is going to appear to move, or the star you're looking at, or the nebula, is going to appear to move twice as fast as when the 26 was in. And if you go down to a 6 millimeter eyepiece, it's going to move twice as fast as when looking through the 12 or 10 millimeter eyepiece. So you're going to have to be moving this a whole lot more. By most, I mean well over 75%, probably 85% of all my astronomy viewing is at low power with a 25 or a 30 or maybe even a 40 millimeter eyepiece in a really wide field, really low power. I find that much more enjoyable than having to deal with something at really high power. And I have a telescope that can track and stay on the target. That's okay. I still like the low power. People get really, they crave that massive power. And, you know, our boxes don't say, 800 power telescope. Yeah, if you see a telescope like that, don't buy it, because it can't do it, right? If it's a department store telescope, it can't do it. Can it do it? Sure, it can do it. Can you get the magnification? But it's not going to work because it's moving so fast, you can't keep what you want in the eyepiece of your telescope. Don't buy into that massive marketing. Why? Because those companies know how to market to you, and they know beginning astronomers think more magnification is better. But I can tell you right now, less magnification is where you should start, and slowly work your way up to understand what magnification does. Again, significantly more than 3/4 of my viewing. And when I do outreach, 95% of my outreach is at low power. Every once in a while, if it's not a big crowd, I've got a telescope mount that tracks. In other words, there's got motors that follows the object across the sky. I'll increase the magnification, but that is a rare day. All right, so here on Amazon Live, we'd love for you to reach out to us and say hi. And if you're new to the channel, click that follow button if you like the educational value that we're offering, as well as seeing some of these products right here. So I'm going to switch telescopes. What you got?
So Fiddlesticks. Hang on a second.
Looks like you're trying to get up a picture of a comet.
Yeah.
While you're doing that, I'm going to switch out the telescopes.
Issues.
And this is going to be an equatorial mount, so we're going to show you how to do a polar alignment here in a minute, because that's a skill you have to learn to use this mount.
There we go. Here we go.
Off into the wild blue yonder?
No, I'm doing something.
That scares me, Paul. Not really.
It's so... I can't seem to do anything right these days. Anyway, keep going. I'll get it.
He's trying to get a picture of a comet up. So anyway, all right. So this is the First Light Series 114 millimeter Newtonian. What that means is it's got an objective end. The previous one had an objective of 80 millimeters. This one has an objective end of 114 millimeters. It's going to collect significantly more light than the 80 millimeter telescope. But this is a Newtonian design. This has a mirror in the bottom, not a lens set. There's a mirror right here that's curved. Light comes in the telescope. Let me see how I can do this and get it to where you can see down the telescope. This is going to be, got an idea. How about that? There we go. So right here, you can see that there is a circle with 3 veins holding up. That's holding up a mirror. The light goes past that mirror down to the bottom of the telescope, which is, we'll turn it this way, to the bottom of the telescope where there's a mirror, right? That curved mirror, the light comes in, bounces off the curve, which is an angle, and starts coming to a point. That point is called the focal plane. So what happens is it's coming back out the telescope, right? Remember that mirror down there? It's reflecting it back towards the front, but it's getting smaller and smaller. It reflects off of a flat mirror that's right underneath the focusing unit and reflects that focusing light out the side, where now we can use the focuser along with the 25 millimeter super plossel this telescope comes with to get the object we're looking at into focus for our eye. Now, it may be in focus for me, but it may not be in focus for you, and it may not be in focus for the next people. So you got to learn to focus. Everybody's got to learn to focus the telescope to make it work. If you wear glasses to see distance, you're probably going to need to use them at the eyepiece. If you use glasses to read like I do, then you're not going to use those at the eyepiece. Probably experiment and see what happens. So this mount is clearly different than the mount we were looking at a while ago. That's because this is called an equatorial mount. Equatorial for equator. So what you want to do is figure out how far north or south of the equator you are. Here in northwest Arkansas, we are 36 degrees north of the equator. So right here on the side of the telescope, there's a little gauge that shows 36 on it, and we're going to move the telescope by turning. Let me unlock it a little bit. We're going to move the telescope. We can raise it and lower it right there. And what we're doing is we're getting this axis aligned with the rotational axis of the Earth, which is based on your latitude. That's how much higher or lower you need to make the telescope. Once that's done, you got that set, then you've got to figure out how to polar align. Well, polar aligning is a skill to learn. It can be done. Paul, you got the video ready?
No.
Well, I told you we're going to do a polar alignment and have the video.
I told you I was working on this.
Paul's going to get you.
I'm busy.
He's busy doing things that don't directly relate to what I'm talking about right now.
They do.
How about that?
All right.
All right.
Fair. Here we go.
Hey, everybody. Kent Martz here from Explore Scientific. Today I'm going to teach you how to polar align your telescope using a broom. Why do you need to polar align? Well, with a telescope that has an equatorial mount, you have to get that equatorial axis lined up with the rotation of the Earth. And to do that, we're going to start with the tripod. We're going to decide which one of these legs is going to point north, and we're going to set the tripod down so that leg is pointed north. First thing I'm going to do is use a level to make sure my tripod is level
So if it's tipped one side or the other, that's going to cause your polar alignment to not be accurate. So we're going to use a level for that purpose. Then we're going to take a compass, and just to make sure that I've got it pointed north, I'm going to use the compass, line up, and go, yep, that looks like it's pointed north. So here's what I'm going to do now. And this is where the broom comes in. The broom becomes a measurement device, if you will. So I'm going to put the broom on the ground with the tip of it right against the north leg of the tripod. And I'm going to back away, and I'm going to use the compass. I'm going to close one eye, and I'm going to use the compass to make sure that the broom is lined up with north, right? And so I can tell I'm off just a little bit, so I'm going to move the tripod just a little bit, and I'm going to turn the broom, and the broom is what I'm seeing that line with to line up. So closing one eye, now my broom is lined up perfectly to magnetic north. Right here is we're going to talk about something called magnetic declination. The magnetic north is not true north. The difference between true north and magnetic north can be off by as much as 15 or 16 degrees if you live on the east coast or west coast of the United States. Around the world, it varies, and you have to figure out what that is for where you live. Because if you point at magnetic north, you're not going to be pointing at true north. You could be off by 15 degrees. Your go-to will never be accurate. So for this system to work, you have to know what that offset is and be able to program that into your compass. We're going to provide a link to a website and a video that talks about that a whole lot more. Now, we're going to make sure that the tripod is not angled wrong. I'm going to use a small tape measure, and we're simply going to come down here and be careful not to move the broom, and I'm going to measure the distance from the tripod leg to the center of the broom. That is 470 centimeters. That way, it is 470, a little, I'm going to call that good. Actually, I'm going to move the tripod a couple of millimeters, just like that. So now, we know that we're lined up true north with that leg, and these two legs are the equal distance from right here. So it's not pushed that way or that way. So now that we have the tripod with a good alignment to the north, we have to put the head on the mount. And that's going to entail this. We're going to be very careful when we do this because we don't want to move the tripod. We're going to put it on and simply screw on the polar head just like this. Remembering everything's going to the north. Now if you're in the southern hemisphere, you're going to do the same thing. You can do the exact same in the southern hemisphere because it's not polar, it's polar alignment. We just don't use the star Polaris, which we're not using here. This is really good if you can't see Polaris, or if it's daytime and you want to do some solar viewing with a solar safe filter. So the last step of this process is to check the scale of your altitude, right? So we live at 36 degrees north, and I am going to turn the altitude until it gets to 36 degrees north. I'm going to stop, and that's it. With this system, using a broom, a compass, and a tape measure, you can achieve a good, decent starting polar alignment. Personally, I've used this, and I've got an amazingly close polar alignment. There's ways you can use to refine your polar alignment, specifically drift alignment, but it all starts with a good polar alignment. You can do this in the daytime. You can do this in the nighttime if you can't see Polaris. It works all the time. It's a good way to get started learning the process of polar alignment. Isn't that great? I hope you've enjoyed this video. For Explore Scientific, I'm Kent Martz. Get out there and start doing astronomy. And keep looking up. There you have it. You now know how to do a polar alignment to get it lined up with the north celestial pole, true north, rather than magnetic north. That's the key that a lot of people miss. If you use a compass and you live on the west coast or the east coast of the United States, the compass may point north as much as 15 or 16 degrees off.
So you got to learn how to deal with that error right there. So we're going to assume we got the mount polar aligned now. And so here's how you use this equatorial mount. First off, it's got slow motion controls. This, remember the first one was just left, right, up, and down. You grabbed a handle, had to move it. This mount is a step up. It's got slow motion controls, and I can turn it real fast. You can see the telescope's moving right there, maybe. Yeah, there you go. You can see it moving right there, okay? And this one turns this axis. So let's talk about these different axes. This axis mimics the rotation of the Earth. This is called right ascension. Don't need to know why. Just understand that this axis is how mimics the rotation of the Earth. That's the polar axis of this mount. There's a little lock over here. It's a little knob you turn to keep it from turning by itself. Up here, this axis is called the declination axis. And it is sort of up and down, but not really. So if we want to look at something that's in the northern hemisphere, or in the north, say, we want to look at Polaris, we just put it straight down and just like this, and you should be able to see Polaris. If you've done a good job of polar aligning, you should see Polaris in the eyepiece. Let's say we want to go to Mizar and Alcor and the handle of the Big Dipper. Let's say that it's right there. So now we're going to find it with the red dot, and you can use a star atlas or a planisphere, and we'll talk about planispheres here in a minute, because we've got a planisphere over in the Amazon carousel that you can pick up as well. So let's say you've got this on Mizar and Alcor, and now you can simply just follow it all the way across the sky by turning the right ascension, right? And it's just going to follow that spot all the way across the sky. If you're off a little bit, it may drift in declination. Remember, this is the direct declination axis going this circle. You simply turn it and center it back up and figure out which way, where you need to go to get it positioned, so it'll stay in the eyepiece a long time. Harder to learn than the Twilight Nano, where you just set it down and just left, right, up, down, point the telescope. But the equatorial mount is more powerful. It's more powerful because, like I said, once you find the object, you should and have done a good polar alignment, and rough is good enough, especially starting out. You've got a good rough polar alignment, start using a telescope, right? And as you get better at polar alignment, you'll find that the mount is easier to use. I said, rough enough is good enough. Don't let the quest for perfection in amateur astronomy or lots of other things get in the way of good enough to start using your device. If you want to get everything perfect before you ever use it, you're not going to, because it's skills you have to learn, and you have to make little mistakes and learn from them to make you get better, right? And I've literally had people who have called in with problems and questions and situations and things they didn't understand, and I finally say, have you used the telescope? And they'll say, no. I say, why not? Well, because of this and that and the other thing. I say, okay, so look, it's clear where you live tonight. Why don't you just go out and use the telescope tonight? No matter what, go out and use the telescope. Because I'm telling you, close enough is good enough. Go out and use it. And learn, enjoy it. See those beautiful things. See craters on the moon. See the rings of Saturn. See the planets of Jupiter move in front of your eyes. Yes, you can see. Did I say the planets of Jupiter? The moons of Jupiter. See the moons of Jupiter move in front of your eyes. If one of those moons is close to the edge of Jupiter, you can actually see it moving over 5 or 10 minutes. It's truly amazing to see something up in the sky that you can tell is moving. So I think we have a question coming in. There we go. What telescope can I get for €350? 350 euro is, that's not euro, that's pound sterling. Paul, would you do a 350 pound sterling conversion? So it'd be 350 pounds to USD. It's going to be like, I don't know what the conversion rate is. It may be 1-to-1. I think that maybe 1-to-1 right now. Just happened. Somebody's currency had gone to a 1-to-1. Paul is over there trying to find it on his phone.
That's something I do every day.
Just, hey Noah. Oh, can't hear me. And he can't do it on his phone.
I can. Try to do everything else too.
What you got?
Trying to do everything else too.
I know, but what do you got for the pound sterling?
350
pounds to USD.
Search.
Noah.
Pounds to dollars.
Search for pounds to USD. Pounds, like pound sterling, British money. Pound sterling to USD.
Well, it
350
won't
pounds is how many dollars?
It's about 200 or 400.
416. So 350 pounds. So $400 conversion rate. I believe it'll get you all of these telescopes we're looking at right now. This telescope right here we have right now, the First Light 114 millimeter Newtonian on the equatorial mount is $279.
It's like
now,
190 pounds.
Obviously, if you're talking about pound sterling, you're probably in the United Kingdom, Great Britain, England. You know, I know there's politics tied up in all of those, and I apologize for
Find it on Amazon.
Consternation.
And you'll get it from Bresser, Germany, I think.
I don't know if they have these or not, but a telescope like this, in this range, all the ones I've been talking about are going to be within your price range. You buy this one, you have money left over to buy a couple of other, at least one other 52-degree series Explorer Scientific waterproof eyepieces, and that'll still be really close or within your budget. What is the focal length of this reflector? It is 500.
That was the reflector, yeah.
Of this reflector, it's 500 millimeters. This is the Newtonian Telescope, named after the inventor of this telescope, the person who also invented gravity, not discovered gravity, described gravity, talked about gravity in modern terms. Sir Isaac Newton came up with this design of a telescope because refractors were getting so long. He came up with a way to get to shorten up the focal length and make them much more user friendly. So Sir Isaac. Julian, but that's just my opinion. Honestly, trying to find a local star group will be very helpful. Yes, Osmosis 007. I'm not sure what Julian said, but if you can find a astronomical society, an astronomy club, whatever, in your area, most assuredly, like learning any other hobby, it's much easier for you to have somebody, a mentor, to teach you how to do it. Kent equals facepalm.
I have no idea. Something you said.
Probably the planets going around Jupiter. I'll bet that's what it is here. Absolutely.
Well, they could be planets if you were something else.
Yeah, I'm going to guess that's what that was about. So, yeah, there we go. All right, so.
With this, you could just go out and plop it down and possibly see the comet.
Yeah, there's a comet, Pan-STARRS 1307 K2 or something like that.
Yeah.
Yes, that you go out and see. I believe it's in the constellation Ophiuchus right now, which is in the southwestern sky. The problem is that tonight the full moon is very, very bright, and it's going to make it very difficult to see that
In
comet.
the northern hemisphere, you should be able to see it until late September.
So my advice is to not try and see it tonight necessarily, unless you're just dead set on looking at the full moon and then looking for the comet. Wait 3 days or 4 days. 3 days, the moon's going to come up well after sunset, giving you time to get the sky get dark and you see Ophiuchus up in the southwestern sky.
Do you think it'll look anything like some of the ones in the past once the moon go away?
From what my Sugar Creek Astronomical Society friends were saying, if you remember Comet Neowise a couple of years ago.
Or Hale-Bopp.
Well, okay, no, it's not going to look like Hale-Bopp. It will not look like Hale-Bopp.
Because that's what I have loaded. That's why.
It's not going to look like that. And again, you have to remember that this is taken with a camera, right? So it's a long exposure. You can tell it's a long exposure because the stars have moved. No, have they moved on that one? Nope, they maybe a little bit.
It says right there. Doesn't it?
It was taken with a telelens, so we know this person is probably not American. The dust tail fans out to the right while the bright, well-separated blue ion tail is pointing straight away from the sun. Chances are this was a tracked photograph. It doesn't say how long it was, but it doesn't take very long for the camera to build up light. You gotta remember, your eye is operating about 1/40th of a second. That's why if you're looking at a light and it's not flashing, and you're on, in the United States, you're on 60 hertz, that light bulb is flashing 60 times because your eye stays open too long, right? If it was a shutter, so you can't see it. So you're really only seeing 1/30th of a second exposure of what's coming into your eye. So if you have a 5-second exposure, you're building up on the sensitive camera surface.
There's some debate over that.
Okay, whatever it is, it's operating slower than 1/60th of a second.
Well,
because it was faster than 1/60th of a second, Paul, you could see the lights flash, and no one can.
Not necessarily true, because if you're going 120 frames a second and you're watching it in real time, or even 200 frames a second, it happens so rapidly you don't see the lights flash.
Correct. That's what I'm saying. It's happened so fast you can't see it. However, if you've ever been watching a sporting event where they go in slow motion, like real slow motion, and you can see the frame getting brighter and dimmer, looks like it's pulsing, you're actually seeing the lights flash on and off. You're actually seeing that flash because the camera is going so much faster than the light is, and they play, a half a second of action takes 20 seconds, you're seeing those lights flash on and off.
What's the fundamental difference between the two telescopes we've seen so far?
One's a reflector and one's a refractor. One's like Captain Jack Sparrow's spyglass, or the telescope Galileo used, got to use to observe the heavens. That's what he really did first. He improved the design of a previously existing telescope, and he used it to look at the heavens. So one's a reflector and one's a refractor. One refracts the light into a point. This one reflects the light into a point.
So they have better uses. There's the right, like you said, the right tool for the job.
So there's different kind of hammers, right? There is no perfect telescope, just like there's no perfect hammer. If you're wanting to drive tacks, the perfect hammer is a tack hammer. Can you do it with a jackhammer? Yeah, if you just set the jackhammer down on it and don't turn it on and turn the air on, the pneumatic hammer. If you're wanting to split wood and beat on a wedge, a splitting maul or a 9-pound sledgehammer works well. If you're wanting to frame a house, a framing hammer is the tool to use. If you want to roof a house, a roofing hammer. They're all hammers. Heck, I've driven nails before with a pipe wrench, right? Because it's the only thing I had that would work, so I used it. The point being, there's tools for jobs, right? Every telescope is a balance. There's no perfect telescope that'll do it all. A refractor offers high contrast views. A Newtonian offers a whole lot of aperture for not a whole lot of money. Aperture, the 80 is this big, the 114 is this big. You get up to 127 millimeter refractors, 152 millimeter refractors, 5 and 6 inch refractors. They start gathering more light. Because they don't have this central obstruction, they offer higher contrast. Now, eyepieces can change the contrast, but this nice short tube makes it really nice. And this is a Newtonian telescope. I don't have one here because we don't have any in stock, but we're getting ready to in hopefully a couple months. Excuse me. They're called Dobsonian telescopes. They're a Newtonian telescope on what amounts to a Lazy Susan and a couple of vertical
we've got
boards
them in the showroom.
with you can show them with some curves cut in, so it's easy to use. Those telescopes, 6, 8, 10, 12. We have one that goes up to 20 inches in diameter. That's the big boy telescope. So Paul's getting up a picture of a Dobsonian telescope. They're called Dobsonians because after the monk in San Francisco, John Dobson, who really popularized that kind of mount. Literally, you just turn it left and right and raise the telescope up and down. It's just like that Twilight Nano I showed you earlier, just designed a little bit different, right? So, what you got?
You're just going to...
Okay, so I thought you had something ready to go. Okay. I thought I saw it queued up. I thought you had it queued up. So, beginners, for the bang for the buck, a Dobsonian telescope is one really good option. They can be bigger and harder to transport, which presents problems. If you have trouble lifting stuff, that presents problems too. Like I said, everything's a balance. You got wants and needs. You've got budget and expense. You've got eyepieces. There's all sorts of other kit you can get as well. That's why a kit like this, to get you started out, comes with everything you need to get started and then lets you get on down the road and figure out what you like. Again, somebody mentioned an astronomy club. If you can find an astronomy club, absolutely you should start going to those meetings and meet up with a buddy. Now, this is
the big boy.
This is the 20-inch telescope, Newtonian. It's a truss tube model. So it comes apart and packs up in a really small package. But a lot of entry-level Newtonians have a solid tube. Think of a pipe 12 inches or 10 inches in diameter.
That's a big boy there.
That's 20 inches across. That's almost 2 feet in diameter. That's a big telescope. But they all sort of look the same. You can't get the scale of the cage on that thing is literally this big around, right? You can't really get that scale.
That's the same
it's
stage
the same everything. Yeah.
that Kent was standing on when we does the how to polar align.
Yeah.
So you can imagine that's the size of a person when it's put together.
It's really big. Yeah, I could come close to getting down inside of that. I wouldn't want to, but you can. Anyway, but a 10-inch or an 8-inch or a 6-inch Dobsonian telescope, it's going to be a solid tube, and it's going to be a tube about yay long. So if you don't, yay long, really long, maybe this tall, so it doesn't collapse down on those entry-level scopes. They're less expensive than these truss tube Dobsonians that you see. However, they can be hard to transport. You've got to have a car big enough, either a back seat that's wide enough or the ability to fold a seat down and stick it out through the trunk into the back seat to transport it. Once again, there's trade-offs for everything. Ken N, does the reflector require a coma corrector? This telescope, there's no real way to hook a coma corrector on to this telescope. The reality is the corrector would cost more than the kit does. Coma doesn't bother me. If I look at it, I can see it, but I ignore it. Coma or field curvature is caused by a curved surface, when the light starts hitting a flat surface like a mirror, like a camera sensor, that light comes in and it hits here and then it smears. And when it smears on that flat surface, it creates little spikes that are called coma, because the French thought it looked like comets, and the French word for comet is coma, and so they named it coma. So field curvature or coma are much the same thing. One's in a refractor, one's in a reflector. If you buy this telescope and you've never looked at a telescope before, you're not going to notice it. You might notice it, but the human eyeball is also a curved surface, right? And so your eye and mind work together to deal with those issues.
Every day at 1:30, Tariq.
Yep, every day at 1:30, unless we're running behind. And then if we're on...
2 o'clock on Amazon.
Yeah, 2 o'clock on Amazon, and we're on till 3 o'clock or thereabouts. So your eye does a miraculous job and your brain does a miraculous job of fixing the coma. Some people see it, and it really bothers them, but those people are almost always people who are experienced observers, and they've learned to see it, right? Or they have OCD, and it just bothers them because they know it's there. I fully understand and appreciate that situation. There's little things my OCD kicks in on, and I'm compelled to do things. And I'll be honest with one of them. I've talked about it, made no secret of it, talked about it on social media. I eat things like M&Ms and Skittles in units of 4. I also, Christopher Hughes, just stumbled into this, going back to the beginning to catch it all. Hey, Christopher, thanks for joining us. We're here, social media launch at 1:30, and then roll into Amazon Live at 2 o'clock. And this is a Amazon Live broadcast going out on, the feed. So we do a lot of education, talk about products, and you'll hear me say over in the carousel, that is a product on Amazon Live where you can click on and buy the products we're talking about. What a finder really do for me, Tariq. Not sure the question, Tariq. Tariq's in the UAE.
Why would he need a finder?
Why do you need a finder? Finding something in the sky, even something like the moon, can be a very large challenge. I was using an ED80 2 Fridays ago at a community festival I go to, and was trying to find the sun manually. And I did it by having somebody stand down from the telescope, and I sighted along the telescope and had the sun directly above her head. And then my brother was there, and he was watching the shadows and everything, and we finally found the sun, but it took a couple of minutes to do it, whereas if I would have had a solar safe finder, I could have done it in a few seconds, right? So finders, whether it is the red dot finder that comes with it or an add-on finder, like over in the carousel, you're going to see our ES Reflects site, and it's a heads-up site that projects 3 circles onto a piece of glass, much like this red dot is projected onto the front lens element here. It's a 0 power. It's really sharp how it works.
Going to have to find that thing.
We had one in here in the studio, and
it's supposed to be with me.
Yep.
It was in my orange box.
And it's gone. We can't find it. Nobody fesses up.
Also, I'm missing a extension tube.
It's amazing how things that are made of metal grow legs. It's weird. It's like if you pop the accidentally pull the tail off of a lizard, it grows a new tail. Tariq, I never have any issue finding anything in the sky without a finder. I can even manually, I can go to. So what the finder is really helped me for. If you can find those faint fuzzy things up in the sky, Tariq, you don't need a finder. It's a skill you've developed, and great for you to be able to do that.
I can do it too, and it's not something that I've trained for. My brain understands how to point something
at
the star, and I can do it every time.
Mine does too, but I'm trying to find the sun with a solar filter on it.
But not everybody can do that. That's just
everybody
has
talent. I was going to say everybody has a skill that they are very good at.
Yeah.
So while we're talking about me trying to find the sun to look at, let's talk about looking at the sun. If you have a telescope, don't do it. Period in the story. Don't do it until you learn how to do it safely. And one way of doing it is with the Explorer Scientific Sun Catcher large aperture solar filter. This thing right here is made out of Thousand Oaks film. It comes shipped, put together, folded together. It's cardboard. Has the Thousand Oaks film, highly reflective, reflects well over 99% of the light away from the telescope. Doesn't build up heat. It's got some internal coatings in there that make it a pleasant yellow-orange glow like the human eye really likes. On the back side, you'll have 4 pieces of double-sided tape that are separate. You're going to peel off one side and stick it on here. And once that's done, you're going to take the 4 pieces of triangle foam and pull it off the tape and stick it on here. Well, the foam in here has been used so much, these won't stick on anymore, but you get the idea, right? And so you're going to stick them on there, and there's going to be 4 of them. And then my advice is you take the lens cap, right, and you press it down in there just like that, and you mark the plastic. Look where the little mark is, and then take a regular knife. And, well, actually how I do this is before I stick them on, I put them in there because I don't want to cut the film, right? So I put them in where I'm going to use them. I put this on here. I mark it. I cut inside of that line. I want to make sure I have a nice, tight fit when we put this up on the telescope, right? We don't want this coming off. We want to have to work this on and squeeze it on there. If it just goes on there, like, then you have it too loose, you need to contact us and get new ones of these so we can get you fixed up. And once I have it sized correctly, then I am going to pull these out, pull the double-sided tape off the outside, stick these 4 in place, and off I go. Now, this is going to mount right there on the front of the telescope. Now we can safely look at the sun with this Newtonian telescope. Lining it up, I just line up the shadow until the shadow gets really sharp and crisp on the ground, and then I look through the telescope, and most of the time it's there, or I can adjust it and find it using the slow motion controls. That's all there is to it. We make these for every size of telescope. We don't make one for the 20-inch Dob, although I guess we could if we wanted to. But yeah, we could engineer one for you. But very inexpensive, yet very effective and very functional. Why would you want to look at the sun? Well, there's an 11-year cycle in the sun called the solar cycle. And it goes from having no sunspots on the surface of the sun to having a whole bunch to having none. That's an 11-year cycle. Right now we're coming out of solar minimum. We had for a couple of years with effectively no sunspots, just a big round disk in the sky to look at. Now we're seeing more and more and more. Right now there's some sunspots that are naked eye sunspots. If you have solar glasses, you can go out and put your solar glasses on, look up at the sun and see the sunspots on the surface of the sun with no magnification. With magnification, wow, looks fantastic. With just a little magnification, you can go more and more, and if you have a tracking mount, follow just individual sunspot areas. What's a sunspot? I heard you ask that. Somebody, I heard who it was, couldn't tell whose voice it was. Sunspots are areas on the sun where the magnetism gets all twisted up. So on Earth, there's a molten core that creates a magnet. And, you know, the poles are just like that. The magnetic lines are well organized. Don't get mixed up. On the sun, there's no molten core that's creating the lines of magnetism like on Earth, and they come out all over the place. Well, sometimes they get all twisted up and tangled. Where that happens, it holds back the production of light, and that area cools off a little bit. Now, cool is relative, friends, because, you know, the surface of the sun is 9,500 degrees, you know, and the sunspot is 6,000 degrees maybe. So it's significantly cooler, but if you're standing next to it, it's still going to vaporize you because it's still super duper hot. Now then, if the sun was just as bright, if the color of the sunspots was all over the sun would still be extremely bright. It's just that these filters cut it out and make it look dark when it's still producing a whole bunch of light from that spot, just not as much as around it. The sunspots move, they grow, they change. You'll be sitting there watching the sun, and I've done this for hours, you know, sitting at the eyepiece just watching, and you'll notice one area starts looking a little bit disturbed or funny, and you keep watching it, and you're like, is that turned dark? And over the period of 15, 20 minutes, a sunspot starts growing, and in a little bit you can see, yes, really is a new sunspot right there. And sometimes they die out. Sometimes they become really big sunspots and grow over time. Some spots, and if you look at the sun, there's two bands where the sunspots are most prominent, and those bands rotate around. Some spots are so big and last so long, they'll go a couple of revolutions on the Earth-facing side, so we'll be able to see the same sunspot a couple of 3 times until they finally die out. But going up into solar maximum over the next couple of years, there's going to be more and bigger sunspots. And you most assuredly want to be ready if you're in North America or Central America. You want to be ready for the solar eclipses coming up. There's an annular eclipse in 2023 and a total in 2024. You want to be prepared for that. You want to start learning how to use your telescope to look at the sun. You want to start learning how to photograph the sun with it. Like anything else, you know, there are people who buy a telescope and it gets delivered today and they want to go out and look at the moon tonight. They may do it, but they're not going to have the pleasure they would otherwise, because they're going to be, especially if they've never used a telescope before, they're going to be out there struggling to make the telescope work. It's going to be very frustrating. That's really not the way to do it. You got to start getting ready for things like that way in advance. So, all right, rolling up on 3 o'clock here on Amazon Live. If you are watching us out there in Amazon Live land and have never clicked that follow button and you like what you see in the education we're doing, we would be honored to have a follow from you. We appreciate it very much. And that follow helps the Amazon algorithms. The more that people follow us, the more people get served our content without having to stumble on it, and that's a good thing, because we try really hard to do a lot of education, not just push product, push product, push product. So today's Wednesday. Tomorrow we're going to have On the Wing. We'll be talking about birds and birding and things like that. Friday will be First Light Chronicles, and roll back into Monday, where... What'd I say? Yeah, okay, focus on astrophotography is Friday. And then we roll into next week's programming. We try to go live on Social Stream at 1:30 and then on Amazon Live at 2. Go for an hour, and there you go. So on behalf of Paul Newton over in the control booth, thank you, Paul, for your work today. Noah Menard, Marketplace Menard, over keeping the Amazon and other platforms up and running and current and correctly priced and inventory correct. And everybody else here in the Explore Scientific family in Springdale, Arkansas, I am Kent Martz. I bid you a great day. Thank you for blessing us with your time. Bye-bye, everybody. Hey everybody, Kent Martz here. Good Monday afternoon, evening, whatever it is for you. Heck, there's some people, it's Tuesday morning. Thank you for joining us today on the social media warm-up for our Amazon live broadcast. Today is How Do You Know? And today we're going to start off with a pair of binoculars. Now this is a great pair of binoculars. These are colorful, obviously. They're 6 by 21, 6 power eyepieces, 21 millimeter objective lenses. Has glass lenses, an adjustable diopter so you can focus on your left eye and then fine tune it for your right eye so both eyes are in focus. And this is a pair of kids binoculars. Now, these things are very affordable, and these are real binoculars. I am advocating, if you've got a kid in your life and you want to do some birding or go out and look at butterflies or astronomy, whatever, get a pair of these for yourself and get a pair for that kid in your life. And go out and use the same binoculars they're using so you're seeing the same things, so you can describe how far away things are and things like that. These are the Bresser Kids Specialized Binoculars. Comes with a neck strap, real handy neck strap. Has safety clips on it, so if they get pulled on real hard, if the kid or you get hung up on something, it's going to pop off and not strangle you or hook you up on something. It's nice and a safety feature here. Made out of metal. The yellow is sort of a rubberized material. The red is a metal. Very good pair of binoculars here, especially for them. They're not waterproof, so you don't want to take them swimming or anything. But I really like this pair of Bresser 6 by 21 kids binoculars. Now we're going to roll on into something else. This is a new product for us. It's over there, out there on our website, explorerscientific.com. It's also over on our Amazon page, and this is a warm-up for that broadcast. This is the Star Maker video kit. I'm unpacking it, as you can see. I didn't have it ready to go. I forgot to take it out of the box. And there we go. And we'll just make the box go away. Hey, this thing is charged up and ready to go. How about that? We can spin this around here with the 300 or 270 degree camera. This is a fantastic device. You can see it right there. And you can see my face right there, so you can see what you're getting in the shot, just like that. This is a really cool device. It's for ages 8 and up. It's so kids can learn, and adults can use this too, how to, let me turn it off, figure out where the off button is, there we go. It's a great little 1080p HD camera. Has an 1.25 inch screen so you can see it. Has a built-in microphone, built-in camera. There's my first sneeze. We'll get a couple more before the day is over with. Spin this around so you can see it a little bit, the front of it. You can put on an external microphone. It's got face detection, so it'll focus on the faces in it. You can record up to 1.5 hours or more of video. It'll also run for 1.5 hours on one charge. It comes with a handy tripod that also serves as you can raise it up, right? Or you can, I'm going to lower it a little bit, or you can use it as a selfie stick, right? There you go. You can use it as a selfie stick. So you got some young ones in your life, or you want to play with making video on an affordable platform, this is the route to do it. A really handy tripod, a 1080p HD camera. It comes with a 16 gigabyte card, and it goes up to 64 gigabyte. And I'm going to make sure that's 16 gigabyte. Now, last time I took this out, it shot across the studio, but I managed to get it out. Yes, it's an 8 gigabyte card. Excuse me, an 8 gigabyte card. Sorry about that mistake. I'm going to make sure I get it in there. I'm going to cover my hand because, boy, it shot out. We found it, though. It comes with a nice light you can turn on so you can do a bright light, a dim light, or a strobe light effect right there on this handy magnetic base sign or magnetic base. You can also, little screw hole, you can mount it on a wall, and look at that. It's got a good enough magnet. It will hold it in place just like that. Comes with a USB cable so that you can charge the camera with this, or you can plug this in and download your video segments without taking out the SD card. Or you can put the SD card in a computer and take it out that way. Also comes with a clapboard, so you can write down the scenes that you're going to video record, get it at the very start of the video. That makes it easier to locate the scenes that you want to get, and when you're ready to start editing, you can find them easier. Now, this does not come with an editing program. You're going to have to pick a editing program on the computer you're going to use and download it, but it allows you to do regular, just like they do in the real movies. Action, and off you go. It also comes with a green screen, blue screen, so you can play with chroma screen. Chroma screen is where you take the background that is a uniform color, in this case blue or green, and you can put whatever you want to back there. Magic swirls, paisley, video from something else. This allows you kids to start working on their video editing, recording, and storytelling skills. We all know how important video has become, and this gives your kids a jump start on learning the skills they're going to need that's going to be important for the rest of their lives as they do video on their social media platform of choice in the future. Who knows what's going to come around when 8 or 10-year-old is 14, 15, 16. Hard to say what platform they're going to be on, but if they want to get a great start, this is a great way to do it. The Star Maker video kit comes with everything you need to get started, including a camera, tripod that serves as a selfie stick, the 8 GB card that'll get you up to more than an hour and a half of video, the camera that runs on a hour and a half on a full charge, the camera head swivels so you can change the angle and still see what's on the 1.3-inch screen, the video clapboard, the light, USB cable, and the chroma screen. So that is the Star Maker video kit, a new product from us. It's been selling well, and I expect it to be a really popular item. If you want to be the hero gift giver, come a birthday or Christmas, by golly, I think this will be the ticket to make you the hero gift giver. So, moving along, let's talk about microscopes a little bit.
So, Kent.
So, Paul.
I forgot because I'm trying to fix the 24-hour feed.
Did you break it?
No,
You
There's
broke
always something.
You broke
that
it.
The instructions don't tell you.
You broke it.
No, it's not broken. It's not broken.
It's just not working.
I know.
Hey, Noah,
I
can you
don't
come get the
understand
monitor up
why.
for
It
me,
doesn't
please?
make any sense.
So, are we not streaming 24/7 right now?
Well, we've been streaming all weekend, but I'm trying to put a piece of media in there that lets me stream 36 hours to 72 hours worth of content. So you don't have to watch the same thing twice. Right? Which would be nice.
Unless you want to stay up for 3 days and do it.
Yeah, I'm not here, so. But I shot new video for the
Star Maker.
The Star Maker. And the V8 engine.
And the V8 engine.
If I can get it to pull up.
Well,
everything is slow, man.
Well, it's Monday.
I don't know what
the
problem
weekend. The
has to
gerbils
be.
is still overhung from their long weekend. So I'm gonna move on. While you're over there banging away.
Oh, it's okay. What's the number on that thing that you got there?
On the Star Maker?
No, the thing in your hand.
The Explorer 1 20x binocular microscope. No idea what the SKU is.
You're supposed to know these things.
No idea, my friend.
Well, why not?
Because I just don't have this SKU memorized. That's
nobody,
why.
I mean, there might be some people watching. I can't tell if there's anybody watching though. I guess we got 3-4 people watching right now. They're not saying anything.
Hey, say something. Paul doesn't believe you're out there. He thinks you're bots.
Bots?
Not really. All right, so this is the Explorer 1 binocular microscope. It's 20 power. So Paul's got some pictures that we took through one of the eyepieces showing a penny and a bug and some other stuff. The penny really gives you an idea of what 20 power looks like.
You always ask for the penny, and you know all I have is the bee.
You have the penny. You've used the penny, Paul.
I've been looking for it. You're going to have to send it to me again.
It's Abraham Lincoln.
Abraham Lincoln?
Yes, absolutely. He's a cool looking babe when he's in copper.
Yeah.
It's you know, his head fills up the eyepiece. Sir?
You know I don't have it. I haven't
you
had
have
it for
it.
like 3 or 4 weeks.
You have it. You just can't find it in your hodgepodge, jumbled up,
You want to come and try to do
massive,
this?
massive database of files in your computer system.
I only have like 10 terabytes over here.
Yeah, no, that's what I'm saying.
I can get you the bee, though. The bee!
So that's a bumblebee / carpenter bee. I think it's probably a carpenter bee.
I think it's more interesting than the penny.
Yeah, but nobody knows. You can't get a scale for the size of what the magnification does.
Everybody knows what a bee is.
No, it's not a bee.
Bumblebee bee?
It's a carpenter bee.
It's
or
a
a
bumblebee
bumblebee.
Bumblebee bee.
Right, but still, much easier to show an American penny so they can
What if they're not
see.
American?
Well, they still have an idea of what size it is.
This is the kind of stuff you do to me, you know.
Oh, I know, absolutely. So, anyway.
So Nancy M says, howdy.
Howdy?
Howdy.
She says, howdy?
Howdy.
Who was it?
Nancy.
Hi, Nancy. Thanks for the howdy. So, this microscope is a little different than a lot of microscopes and one we're actually going to look at. This does not have light that shines up through specimens, and you see very, very, very narrow slices of that, so you can see all the little intricate pieces in the inside of it. No, this microscope has light that shines down, reflects off of the object, and then back into the microscope. As you can see, there's a bee. It also comes with this sample of rocks that you can look at, which amazingly, the rocks under magnification look pretty cool. You can see things in the magnification that you can't see when you're just looking at it with your eyes. It's pretty cool. Also comes with a bunch of prepared slides.
Why don't you like the bee?
I didn't say I took the picture of the bee. I think the bee's fine. I just think the American penny gives them...
You got something against bees?
No, I have something against half dollars. You don't have against half dollars? They're not whole dollars. So, comes with a sample of glass slides, human sperm, fly head, a bunch of other stuff. The fly head is actually a whole stinking fly. You won't be able to see it, but under the microscope, man, it's pretty cool looking. Now, you could use these on a standard microscope where you have, light coming up through it, but these are thick specimens. But the cool part about it is you can see in 3 dimensions because you're using your eye. And it's just, when you go and see the veins and the limbs, you can see the squished body. You can see the mouth parts hanging out there. You can see hairs. Just a fantastic little microscope. I would have loved to have had this microscope when I was, say, hey, Annie.
Hello.
Come on, join us, will you? Annie just walked in the studio, and as most of you know that are regulars, when you watch the show and you walk through, you got to come up here on the screen. Hey, Annie, how are you?
I'm good. How are you?
I'm good. Sitting here talking about microscopes.
Yeah, Lucy and I play with this all the time. Have you looked at these rocks?
Oh, they're cool, aren't they?
They're so cool.
Yeah, they look completely different under a microscope.
This one right here was really hard to see because it's white. So
Put it in there. Let me take a look at it.
It was really, really, well, you got to turn off the light. It was really difficult to see.
What do I have to turn off the light for?
Because the lights in the studio
Because
are
the
too
lights
bright.
in the studio are too bright.
It is indeed very difficult to see.
It's very difficult to see.
I'm going to go to a flat
Oh my
side.
gosh, I forgot I had my sunglasses on. Sorry. I'd look like I just came in.
Ow!
Here, let me bounce it for you. Boop, boop, boop.
No, you can see if you get the flat side. Here's a flat side.
It's pretty cool. Now then turn the lights on because it makes it, you can like see a little bit of like luminescence or something. I don't know what you call it.
Fluorescence. Look at that. That is very cool.
I know, it's like rainbow colored. Isn't that so cool?
You got your phone on you?
No.
Huh? We're trying to take a picture real quick.
I can't take a picture. I don't have my phone. Where's your phone?
On my desk.
No. Do you want me to go get my phone so you can take a picture of it?
Yeah, let's try it.
I will be back.
So, I would have loved to have had this microscope when I was a teenager because it's just so very cool, right? This is the different colors of light that you can see in here. It's like the rock turns the lights into a rainbow. I'm trying to get a hold of it and get it moved. Boy, there it is. Because you can't see your fingers. And when we turn on the light for the microscope, it basically just disappears because we're looking at such bright lights in the studio. And I'll be back with my phone and I will take a picture and then we'll send it to Paul via the magic of the internet. And then through the wonders of all his little switches and everything, he will be able to show you what this looks like. He'll be able to say, take a picture live and do this live. Never thought about this before. But anyway, thanks everybody for joining us. Give us a shout out. We would love to see you. Give us a hello so we can give you a hello back. That's not my phone. God, you're killing me.
I said, do you want me to go get my phone?
Okay, use that eyepiece because that's the one I've got in focus.
Listen, lights, camera, action.
That's the one I've got in focus. So I'm going to hold. let me hold it.
I'm too short.
And I want
I'm too
you.
short.
No, don't touch the table.
Okay, hang on.
Hang on. Let me.
No, it's not going to work.
Yes, it is.
Why don't you put a telescope camera?
Tap it. Take a picture. Tap it. Focus it. There we go. Ooh.
Oh gosh, is that me?
No, it's me.
Oh gosh.
It's hard. There it is. There it is.
It's great television, by
Tap
the
it
way.
in the middle. Focus it. And then
This
send
is
it.
how you take a photo with a microscope.
Tap it again. Hang on.
You keep getting in the way.
I'm not in the way. It's the shit.
It's really hard when my phone is really dirty.
All right, send one of those to Paul. Pick one that looks good and send it to Paulie.
Send it to Paulie?
Paulie.
Oh, that is nice.
Let me see it. Yeah, so maybe you blow it up a little bit, stretch it, and then take
Just
a
send it to me.
screenshot.
Don't do anything to it. Just send it to me. Let me do that.
All right, we got to do what the boss says until we don't.
Do what I say.
So how did you get that open so easy? I couldn't get these open last time.
I'm a professional.
Yeah.
There we go. I got it. I gotched it. All right, so anyway, we'll get that picture up in a few minutes. Going to move along to another microscope. Here we go. We're going to switch, and we'll come back and show you what. We'll switch back. When we go to Amazon Live, we'll have it up on Amazon Live. Ay, 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 caramba. So, here we go. This is the Discovery 400x to 900x microscope. I think it's 400, 100x to 900x microscope. As you can see, it comes with a nice hard-sided keeper case in it. The microscope, a hatchery, not for chickens, but shrimp. And not shrimp, but brine shrimp. Sir?
Can you get chickens that small?
Those would be ultra bantams or toy bantams or something. No, you can't get chickens that small. Hey, there's Daniel. Come on over here, Daniel.
Daniel. He ain't going to do it,
He looked at
man.
me like, you're crazy, kid.
He ain't going to do it, man.
Has a petri dish, a sample maker right here, prepared slides, beakers, tools to manipulate your samples, red dye, blue dye. Now, I'll tell you this, that red dye and blue dye, that's food grade dye, not poisonous. If your kid drinks it, all it's going to do is turn their mouth and tongue blue or red, and if they drink it together, it's going to make brown or purple, one or the other. Has sea salt and brine shrimp eggs. Brine shrimp, I always saw those in like Boys Life magazine and places like that, known as sea monkeys. Now they're just brine shrimp.
So I've always tried to see the monkeys, but it never could. They don't even look like monkeys. Why did they come up with that?
It's just marketing, my friend. Marketing. You know, which monkey did you like?
None.
Are the Monkees a real rock group? Should they be in the Rock and Roll Hall of Fame?
They are not a real band.
But they were. They wrote their own songs and played their own instruments?
No.
Just because they were formed for TV doesn't mean they're not a real band.
No.
Yeah, so you're rock and roll pure. So Elvis Presley, he wasn't a band.
No, he was a man.
But Peter Tork was a man, wrote songs, sang them, played them. The Monkees was a rock band.
The Monkees, everything you heard was a session musician.
No, they toured.
They toured, but when you listen to them on the record, or if you listen to them on the TV show, those were session musicians.
Glenn Campbell played on hundreds of #1 hits.
Yes, so did Willie Nelson.
Have you ever seen the documentary, The Session? What's it called? About Testoro. His son did it. About the Wrecking Crew. Bands would come in and go, "We need to play our own songs." They're going, "You can't do this," and they would watch guys like Glenn Campbell and all those guys who were on the Wrecking Crew do their work, and then go, "Yeah, I can't do that." Those people were good musicians, but they didn't have the skills that the Wrecking Crew had. Like the Beach Boys, for instance. The Beach Boys didn't record some of their own music. They used session musicians. That doesn't mean they don't belong in the Rock and Roll Hall of Fame, but the Monkees do. The Sea Monkeys may not, but the Monkees, I believe. Daniel, should the Monkees be in the Hall of Fame, Rock and Roll Hall of Fame?
He doesn't know who they are.
Do you know who they are, Daniel? He doesn't know who the Monkees are, so he can't vote. If you don't know, you can't vote.
I was a baby. You're lucky I remember it.
You were a wee little tyke. So this is the Discovery 900X microscope. This is a microscope just like you think about a microscope being. You take a slide. Where did the case go? Oh, I set it down. You take one of the prepared slides.
The person to ask about the Monkees is Noah. He's like, "No, leave me alone."
The Monkees had a huge influence on society, therefore they deserve to be in the Rock and Roll Hall of Fame for the influence they had on society.
John Lee Hooker needs to be in there then, too.
You can make that good argument. So, I have a prepared slide. This is Hydrilla verticillata leaf. I pronounced that middle word wrong.
Not correct.
Verticillata. Verticillata.
See, osmosis is crazy.
So, here we go.
Osmosis says
I'm not seeing
monkeys are the
anything
best of the British invasion.
Say again? What do you say?
You're going to make me say that again? It's
Yes.
heresy. It's heresy. Osmosis 007.
Maybe.
Says the monkeys were the best of the British invasion.
Say, hey, we're the monkeys.
We don't even make our own music.
They did.
No.
They did. Look it up. So here we go. Here we go. Talking about this microscope for just a wee little bit. What time is it, Paul?
We are going on Amazon in like a minute.
Oh, okay. So I'm going to do a quick reset. We will come back. And redo what I just did.
What you did done?
What I did done.
I'm just going to change the...
We'll start over.
So we need... How do you know?
So, how do you know? Back in a minute, folks.
Oh, Kent.
of Jamie Heinemann. Hello, everybody.
Now,
I think
you're
that
on.
guy in the warm-up that punches the screen looks a lot like Jamie Heinemann.
If he was like Indian.
From Mythbusters, one of the
If
cool
he was Indian,
science
maybe.
shows. That guy's not Indian?
Yeah, he was.
Negative.
Let's see. Hang on. We have to look at it again.
You're talking about subcontinental Asian Indian, not Native,
American
Native
Indian,
American.
no.
Not Native American.
Yeah.
Nothing's happening, Paul.
I'm working on it.
Takes you so long to do things, Paul. It's crazy. So, hey, while he's doing that, hi,
All right,
everybody. Welcome
let's change then. You come over here and run the stuff.
And I was born in the 80s, had a good upbringing. I graduated college in the 80s, and I had a good upbringing as well. So,
I was listening to Molly Hatchet. Thank you very much.
I had no problem with you listening to Molly Hatchet. You're welcome very much. So, he's getting a picture of that fella. So, here we go.
All right.
Today is Monday,
go?
which makes it How Do You Know Monday. And how do you know what time it is? Well, you use a clock, of course. And what better clock to use than...
How do you tell what time to use a clock? Well, you could also use Siri these days.
You can use Siri these days, but Siri is not
Siri, what time is it?
Siri may have a beautiful voice, but Siri does not hang up on your wall, Siri does not hang up on your wall, though, like this beautiful Explorer Scientific analog clock. Well, it may be an analog clock. It also sets its time automatically. It's an atomic clock with WWVB, the federal government's broadcast that's good for setting atomic clock devices in North America, including Canada, the United States, and Mexico. Over in your carousel today on Amazon Live, you can pick this up. Not sure of the price. It's a beautiful clock. If you're an Explorer Scientific fan, what way to better celebrate than putting this clock in your
Did you say pudding?
Man cave, office, or whatever. That way, you can always answer the question, how do we know what time it is? Well, I'm going to look at the $39.95 retail Explorer Scientific clock. Very fantastic looking thing. Ooh, there's a coupon where? On Amazon Live?
Yeah, let's see where the...
There's a coupon on Amazon Live. How about that? So go to the carousel. How do you get to it, Noah?
Go to the carousel, you click on the item, the clock, and once you go there and look at the buying options, it'll show you the coupon for 20% off.
Woohoo, sweet. So you go to the carousel, you click on the item, go to the cart, and it gives you see all buying options, and click on it, and there you go. It comes
I
up
guess
with
he's not Indian.
Save
He's
an
just
extra
got
20%.
that on.
Save an extra 20% by clicking on the coupon and adding it to the cart that way. So you can save 20% on everything, or just selected items? Just that item. Okay, very good. Just that item. So shifting gears to a new item Explorer Scientific has come out with. This is the Star Maker Video Kit. The heart of the system is this nice, compact, yet very powerful digital camera. This is produces video in 1080p HD. It comes with an 8 gigabyte card that will hold more than an hour and a half of video. That's a lot of video. It'll take up to a 64 gig card. Now that's a lot of video right there. It has a nice 1.3 inch screen. I can make it come on real quick. Hit the correct button, and there we go. It's the Explorer One. This camera has a swivel head, so it swings around backwards. And now, I don't know if you can see that or not. Can you see me there, Paul, on that little 1.3 inch screen? Is that visible?
Hang on.
Hang on. Paul's going to maybe do a digital zoom right there. There you go.
You're
Hi,
squished.
everybody. Yeah, I'm squished. There you can see it. See, it's me. Waving, not there. Hey, great little camera. So if you're wanting and to learn how to do some video and get started, you can use the Star Maker Video Kit. It's for ages 8 and up. Comes with a tripod, as you can see, that the camera mounts on, or will fit in your pocket, and you can use it handheld. The tripod extends up to 23 inches. And here's something cool. You can turn it into a selfie stick right there. Now I'm doing the selfie stick as we speak right there. Pretty cool. I'm going to turn it off just to save the batteries. It also is a camera. It takes, I believe, up to 6 different sizes of pictures. When you're shooting video, it has face tracking technology. The head doesn't move, but it keeps the face in focus, so it can ID faces as well. Comes with, put this back down, comes with nice little light that's magnetic, sticks well to the base, so you can put it on a table and use it to provide a studio light. If you need some light, you can hang it on a wall and rotate it so it shows the light where you want it. It has a bright mode, a dim mode, and a strobe light effect right there. So cool. Also comes with a USB cable, so you can hook the device straight up to your computer and on it to pull the recorded video out of the SD card, or you can remove the SD card, put it in your card reader. Once in your computer, you're going to use your favorite editing program. This does not come with an editing program to edit your video into your story. Now, it also comes with a handy clapboard so you can action when you start a recording. Easy to use, some chalk to write information on the clapboard so that you can set the scene, record this at the very start of your scene, so it makes it easier to find your video when you get into editing and start going through and picking out the ones you want. You know what the scenes are, right? Easy to start and stop with the button on front. This also comes with a chroma screen. It's a blue-green chroma screen, blue on one side, green on the other, right here. So what's chroma screen? It allows you to put in artificial backgrounds. If you want to put in a paisley background or a picture of Paul back there acting like, what would he act like? A director. That's what, acting like a director back in the background, and you work in front of him on the green screen.
Yes, I just act like a
You
director.
can do that. It's a cool technique that you can. Well, you're not a monkey or a director, or, yeah, you're a director, but you're not a monkey. So you can connect. You can learn to use the chroma background to add special effects, just like the people do on TV if you watch the weatherman. Also, a lot weather forecasters, the meteorologists, don't mean to say weathermen.
Weather
and
forecast.
additionally, a lot of these videos you see where people are doing tricks and stuff, and they're using green screen and editing in the background, so you don't see what's really going on in a lot of those videos. So this is the Star Maker video kit from Explore One, an Explore Scientific brand. If you want to be a hero gift giver this year, and you got somebody that's interested in doing this, right here's the ticket to being the hero gift giver in your family. So, shifting to microscopes a little bit now. This is the Explorer One 20 power binocular microscope. Paul, did you get that picture from Annie we took a little while ago?
She has not sent it to me that I can see. No. She has not sent it to me.
Well,
it is not my fault.
why
not
don't you
try and blame me?
I'll switch to the other one, and why don't you Skype her or text her and ask her to send that, or
Is
get
that
up
your
and go
cup,
ask
or
her.
is that her cup?
Because I want to see that, sir. I want our customers to see that beautiful fluorescent crystal in there. This is the Discovery 900 power, 900X biologic microscope. As you can see, it comes with this nice hard case with a clear plastic cover that allows you to keep all of your kit. Brine shrimp. Hey, no. To Paul ASAP, please.
We're still going.
Okay, we're still going. So you can make your own slides, very thin slices of stuff, using the slip covers and the blank slides that are in here. As a petri dish, comes with blue and green dye. And I'll tell you right now, that blue and green dye is food grade dye. If your kid drinks it, their tongue is just, and mouth is going to be blue or red, or if they're doing both, it's going to be probably brown or purple, one or the other. But I can tell you, things may come out blue and red too. So there you go.
What?
Salt crystals. So you can do sea salt experiments and grow salt crystals. And the ever popular brine shrimp, I knew them as sea monkeys from reading the Boys Life magazine. You can hatch out these brine shrimp and watch their life cycle. Sir?
This is where we all of a sudden went off into a tangent about the monkeys, the TV show.
Yes, the monkeys on the TV show. Paul asked what the monkeys were, and I said they're a rock band from the 60s, a pop rock band that should be in the Hall of Fame.
I didn't ask what the monkeys were. I said, are those monkeys? They don't look like monkeys.
They certainly don't look like Peter Tork.
Oh, God.
But they're brine shrimp. They can survive for decades in a state of dryness, and sounds sort of Irish or something there. Or they can get wet and come to life and go through their life cycle. Comes with some tweezers, a couple of vials, a beaker, some probing tools. And let's now talk about the heart of the system, the microscope itself. So the microscope can go from 100 to 400 to 800 power, and that happens by turning the turret right here. If you look, there's a short lens, a medium lens, and a long lens. The short lens is the lowest magnification. When you're going to focus on this, always start out with the lowest power magnification, whether it's a telescope or a binocular or anything else. Start out with the lowest power you can. That makes it easier to find.
I don't think these pictures turned out.
There was one of them that looked real good.
No.
That's why you need to put them in Photoshop and sharpen them and deal with the colors.
I could do all that here, and it's not.
Well, we'll go on if you don't come up with one. Anyway, so how this works is you have a slide, really thin piece of biologic material. In this case, it's the piece of a water plant, right? A Hydrilla verticillata. I know I'm pronouncing the second word wrong. It's the best I can do. So it goes into the stage, which is where the things go, and there's a hole in there that light comes up through.
Push it forward about 4 inches.
Is that good? Huh? Keep going. Okay, so it comes with an LED that turns on, and spin this around. When you rotate it to up, the LED comes on. So I'm going to put the LED so it's shining the light up through it. I'm going to back up a little bit so I can focus on it. And now I'm going to focus the microscope all the way down so I know it's all the way close. From experience, I know that this comes into focus extremely quickly, right? Very, very quickly. What happened? Turned the light off.
Battery's dead?
No, I just turned it off.
Just use the lights in the room, Kent.
And so...
use the mirror.
I can now...
it has a mirror on it.
Start
just for
focusing.
This occasion.
Let's just see if the mirror's any brighter.
Oh, yeah. Even I can tell.
No, not.
Yeah, you're not even close to it. You had it a second ago.
No, I can see it.
There. No, go back the other way. There it is. Oh.
You're not looking at the microscope, knucklehead.
Yeah, but I can see where the mirror is
Whoopsie.
reflecting on.
Luckily, these are nice plastic slides, so when I just pushed it open and couldn't see what I was doing because they had my glasses on, didn't break anything, right? It's always good not to break stuff. So, going to go something not quite as thick. This is red, and so I'm going to start looking for red. Red, red, red. Get the light on. There we go. Now then I'm just going to move the slide a little bit because I found it. I think the batteries may be dying in this. Wow. Pretty cool looking. So, looks like little prisms almost. These come to focus really quick, as in you barely start turning it and it gets into focus. And people oftentimes go right past it and they don't realize they're turning the knob too fast. Turn the knob really, really, really slowly. That will help you get it into focus. This is a great way to get into microscopes and learning about the different parts of cellular level plants and animal stuff. Once you have it in focus and the subject that you want centered up, you can turn the turret and go up to 100 power and then get it in focus, and then you can turn the turret again and go up to 1,000 power. 900 power. That gets you the highest power using the longest lens on the turret. Now, this also comes with a wheel right here that changes the color, and I'll show you what it looks like because I have one off of one that we took apart. For parts, it has a clear circle. You can see a green circle, a red circle, and a blue circle.
Got to lower it a little.
Ah, sorry.
And back it up a touch. There you go.
So you have a blank circle, a green circle right here.
Empty circle.
Yeah, not blank. It's an empty circle, just white light. The green filter, the red filter, the blue filter, another empty circle, and then some much smaller holes if the light's too bright. What's the purpose of these color filters? The purpose of these color filters are when you change the color of the light going through your sample, your biologic sample, it changes the contrast and changes what you can see. It highlights other colors and takes out some colors so you can see different pieces of the cells as you're using the Discovery 900X biologic microscope. As it comes with 5 prepared slides and 7 blank slides, you can use those to make your own samples. It comes with a downloadable experiment guide that tells you how to execute growing the brine shrimp, growing the salt crystals, how to cut your own samples and dye samples and things like that. Gets you down to a really cool process of learning how a microscope works and becoming a junior biologist with this fantastic starter microscope right here. And let me turn the LED off. I think we're going to put new batteries in this because I think these batteries have been on a while. I didn't tell you, it tips like this so you can find, let me see if I can do this. I bet I can get some brighter light up in there. Tipping it way back like this. Let's see here. I'm going to look through. Let me go to the lowest eyepiece because you always want to start, no matter what, with the lowest power eyepiece. And nope, not getting anything. Nothing. Nothing coming through. That's all right.
You want me to try it?
Nope. We're going to go on down the road and look at something else.
I always end up figuring it out when you guys don't.
I'm not worried about it. It comes with an LED. Put a battery in it. It's bright. It works well. This is dim. I'm going to say the battery's got left on. And you know what happens when that happens? Things die. All right, so let's talk about a pair of binoculars. I love these little binoculars. These are the Bresser 6x21 binoculars. It means they have a 6 power eyepiece on them and a 21 millimeter objective lens size. Now, these are colorful. They're fun colored. The orange or red is made out of metal. The yellow is sort of a rubberized gripping surface, comes with a neck strap. The glass elements in here, the lenses that make these work, are glass. They're not plastic. You can focus it for your left eye. It has a diopter, just like real binoculars, and I do that in air quotes because this is the Bresser Specialized Kids Binocular. It says kids, but I'm telling you, these are the real deal binoculars. I advocate, you got a kid in your life and you want to introduce them to birding or astronomy or learning how to use them for sports or whatever, buy a pair, for your kid in your life and buy a pair for yourself and go out and use the same binoculars they're using. These are great binoculars over there. We got a question. Hi, Kent and Paul. That's from Tariq. Hello, Tariq. Scott is in the building, although he's tied up doing something all afternoon. I think he's getting ready, working on getting for the Global Star Party tomorrow night. And got another question coming up. Aquilus started following. Hey, Aquilus, thank you very much for that. We appreciate it immensely. By following us, you get to see more of our great content. Tariq, I am saving to buy a cheap 152 scope from somewhere later next month, hopefully, but when I get a budget soon, I will buy a second 90mm triplet scope. Tariq, you gotta have goals, right? None of this is, you know, Tariq in certain parts of the world, it gets B. Parts of the world, it gets B.
But I'm holding it till we get to a particular section, which will help him with the answer.
Okay, which section do we want to get to?
Well, I'm looking at, you know, it's a telescope question.
Oh, okay, all right. So
waiting on the telescope.
Oculus says, your channel is great. I love this. Thank you, Oculus.
Do you like us fighting?
Because
we just really just banter and kick each other
yes,
with words.
This is a sales channel through Amazon, but we also love to do a lot of education and trying to get people to understand how things work and why things work.
Yeah.
I really enjoy doing that. Sir?
I got kicked off here once.
By who?
You.
Oh, yes, absolutely. You're getting ready kicked off again, too, if you don't watch it, bub. All right, so if you're just watching us on Amazon Live, thank you for joining us. We're working in the astronomy, birding, educational toy section. We don't really have anybody else who's doing this. If you notice on the screen, my forehead looks red. That's because yesterday I went out picking wild blackberries and forgot to take a hat with me. And by the time I realized it, I didn't want to walk back to the truck, and I burned the top of my noggin just a little bit.
It's awful late in the season to pick wild blackberries.
No, they're just starting, man.
No,
Dude.
We've already collected all of ours.
There's tons of them up at my farm in Pea Ridge. There's tons of them. I mean, we collected 2 gallons.
Here you go.
2 gallons of blackberries. I have the scars on my arm from all the thorn pricks.
My dad used to have to fight the cows for them.
Listening to you two banter back and forth is like witnessing a Wisconsin Thanksgiving. Well, I guess happily, Osmosis 007, I have never witnessed a Wisconsin Thanksgiving. Probably that's a happy thing for me. So the specialized 6x21 binoculars from Bresser. Get yourself a pair. Get yourself a pair for your kid in your life. Go do astronomy. Go do birding, and get them happy. Most kids just want to spend time with you, right? Or they don't want to spend any time with you, one or the other. All right, so we're going to move into the telescope segment. This is the First Light, Newtonian. First Light is a brand from Explore Scientific. First Light means, you know, the first time you use a telescope, the first time you look through something, that's the first light for that telescope. This telescope brand was designed and promoted and really starts as a starter scopes for people, therefore it's first light as well. So this is a 114 millimeter telescope, which means where the light goes in, which is right here, if I can get this off, take off that little, gets stuck on there. That
I will make sure he gets all the questions when he's ready. Because one of the things that Kent doesn't like is me interrupting him as you look at him right now while I'm talking, telling you.
I'm looking for the comment. Normally you just wave your hands and point at your eyes and I know there's a comment
Well,
coming.
no, Tariq wants me to ask the question now, but I am letting you finish your spiel.
Ah, well, it's 114 millimeters in diameter. Paul, you got a question there, I hear.
Well, Tariq was not first.
I don't care which one you give me, Paulie.
Mr. Connor Bradley. Hi, I have an issue with my Bresser Messier 12-7i. The bottom of the scope hits the tripod legs at certain angles. Would an extension tube or peer fix this issue? It's on, and then it cuts off because it doesn't like that many characters.
So, Connor, my thoughts are typically when there's a leg strike, you simply need to move the telescope farther skyward. In other words, that way, so it's not so long. Leg strikes are not uncommon. Well, they're more uncommon than they used to be, but putting a pier on it introduces other problems as well. It would be, you know, you may have to run into some balance issues if you move it that far forward and move it that way. Now it may not balance well. If it doesn't balance well, you start putting weight on the back end. I've seen people use bags of lead shot or steel shot. If there's a place where you can hook if it's a steel tube, you can set a magnet on it. There's all sorts of ways to add weight on the back side, on the eyepiece side, if that's where you're having trouble, Connor. So if you want to send us a picture of your rig, we'll be happy to take a look at that. You can contact us. The easiest way would be go to our Explore Scientific store and here on Amazon.com, click on Contact the Seller. Send the pictures to Noah, and he will get them for you. Kent, look at the telescope next to you. Do you have a similar cover cap for the reflector with the center hole? No, typically we don't, Tariq. That's called a field stop. You can make one yourself out of cardboard. They don't have to be perfectly round. They can be square. It doesn't matter. It's not going to make the stars square. The telescope is just going to be fine. This is a field stop, and what this is if you look at something real bright, you can just put it over, and I always make sure when I do this, see the little angles in there? Just make sure that it's between those legs of the spider that holds the secondary mirror, and voila, you've now cut the amount of light going to the telescope a whole bunch, but you don't know it because it looks perfectly fine in the eyepiece. It's a pretty cool effect. Also, never look at the sun with this telescope, it says. You know why not? You'll put your eye out. Here, I'm going to show you, though, a way to do it safely. I like the bickering. Please don't stop. Yeah, thanks, Egon. Don't encourage him. Don't encourage him, Egon. Don't encourage him.
What?
So, this telescope comes with a red dot finder as well as a 25mm super colossal eyepiece, a great eyepiece to get you started. Now, this telescope is mounted on what's called an equatorial mount. There's also a Alt-Az mount, which I've got one over there. I'm not going to get it. It's, think left, right, up, and down. Real simple to use. However, the equatorial mount, once you learn to use it, is a whole lot more powerful. You have to get it polar aligned, which means this axis right here has to match the rotational axis of the Earth. How do you know what that is? Real simple. Figure out the latitude you live in. Where here in Northwest Arkansas, we're 36 degrees north. So there's a little scale on the side. I just put it at 36 degrees north and then point the telescope to the north. Egon, hi Kent. I tried to leave a good review with great pics of the new little 60mm with the IXOS 100, and my Amazon posts have been blocked.
That's a Noah thing.
Noah, why would that be? Because he didn't buy it through Amazon, maybe?
No, he sent me a question through the Amazon contact center.
Okay, Egon, Noah's doing some research on it. He had sent him a message, and he's trying to figure out why that would be. Amazon, works hard to make sure that we have, that their reviews are legitimate. So it may be related to that.
Yeah, Amazon bots are not. They are not.
Osmosis 007. Osmosis 007. Absolutely. Neutral density filters generally, get this out, will screw in to the eyepiece right here. This is an 1.25 inch eyepiece, meaning this is 1.25 inch across. You get a neutral density filter and just screw it in. Neutral density filters work well on really bright things, especially the moon. As it gets more and more towards full, the moon can get very bright, and that, it won't hurt your eye, you know, it won't damage your eye.
I don't know, man.
But when you look into it, sometimes a full moon, or close to full moon, can be so bright that it's like, that's really bright.
Slightly painful at times.
It can be painful at times, absolutely. So you can get a neutral density filter. We do sell them. I don't know if we have them up online or not, but if we don't, you can contact again through the Amazon.com Explore Scientific store, because this is an Amazon broadcast that's going out all over the place. So I can't say where else to go to find us. So it screws in there and cuts down. Generally, they come in like a 0.9, so it cuts down a whole bunch of light, so you don't get overwhelmed by the brightness. Obviously, the eyepiece goes in there. So let's talk real quick about how this telescope works. This telescope has an opening right here. The light comes in, comes down unchanged. Right here is a curved mirror. Light hits the mirror, starts going off at an angle. All that starts coming to get together in a point. And at that point where it comes together is called the focal plane. And that's where you use the eyepiece and the focuser to focus inside out, or inside, in and out, to find the perfect focus for your eye. When viewing the moon, I put it in my star diagonal so I can switch eyepieces on the fly. Great idea. If you have an 1.25 inch diagonal, you can put in an 1.25 inch neutral density filter, or if you have a 2 inch diagonal, you can put in a 2 inch neutral density filter. Obviously, the 2 inch neutral density filter is going to cost you more than the traditional 1.25 inch eyepieces. So if you're out there, just join us here on Amazon Live. Click that follow button. We would love to pick up a follow from you. And again, we've picked up Oculus today. Again, we can't say how much we appreciate you because you're sharing your time with us, and we truly do appreciate that very much. So got another question from Tariq with Mac. I don't need neutral density because the Mac takes care of brightness perfectly. Yes, when Tariq says Macs, he means Maxudo of Cassegrain telescopes, and they have an inherently long focal length which reduces the brightness of the light. Tariq, I want to use a refractor for solar imaging, and I want to stop down the aperture. I prefer something done by manufacturer than DIY, and for HI, I won't use a neutral density filter. Tariq, as long as you're using a solar safe filter, you don't need to stop it down any at all. It's not required. And you can't stop down the sun enough to be able to photograph it without a safe neutral density filter, because when you just keep stopping it down, you're just going to create a pinpoint of incredibly bright light that you're never going to be able to take a picture of the surface of the sun with. So if you're using something like our sun catcher solar filters, and Tariq, I know you've seen us talk about this before. The sun catcher, large aperture solar filter, is a 1,000 Oaks Mylar film that reflects 99 point whatever, nearly all the sunlight that's hitting it, and it has some film in there also that gives it a pleasing yellow, orangish color, depending on how your eyes look at it. That allows you to see the visible surface of the sun. You're going to see sunspots. It does not allow you to see loops and prominences and things like that, but it does let you see sunspots. And by the way,
if you try to cut the sun after it's got into your telescope, all you're doing is concentrating that energy, and it's going to, like a laser, go straight through your head and out the back of your skull.
It may not be that bad, but it's going to poke your eye out. It will burn. It will instantly etch your retina and cornea. It'll be brutal, and it won't ever go away. My Mac 127 burns my eyes on a full moon, osmosis 007. I'll tell you what, it all depends on what kind of Mac you use and how long it is, how long the focal length is. But yeah, 120, big Macs collect like a 152 Mac or a 180 millimeter Maxudo of Cassegrain is concentrating a whole bunch of light, even though it may be a focal length of 1900 millimeters or 2200 millimeters, is still uber bright. What's crazy is the moon's color is like, a couple-year-old black asphalt, not quite black, and it still, Paul, reflects that much electricity.
So I think
that much
Tariq
energy.
was talking about HA filters.
Okay, for HA,
Helium
it's a completely
alpha?
different story. That's what he's saying. Yes, you're going to have to consult your HA filter provider for that on how much, what they need to stop down. I know that I've used both over the weekend. Went to a star party Friday night outside of a bar. Had a great time. Multiple hundreds of people looked through our telescopes. We had a quark. I think it's a Daystar quark energy rejection filter that was really nice. People were in a low power view of the sun, looking at the sunspots. And we also had a hydrogen alpha double stack. The guy that owns that, Tyler, could not get the tuning exactly right, so he took the double stack off and went with it's like a 70 millimeter telescope. It was not a big telescope, but provides some really awesome views of the hydrogen alpha region. It wasn't very active. There wasn't much to see. Although, right now, folks, there are a ton of sunspots. If you've not gotten into solar viewing, you need to do that. And one really quick, inexpensive, yet safe way is with a Suncatcher large aperture solar filter. It comes already assembled in this cardboard case.
And this is for visual.
Yes.
You can't see hydrogen alpha with your naked eye.
This is for straight white light, right?
Yeah.
We color it yellow so it looks pleasing because it's not just it's not just white light. The quark that we were looking at does show white light. So this system, you can order one that fits your telescope. Osmosis says the moon is totally underappreciated. So much fun following the Terminator shadows in craters. Absolutely, that's the fun part of watching the moon, is following the Terminator across the face of the moon as it works its way up to full, and then as it goes away from full. That is an awesome thing to watch. What I like is, hello Kent and all, from Mike Overacker. Hey Mike, thanks for answering that question for me. Truly appreciate it. And you answered it thoroughly, it appeared. So thank you very much, Mike. Referring to
what question?
Mike has motorized our 20-inch Dobsonian telescope. And there was a customer who has bought one and was wanting to put setting circles on it so he would be able to use it as a push-to and get it in the right spot. Mike gave him a lot of information that I didn't have because Mike had measured it and figured it out by measuring it. So that was a very helpful piece of information that I have now written down and have it in my documentation sheet as well. Again, thank you very much, Mike, for that. If you haven't started solar viewing, you need to start. As I said, the Suncatcher, fantastic way to watch that to watch the solar viewing, to watch sunspots. There's a bunch. We counted on Friday night 22 sunspots, and that was at low power. There's a bunch of sunspots on the surface of the sun right now, and going to be some. As we go through the next 1.5 to 2 years, we're going to be going to solar maximum. The sun goes through an 11-year cycle of a whole bunch of sunspots, not very many or no sunspots. So we went for 1.5 or 2 years without very many sunspots or no sunspots at all. Now we're coming out of solar minimum, working our way up to solar maximum. We'll have tons and tons and tons of sunspots, and they'll get bigger and bigger and bigger, and then they'll taper off and go back down to none, and that's the solar cycle. It's an 11-year progression of sunspots. So awesome to watch sunspots. What I like about sunspots is it changes. So sunspots get bigger, they grow, they change shape. You'll be watching. You'll be just sun. That's getting a sun. suddenly you can see the go right here. Burn a hole through a filter. Sunlight that is going to some video from Scott.
I wanted to you some things about safety. ISO standard. So if you're going to look at the partial phases, let me underline partial. You use Eclipse Glasses sun in partial phase. During that time, 2 minutes this time on because it's completely blocked. Corona, you'll see effects that will so what you shouldn't do glasses and look through filtered and I'll directly at the sun and I can turn that up a little bit and look right at the filter through the solar filter material is. So this is definitely something you can now see that there is a filtered telescopes or binoculars right into your eye. Binoculars to watch the parts or just to observe the sun. Make sure that you are using that has the so what I'm going to do is I'm going to put this about to come off. You have a loose fitting filter to make sure that the and then the other thing is optical finder scopes are like little telescopes. In this case I just have a red dot finder. Find power to it, so sight in the sun is and align the scope and align now I can safely and look at sunspot and look at
one. Going to do to your mark 1. That's going to do to your mark L eyeball. Having that happen to an eyeball. Boy. Question or comment? Question or comment? As a space pirate for Halloween. As a space pirate for 80, you know, with that, with those. I never joke with the sun, and I never joke with the sun, as I said, who lives in the UAE. Yes, lives in the UAE. Yes, his doctorate in getting his doctorate in Baghdad, and out of Baghdad. And, oof, and yeah, oof, and yeah, I know it's a dry heat. Just you know, being that, you know, being in that, you know, being in that. Egon. Egon. Yes, indeed, it experienced observer. Experienced. Is it okay if I do this? You know, even though this is a key thing that and at some point when you start playing with your video, you, Tariq, if you came here, Tariq, if you came, absolutely, but you know, is SPF going to be out? So whatever. My son, I always wear a cap. I umpire youth baseball. I'm always out there with a cap, or the caps I wear might have the mesh in the back, but that's filtered sunlight. It doesn't burn, but you know, it doesn't hurt. It's just got a little bit more sun right here than it's used to.
To visit Tariq, you might need an SPF 2000. Or
you can buy some of these Habit Brain shirts that have, this is actually a SPF 40 sunscreen shirt. Buy a long sleeve shirt and wear a straw cap, and you know, you're still going to get, your skin's still going to have to get used to the reflected light.
I went swimming at the lake for like 2 hours and didn't get any sun at all with no sunscreen.
Well, that must be some good genetics coming out in you, Paul, because I most assuredly this is, I mean, I'm out every weekend. That's with sunscreen, right? So I'm not worried about my arms, but I didn't think about tops of my ears and my head. So sunburned a little bit, not bad.
Egon burned a hole in his shirt once.
With a
telescope.
I have done that. I was going to do some solar viewing, and I was using the finder scope to line it up, and took the lens cap off, and we were at a public outreach. Somebody asked me a question, and I was using a Schmidt Cassegrain 8-inch telescope, and there's a hole in the back, and I just always plug it with an old black film canister, and I was sitting there, I started going, it smells like burning plastic. I turned around, and I couldn't find it, and then I saw a sun projected on the ground and went, uh-oh, and it just melted that black film canister, just gone to bits. And yeah, I can imagine, you know, being able to set your clothes on fire or something like that and not realize that if it was a baggy shirt like this, it's, you know, not touching your skin, and yeah, I don't want that. So anyway, how the sun catcher works.
That we've been asked here about the shirts.
What's the question? What, Paul?
Look at the screen.
Does Explorer sell the 50 FPS shirts? We do not, Egon.
We have a link to them in our Amazon carousel.
You know, I've thought about buying some because I have a source. And in fact, Tyler and I are getting ready to order some that we're going to take and have Explorer Scientific logos put on them. Yeah, but they're not Explorer. We're going to get the Explorer Scientific logo right here, I think. We might get them on the pocket. We'll go see what the embroiderer says we can do.
I prefer Tommy Bahama myself.
These are, I like these shirts. They're vented in the back, you know, variety pack colors. The problem is, Egon, that, you know, carrying inventory of every size and every color gets to be pretty expensive, and then they don't move, and then, you know, they get grabbed for somebody needs a shirt for a broadcast, and they don't go back, and they don't come out of inventory, and it just becomes
It's
know,
okay.
Yeah. So
Tommy Bahama.
but
you start
you know
start
what?
doing the Tommy Bahama shirts, and I'll start wearing them.
If you're
all I wear.
interested in getting one of these shirts with an Explore Scientific logo,
Fresh.
we'll have a better idea of cost probably middle of next week or something like that would be my guess. So finishing up about the solar filters, how does
See
this
how
work?
he just ignores
How do
me?
you make,
Just ignores
how do
me.
you make, sir? How did I? Go
And
buy
I'll-
them. Go buy
I'll wear
them.
'em.
Talk Rob into it. So
Eh.
these comes with 4 of these triangular pieces right here. If I have 4 pieces of double-sided tape, you'll pull one side of the cover off, stick it down, put your square there, put your triangle there, square. Put your triangle
Make
there,
sure
triangle
that
there,
thing
triangle
is
there.
on tight.
And then you're going to cut these to fit. And how I would do it is take the dew shield and press it down really hard so it makes a little mark. And then cut inside of that mark, right? Because you can always cut more off. But if you get it too loose and it blows off, you don't want to use it, because we can sell you more of these things, no problem, but you want to proceed slowly. You want this to be a tight fit like in the video Scott had. He had to work to get that on there to get it to stay on. Why? Because you don't want somebody to walk by and just touch and it come off. You
Wind
don't want a big
blows.
old gust of wind to blow it off. You got to have this thing on tight all the time so it won't come off. I have a question coming up here. Hey, there's Dr. Daniel Barth.
Hey.
During my solar outreach program, go get a mic. Mic him up, please. During my solar outreach programs,
okay.
I've had 6
He
to
can-
10
we can hear
solar
him.
telescopes.
I can get
Okay, yeah, you're greenish today. And constantly announce that these telescopes are special and make the people repeat it back to me so I know that they know. Mike, I do the same thing. The first thing I do is say, you know, if somebody comes up to you and says, hey, you want to look at the sun? No, don't do it unless they seem like they really, really, really know what they're doing. And even then, Daniel, this is Dr. Daniel Barth.
Hi, guys.
He has the social media blast for How Do You Know?
How do you know?
And he's talking about planetary nebula
Planetary nebula
today. So
I always told folks to put their hand over the eyepiece, and if you go, ow, or the light's really intense,
Yeah.
then don't put your face there.
But if you see people, but we'll be out doing it, and there'll be people after people, person after person do it, and then somebody will come by and they'll go, no, I don't want to. And why not? It's fine. It's perfect. I said, no, I'm not going to look at the sun. And although they can see 10 people before them, yeah, and 10 people after them say no, they still won't do it. Osmosis 007. Since I can never catch the astrophotography segments, is there an
Photography camera.
Thank you for reading. I've lost my ability.
Come on,
with
Ken.
A cell phone. I will tell you, you can use your cell phone for astrophotography. However, 2 caveats here.
Step in a little bit more.
Sure. 2 caveats. First of all, things that are really bright and impressive, like the moon, work best. You need to have the latest model cell phone to have it sensitive enough to detect this. And a lot of people try this handheld. I want
It's
to take
hard.
a picture. It's hard,
hard.
but it's doable. I teach my students to do it. But if you've got a tracking system, and Explore sells a mount to affix your camera to your eyepiece, and you can attach it. And if you've got a tracking mount, you can go ahead, but it's going to be like 30 years ago, because you can't stack frames. You just got to get one long tracked exposure.
There's actually programs out there you can download on like an iPhone, I know, that you can stack in your iPhone that'll actually do it in the iPhone.
Technology changes so quickly.
It does, because that's what's happening. I can take a 4 or 5 second exposure with my iPhone,
right,
and it's not blurry or anything, because it's actually taking a whole bunch of series of pictures and stacking them up,
right,
and the ones that are out of alignment, it just rejects and they're gone.
Right.
Now, our friend Mike Wiesner, he takes pictures of galaxies, and Nebula all the time with a smartphone.
There's this
Yeah.
weekend.
Yeah, I saw that. You posted that on the Facebook.
Yeah,
Hey, Paul, zoom in here.
I don't know if you can zoom in here and
No.
see this.
You can put it down there on top of the sun catcher.
Right there?
Yeah.
Not using the camera on the cell phone, just a camera that
You'll have
uses
to bring it
Bluetooth
up
to send the images
and
to
to
your
your
phone.
left.
We do not. It's not in focus.
Up and left. There you go.
There you go.
Back up just a touch.
Yeah, I'll
There it is.
I'll give Kent a copy of that to post.
Yeah,
And
this is
this is a single exposure, handheld, no guiding, and no processing.
it's nice and bright. Did you handheld this at the eyepiece?
Handheld at the
Yeah.
eyepiece.
And how many did you have to shoot to get this?
About 8.
Yeah. Okay.
And I shot 8, and I kept, adjusting the parameters.
Right.
You go to Pro Mode so you can make the focus manual so you can control it. And you have to keep tweaking and trying. And then when you're done for the evening, the next morning I went through and, I ripped them down and said this is the best one.
Yeah.
But I think
So,
it turned out
so
quite nice.
osmosis. Oh, it's beautiful and blows up well. Hi,
So
Paul.
I have an answer to this question. The Sony a7 III and up and the a7 II will send, using their program on your phone, they will send the image to your phone. However, you only get the JPEG. You do not get the
raw.
ARW.
You don't get the RAW or the TIFF or whatever. I know
ARW.
Nikons and cameras, Nikon and Canons will do the same thing.
Right.
But they
again,
only send the JPEG.
They're sending the low qual JPEG. They're not sending the high res one. I don't know of any. I don't do a lot right now. I'm not doing any astrophotography. That'd be a question for Tyler. Go find Tyler, please.
Just telling him what to
Go
do
find
now.
Tyler real quick.
Who's
And we'll ask
Dr.
Tyler
Barth,
that question because he'll
Mr.
know.
Kent Mark's slave
So Dr.
already.
Barth works for the university, and a right good one too, sir. Then he works at the University of Arkansas, Department of Education. He teaches the teaching students how to teach astronomy. And I'll tell you what, Dr. Barth is full of brilliant ideas. Planetary nebula are made up of planetary gears. Ha 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 ha, Mike Overacker. Some people won't get that one.
I
That
don't
one's-
get it.
That one's funny.
I don't get it at all.
Shake the bush, boss.
Yeah. Planetary gears, like in a transmission or a internal power transmission system. Planetary gears, they're a gear that's inside of another gear. Come on, join the club, buddy.
What is?
So,
Where'd the question go?
the question is, there you go.
Not using a camera on the cell phone, just a camera that uses Bluetooth to send images to your phone.
So do you know of astro cameras that are there any astro cameras that have Bluetooth that sends the pictures to your phone?
No.
I don't think so.
They're all wired connections, unfortunately.
Yeah. And the reason is?
Because it's a wired connection.
No, but why, Dr. D?
Well, the
join us on
the
the line.
wired connection would
He's leaving now.
a lot faster
And
you
stable.
have to, and more
Get out,
stable.
Tyler.
There are DSLRs with Bluetooth, and there are DSLRs with options where they will. It's not Bluetooth; it's a different kind of wireless transmission, and they will send a picture to whatever off camera storage you want to. But if you're using a DSLR, then you can just take the little card, the memory card, and transfer it anywhere. If you're talking about a straight astrophotography camera like the CCD cameras that are just designed for astrophotography, they're really designed to hardwire port into a computer, and that's about it.
Because there's so much data. I mean, you're talking about 20, 30, 40 megabytes of pictures sometimes.
Phones today are so spectacular that I wouldn't doubt that there would be some way that you could take that wired connection and get an adapter and put it right into your phone.
Okay, thanks for the answer. Thinking I enjoy visual but would like to share some images. I work on cars, another hobby I have, and I have a diagnostic scope that sends to my phone. Neat as heck. Yeah, things like that. I know there's I've seen like at auto parts stores where they plug in the module to do diagnostics, and you have the app. Those are awesome. I have a borescope, or a little camera with a 30-foot lead that you can run down into stuff and use. When I was doing welding, we checked inside of pipes for sugaring on stainless steel.
Thing is,
with an app, low res.
Right, low res, low data rate transmission, and they're usually for applications where dropping out a little bit here or there isn't a problem.
Isn't a problem.
But transmitting an astrophotographical image, that would ruin the image. So you need some kind of a hard connection.
Because those, if I remember correctly, those aren't packet transmissions like the internet uses.
They are not.
Those are stream.
FTP.
Right.
FTP.
So, so they just, it's a file and it sends the whole file.
Correct.
Whereas over the internet, it's sending, the whole design of the internet was by the military was really straightforward and simple. So if this node
very
got blown out and we're sending a message to this, we're going to break it up in packets from the pentagon, or this would be the octagon, from the octagon, and we're going to send a message over here to this station, and we're going to send in a bunch of packets, and it's going to go all different directions and end up there, and then reassemble at the end. And so for that method of Bluetooth just doesn't do that. No. And when the camera sends a file to your hard drive, it just sends that file.
Correct.
With zeros and ones and zeros and ones.
Correct.
It's not sending packets. No. The whole idea of the internet was so if a nuclear launch message went out, they could figure out what the message was, right?
Even if pieces of the network dropped out.
Yeah, that's correct. All right, so we got to be careful what we say here. So you're getting ready to talk about Planetary Nebula in an hour. We can't say where or what because we're on Amazon.com.
Do we have this on our carousel?
No, we don't. Do we have Star Mentor up?
Let me see.
The new book? It's a brand new book. I don't think. Talk about it because we
There
can
it
get.
is.
The,
We've got it up.
Pull the book up. Talk about it real quick.
Got it up on the carousel.
Paul's giving us to cut it off, but we're going to ignore him for a minute.
That's right. Okay,
I'm
here
used
we
to
are,
it.
folks. Star Mentor.
Here, sit that on top of that.
We've been.
Kent, you're his microphone.
I know it. Hang on.
We've been talking about this for weeks, folks. This has been more than a year in the writing, and it's been a long process getting out. But I received my copy from the publisher this week, and it's all there. 40 plus years. This is my 45th year in education. So, and most of those teaching astronomy and physics, and I put it all into here for you folks. The idea, there's so many people with new equipment that don't know how to use it. They want a mentor. They want somebody to guide them. And there's other people like Kent who are really experienced, and people are asking them, teach me, Kent, teach me, show me the light. And for both the people who want to share their knowledge and the people who are isolated, that is, out of the astronomical community, there's not a club in your town, this is for you. There's more than 50 activities here for you, and they ramp up from easy to more difficult. They will teach you how to set up your telescope, how to track, how to find objects, learn the sky. And this book has this has like 180 illustrations.
Here, let me just.
And many of them are in color. And it's just lavishly illustrated.
So it just starts at the basics and works your way through.
Works your way up.
And works your way up. Yeah.
And there's some cloudy night projects here.
Right there's one. I'm trying not to break the back of the book right off the bat.
Oh, go ahead. That's my handle, and pass it around so people can
So you see right there how to use
modeling clay.
Modeling clay to make your own craters.
The modeled surface of the moon.
Right.
So that when you get out with your telescope, you've now got a better idea of what you're looking at.
And because of the different colors, you can figure out what happened when.
That's right.
And you can actually start seeing, maybe not knowing the ages, but you get the idea these are younger than those because this has ejecta on top of them.
And how many times, Ken, have you had people come up to a telescope when you're at an outreach event and say, now what am I looking at?
Yeah, the moon.
Yeah.
Yeah, or
and
craters.
When you bring a little more knowledge to the eyepiece, you take a lot more value away from it. And this is a life's work here, folks.
Yeah.
This is 40 years of teaching people how to use telescopes, how to do astronomy, and all the basics, all the fundamentals, and it's here for you in one volume.
I have not read it, but knowing Dr. D and seeing his other offerings, This is worth $31.88 over in the carousel
Wow.
right now.
Because the list price is $35, so that's a great deal.
Uh-oh. Noah, don't tell the book owner that we're cutting his deal.
No, I
know. Hey, sell. Yeah.
Folks, I'm the author, not the vendor.
Right.
So whoever is buying these, it's great, and thank you. But I already sold the book to Springer. So when you buy this and take it out and use it, mostly what you're doing is helping me advance the cause of amateur astronomy, build my brand, and get more products out there. I'm working on a new book called Begin with Binoculars.
Yeah.
And that's my project for this year. And I'm so thrilled with this. This came out.
Have you taken out the Tetons?
Have I
taken out the new Teton binoculars?
No,
Probably
I have not.
So
No.
this is not a self-published book.
No, it is not.
This is a publishing house.
Springer Verlag. Springer is a European company based in Germany, and they have offices around the world. And this is part of the Patrick Moore Practical Astronomy series. For those of you who are familiar with astronomy outreach, Sir Patrick Moore was the British Carl Sagan. I think I can say that.
Yeah.
He was a very popular popularizer of science and advocate.
What show did he have? He had a show. What was his show?
It was in the UK for years,
Yeah,
for decades. The later years, it came over here for a while before he passed.
I remember he had a show. I can't remember what. I've seen his shows before.
So
Springer
I
publishes.
propose that if someone buys the book and has seen you on here, they may contact us, and we might be able to set it up to where you can autograph it for them.
If
they'd have to send it here and we send it back, but we can arrange that.
Scott and company are good with it, anybody is.
It'll cost shipping both ways.
Yeah. Basically, send it with a self-addressed stamped envelope.
But even more,
right? So I can sign it, put it back in the envelope, drop it in the post for you, and give me some hint about what you'd like, because I have kind of a strange sense of humor. How I would sign a book for Scott or for Kent might be completely different from how you'd like yours signed.
Yes.
But I would
Because we had
be happy
Mike
to sign any
Overrecker.
copy.
He's asking that.
Yeah, so
exact
that's how we
question.
could do it. We have them here. If you order one, hey, Noah, are those FBA or FBS right now?
Books are not sold by us.
Okay, not sold by us at all. So we would have to.
You'd have to send it to us.
Yeah, you have to buy it, get it, mail it to us, and then we'll mail it back to you. We can work that out.
Explorer store here in Springfield.
Talk to one of us.
Yes.
You know.
Yes.
Since I'm on
customer service.
Since I'm on Amazon, I have to say it this way.
Okay.
Go to Amazon.com to the Explore Scientific store on Amazon.com. Click Contact Seller. Send Noah a message, and Noah will tell you how to go about getting the book here and get it back. Because we can't just have a book just appear.
No.
Yeah, we get so much mail in boxes. We don't want that. So also, if you do buy it here on Amazon Live, get the book, read the book, come back, and give it a review.
Please.
That goes for any product you buy here on Amazon.
That's so important.
Live. Reviews are hugely important. Obviously, you know, we like good reviews. But honest reviews.
People aren't entirely happy. Helps us improve products.
Correct.
And helps me as an author improve my product. Education and outreach is my product. And when I hear from people who are using my stuff and my work and my activities, and they say, "Oh, Doc, what about this? And I saw this and I didn't understand it," or "I saw this and what's the next step?" And anyone who has questions reading the book is welcome to contact me. I don't know, is it kosher to give out an email on here?
No, we can't do it.
We can't.
So
go to the
Amazon
information
bots.
for me is actually in the book.
Yeah.
Yeah.
Amazon bots are really, really finicky, and they don't care. And so they'll kick people off. We have products.
We can't send people off of the website to contact us.
Let me give a good
else.
example.
Contact for me is in the book. So you buy the
Let me
book.
give a good example. We have, it's so weird. We have products that are taken off of Amazon from time to time because they say we are selling pesticides.
Yeah, there's
So what? Pesticides?
Yes.
telescopes. Oh, I can't sell it because it's a
I've
pesticide.
zapped an ant with a magnifying glass in my day when I was 10 or 11. But
Science.
Yeah.
That's not. I don't know
So-
if that's pesticide.
That's why we have to be so careful on Amazon
Yes, of
because it's the algorithms
And
don't care. They have no
argue-
feelings.
No, and it's very nice of them to host us, and we want to be a good guest and follow their rules.
And you can't argue with an algorithm.
Nope.
There's no one to talk to. All right, so run over a little bit. I'm glad you came in so we show you a book. Get the book, read it. You're going to learn something that's going to help you in your outreach. 100% guaranteed. It's well thought out. As I said, all the education students at the University of Arkansas in Fayetteville take a Dr. Barth class or two, learning how to teach astronomy to whatever age group that they're in.
I train mostly K-8 educators, but occasionally people who teach older kids.
Right. So you will learn something, and you will up your outreach game. Dr. Barth talked about, building the brand. Look, as amateur astronomers, our brand is amateur astronomy.
It absolutely is.
And this will help you build the brand of amateur astronomy right there.
And I've always said, Kent, and you know this is true, the telescope is a party in a box.
Oh, yeah.
You go set up your telescope in your driveway, and you're looking at the moon, you're looking at Saturn, you're going to draw a crowd. People will literally pull their cars over coming down your street. Is that a telescope? Can I have a go? And they come up, will you teach me? What am I looking at? How can I see this? Is this different? What's the magnification? So immediately the questions start bubbling out.
We had a couple, man and woman, that came down from Springfield.
Sure.
Close to Springfield. Up close. It doesn't matter. Missouri. And they knew the store was here. And their anniversary was Friday, and she wanted to come down and buy her husband. He was interested in astronomy, and she wanted to buy a telescope and a mount, and what are they going to need, and getting their budget together. And I said, oh, well, hey, we're going to have NWA Space, the nonprofit board I'm on with Dr. Barth, we're going to have observing at a bar in downtown Bentonville, Arkansas, and, you can go eat at Wright's Barbecue, and come on by. And she's like, yeah, we'll do that. So they went to the Walmart Museum, and I don't think they went to Crystal Bridges, but then they showed up and looked at the sun, and she was buying it for her husband, right? She is...
Look got set, didn't it?
Deep and hard, brother. She was like, oh my gosh, that's the... And we were talking about it, and the moon came up, and we got the 16-inch knob out and put it on the moon. And she messaged me on Saturday going, okay, that star party you're talking about in Arizona, when is it? Because we're going to come, right? She was hooked and had just been, and she was sort of interested, but she left there inspired by looking through a couple of telescopes. And we had people literally who were driving down the road. It's in a residential / bar industrial area. And there are people who you'd see them looking, and they'd go down and park and come walking back. People ride, it's a bicycle. Can't call it a biker's bar because it's a bicycler's.
Cycler's bar.
It's a cycler's bar and restaurant. Really good food. And called the Meteor Cafe. They'd go riding back, and you'd see them pull a U-turn and come back,
Yep.
And it was awesome. It was just absolutely awesome.
Yep.
We were there until midnight.
I'm sure.
Pekka says hi, by the way.
Who does?
Pekka.
Hey, Pekka, how are you?
There's Pekka.
There. Howdy, Kent and Daniel. Howdies. Howdies back at you, Pekka. For those of you who have not maybe been seeing the broadcast before, this is a global audience. Today we've had, I know, people from...
Dubai?
Dubai,
Not Dubai.
Sweden,
UAE.
Not Dubai. UAE, Sweden, all over the United States. I haven't seen anybody I know from anywhere else, but a truly global audience, and this is the cool part about it. All right, last comment, then we're going to have to go.
About
Pekka.
Dr. Barth's books immediately. If he could send them private post, not company, that way I would skip the unnecessary taxes.
Pekka, we'll talk.
We'll talk. We got you, buddy. We'll fix you up.
Oh my
gosh.
gosh.
We'll talk off the show. And I'm gonna address your other question you emailed me about today on my show later, so that'll be fun.
All right.
But this, you know what? I'll be willing to put it out there, hands down. This is going to be the best guide to introductory astronomy you've ever seen. You want to, people who already own a telescope, and you know the fatigue sets in after, what do I do now?
Mm-hmm.
Here you go. Somebody comes up and says, oh, but I have this telescope, and now my neighbor's 12-year-old kid is asking me to teach him. What do I do? Here you go. Somebody says, oh, we have a club. We want activities to do on our outreach. Here you go. You're a school teacher, and you're planning activities that will engage hands and minds, both in the classroom and out under the dark sky. I wrote this for you. I wrote it for y'all.
We got to go. Okay. We have to get out of here. Osmosis 007, I know I saw a message pop up. We've got to go. No time to answer it because we got to get the studio reset for Dr. D to get going here at 4 o'clock. So ask next time if you get on, and we will go from there. Everyone, thank you very much for sharing your time with us, because it's an honor to see how many, it truly is, how many people are willing to give us their time to participate in How Do You Know, in Global Star Party, in First Light Chronicles, On the Wing,
and
Focus on
Amazon Live.
Astrophotography, and on Amazon Live. We truly appreciate your time, because you know what? Our brand is Amateur Astronomy. You're part of our brand. We're part of Amateur Astronomy. Everybody that gets into it helps everybody else.
That's right.
With that, on behalf of everybody else here at Explore Scientific and Dr. Barth, as well as Paul Newton, the disemboweled voice, the disembodied voice. He's not disemboweled anymore. And hey, Noah, wave to the camera. Here's what it looked like today. He waved with his right hand today, not his left. And we're going to get out of here.
He has much more hair than you. He has much more hair than you.
He does, but I have a lot of hair. I just get a burr every 3 weeks.
All right. Bye.
Out of here. Bye. Bye.
National Geographic CF600 PM telescope lets you explore the intricate contours of lunar terrain or the brilliant clusters of Pleiades. Use the red dot finder to accurately line up this entry-level scope with the Alt-Azimuth mount and tripod to begin your journey into the world of amateur astronomy. The 90-degree diagonal mirror assembly makes viewing comfortable, and the built-in storage trays keep your 2 included eyepieces safe and secure. The easy-to-use telescope lets you see clearly with an aperture of 50mm with a 600mm focal length, and the unique carbon fiber styling of the CF600 PM gives this scope a modern, rugged edge. Use the included online astronomy software and star map with the National Geographic CF600 PM telescope to begin your journey to exploration of the stars.
Thank you for watching our 24-hour-a-day live stream here at Explore Scientific, where we show you all the programs that we run live in front of a live audience. Programs like Global Star Party, On the Wing for birders, First Light Chronicles for beginners, and Focus on Astrophotography for astrophotographers. We bring in astronomers and explorers from around the world to answer your questions live. But there's so much cool information there that we decided to package it all together and run it 24 hours a day. We're also on Amazon Live, where we do deep dives into our products and our gear. There's so much important information as we share the education, the experience, answering questions from the audience, that kind of thing. So tune in, and thanks for watching.
Hi everybody, it's Mike Hatch with Explore Scientific. Today we're going to show you exactly how to collimate your refractor telescope. What you're going to need is a Cheshire eyepiece, a hex wrench, and a flashlight. So collimation is the alignment of the lens cell on the end of your telescope. The lens cell is what's holding those optics in, so you want to make sure those are aligned and centered to give you the best performance out of your telescope. Now looking at our board here, we've got two examples, one of a collimated telescope and one that is out of collimation. By looking through your Cheshire eyepiece, you're going to be able to see crosshairs or circles depending on the design of your Cheshire. A collimated telescope is going to have one solid crosshair right in the middle of that lens cell. An out of collimation telescope, you're going to see multiple crosshairs that are out of the center. Your goal is to bring those crosshairs into the center to create one bold crosshair. So this is our Cheshire eyepiece, and you can find these across the web and order one at any range of price. Now, you will install this into the back of your telescope into the focuser. You're then going to snug your tensioned collar to hold this in place, and you want to make sure that it's nice and flush against the end of that focuser to ensure an accurate collimation reading. Once it's installed in the back of the focuser, you're going to take your flashlight and shine it right through the top of that opening, like so. And there's then going to be a peephole in the back of the Cheshire, and that's how you will view the position of your collimation. Now, to understand the front of your telescope a little bit better, you will see 3 to 4 groupings of 2 screws around the front of your lens cell. One is your adjusting screw, and one is your locking screw. The one on the right is your locking screw, and you'll see that it's sticking out a little bit farther than the adjusting screw. Now, to start your collimation process, you're going to loosen this locking screw very slightly, anywhere from 1/4 to 1/2 turn. Then you will be able to adjust your adjusting screw to achieve perfect collimation. Here we have 2 examples, one of a collimated lens cell and one that is out of collimation. The collimated lens cell, you can see there's one solid crosshair in the center of the optics. The out of collimation, you will see anywhere from 2 to 3 crosshairs that are out of place, not in the center. So our goal is to bring those in and stack them on top of each other to create that one solid crosshair. Now, after you've loosened your locking screw slightly, you are then going to evaluate the position of the out-of-place crosshairs. You are then going to find the adjustment point that is opposite of those out-of-place crosshairs. You will then adjust your adjusting screw, snug up all the locking screws around the lens cell, go back to your Cheshire eyepiece, and evaluate your collimation. If it's still out of place, you'll go back to the front of the lens cell, you'll loosen up those locking screws, do your adjustment on your adjusting screw, and go back to the Cheshire and repeat the process as necessary. And don't forget to lock it. That will ensure that your collimation will stay in place after it's been achieved. Thanks for watching, guys. That is exactly how you collimate a refractor telescope. So if you run into any problems or have any questions, go ahead and call our 800 number or reach out to our customer service through email, and they'll be able to help you with any of your needs.
Discover the inner beauty hidden inside common rocks with the Explore One Rock Tumbler set. The set mimics natural weathering processes, and in a matter of weeks, the tumbler can turn rough-edged rocks into smooth, shiny stones, showcasing intriguing colors and patterns. Junior geologists can start immediately with the included selection of stones and will love seeing the everyday rocks they've collected transformed into shiny works of art. And the learning continues by investigating rock composition and learning about geological processes. Turn learning into art with the Explore One Rock Tumbler.
Hey, this is Tyler with Explore Scientific. Welcome back to this wonderful series we're going to have on Explore First Light. Today we're going to talk about mounts. What mount do we want to use them for? Either German equatorial, an alt-azimuth, or a go-to system, which are these two over here. Today we're going to discuss the German equatorial mount. Now with the German equatorial mount, it is greatly advised that you always point these mounts north, towards the North Celestial Pole. That way you can get a decent polar alignment, and that way you can track the said object with our slow motion control knobs in the RA axis, which is the top axis right here. So you'll line up with the said object, we'll just use the moon for reference, in the deck, and then we'll just sit there and rotate back and forth to the object in just one direction. The next mount is our alt-azimuth. Now with this particular mount, it doesn't matter with polar alignment. You can just plop it on the ground, salute a said object, left, right, up, down. This is the deck, or the left, right, up, down version. And here is the east to west, north and south. Next, we're gonna actually go with our go-to systems. This is our iXOS 100, and this is his bigger brother, the Exos 2 PMC8. Both can be controlled with Android tablets or Apple tablets. We have what is called the Explorer Stars app within the said systems, one in the box here and one in the controller here. Now, you can use the Explorer Stars app to do Messier objects, IC objects, or deep sky objects as well. I hope this explains a brief introductory of our mounts, and I hope to see you in the next video. We're also going to be talking about Newtonians next. I hope everybody has clear skies and keep looking up.
Thank you for watching our 24-hour-a-day live stream here at Explore Scientific, where we show you all the programs that we run live in front of a live audience. Programs like Global Star Party, On the Wing for birders, First Light Chronicles for beginners, and Focus on Astrophotography for astrophotographers. We bring in astronomers and explorers from around the world to answer your questions live. But there's so much cool information there that we decided to package it all together and run it 24 hours a day. We're also on Amazon Live, where we do deep dives into our products and our gear. There's so much important information as we share the education, the experience, answering questions from the audience, that kind of thing. So tune in, and thanks for watching.
Are you having a hard time trying to figure out what telescope to get? Don't worry guys, Tyler here with Explore Scientific is going to help you figuring out what you're wanting to do, either astrophotography or visual. I always tell customers that telescopes it's kind of like golfing, it's carpentry, it's a hobby that you have to learn specific tools in what they do, because these are tools. I consider them as tools, and they have a specific purpose in what you're wanting to do, either visually or astrophotography. First, we're going to talk about this little beauty, the Maxudo of Cassegrain. Great for planets, so if you are wanting nothing but planets, this bad boy is the way to go. If you're wanting some deep sky objects and some planetary, the reflector right here from Explorer First Light is also the way to go. But if you just want deep sky objects, if you want wide field of view, a refractor is the way to go. These are just a couple of basics here at the Explore First Light series. The Maxudo of Cassegrain, the Newtonian, and the refractor. All of these scopes come with a red dot finder, a smartphone adapter to get you started in astrophotography, as well as an eyepiece, and whichever mount that you want to choose with the combination of telescope you want. If you need help out there on Amazon, don't be afraid to reach out through the live chat. We'll make sure that we get back with you as soon as we can here at Explore Scientific. Hi, I'm Tyler and welcome back to our Explore First Light series. Today we're going to talk about the Newtonian, and specifically this is the 114 millimeter Newtonian with a 4.5 inch mirror. How these Newtonians work is light will enter through the main objective, bounce off the primary, hit the secondary, and goes right into our diagonal, or our rack and pinion with an eyepiece or our cell phone adapter. This has 40 millimeters of draw tube, and now all these telescopes come with a red dot finder, a 25 millimeter colossal, and a cell phone adapter. Now with these particular First Light telescopes, they always come with a couple of options as far as mounts. The EQ3, a nano mount, a Twilight 1, or an Alt-Az mount. Now with these particular telescopes, it is always recommended that you get multiple eyepieces. And I always recommend the 52 degree series that we see here, also with a focal extender. Usually 2 times is plenty enough. Now with these eyepieces, they are waterproof and argon purged, and they make a perfect addition to these telescopes to help you visually acquire what you're wanting to see. Now again, I hope you guys tune in for our next episode. We're going to be talking about our 80 millimeter refractor on the First Light series. And again, my name is Tyler, and I hope you have clear skies and keep looking up.
Products. I tried to get Tyler Bowman to help me, but he's a little grumpy today, so he's not here. All right, so if you're out in the Amazon world, please give us a shout out. I want to know that you're out there. I want to see who's watching. I like to talk to you guys, and let me fix my TV real fast. And so anyways, so here at Explore Scientific, we have quite a few things that are geared towards children and that a teenage age range. And so anyway, so I wanted to show you some fun things that we have for kids. So here we go. So the first thing I'm going to show you is our nature, water, and land habitat. This I really like. It has a magnifier on the top, which you can take off. So there's a magnifier on the top. So when you put whatever it is in there, you can see down in it and get a close-up view of whatever you have captured. Make sure that you release whatever you capture. Then this comes right off, as you can see. And there's air holes in there, so whatever it is that you have found and want to observe for a little while can still get oxygen. The great thing about this product is that it is a land and water habitat, so you can take it down to the creek, lake, river, whatever you want to, and scoop you up something out of the water and see what you can find. So there's obviously the bucket. Then it comes with